It's just short for kosher chocolate. That's what it's short for.
So what does it mean for sure? Is that what it means? Like,
I just told you it's short for kosher chocolate.
Oh, you're lying.
It used to be, it used to be Kosho Choco, and then before that was Kosher Chocolate. That was my first name.
Here's what I'm feeling. I'm feeling like the hundred of times previous where you denied to elaborate on your name, it would be out of pattern for you to just casually throw it out there and give the.
I feel like you've asked me before, and I feel like I've told you this before. The same thing. My buddy John Roberts.
You've been rather cryptic with it.
No, so I said it's Kosho, kosher. It used to be Kosho Choco because it's kosher chocolate. It was my old screen name. My friend, the name my friend gave me. Sorry. Okay, so one thing down. You know what the problem is? I procrastinate too much, man. We're getting ready to work on that. I was working on this fucking project, and then I went over the AI thing, and I told Scott Veach I could get it to write a screenplay, because I did. I got it to write a screenplay the other day, and then I had it writing a Bible just a second ago. I had the whole fucking AI writing. I told it I wanted a third installment to the Bible, a sequel to the New Testament. And it was like writing a Bible for me. But I see it's got new features on here, so I'm checking it out. But I need to stop procrastinating, dude. That's just crazy, dude. So there's a new fucking thing. Let me see. So I'm using the codex from OpenAI, and I'm gonna see if I can get it to write me this program. Uh, did you still want that magic card thing, Don?
Me?
Yeah.
No, I don't need it. No. I'm just telling you. Like when you said we're scraping, I was just like, oh, I know what you're talking about. But look, I'm about to get off. We're about to go eat, man. Hit me up, man.
Yeah, I'll hit you up.
Dude, I got way awesomer programs that way awesomer shit. Way awesome.
You guys hotboxing?
Way mo awesome. So yeah, no, for real. Hit me up. You know what I'm saying? Can shake my hand, man. I'll have you sign a little contract, and then we'll be taking over the world. Let's go. Let's get excited. But finish that up. You say you're on if you're on whatever it's called, just deadline, just finish your thing and come out Wednesday. I'll holler at y'all.
All right, I'll see my man. Sorry, I'm hitting over my friend now. She might have to come.
That picture looks a little bit like what Amber Heard did on Johnny Depp's pillow. Hello. Yo, where's everyone at? What the fuck?
What's up?
Chilling, bro. You out here? You at work?
Nah, I'm going in a little while though.
Oh, what's been happening today, man?
Not much.
Why were you posting definitions of what a hypothesis is? What were you guys arguing about?
If you can do an experiment on a law,
On a scientific law?
yeah, like I don't know, the conservation of momentum or
Yeah.
something.
I don't know if the conservation of momentum is a scientific law per se. You know, it derives, it doesn't even derive from a scientific law. It's explained well by scientific laws, but
No, it's
conservation of
described
momentum,
well. It's
yeah,
described
our
well.
conservation.
Explaining something and describing something is two different things.
Yeah, you gotta let me finish, bro. But I'm just waiting for you to finish
Yeah, my bad.
what you want to say.
Go ahead.
You sure? Okay, cool. Yeah, what I was going to say is our quote unquote conservation laws come from symmetries. You know, and symmetries are kind of postulated. You know, it's something we all agree on because we have no reason to disagree. For example, symmetry through time. If you do an experiment today and then you wait 10 hours and you do the same experiment the exact same way, you should get the same results. So that shows you the laws of nature don't change over time. But there's no way to falsify that. The only way we would be able to falsify that is if we actually saw the laws of nature change. And until that moment happens, we are stuck with these symmetries and these conservation laws. But I would
There's no
say
way to,
these laws. Mhm.
so there's no way to falsify the conservation momentum, right?
Yeah, because how do you get rid of momentum? How do you destroy and make energy and matter? There's no way to falsify these laws. They come from these
If you're gonna
symmetries.
do,
Now,
go ahead. My bad.
yeah. Yeah, I was going to say now something like the law of gravity or Boltzmann's law or Hooke's law. These other kind of laws, they are observations we see, and from these observations we derive an equation that explains the observation. So for gravity, we see things fall down. We make a measurement, and then we have a equation that explains the measurement and the observation, which is Newton's universal law of gravitation. So it's a statement made on an observation we see. So there's no way to falsify that as well, because we see it happen. You see things fall down. You and I can debate on what's causing things to fall down. It could be mass attracting mass. It could be relative density. But the law just states this is what we are seeing. And we see
Would
this
you agree that?
happen. Mhm.
My bad.
No, go ahead, bro. Go ahead.
Would you agree that a hypothesis has to be falsifiable?
Not really, because a hypothesis is just a guess. You are hypothesizing something. And what needs to be falsifiable is the experiment you subject that hypothesis to. I could guess, I could just make a well-educated guess that I could hypothesize, because I've seen in nature that when you put a flame to something, its temperature increases.
Real quick.
Right?
Real quick. This is from Britannica right here. The two primary features of a scientific hypothesis are falsifiability and testability. Like, I don't know, you might just be wrong on that. A hypothesis being falsifiable.
Well, I mean, like I'm saying, it's when you subject the hypothesis to experimentation that it now needs to be falsifiable. If you want to subject the hypothesis to an experiment, but the experiment can only give one result, and that result confirms your bias, then that hypothesis is not falsifiable. But a hypothesis in itself, just a blanket statement that you make about an observation you see in nature. Something was exposed to a fire and its heat increased. I'm hypothesizing that fire increases the temperature of things. Just as a blanket statement like that, it's fine. But now the question is, do I want to prove this statement true or false? And it's in wanting to prove it true or false that it needs to be falsifiable, because I'm going to subject it to an experiment. Does that make sense? I don't know if you heard me, bro. Because we hypothesize things every day. We make statements on things we see every day, but it's not to say you're going to subject everything you do to an experiment. It's only if you want to falsify it, prove it beyond reasonable doubt to be true or false. That now, because I'm going to subject it to an experiment, it needs to be falsified. I need to be able to prove it right or wrong. But that's my own personal interpretation at the end of the day.
Yeah, I mean, I
I
got plenty of citations saying that a hypothesis has to be falsifiable. I mean, that's not even a question. I mean,
I don't disagree with that. That's why I keep saying, bro, if you want to prove a hypothesis true or false, then it needs to be falsifiable. But if you just make it a blanket hypothesis, I think Jesus is the Son of God. And you want to talk about that on a metaphysical level. You don't need to be able to falsify that statement. But if you want to subject it to science and prove whether or not it's true or false, then it needs to be falsifiable. You need to be able to subject that statement to an experiment if you're trying to do science. Yeah, and I think that's the crux of it. Within the realms of science, if you want to subject the hypothesis to science, it needs to be falsifiable. But if we just on the street talking, bro, and we're spitting ideas, like, are we really going to start science and shit? You're so quiet, bro. I don't know if you're listening to me. And
hold on a second.
yo, she made me wait like yesterday. I believe though.
All right, I had to get my kid off the bus.
Oh, well.
So yeah, hypothesis got to be falsifiable. Scientific
Within the
hypothesis.
realms of science.
Yeah,
Scientific
we're talking.
Exactly.
Yeah, if we're talking.
Exactly.
If we're talking science, yes, hypothesis definitely got to be falsifiable. You can't falsify the conservation of momentum. You said, right?
Yeah, because that doesn't derive from experimentation. That's a conservation law that derives from symmetry. It doesn't. It derives loosely from observation, but it's from the fact that we don't observe the opposite. We've never observed energy being created or destroyed. We've never observed, the conservation of momentum being violated. So we have to stick to these symmetries. We've never seen something to make us think this statement, this postulate isn't true. It's the same with relativity, for example. Relativity is based on two postulates.
Hold on.
First one is
Hold on. Hold on. Let's just stay with the conservation momentum because I'm deep in an argument with
but
this
you're breaking up.
guy that thinks you can do an experiment on it.
You were breaking up. I didn't hear a word you said, bro.
Good now?
Hmm?
Good now?
Yeah, you're good now. Sorry, you were saying?
Okay, so I mean, I think we both just came to an agreement that the conservation momentum isn't falsifiable, and in order to have a hypothesis on something, it's got to be falsifiable, right?
Yeah, but as I said, the conservation of momentum laws do not generate from experiment. It is through
I
falsifiability
know.
or
I
experimentation.
know that.
Yeah, so they're a bit special. You can perform experiments to show that conservation can't be the conservation of momentum can't be violated, but you know I would like to see you do such an experiment in an isolated system where you want to show it can be violated. That's impossible. You can't do an experiment within an isolated thermodynamic system where momentum is violated. So if you cannot do that, can you say it's falsifiable? You see what I'm saying? So it's a very special case.
Can you have an experiment?
Right.
Can you have an experiment without a hypothesis?
An experiment without a hypothesis? No, I don't
Scientific
think so.
experiment, yes.
You're
You
you're
can't.
breaking up.
Okay, that was the
You're
correct
breaking up.
answer.
No, I just said I don't think so. I need to think about it, but I don't see how.
No, you don't need a hypothesis to do an experiment.
Yeah,
Get the fuck.
Experiment is the
Are you
evidence that
serious?
supports. Experiment. Why do every single time I say a
yeah.
word, you gotta jump
It
in?
depends.
It
Yeah, it
doesn't depend.
depends how
It's
you define
they're
an
different.
experiment.
No, we know what an experiment is. It's a test of something.
It's
A
a
hypothesis is a story.
Yeah.
Yeah,
A
of
hypothesis is
something.
a story
That
that
something is
tells
a
about why you think something happens, the observation, and then you support it with experimentation. You're still listening to fucking QE about this nonsense. Stop doing that. You're just going to become dumber.
Zanik,
You
could you?
just said it. You just said it. An experiment is a test of something. That something is a hypothesis. It's a
Yeah.
hypothesis.
No, it's
Zanik,
not the
can you
test
give
of the
What an
us
experiment
hypothesis.
is.
The test
Zanik,
is the
can you give us an example of an
yes,
experiment where there
yes,
is
an
no
experiment.
there is
I have
no
I have a
hypothesis?
plant, and I want to see how much it grows when I add water to it.
Mm-hmm.
All right, I can have another test.
That's
It's not a hypothesis.
isn't
it
that
is.
more
No, my
measurement?
hypothesis.
Would you call that an
Let me
experiment?
tell you my hypothesis. My hypothesis is that in order for a
No,
plant
no,
to grow,
you
I need
shouldn't have
all these things:
a
water,
hypothesis.
sunlight, soil. Let me finish. Water, sunlight, soil, temperature. All these things are my. And when it does, it chlorophyll, and there's reaction
Then
and
you're doing the
photosynthesis.
wrong
God
thing,
damn
Zanik.
it! Why? Why is it
Zanik, I
necessary?
need to stop you because you don't understand the convo Jeremy and I are having, and this is what you're saying. What
No, I
Jeremy and I
do.
want is an example of an experiment where there's no hypothesis. You keep on giving us experiments with an experiment
Well,
or
no,
measurement,
I
in
can
this
give you.
case, with a hypothesis. Can you
I
give
can
us
have
an
an experiment.
experiment without an hypothesis?
Easy. I want to see
Mhm.
if what happens when I light a piece of wood with a flame. Does it burn?
Mhm.
What is it? What color is the flame? What's left over after it's done? That could be an experiment. There's no hypothesis there. I'm just going to see what happens. I'm
Oh
having
my
an
gosh.
experiment, right?
Oh my
Wouldn't you
God.
call
No.
that an observation?
Yes.
Well,
I
you're
don't know.
observing an experiment. No, it's not an observation.
I know.
An observation is
Sure.
something where you see something happen. God damn it.
I
Yeah, so, Gio, you see
You
what I'm
gotta
saying here?
calm
You're
down.
always accusing
Calm
me
down.
of shit. And now look at this.
Zanik, calm down, bro.
We
calm
can't
down,
even have
Zanik. Calm
a
down.
normal human conversation.
It's because you're
Can
getting
you
so
calm
worked
down,
up,
Zanik?
man.
No, because I don't.
Yeah,
Yeah,
please
I
calm
always
down.
get worked up when I'm overspoken. I don't
Well,
like it.
calm down.
All right. Zanik, the floor is yours. Explain yourself. No one's going to
No,
interrupt you, but
an
please calm down.
experiment can be anything with no hypothesis, because a hypothesis is a story of what you do an observation and you describe with a story about what you think causes this thing to occur, and then you bake it. Then you say, okay, I'm going to do some experimentation. So that's what you didn't want to know. Now, experiment without hypothesis is just I want to test something. I want to do a test. I want to like poke a screwdriver in my freaking tire and see if it leaks air. I don't know if it will, or I don't know what's going to happen. I'm just going to poke a hole in the tire and see what happens. It's not, there's no hypothesis.
That's an isn't that an observation,
No,
Zanik?
the observation is what happens when after I poke. So now, there we go. Good. I'm glad you said it's a good segue. I poke the freaking tire with the screwdriver and it sprays it. Water comes out of it. And then some steam, and then just air. And I go, oh, that's weird. Now I observed this. Now I develop a hypothesis. Why did water come out?
Exactly.
Then
Yeah.
steam
So
come
you're
out?
agreeing with us.
No, I had no
Yeah,
hypothesis.
because you just had your observation. You had your observation, which wasn't an experiment.
No,
You
I
saw water
started
come
with the
out the
experiment.
tire. You don't
I-
know. No, you didn't. You just started with an
Yes,
observation. You saw
okay,
water come out
stop
a
again.
tire after you poked it. That is
Stop
a
again.
naturally occurring phenomena
Stop
in
again.
nature.
Stop
Now
again.
you want to know why did that happen? And
Stop
you're
again.
hypothesizing.
Yeah, so you just double spoke right there. I'll start to say it one more time really slowly and quickly. I want to just do a
Right.
test. My test is what happens when I stick a knife into a tire. It's just an experiment. There's no observation yet. The observation comes after. As a result of this experiment, I observe what happened. Why is this so difficult?
The first step is an observation, dude.
No, I'm not doing an hypothesis. That's the first step in a hypothesis. I'm not
An
hypothesizing.
experiment requires
No, the first step is always observation. You can't
No, I'm not. The
hypothesize nothing.
observation is what happens when I do.
You don't
Oh
hypothesize
my
thin
God!
air.
Okay,
No,
you're
Zanik.
wrong.
Then
and that's
you've
okay.
never done
You can
science.
live in this
You
ignorance.
always need whether you are doing an experiment or a test or a measurement. You always need your naturally occurring
No, you
phenomena
don't.
that you have
just made that
observed
up.
in nature.
You
It doesn't
just made
happen
that
Yeah,
up.
before the
you need to
experiment is set up.
need to
No, you
observe
I want to
something.
do an experiment.
No, you don't.
I do
All right,
something.
all
And
right.
okay, here's an experiment.
Come up with an
I
hypothesis
I'm
on
think
about-
something
about.
you haven't observed.
Stop it! Stop it! I'm going to drop a ball and see which way it goes, up, down, sideways, whatever. That's my experiment.
Yeah,
Here's my experiment. I'm going to drop it. The experiment is I'm dropping it. The observation is observing what happens when I drop it. The dropping part, I'm going to drop it, is my experiment. It's not based on a hypothesis. Now, the hypothesis would come afterward. Wow, it dropped. I observed it dropping. Here's the rate at which it fell. Here's the mass at which it is. Okay, let me make a story about what I think happened. that would be my hypothesis. Now I start testing it. I change the mass, change the distance.
Oh, an
you know.
experiment. Okay.
Yes,
I
the
think,
experiment will
Zanny, I
validate,
think
will
you- I
provide
think you-
evidence. What's it? The experiment will provide evidence and validate the hypothesis. This is not that hard,
Yeah,
guys.
it verifies or falsifies it by manipulating the independent variable that you are assuming is the cause of the effect.
In the experiment, not in the hypothesis.
The hypothesis is part of an experiment, man. That's the
No,
scientific method.
no,
Dude,
no.
Dude,
You're
that's
wrong.
how
You are wrong.
dude.
God, Mike, come on. What's it? We went over this before. Remember, you do all this reading on Wikipedia and this and that. And if you go to school, you learn the difference between experiments and hypothesis. You don't know this because you listen to QE too much.
Okay, first of all, I don't listen to other people, nor do I read Wikipedia. Secondly, do you ever work out? Because you really got to chill out, man. You need to start working out or something.
God, shut up.
You're
Right,
just being
so
very
someone was-
frantic and
No,
impulsive.
I do work out, and I have a high
Yeah, you are very
intolerance
excited.
for
Simon.
knuckleheadedness.
Right,
All right.
Calm down, man.
Can
So
I just
work
tackle
out.
this issue?
Danny,
I would
calm
crush
down.
you in any
It's
kind
just-
of
it's just
sport
people-
whatsoever.
Yeah, but
So you
Danny,
don't
it's
tell
just
me
You would
I'm
crush
supposed
that
to
you're
get
talking
talent.
about Discord. Please calm down.
Real fast, Zanny.
Right,
You said
please
you
calm
crushed
down,
me.
man.
Hey, so
I
I'm
want to
gonna
ask
have to
Zanny,
start
Jeremy,
muting
Jeremy,
people.
Zanny. Did you just say you'd crush me in any kind of sport?
Oh, shut up.
Yes.
I'm just.
So-
What are you talking about, Zanny? Are you
Yes.
serious?
Right, so be
Okay, we can
quiet.
move on.
So
We'll move
here,
on.
I want to tackle this idea that you need to have a phenomenon before you do something. It's utter bollocks. That's something you see in high school books to try and teach people about scientific experiments. For instance, the discovery of the positron or the neutrino. They were proposed to exist. They hadn't been observed, but some modelling of what they believed the process of radioactive decay, for instance, was, in the case of the neutrino, was that there should be this other particle. It was proposed. There was a theoretical physicist saying,
You're right,
we've
you're
got
right.
this
He's
constellation
right.
momentum.
But is-
This the whole Jesus, can I bloody finish?
No.
So then this other particle was proposed. No phenomenon, this was proposed. And then many years later, someone then was able to test whether or not this existed using this proposal, this in a paper saying this should exist, and they then did an experiment to test with it, and it did. So you can do science without having any, and generate your hypothesis first before you have a natural phenomenon. And anybody who suggests you have to have a natural phenomenon is clearly just mouthing QE nonsense over what he's read on high school websites. And if you say that, you are a moron.
All right, let me
Yeah,
respond.
but-
Let me respond.
Yeah,
Let me
he's got
respond.
a point there.
Wait,
Winston.
wait,
Let me
wait,
respond. Let me respond, man.
He's got a
Before
point
you
there,
go,
right?
Winston, I'll be very short. Whoever was speaking out, British guy, you are kind of right.
I'm
That is how
always
some
right.
particles were discovered. Not the
Not always.
positron, though. The positron was not hypothesized. It was actually discovered and identified before
Now he's
anyone had
going to
hypothesized.
respond for
No
20 minutes.
bollocks. The positron was
But you are
no.
that is the
Dirac
truth. But you
proposed
are
the
right that some
existence of the
particles
positron
were done that
before
way.
it was detected. He was detected many years after. The same with the neutrino. You're talking utter rubbish. You've no idea what you're talking about, you moron.
Bro, look into it.
This is all.
Look into
I
how
have
a
looked into it. I
positron
know.
was
Do
discovered.
you know who proposed the
This is-
existence
And
of
you
the
don't know what you're
positron?
talking
It's all
about.
around.
Who he proposed the existence of the
Because
positron then, if you're such an expert on this
Paul
subject?
Dirac. It was Paul Dirac.
Yes,
Finding the-
and he
Jeremy,
proposed
you're
its existence
roboting.
well before
Second,
it
this
was
is all-
detected.
Jeremy, you're roboting.
You utter
You're
moron.
roboting, Jeremy.
I get in.
Can I respond to this? Can I respond to
Jeremy,
this? Okay, before we go into Rumpus ranting for 40 hours, okay, this is the thing. You said someone hypothesized and they proposed that this particle was there, okay? Now, proposal is not an experiment. You then said it
No one
was
said it
observed.
was an experiment.
I'm talking.
It doesn't start with a
I'm ta-
phenomenon. The experiment did not start with the phenomenon of the
yo,
existence of
can you
positron.
mute this guy,
Someone
Jeremy?
said
He's
there's
just
this
interrupting
theoretical
people.
theory that a positron exists, and I'm going to go and do something
Rumpus,
to
shut up.
establish its existence, which is an observation.
Rumpus, you have one more chance, dude, okay? Because you just now went on a very long-winded
No,
explanation.
the only long-winded crap is from you. I'm being very concise.
No, stop interrupting. Okay.
You know, you're too
So-
busy shouting at Zanuck over whether you're tougher than he is, you little twat.
Oh my goodness. You need to work out too, man. You guys are freaking out. But anyway, so the point is that you brought up that someone proposed that they thought these particles existed. Okay? It was just a proposal. It's just an idea. I mean, you know, I propose that fairies make the stars move. It doesn't matter what you propose. That's just an idea. Okay? Once they made the observation, they then were able to try to test it. Okay? based on the first observations they made that were consistent with their proposal. Those are two different things. So the proposal, the theoretical proposal, has nothing to do with scientific experimentation. They had to make the observation to manipulate variables to try to verify the proposal. Do you understand? That's clearly different. So to say that the proposal is synonymous with the scientific experimentation is insane, bro. Thanks. Well, we got that covered.
Yeah, but you're still wrong about Dirac hypothesizing that positrons exist. He never did any such thing.
No, he just proposed an idea. He proposed an idea, but my point is that the proposal is not a science experiment.
Yeah. He proposed. Yeah, definitely. But they are not saying that either. They're not saying that a hypothesis is an experiment. They were just trying to say that you can have a hypothesis without observation, which I tend to agree on certain things, but not on the positron. The positron as a particle was never predicted. All Dirac really said.
You're good now.
No, Jeremy, it's calm now. Don't worry. All Dirac really said within his equations was that a electron could hypothetically have a positive and a negative charge. It was only later when the specific particle was discovered that it met these conditions, and we thus called it the positron. And we had this idea that it's basically an electron going backwards in time. It's like the mirror image of it. But Dirac never wrote about a positron. So what Rumpus is saying isn't 100% correct.
Yeah, this is all irrelevant anyways, because finding the existence of something is not a scientific endeavor. There's no experiment. There's no hypothesis.
No, that is science.
Existed.
Though you've discovered something, Jeremy. That is science.
There's no experiment involved. There's no hypothesis
but
involved.
Science isn't only experiments.
Well, dude, it's not just observation. If science was just observation, then there would be no such thing as science. It's a mixture
of them.
Well, no, that's not true.
Yeah, it's a mixture of them.
We do animal behavior sciences. It's a science. We study animals. We don't do experimentation. We only do, and it's strictly based on observation. It's an observational science. That's what they call it.
Observation based on certain variables that manipulate their behavior.
No variables are manipulated. There is only observation. You study the behavior of animals in the wild.
By isolating certain variables.
No, you don't. You can think you're right, but you're not.
I am right. So it's like if you're studying bears and they're in a certain environment and you study bears outside of that environment, you can see the different behavioral characteristics. Okay,
that's not how they do it, though. That's not what they do. They don't do that.
Zanuck, if all you have to do is see something to be science, then every single thing that you've ever done your whole life is you doing a science experiment. That's as dumb as I could imagine being.
Well,
it's like if I look in the sky. If I look in the sky and I make up stories, I'm like, hey, look, this is what I saw. Hey, I saw stars in the sky.
What you're saying is right out of QE's playbook.
If I look up in the sky and I say, hey, look, there's a star in the sky, that's not science, okay? That's me seeing a star in the sky. Now, if you want to try to explain it, you can pretend that that's science, okay? You can try to explain it.
I said behavioral sciences. Astronomy does require test and experimentation. And you can still do that because there are independent variables that we look at. But don't interrupt me because I'm about to have the next sentence that's tied into this. You can tell I'm still talking. Behavioral sciences are studying bears. You don't put them in a cage and see how the differences are. That's not how behavioral sciences work. You study the bears, you see how they deal with their young, you see how they fight off would-be intruders, you see how they hibernate, you see what they eat, you see what they poop. All this is behavioral science, and it is a true science with no experimentation and no independent variables. Thank you.
Observations are not synonymous with science, man.
You keep on saying that, but you don't know what the fuck you're talking about.
Why are you always so mad, though? That's what I'm trying to get.
Because I don't work. Maybe I need to work out more. I don't know. I work out every other day. No,
drink some water.
I get upset because I'm around smart people most of the time, and so I come here, and it's fun here because I thought I could help people that are a little bit confused, like yourself. But no, you're going to teach me the things you learned on Wikipedia and what you learned in QE's forum.
Only Globers read Wikipedia, man. Why do you keep bringing up
Wikipedia?
Okay, so I always every time I cite something, it's like Stanford and Harvard.
I'm usually, partially wrong about everything I bring up because I can't remember everything. But I'm right about the fundamental foundation of these things I speak about.
Dude, I don't even invoke regular universities. I stick with Ivy League. So why do you keep strawmanning me and talking about how I bring up Wikipedia, man? It's so dumb. It's just retarded. So
no, it's more of a catch-all for you're going to an Ivy League website and trying to learn physics. That cracks me up. You
Oh,
can't
no,
learn
that's a
physics
straw man
by just
too,
going
so-
to a website and reading things and think you understand it because you don't have the foundation. You don't have the math. You went to school. I know you went to college. You did all these great things, but you didn't build on that. And you say things that are the logic you use and as well as your math skills are ailing. We talk about
My math
refraction,
skills?
diffraction. We talk about terms like Coriolis. We explained it to you in detail, and you still get them wrong. Not that
talking to you
either
about
happen- Hold on,
Coriolis.
I'm still
Shut
talking.
up.
I'm still talking. Not that you get them wrong because
I'm
you
gonna get
don't
out of here.
apply. We're not saying it's either true or false. We tell you the conditions of which these things exist, and you can't keep them straight in your mind for some reason. But you claim to be a genius, and it's a little bit
Zanuck,
entertaining,
he left.
but it's
He left.
also
Are you done?
sad.
He left, Zanuck.
I
Okay.
haven't left yet, but are you
You
done
sound
yet?
like someone's dad right now, Zanuck. What the fuck?
You got it.
Well,
You
no,
got it
because he's
still,
acting
man.
like someone's kid. That's right.
No, but
I
you literally give the
coach
grown
eighth
men
graders
lectures.
and high school
You're
kids,
talking down
so I
to them.
know this. This
Like,
is like a
calm
template
down, man.
for rebellion and obstinance. This is what it does.
What? Are you done?
Oh yeah.
I have to be honest, man. I think it's kind of weird that you're so like emotionally involved in your opinion of another man. That's my honest opinion. But we can move on. I'm not going to take the
It's
bait.
not you. It's what you say.
Okay. So I'm not going to take the bait to get in some personal dick measuring contest with
I'm
you,
not
Zanuck.
measuring my dick. Please, you lose that too. Listen,
No,
we're not
you
talking
wouldn't.
about
No,
you.
no.
We're talking about
Zanuck,
what you're
Zanuck.
saying.
Only
Get it
people
straight.
with little dicks say stuff like that.
Well,
you know, but like, here's the deal. Here's the deal, Zanuck. Buddy,
I'll put
I'm
my
trying to
girls
talk
up
about
against
the
yours any day of
subject.
the week, but that's okay. Listen,
Oh my
and I'm much
gosh.
older than you, by the way. All right. So, and
I don't
done
care.
things- I've done enough of the things you're going to dream about doing for 5 lifetimes. So I'm not worried about doing any dick measuring comparisons with you. All I'm talking about is what you say,
This is
Whitson.
weird as
Coriolis.
hell.
Yeah, it's
if
so
this
weird.
is true,
Think
then I
about
should
how
jump up and the earth's rotates underneath me. No, that's not what we say. These are things that you just get wrong. Fundamentally get wrong
well,
from the
why
get-go.
why would it invoke an emotional response though, right? Like if under
Because I
your
get,
parent,
you
you
know,
have to
that's my
interrupt
problem.
every time I
That's
talk,
the
man.
cross I bear. I try to help people, and I like right, I like correct. And when people are incorrect and get completely off the rails, incorrect, I go after it. I have fun
Okay.
sparring.
Stop
It's a sparring
interrupting,
match.
man. If every time I just want to enlighten you, okay? So when other people listen to a conversation, and every single time one person's calm and tries to go respond, the other person impulsively interrupts them like 3 words in every time. What do you think the third party thinks? That you're not winning anyone over with this type of behavior, man. So just chill out with the emotional implosions, okay? I'm speaking. Sorry, I'm speaking very simply. Right? Observations are just observations. They're not exclusive to anyone. Everyone can make an observation. That's our first step. That's what we have to go with. The entire idea of science is an attempt to explain what is observed. That is what science is, man. Okay, so observation does not equate science. It's literally what you. It's the
just said the
prerequisite.
same thing.
It's the
You just said
prerequisite.
it is. Yes, observations. You try to explain these observations. That's
Right,
science.
it's the
I agree with you.
prerequisite to science. So to conflate observation to science is very, very ignorant.
I
Okay?
didn't. You just said it wasn't, and it wasn't. Which is it? I mean, come on.
How are you not understand? See, it's like,
No,
and you
you
call me
said
dumb.
everyone
It's
can observe
so
things, but it doesn't mean you're doing science,
wild.
right?
Okay,
Everyone
so
can observe things. Everyone can observe things, but that's not doing science. But science is about
That's right.
observation and explaining
No,
what those
observation is listen carefully, bud. Okay, so observation is the prerequisite to science. Okay, that's science is an attempt to explain what is observed.
Right.
So if you just make an observation and then scream it at the top of your lungs and say that that's science.
I never said that.
No, but that's basically what this conversation is.
No,
Is you guys are conflating observation to science. You do the same thing with the sky. You guys look in the sky and you're like, look, we found a new thing in the sky. Science. And you then think that whatever you come up with as to what's going on in the sky is automatically true. Science is an attempt to explain what is observed and test that theoretical explanation.
And so,
That's it. It's very simple. A 5-year-old can get it.
I don't know why I have to explain this again, but you just talked about 2 different sciences: astronomy, astrophysics, or observational sciences such as observing wild animals in the wild. Both have observations a part of it, yes, and both require explanations of why things we saw happened. Also science. We both agree.
Okay.
They're both a little They're both a little different in that in the observational sciences, it's not oxymoron. It is an observational science. We're studying the bear in their natural habitat. And we're not taking them out and putting them in a zoo and seeing how it's different, as you said. That's incorrect. We don't need to ever take a bear and pull it out of that environment to test anything. All we do is watch what it does, and that's science. Now, the astronomy is different. We don't just look at things and say, wow, that's science. We're looking at the moon. No, we can measure its velocity, we can measure its intensity, its reflectiveness, its speeds, its distances, what it's made out of. We can go there. I mean, everything we do in astronomy involves experimentation. And experimentation, even when we can't touch it, we can use spectroscopy, we can use optical effects, we can use different wavelengths of light and analyze that. There's all sorts of things we can do as tests. Okay, so it is a science, and it does use experimentation to determine why things happen that we see. Observation, i.e.,
that's right. That's what science is. So it's very
we don't disagree there.
Yeah, it's very simple. So we can observe everything, right? Like that's how we start, dude. It's so crazy that this is some place of contention, right? We have observable phenomena. Okay. Now, the pursuit of knowledge, the colloquial use of the word science nowadays, the pursuit of knowledge, right? This is our attempt to understand what we observe, to increase our understanding of the world that we observe, okay? Now, if you say, look, I found something new, that's not science. All you've done is now bring a new observable phenomena to the table for us as people to try to better understand. The process of understanding it or increasing your understanding is trying to set up tests or experiments to then verify the cause and effect relationship of your observation. That's how understanding how something works requires you to figure out the mechanism of how it works. That's what science is, okay? It's very simple.
We don't disagree on any of that.
Okay, well then just leave it be. There's no reason to even talk. It's like the point is that observations alone are not science. Modern quote unquote.
Said they were.
Yeah, but today people think that observations are science. They're like, hey, look, isn't science amazing? Look what they found in the sky. That's not science. Finding something in the sky is not science. Okay, that's observing something. The prerequisite to any type of understanding. It's not science.
Wait a minute. When someone sees a dot in the sky, and it could be the same dot that an astronomer sees, they're not going to be going through the same process, one doing science, one just observing, like you said. The person that has a knowledge of astronomy will be looking at it and seeing some of its characteristics, will be understanding its brightness, maybe where it is in the galaxy, or where it is in our solar system, whatever he's looking at through a telescope, and he will be able to do science because he's going to analyze and say what this thing is
but they're going to analyze it and they're going to theorize, right? Like, for example, yeah, so it's like that's not science though. Like
that is science.
Okay, you can say that, and I don't want to argue about the semantical part of it.
Let's say we see a comet. Let's say we see a comet. You and I both see a comet, and I'm the science guy, and you're not. No, you be the science guy. I'll be the not science guy. I look at that comet, and go, that's kind of cool. It's kind of like a jet coming out the back. It's probably making it. It's like maybe like fireworks. It's shooting out the back, and that's what's making it go real fast. You know, that's really cool. And I draw a picture of it. I'm an artist. I draw it. I may take a picture of it. I make a bullet, put it on my wall. I'm really excited about it. Tell my friends I saw this thing. I call it a comet. That's not science, right? The scientist, the astronomer, looks at it and goes, wow, look at this trail coming off of it. Now, I know about what space is, and I know there's nothing out there, and this comet isn't propulsive. This is reflective material coming off of it, and it's actually reacting with the radiation coming off the sun, the solar winds, the solar rays. Everything is making, and it has this period that I've timed now. It's going around the sun, and I predict it'll come back here based on the observation I've just made. In 30 years, it'll come back again, and it'll be in this orientation. And I think it's made out of ice and this and that. That's science. You're not touching it. You're just doing whatever you have to your disposal. You're analyzing. Now, it might not be very accurate. You might be wrong everywhere. It's all about probabilities. But you're doing science. You have to agree that is science.
If that's what you want to call it, right? It is a version of pursuit. Really? It's a version of pursuit of knowledge, and I would say I have no problem calling it science as long as you accurately differentiate between natural science and then these other types of sciences. Now we're talking about the natural world. So if I look up and I see Polaris, and I'm like, look, there's Polaris, and then some astrophysicist come over there and is like, yeah, guess what? I'm going to use this and this and this. Polaris is 423 light years away. Now, then a few years later, he finds out it can't be that far away. Well, we're still in the same place. We both have the same thing, which is that we see Polaris in the sky. Now, it doesn't matter if he comes up with all kinds of theories and changes them every year. He's no further ahead because it's just limited to theory. Okay, that's not science. Science is being able to test things, man. Science is testing.
And the reason they know that distance is changing is because the instruments which are using to measure them are getting better, like we've done throughout history. It doesn't mean that it does mean that he's doing something better than you because you're just looking at it. He's measuring it. Now, he might be correct, absolutely correct. He might be in a certain range of an acceptable range of error. And that in science, error is a huge part of science.
Yeah. Well, what's an acceptable error bar? It's like 3%.
It depends. It could be 100%. It could be 5,000%. It doesn't matter. It depends on what you're looking at. It depends on what your goals are.
It can be 100%.
Yes.
Okay.
It just means it's double. I mean, if I think it's a light year away and it's really 2 light years, well, what's the problem with that?
Let me give you an example. So they say that this black hole they took a picture of is like, I don't know, 500 million light years, or I've heard different things. Doesn't matter. Really far away. Okay.
Yeah. 50 million light years.
Right. And they say that their error bar is 3%. Now, if in like 2 years they find out that it's 30% off, their error bar got blown out of the water. And objectively, what we can now say is that their first claim, objectively, what we can say is that their first claim was completely wrong, effectively useless, and it holds no bearing.
Effectively useless. In these vast distances, that is not a big deal for what they're really trying to accomplish. They're not trying to go there, and they're going to end up 1/10 of the way there, and know that, hey, we should have been here, and it's 10 times further away, or 1/10 the far we brought. You know what I'm saying? It doesn't matter.
Let me ask like this. Maybe this will work. Maybe this will work. Do you agree that there's value in having a distinction between something that's limited to theory and something that can be physically tested? There has to be some type of distinction there. We can't conflate them and throw them all in one big basket and swirl it around and mix everything up and muddy the waters. And, well, really, if you physically test something with experimentation, manipulate the variable, prove it's the cause and effect, that's the same exact thing as when I go back, I look at the sky and I make up stories. If there's not some type of distinguishment there, yeah, there is. You're right. One's called natural science with scientific experimentation that can be verified. One of it is called theoretical physics. Theoretical physics is not in any way synonymous with scientific experimentation.
Oh my God. Are you kidding me? So is quantum physics theoretical physics?
The phenomena are real. The explanations are theoretical physics. That's right.
Okay. And
that's why there's like 50 different versions of them, Zanuck. There's quantum fields. There's all kinds of different versions.
So isn't it interesting that quantum physics is the fundamental foundation for building the chips and semiconductors that are in your computer right now? They seem to work real well, and these theories seem to work well. Now, do they tweak them on occasion? Of course they do. But they are useful. It's not pseudoscience. It is actual science. That's why I call it theoretical physics. And, particle physicists and things are doing all sorts of good for society and in the science field and engineering with their knowledge. But these theories that maybe tweak. Hold on. It's good enough for the things they're doing with it. And the theories are actually proven to be right for the most part. Now, are they perfectly accurate? No. Will they be tweaked over time? Yes. But you're really trying to lump anything that you can't touch or make it perfectly accurate as basically fake science. And that's kind of silly.
I don't dispute the value of quantum mechanics. I actually think it's one of the most experimentally valid fields that exist. Meaning, okay, no, it's not. Okay, quantum mechanics is not theoretical physics. As in, if you actually isolate a phenomena, you manipulate variables, you make the phenomena either exist or not exist, go away, change, increase, decrease. This is actual experimentation in the physical world. This is very valuable. This is why we get such precise quantifications where we can make chips in computers and stuff. I think that's very valuable. I have no beef on the surface with quantum mechanics. My beef comes when people then step aside and where we reach our limit of what we can fully test and understand about what we've seen, we just make up stories. And then we have people that run around like laymen on the internet and they say, you're so stupid if you deny this, when you actually go research it, there's like 10 opposing theories about that same phenomena, and there's a huge debate about it within that field. Okay, so the problem is that you conflate the phenomena that you can isolate and test or experiment with you conflate that to whatever explanation you can't test. Okay, and those are two separate things. And an intelligent mind would never conflate the two because it's going to result
Wow.
in you not learning anything.
So Einstein's theory of special and general relativity, are they theoretical physics?
Of course.
Okay. Do you know how GPS works?
Yeah,
General.
it existed long before anyone said the Earth was a globe. So
Do you understand how global positioning systems work?
I'm not arguing about relativity and GPS, dude.
Well, is part of the fundamental way that GPS works based on theoretical physics?
No.
Okay, then you've just made a statement. You give me the answer. If I was the instructor, you get that question wrong.
Well, I know what answer you want, though, right? So if you were the instructor, I'd make 100.
They depend on this bending of space time, or this distorting of
time dilation.
Time
dude.
dilation.
You don't even know your own claim, man.
Because I'm thinking about something else. Yes, because the time dilation, they depend on that for it to actually work. So it's based on theoretical physics, but it does work.
Well, no, the effect may be real, but what you're claiming is the cause is just theory, dude. Stop conflating
you're right.
them.
No, you're right.
You're going in circles.
You're right. No, I'm not going in circles. I agree with you that it's theoretical physics, and it could be caused by something else, but it does happen.
Thank you.
And it does happen, and it is part of theoretical physics. And the understanding of theoretical physics, regardless of what they call it or think it's caused by, the effect does work in their calculations and their creation of this technology.
Yeah, really, that's actually amped up to be way more than it actually.
I'll take that as a
no, it's amped up to be way more than it actually is. The idea of relativity and GPS is a joke, dude. But I'm not talking about that. I have stuff to do. Actually, I just jumped in to kill time while I was walking in the store. I just want to make my point very simple one more time, not to be too reiterative. Okay, but if you want to actually have productive pursuit of knowledge, okay, you have to be intelligent enough to decipher between what can be proven or verified physically and tested and what is limited to theory. Philosophical, ontological proposals are not the same as science, bro. Now, you can say it's a part of science. You can say it's a part of us trying to understand things, whatever you want to call it. If you want to have a semantical argument, cool, okay? But scientific experimentation is not synonymous with an idea that can't be tested. And if we are being honest, there should be a distinguishment there, right? And that's how we're going to move together productively to learn things. This is a very simple concept. It's only in the globe earth, flat earth, fake little binary paradigm where there's some argument to be had here, because it's just very simple common sense. Natural science, study of the natural world, scientific experimentation proves claims of the natural world within the natural world. Natural validation, that is not synonymous with coming up with ideas metaphysically, philosophically. They're two different things. Today they get conflated. They get conflated today, though, don't they, Zanuck?
I don't think they do.
Okay, well, you do it.
I don't do it.
Yeah, you conflate the ontological idea with the actual observation that can be verified. You conflate those two as if, see, I observed it again. I told you I'd observe it again. See, so that means what I said causes it is real. That is ridiculous. That's lunacy.
No, that's not what I said. It's not a fair example at all.
That's pretty much what you guys do.
No, we don't just say, okay, here's the moon, because that's what they did in the early days, about like looking at the rotational patterns of the planets and the moon. Hey, I see it. I'll predict it, and I'll do this loop right here, and because we're the center of the earth. That's all science, but they got it wrong because they thought their hypothesis was that they were at the center of the universe, and these things just do this crazy pass, and that's what it is. That's all they knew. They didn't have any other tools at their disposal to really work this out. Although even the people that did have the tools came up with a different idea that happened to be correct. That we weren't at the center of the universe, that we were revolving around a sun, and all these planets were like us revolving around the sun. And with the philosophy, period, and the distance, it's not philosophy. It's period, the distances. We can know the surface qualities of these places. We've sent crafts to them. I mean, we know so much about our local solar system. It's not even funny. We know about the orbits. We know about the masses. We know about what the sun is. How what reactions are taking place. What kind of energy we receive from it, our energy balance.
No, we don't know. We don't know. We have theories that have evolved and gotten more specific with the claims.
We know,
but they're still
just.
Actually. We don't know. We don't know what the core of the sun is.
Do you know what we don't know?
Yeah, you don't know what the core of the sun is.
Yeah, we hypothesize about that. Correct.
Yeah, I know. And you actually don't know the full elemental composition of the sun either. That's also a theory.
Well, it is a theory. You're right, but it's very
Yeah.
strongly. Hold on, it's strong. So here we go. This is we get into science. It's strongly supported by the experimentation we do.
Well, that's what you say, and that's when again it
Well, we
comes down
see
to
the reactions in the through spectroscopy. We see the actual signatures, these hardened signatures that we can simulate here on Earth of the temperatures and the reactions that are happening there based on the technology we have to be able to evaluate.
Yeah, I get it. You think that your theory works?
It's not wrong. We can look at I can look at a hydrogen bomb go off, and I can use these tools and say I can tell what temperatures, what reaction was happening, what was the fundamental cause of this particular reaction, and I can say if I see that someplace else, it's pretty likely that it could be similar to what I saw here on Earth. If we can,
so pretty likely that
it's science. It's all about probability. It's all about likelihood. It's all about how best does this data represent and statistically give substance to your theory.
Yeah, philosophy is an attempt to propose what you think is most probable. Yes.
No, that's not. The philosophy is more about philosophy is not. That's more the metaphysical. That's more like I feel this. This feels right. I think
anything that can't be physically tested is.
I think in the big scope. I think in the big scope of things, this needs to be here because it has purpose in our lives. It makes me feel warm and fuzzy. That's philosophy. This is not science.
Anything that can't be physically verified.
What do you mean physically verified?
Yeah, physical manipulation of a cause and effect. It doesn't require tangibility. It requires physical manipulation, right?
What do you mean physical? What do you mean physical manipulation?
You physically manipulate the causal agent.
Wait. Now you're falling down the rat hole of causal.
No, it has nothing to do with QE. Feel free to leave him out of it.
You read my mind. I was thinking I was going to say it, but no. QE talks about. He thinks an experiment is synonymous with the hypothesis. He thinks that there is a cause and effect relationship in the hypothesis. He thinks, and if that's true to a certain extent, but there's also a cause and effect relationship, which is really related to the dependent and independent variable relationship in the experiment, which is not in the hypothesis.
That's what the hypothesis is.
No, the hypothesis is the story. The test has back to the plant. It's the easiest one. I always like using this because it's easy. We talk about why plants grow, and I'm not going to go through in detail. Here's why I think plants grow. All these details, right? Now I do an experiment. I'm going to take this plant. I'm just going to do my independent variable is the water, and only the water. Everything else is controlled. I'm going to see the effect on growth of water on this plant. That's one experiment. Tomorrow I do sunlight. Next week I do nutrients in the soil, and so on, temperature, so whatever. Those are experiments, and that at the end of the day, at the end of the year, I will have all this data supporting my original hypothesis of why plants grow. Made up of thousands of experiments. They're not the same. Now, the cause and effect relationship of a hypothesis can say, hey, I think this thing grows because of these factors, and all these factors can be multiple independent variables. You can still have multiple independent variables in scientific exploitation.
Yeah. That's why you have to have control variables to isolate a single one at a time.
That's the experiment.
But here's the point, right? Here's a hypothesis in that scenario that the introduction of water, the amount of water the plant gets, will directly affect the growth of the plant. That is intrinsically the hypothesis. If you were going to manipulate the amount of water to see if it affects the plant,
that's not why it grows, though. That's not the reason. That's not the cause.
So plants can grow without water.
It's a cause. It's a cause.
I never said it. Yeah, I said you have to control the other variables to isolate one at a time. I already said that.
No, that's not what Huey says. He says that there is one cause of this effect. If in the hypothesis, cause and effect relationship, growth, and I vary the water. What if I just watch it for a year, don't do anything, let it watch it for a week, and watch it grow? Then time was the cause.
It's the actual chemical reaction of all the variables that cause the plant growth. So there's one cause. It's the chemical reaction.
So you're lumping all these things into one thing called chemical reaction.
That's what photosynthesis is.
No, that's not photosynthesis. Photosynthesis is a conversion of energy. The sunlight in the presence of, we have water and this reaction creating C6H12O6. How do you create a carbon molecule from just water and sunlight?
Yeah, okay. So the cause of plant growth is a combination of different variables that result in chemical reaction. Are you disputing this?
No, I totally agree with you.
Okay, so the cause of the plant growth is the chemical reaction itself. If we want to go further, there's many variables that go into what causes the chemical reaction,
So
right?
you're saying the hypothesis and the experiment is synonymous.
No, hypothesis is part of an experiment. See,
Wait,
hypothesis is a
part of the
cause and
experiment?
effect relationship.
Wait, Huey says the hypothesis is the cause and effect relationship.
Test. Yeah, it's the proposed test of the cause and effect
Okay,
relationship.
so
That's right.
give me a simple hypothesis and give me the test.
Okay, so
this
we
is
got
the thing
what?
though. Before you go to that, and Kiwi does not say there's only one thing is a cause, because in a scientific theory, it could be one hypothesis or multiple.
We're not talking about multiple. We're talking about one hypothesis which has multiple factors.
No, that's when you have multiple hypotheses
you
for
test
plant
you
theory.
test these factors in the form of experimentation, and experimentation will then, in the end of the day, Witsit and Ebo, we will find out if this experimentation and those results of the experiments support and validate our hypothesis. That's how science works.
Plant growth theory, there is multiple hypotheses.
These are different stories, and I wouldn't doubt that either. But I'm saying the hypothesis that we're using, we have one hypothesis, the mainstream hypothesis, and to validate that, we would have hundreds of experiments spent over a year, and with all the data we would accumulate from that experimentation, we would then support or falsify our hypothesis. We usually try to support it through experimentation. That's just basic common sense science. Come on.
Okay, yeah. So, like, if I have water on the stove and I'm going to introduce heat to it, I'm going to have to control the variable of the ambient pressure because
Which hypothesis?
That heat makes water boil.
So your hypothesis, it's a very simple hypothesis. But you're going to stay with that? That's your final
Yeah, that's right.
So your hypothesis, I see water boiling, and I think heat is the cause of water boiling.
Yeah.
Okay. So it's going to be falsifiable when I provide as a peer of yours at this local college that we both work at, both professors. You're making a hypothesis that heat makes water boil, and I'm going to falsify it.
Yeah, how so?
Because I'm going to put water in a vacuum chamber and watch it boil without any heat.
Oh, so that doesn't have anything to do with the pressure-temperature relationship?
I just told you I didn't use heat. All I did was remove the contents of the gases in the
pressure.
chamber.
You manipulated the pressure.
Yes, I reduced the pressure, and I didn't change the temperature, and it boiled.
Okay, yeah, but pressure and temperature have a direct relationship, right?
Only when it's in a single container.
It has a proportionate relationship, right?
No, only in a container. It's gas law, and it has it's dependent upon the size of the container.
Okay, so that's why I said at the beginning you would have to control the variable of pressure.
You made an example that I just called you out on. You said I think it's heat. You think it's heat. If I reduce, so what happens to the temperature when I reduce the air for following gas laws?
What happens to the temperature if I remove the air?
Yeah.
Depends on what's inside the vacuum. Right now it's water, and if the water starts boiling, it's going to increase the temperature.
I got a glass of water. You just said it's temperature, it's heat that'll make this water boil. I put that glass. Let's see, we have a glass of water, and you made it boil by firing a blowtorch on that cup, and got the whole thing hot and started boiling. Okay. Now I put the same pan. Let's say it's a pan of water. Now I put the same pan in a vacuum chamber, and all I do is move the gas in that chamber, regardless of what it is. What happens to that water when I remove the gas?
It starts
what happens to the temperature? Is there any temperature change in there?
Yes.
Which way does the temperature go?
The water's temperature would increase.
When I create a vacuum, the water temperature increases?
Yeah, when it starts boiling, it's going to increase friction, and thus temperature will increase.
What increases friction? Where's the friction?
The boiling itself. Are you saying the water won't increase temperature, Zanik? Because it objectively will.
No. You have a latent heat energy of a changing states, but that's overall the temperature. That's not. We're not adding heat to your problem. You're getting at something that you probably don't understand either. But just for your experiment, your hypothesis, you said you had a heat to it. We're not adding heat. All we're doing is removing the air.
No, what I said specifically was you had if you control the variable of pressure. That's what I said. So then you responded with, "Well, what if we change the pressure?" But I literally said before I even proposed it that we would control the variable of pressure because temperature and pressure have a proportionate relationship. It's very simple.
Not always. Depends on it has to be a certain has to follow a certain container because something the volume's related. I mean, think about all the laws of gas laws. Should I print them out for you? Because there's 3 of them that come to mind right immediately. So let's not go there. Let's just talk about, you said heat made it boil. I'm just removing the oxygen.
Yeah.
I'm just removing the air in the chamber.
My hypothesis is that at like roughly just over 200 degrees, water will boil.
Okay, well I have the water at 34 degrees and I see it boiling.
But the pressure is going to increase. So yeah, it's all relative to pressure.
That's why the pressure's not going to increase. No, the pressure's not increasing.
So a more specific hypothesis would be that the temperature-pressure relationship causes water to boil. The cause of water boiling is the temperature-pressure relationship.
Oh, see, now you just change your hypothesis.
Yeah, that's why I said when I first said it, you'd have to control the variable of pressure if you wanted to isolate heat with your hypothesis. So if you want to make the all-encompassing hypothesis, you would include both variables, right? So it's like a diversion argument.
No, it's not, because you eventually said it was heat that made water boil. Now you're saying you're controlling. That's kind of a contradictory experiment, because you're saying we're going to say heat causes it, but we're going to control the pressure also.
Heat and pressure are directly related, man.
What do you mean they're not directly?
You can't change temperature without changing pressure, man.
Can't change temperature without changing pressure? Sure, I can add energy to the system.
Okay, and the temperature will stay the same, but the pressure will increase.
I can increase the pressure. I can decrease the pressure. I can have the temperature at any pressure.
Yeah, and so the temperature is going to change relative to the pressure.
What you're talking about, having a closed system or an isolated system. Now you're making another requirement. Hold on. Now you're making another requirement. You keep on changing. You keep on moving the goalposts on me.
So if you increase the pressure to 15 psi, what will be the boiling point?
It'll be a lot higher.
Yeah, about 45 degrees higher, right? So the lower depending on temperature, it's definitely a relationship between. So that's why you control.
Well, yeah, no one's ever. But no, his original statement was we had. My hypothesis is that heat added to water will make it boil.
Yeah. Okay. So the less pressure you have, the less heat you need. The less pressure you have, the less Zenik, the less pressure you have, the less heat you need. But it's still heat, though. Jeez Louise. All right, I gotta get out of here. I gotta do a stream. I'll talk to you later.
That's not how it works. You don't. Yeah, I now have less heat, and that makes it boil. So that's why it supports my hypothesis that heat causes it to boil. I removed the heat, and then it boiled because I changed the pressure. Maybe pressure and the heat are related, and that's what the answer is. It's for other things.
That's what he said.
I know he said that, but he's double talking because he made a hypothesis. He realized he's wrong, and he's trying to cover for it.
No. He said what he said, right? And
no, you can't say it's both. If you do, then you're falling into the trap.
If you add heat to the water, then it's going to change the pressure inside the container.
No, but what if there's no container?
But yeah, but I thought we were talking about a closed system here.
No, that's what I kept on asking. He wouldn't clarify. That's why you make the hypothesis really clear.
You can't change.
Hold on. So it can be falsifiable. So I would say, water boils because the molecules start moving so fast that it'll change state. Or and you can do that with an exam. Then experimentation will be adding heat and then reducing pressure, and we can do it in a container, out of a container. We could do all sorts of things, right? So he's not being very, and the experimentation would be the part that validates that hypothesis. He didn't want to do that. He wanted to say starts out with heat, causing water to boil, which can make it boil. There's no question about it. He can make water boil, but it's pressure dependent, as he said afterward as well. So now it's heat, it's pressure, temperature, all sorts of things.
Yeah, I guess just confine this into a closed space, and then whatever you do to one thing is going to change something else. So you might try to control a variable, but you can't because something else will give.
I can lower that pressure so much that it doesn't boil at all. And so how's that? What's the answer to that?
What happens to the?
It freezes, and then it starts sublimating. So there's no boiling. It just directly goes from a solid to a gas. No boiling by pressure.
Have we ever measured the temperature of the water when we've taken the air out?
If you have so you got to be clear too. Are you talking about a closed container?
Yeah.
Well, as you start removing air from it, what's going to happen to the temperature?
Of the water. Well, what will happen to the temperature of the water, do you reckon? I mean, I don't know.
Well, as it boils, it'll shed heat.
Yeah, but have we ever measured the temperature of the liquid?
Yeah, because it'll be the temperature that the water or what will become as you remove the oxygen. It'll start to turn into ice.
Yes. So you in one way, we're saying that it's getting colder, but in another way, we're saying that it's boiling. And
Yeah, but boiling doesn't mean heat.
Well,
I mean, there's a latent heat energy that's released when it's boiled, but that's what he was kind of latching onto. But it's a weak foothold.
It's an observation. I think when we say that we observe that the water's boiling, it's doing. It looks like that, but if the temperature isn't actually rising and actually getting colder, then naturally we can say that it's reaching a boiling point, but it's not actually boiling itself. It's actually freezing.
No.
This is why there's a problem with his hypothesis, because he's not thinking this all the way through. You're asking all the right questions, but you're not understanding what happens through the process of lowering the pressure, keeping a temperature constant. It's changing states. It might bypass boiling and go right into a solid state, and then it starts sublimating, which is going directly into a gas versus boiling. I mean, this is the physics of materials.
If you have a candle and then you put an exhaust over it, like a bell jar, a glass, or something like that, and then naturally runs out of air, what's left in that space?
Carbon dioxide.
Carbon dioxide, because naturally that's coming off from.
Yeah, you have an excess of carbon dioxide because you've used all the oxygen that was in the air, or most of it, till it wouldn't burn, till it couldn't combust anymore. You would agree, right? You snuff out a candle and you light something in a jar. It burns for a while until it consumes as much oxygen as it possibly can to support combustion, and then there's obviously less oxygen in that container and more carbon dioxide, because carbon dioxide is a byproduct of the burning of the candle wick and the wax.
And what about the nitrogen? I guess in that original glass,
it's inert.
It
doesn't do anything.
Pretty much unchanged.
It doesn't change.
Cheers, man.
That was fun.
A scientific experiment is a hypothesis test. That's how you know what you're testing for inside your experiment. You'll have an independent variable and a dependent. Those will both be stated in your hypothesis.
Nope.
Yes.
They're not stated in the hypothesis. That's in the experiment. That supports the hypothesis.
Oh my God, I have so many citations saying you're wrong, dude, from EDU sites and everything. You're bugging.
I'm not wrong.
I don't know who tells you this stuff. Who told you that?
Many years of schooling, Jeremy. You're searching and misinterpreting what's being said. Hypothesis, again, you can quote me on this. Hypothesis is basically a story that supports and gives cause and effect relationship of your observation. Basically a story, what you think is happening. Then you have experimentations, which then whittles into the cause and effect relationship in that particular experiment of the independent dependent variable relationship. The independent variable has changed, and how that change affects the dependent variable, the effect that you observe in that experiment, not the hypothesis. Hypothesis then will be supported by a series of experiments that you conduct to provide evidence and data to either validate or invalidate your hypothesis.
Changes with respect to.
He's still wikiing. Wikiing.
You can also quote Zanuck on being, I am the citation.
He cracks me up.
That's kind of like Heisenberg saying, I am the one that knocks.
Now, what did he say? What was his quote? Heisenberg?
I am the one that knocks.
I am the one that know?
That knocks on the door.
Did he say that?
Yes. When they were him and his wife were having a discussion, and she's like, I'm afraid I'm going to get a knock at the door sometime in the middle of the night. And he goes, I am the one that knocks.
That's right. Okay. That's like the greatest series. I love that show.
Zanuck, does the hypothesis need to be falsifiable?
Yes.
It has to be falsifiable, right?
A good one.
A good one. If it's
What does that mean,
unfalsifiable, is it a hypothesis?
I suppose. Let me see. You can have hypothesis unfalsifiable.
So you're just kind of contradicting
I
yourself.
haven't thought about that. I mean, I'm just thinking out loud. I guess it probably could. It wouldn't be a very good one, obviously, if it's not falsifiable. But I mean, you could say this is due to that, blah 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 blah, and then you can't really test it because it's things we don't have knowledge of.
Ooh, I have an answer for that one.
No, I don't. I mean, I'm not saying I know it all for that, but I'm just guessing.
Can you do an experiment on a hypothesis that's unfalsifiable?
Yeah, you can. Any experiment is any kind of test. I mean, probably infinite ways you can conduct tests on any topic or subject matter. Whether it's a valid test or whether that test can be falsifiable. Valid test should be falsifiable. Hey,
it says a hypothesis, about the natural world. In order to be considered scientific, hypotheses are subject to the scientific evaluation and must be falsifiable, which means that there will be such a way.
Is that for the experiment or hypothesis? What was the
hypothesis?
The hypothesis must be falsifiable. Yeah, I mean, it stands to reason.
So, do you now agree or what? I mean, you don't even.
No,
know
I said it should be falsifiable. We both said that. I said, can you have a hypothesis that's unfalsifiable? I guess you could have one that's unfalsifiable. That wouldn't be a very good hypothesis then.
It wouldn't be a hypothesis.
I think it says should be falsifiable. It doesn't say
no. It has to be. Must be. It says it must be.
Must be. Okay. Well, then
read it again. Read it again, Elbow.
We agree. I'm just being devil's advocate.
Read it again. I don't care if we agree. Read it again.
So, in order to be considered scientific, hypotheses are subject to scientific evaluation and must be falsifiable, which means that they are.
Okay, good. Thank you. Must be falsifiable. I'm glad. All right, we agree.
We always agree from the beginning.
Yeah, you're trying to play funny little word games though.
No, I didn't. I
I
said
don't know why.
he asked, could you have a hypothesis? Is it possible to have a hypothesis that's not falsifiable? I said, I guess it could
Not a
be.
scientific one. Not a scientific one though.
Yeah, so it's scientific. Well, there we go.
We
So
just
there's
we just learned that a science
right. There we
because
go.
we just learned a scientific hypothesis must be falsifiable.
We already talked about. We already said that at the very beginning.
Okay, great. Let me ask you this next question: Is the law of conservation of momentum, the law of conservation of momentum, is that falsifiable?
Law of conservation momentum.
Yeah, is that falsifiable?
Yeah, of course.
Yeah. All right. Oh, how do you falsify it?
You would try to show an example of it not being true. So show a mass hitting another mass and losing energy or losing momentum, not due to energy, noise, or transfer.
All the energy
So,
can be accounted for.
oh yeah, the all accounting of the energy will be accounted for.
And you're
Once
saying
you show that that doesn't happen, it's false. It's been falsified, and then we would then rewrite the conservation laws, because right now
how
that's
would you
never been
show
seen.
it's never been? Yeah, it's never been falsified. So you could put the conservation of momentum into a scientific
Experiment.
experiment
You're roboting, bud.
Get some earbuds.
or hypothesis where it's falsified.
You're roboting.
And you have
Hypothesis.
no idea what
We
you're
had
saying
Talking
like,
about a
there,
hypothesis.
earbud boy.
yeah, we heard like every other voice word you said in every other sentence.
Okay, so you're telling me you can put the law of conservation of momentum into a hypothesis and have it be falsifiable.
Sure, it's possible to falsify. You'd have to show a loss, the energy not being accounted for.
Just develop an experiment that you can show. Dream up something where you show that momentum is not conserved, and then you will win a Nobel Prize.
A perpetual motion machine.
Perfect. Yep. There you go. So it is falsifiable. If it's falsifiable, you'll be able to make a perpetual motion machine.
Nobody has
Well,
falsified
Nate
it.
told me earlier it wasn't falsifiable, so
Someone told you that. That was and we were already contentious about other things too. He was just kind of playing with you, though.
Now, with the Big Bang, that's a hypothesis, or a theory, actually. But in the hypothesis, where were we able to falsify it?
I don't know. It's a good
I
one.
guess thus far, everything seems to, look like it is, basically all the tests we do are analysis of travel, distance, stuff like that, mathematical proofs.
Maybe the universe expanding at a rate greater than the speed of light, which means that maybe it wasn't a Big Bang. There's a big super bang. Maybe a external ether magnet on the outsides of the universe pulling it apart. Maybe everything's attracted out of the universe.
Yeah, it's falsifiable. All you have to do is go back to when it happened and show me it's wrong.
Just go there, take a picture, make some measurements, and bring it back.
YouTube video. YouTube video, nothing.
Yeah, you have a YouTube video, or it didn't happen.
Most of the experiments I do are like not necessarily technically experiments; they're demonstrations of principles.
Right.
Like if I did Cavendish, I would just be demonstrating the principle that materials attract each other.
Right. Witsit is exhausting.
Because he's so good.
He's good.
He's a liar.
He's a liar?
Yeah.
I don't know if he's a liar. I think he has such a contrarian perspective of everything.
The last time I spoke to him, he turned around and said, "Oh, you've been in here the past 3-4 days, spouting shite, right? And I hadn't even been on Discord at all for about 2 weeks."
Right.
And I was like, "How could I have been on here the past 3-4 days if I haven't been on Discord for weeks?" And he's like, "Oh, yeah, you have." And I was like, "No, I fucking haven't." But yeah, he's a liar.
He's an interesting cat, that's for sure.
Let's not call names, please. Thank you. And Zanuck, you're exhausting. Okay.
No, I'm not actually. Look at how calm I am now when no one's going crazy on me.
Right this moment, yes, but when things get tense, you will turn to exhausting mode.
Tense, meaning people talking. Oh, yeah, maybe that's my weakness. I just don't like the whole interruption thing.
Yet you interrupt a lot.
Somebody's roboting.
Yeah.
Hey, get some new AirPods, motherfucker. AirBuds.
It's not the AirPods, dude. It's the signal.
Sure it is.
I got a rainstorm. Thunder's coming. It must be blocking all the satellites.
Are you hooked up to satellite or are you hooked up to your Wi-Fi?
A cell signal.
Cell phone? You're using cell phone? Okay.
Yeah.
That can be weather. That can have some.
Yeah, man. Yeah, hell yeah. Oh, dude, we used to have a satellite dish. When it would snow, it would start to get so pixelated, it'd be unwatchable.
All right, you get about an inch of snow on there for me, and that's enough to take me out.
Yeah, no, even during the snow, before any snow accumulated, just as it's falling, it would start to become so pixelated that you couldn't even watch it.
I used to get that with thunderstorms. You get a wicked thunderstorm to the west, and it would fuck everything all up. Which is funny. That's the same direction my antenna is pointing up into the sky.
So you don't think an experiment is a hypothesis test? Scientific experiment. Just so we're clear.
Oh, I would have to say I kind of agree with that. I'd have to hear an exception to it.
That sounds good, right? I mean, that's where you get your independent, dependent variables from, because that you're going to test your experiments just from your hypothesis.
Sure. Who is disagreeing with that?
Zanuck.
So he doesn't think it's a hypothesis test.
Yeah. Crazy, man. Crazy. Set your voice straight over here, will you, for me? I don't have the energy to do it.
I would have to hear his reasoning. I missed that. So
He's a spaz. He says, I am the citation. So
nobody says it that way, but
and literally everybody says it that way. I Google it.
That's a hypothesis test?
Yeah. A scientific experiment is a hypothesis test, yeah.
Okay.
Again, the hypothesis test means something that is providing evidence to either falsify or support the hypothesis. So the tests support the hypothesis. They're not the hypothesis.
I thought
No,
the
he said
hypothesis. I thought the hypothesis was part of the experiment.
it's the cause of the experiment. You're making the hypothesis to test. It's the story, and you're testing it with the experiment.
Yeah, you hypothesize. Okay, I think heat causes water to boil. What do you do? What do you do in your experiment? You put heat to water. Your hypothesis lays out your experiment for you. Essentially, it tells you what you're gonna do in your experiment. You're testing the hypothesis. I don't know why Xanix's fighting this.
No,
I
then
mean, I have some ideas why he's
if I
fighting
don't
it, but
add heat, and I can get it to boil without adding heat, then I just falsified your hypothesis. That's how it works.
right.
So
we would also
my
have
experiment.
control
Hold
variables.
on, Jeremy.
We would also have control variables.
Jeremy,
You're skipping over the control variables.
Jeremy, no, I'm not skipping. That's part of the experiment. In that experiment, I've just shown that is your hypothesis was falsified, so it doesn't support your hypothesis. That's why they call it experiment. Jeremy, this is why I get upset. This is why they call it a hypothesis test, because the tests support or do not support your hypothesis.
In my experiment, though, I would have pressure be a control variable. So, all right.
Okay. Fine.
Not you.
That's
Drink some water.
Yeah. So tell me what you're going to control there, Jeremy.
No.
Your control variable is going to be what?
Monday already. Xanax,
So
inside your. How's it going, Anthony? Listen, in your hypothesis, you're gonna in your experiment, you're gonna have a control variable.
Of course.
Right?
Tell me the conditions. Tell me the conditions.
Be pressure.
What? How do you control? What's going to be set at?
It's going to be pressure at a certain what? Get up set at 14.7.
What's it going to be set at?
14.7.
Okay. So at 14.7, I had heat to water, and eventually it will boil.
Yeah, if you can't constantly increase the heat, it will boil, yes.
Okay.
So you can't have the heat at one temperature then?
Yeah, no. He's going to keep on adding heat, he says. Okay, so what does your hypothesis say then?
Heat causes water to boil, dude.
No, but you said you're controlling other things, though. They're not controlling the independent variable.
You don't control your independent variable. You manipulate it. That's the heat. The control variable is the pressure.
What?
You manipulate your independent variable.
Okay. So you've kept your pressure at 14. So your experiment says, I think heat causes water to boil. And so I'm going to control all these variables, one being pressure, and I'm going to set it at 14.7.
Yeah, and then I'm going to keep adding heat.
Hold on. Under that condition, heat is the cause of water boiling. And what I would say to that is it's a lousy hypothesis.
That's a lousy hypothesis, really?
Yes, because I can hypothesize that it's not the heat that actually makes the water boil.
All right, what's your hypothesis?
I say it's the pressure. So I'm going to control the heat and change the pressure and watch it boil.
You could do that. You could do that, but in my experiment, I showed it was the heat.
All right, in my experiment, I showed it was the pressure.
We can do another experiment to show it's the pressure, so we can come out of it. Yes, so we can come out of that knowing that whether we set the pressure and temperature at a certain point, we can manipulate one or the other, and water will boil. Yes,
that's not a good. So it's not. You're not really in your hypothesis. You're not describing what causes water to boil. You just confirm my whole argument completely,
hold on.
Jeremy. Do you understand?
Jeremy, hold on, sir. Jeremy, let's put it this way, right? I watched you do your experiment with the heat, and then I watched Zanik do his experiment with the pressure. What conclusion should I come to then?
You can come to the conclusion that if we control for pressure, we can make heat cause water to boil, or vice versa.
Yeah, but you say it's the heat, and Zanuck says it's the pressure.
Yeah, it's both.
The more
Depending
accurate,
on what you control for, depending on what you control for, it'll be one or the other.
You see
the
how weak
more
that is?
accurate.
See how both those hypotheses are so weak? They're both very weak.
It's because they're dependent variables. Energy is the actual independent variable. So in what you guys are talking about, you have to put in enough energy to overcome the intermolecular interactions of a liquid to get it to phase transition into a gas. And there's many ways you can do that. Decreasing the pressure or increasing the temperature are both valid ways to accomplish that. But it's the energy that's the actual independent variable.
And that would have to be shown by a different experiment, Jeremy.
That's why you're running into the issue of that both pressure and temperature. You guys can have a dual hypothesis. It's
Well, that's
because
why
the energy is the deeper unifying.
right. That's why I'm trying to show him that both those I only gave him the pressure one to show him how wrong his and how weak his hypothesis was to begin with. I produced a exact opposite hypothesis, would also prove to be correct, but it doesn't mean that's their valid hypothesis because they're both falsifiable, and they both can be falsified.
I misspoke. Energy is the dependent. Energy is the goddamn mic. I misspoke. So just to clarify, energy is the dependent variable. Independent.
The dependent variable is the water boiling. So you were right the first time.
Yeah. I guess it depends on how.
Yeah.
You're right. Depends on how you want to set up hypothesis.
Yeah, the changing state of water requires a certain amount of energy, and the real hypothesis will really address what happens to those molecules in that substance when there's less pressure acting on it. Why does it change state? What's the hypothesis, Jeremy, for why it changes states when either lower the pressure or raise the add heat to an environment? There's a reason, and it's not adding heat causes water to boil. It's not lowering pressure. It's something else, and that's the hypothesis that your physics instructor wants to see you produce, and then you can test it by whatever that hypothesis is. Look at this. I can prove it by when I raise the pressure, the boiling point goes down. It goes up. When I lower the pressure, it goes up. It boils. I add heat, it boils, but it doesn't boil if I add heat. If the pressure is too high, I mean, all this you would support this real hypothesis, which you haven't produced yet, of why water really boils. What's really happening in this phase change? Why is it changing states from a liquid to a gas? He's not even there.
Why are we discussing boiling water anyway?
Oh, because Witsit was in here talking about science.
It's the one scientific experiment that he can agree to as actual science. And then he got it wrong.
Right.
Essentially, if you use their method, there is no science whatsoever that exists in the entire world.
So has anybody on the flat Earth side come up with a reason why the eclipses happen yet?
Klaatu and Rahu,
What?
invisible space bodies, or sorry, invisible bodies in the sky that block or filter light coming from the moon.
Mm.
Other ones are bioluminescence.
Yeah, I'd say they're definitely functions of the sky, part of the sky system. I think they're connected to magnetic nodal points. The nodes of the moon are what are. So when you have an eclipse, you have the sun and the moon, and then there's two lunar nodes. Those two lunar nodes are 180 degrees from each other, and they're always 180 degrees from each other, and they're in their own cycle. And when the sun and the moon align with the lunar nodes, you get an eclipse, either a solar or a lunar. So those lunar nodes are definitely correlated because they are aligned with them. That's why you get a partial eclipse if the lunar nodes are only partially aligned, and you get a full eclipse if you get a perfect alignment of them. So
what does magnetism and light have to do with each other? With magnetic nodes, what do they do to the light?
polarization.
Polarizing the light. Can you show me, like, I mean, do you have any kind of indication that I can polarize light with a magnet?
Well, it's not a magnet. They're nodal points. It's not.
I understand, but essentially it's magnetism that you were talking about when you're talking about a magnetic node. So whether it be the point where they all converge or whatever, but I don't see any correlation between a super strong magnet and light. So I'm not sure why you would think that a force such as magnetism could be involved at all with how the moon presents itself.
The thing is that the magnetic field that you're talking about would have to be magnitude stronger than the Earth's magnetic field. And surely we would notice something like that.
Well, why do you even say that? I mean, I'm curious now. Is there some level of magnetism that I can start producing changes to light, like 10 million Teslas?
No, I'm just saying. I'm not saying that that is what's happening. Yeah, I'm just saying that if Geo's theory is correct, then surely we would have noticed some massively powerful external magnetic field other than the Earth's magnetic force. Because the light seems to get to us no problem through our magnetic field.
Yeah, I think the way I would approach that would be show that light has an inherent interaction with magnetism. Then I would say, oh, okay, well, now I think that magnetism could be causing this.
Are you
And
familiar with
then I would go to how much magnetism would it take to do, and can we get that in the real world?
Are you familiar with the Faraday effect?
The Faraday effect. No. Let's see.
Okay, I'll read this to you. The Faraday effect causes a polarization rotation, which is proportional to the projection of the magnetic field along the direction of light propagation.
All right, looking.
Formally, it is a special case of gyroelectromagnetism obtained by the dielectric permittivity tensor is diagonal. When the dielectric permittivity tensor is diagonal.
Oh,
yeah, there's a ton of information about polarization, magnetics, light, and how they all interact and interplay together.
What was the source of that?
That was just straight from Wiki. I'll post it.
Thank you.
I just read it because just to use their wording. Magneto-optic Faraday effect. Here's another article here. Light polarization using ferrofluids and magnetic fields.
The ferrofluids, I don't like those at all, because that's really just essentially sending it through a lens.
Yeah, how do you know that the eclipses are not connected to lenses and ferrofluids?
Where is this ferrofluid? I don't see it in the atmosphere.
The water's above.
Is water a ferrofluid?
I mean, the one thing I'll say about the sky, like if you're looking, like here's the thing, in my viewpoint, the sky has always been a mystery to humans, meaning we can't go, I know NASA claims they're up there probing things, but I don't believe them. So the sky is something we can't touch, we can't tangibly measure, we can't go up there and get a sample ever. Humans have never been able to since the beginning of time. Being a physical human means we're physically on the physical plane of the earth. And the sky is something that we can look at, we can observe, we can look with wonder and mystery. We can see the way these things align. We can see the cycles and everything, but we can never go up there to get a sample. So if you're looking for like some absolute 1000% proof, you'll never find it as being in a human body. Now, maybe in a spirit plane, or maybe you could leave your body, or maybe you could have some kind of transcendental experience. So if you want to get that kind of answer, it's impossible. But we could talk about possibilities. And there is obviously something happening up there. So I like to think about it in that way. But I'm just saying, if you're looking for some kind of absolute 1000% proof, it's not going to happen. Sorry, that's just the reality of it. I think you could get proof through other means, like metaphysical means, spiritual means. I mean, the sky is something, and it clearly has an interaction with the physical world. So I'm not saying that you can't get insights. I'm not saying it's just a useless journey to think about it at all. I mean, it's part of the mystery and part of the. So I'm not saying that. I'm not trying to like shut down the journey or anything like that. I mean, in fact, I love thinking about it and talking about it. But I'm just saying, in terms of like, if you want some kind of absolute tangible proof, I don't think that's going to happen, because we can't go up there and get a sample. We can't, go up there and touch them and, see exactly what it is. So it's sort of
what would going up and getting a sample mean to you? Because I mean, as far as I'm concerned, we have gone up and found samples. So where do you? We have the Go Fast rocket that went up. I don't think it took a sample, but there's no reason it couldn't go up there, open up a container, let in whatever's up there into the container, and then fall back to Earth.
There was a mission that was done where they collected debris using aerogel. They brought it back to Earth.
Yeah. Going through a comet's tail, wasn't it?
Yeah.
But they don't believe that happened, so easy enough to say, to deny it, and it doesn't exist.
Well, NASA and government-based agencies claim, of course, that we live on a globe and that you can pop out, you can go float around, and then there's all these things you can probe and things. So if you believe that, then yeah, I guess from that perspective, you could go get a sample in theory. You could go to the moon and get a moon rock or whatever. So from that worldview, sure, I guess they're probing, and it's a nice thing to believe in, I guess. It makes you feel comforted. Oh yeah, look at that, they're doing it. You kind of want to ride on the shoulders of the giants or whatever. But if that's real, then I guess great. I guess you're riding on the shoulders of people getting moon rocks from the moon. But if that's all a massive deception, then of course you've just been led astray. I'm not saying you, but whoever believes that has been completely led astray and believes in a deception of somebody. And then in reality, those people are not doing that at all. So the sky is just as much of a mystery to them as it is to us. And so we might as well use other ways of thinking about it, because what they're doing is far from the truth.
Okay, I'm looking at this magneto-optical effect. It seems like it happens inside of lenses, so it still leaves what I was saying is true, which is, in an atmosphere or a vacuum, there's no effect of magnetism, or no appreciable effect. But it does say in fluids, which you could loosely call air a fluid.
Well, I mean, I'm just Googling magnetics light polarization. There's tons of articles and information on it. So like I said, I mean, to be able to prove this 1000%, like I said, I don't think you're let's say you could go during an eclipse, if you had a Tower of Babel or some kind of, or you could go up there with an airplane and you can get right up to it. I mean, that's what you would need to really see what's going on. And is it in a fluid, or what are the magnetic readings, but that's what I'm saying is not possible. Like that, it's nothing that humans have ever done since the beginning of time in terms of that, of being able to get up there. I mean, even the Tower of Babel, it's not even about getting up there and looking at the eclipses. It would be more about transcending to the spirit world, essentially being able to build a connection. But that still doesn't mean that you would be analyzing this, being able to get samples of the sky, perhaps.
What do you think the Tower of Babel was? I always find that that's the most hilarious story ever. Because, basically you're talking about building a structure by stacking rocks together, or whatever technology they wanted to use. But get up more than let's say 5 miles, and you got yourself a problem. And we definitely, reliably, every day go up higher than 5 miles. So what was the big
These
deal
guys
of
used
the
to
Tower
argue.
of Babel?
These guys used to argue with me about how high you could stack dirt. They would say, you could only because they say there's a limit to how high you could build, and I'd be like, well, what if we're just stacking rocks and dirt? And they used to say, well, if you got too much, it would liquefy under you or something. I don't know. It's weird.
Yeah, no,
But I mean, it
essentially
could have
that's
just
true.
been something.
There's only so much strength that a rock has and can support.
Yeah, so if I keep stacking rocks on top of each other, what happens to the bottom rocks?
Eventually, they start to break down.
To what?
Could be a liquid. It could be like think about how ice in a glacier moves. I don't know if you technically say it's melting, but it's in some kind of a liquid state because of the pressure that's on it. And it just sort of mushes down like water. If you watch it over time, it looks just like water.
So you think there's a limit to how high we could build? We couldn't just stack rocks or dirt, as high as we wanted?
Nope. And what is the compression strength of a rock?
I don't know. How many miles of it are we already standing on right now that's underneath us?
Even as a liquid, it would still maintain its shape at some point. So yeah, you can stand on miles of it because it's going to tend towards a sphere.
Yeah, I know.
That's when the pressures from the other direction are coming in equally to counteract it.
Yeah, that would be a totally different scenario in terms of the forces involved. I mean, if the only way you could stack rocks infinitely high is if the rocks were infinitely strong.
But you could make a sphere, theoretically infinitely large until some kind of black hole formed. You could just keep on getting bigger and bigger.
Well, like if you went to the top of Mount Everest and then started stacking rocks, I would say that at some point you're not going to have breathable air. Like you're just going to not be able to breathe. And even if you use some kind of,
I was going to say,
and even if you use some kind of like a scuba tank type thing, like pressurized, mask or whatever, like at some point, I think the pressure would just be inhabitable, which of course is what they claim that, these space agencies claim that they're building these pressurized things and they're shooting up there or whatever, but I don't think that's happening.
Well, you do have a good point there. At the top of Mount Everest, let's say that Mount Everest was right at that point where the rocks underneath can't support its own weight. But if you go with a tiny structure on top and start building that up, you can still go up quite a bit higher. So, I mean, that's that whole pyramid shape, where if you make the pyramid big enough, you can start containing some of the loads that start, the loads that are pushing out laterally as the rock tries to crush, and it has to move all that material out laterally. But you'd be talking about, go up 5 miles, you'd need a base that was, enormously larger. And then at some point, that still all falls apart, and it will eventually collapse on itself. Every time you put a rock up at the top, the mountain will get one rock shorter.
Do you mean like Jenga? The game where you pull the block out?
Yeah.
Well, I mean, like the idea that like the sky is like the ceiling. Like in a room, you can get up to the ceiling. You can put a ladder and get up there and touch it. So that's the question. Is that possible on this Earth? Now, NASA claims that they've done that. They're out there and they're floating around. They're probing things and whatever. But
well, whatever you say that they claims, I think that is one of these things that just irks me because I'm looking at it. They don't just claim it. There's evidence that you can verify to a large extent. Unless you think that they control the laws of physics and make things appear where they aren't.
Okay, what can I verify that they're floating in a vacuum surrounding
You can verify the elevation of things all the way out to geostationary orbit, and beyond. Then we got to go to planets and stuff. But man-made things, you can verify their height and speed.
Reb's Rhetoric did a really good example of this with the ISS, where they documented everything, and they used parallax, and they did all the calculations, showed all the calculations, and showed that the ISS is hundreds of miles up. That's one good example. That's somewhat easy to do.
Well, it's not really verifying anything because you're depending on data that's given to you by space agencies.
How many hundreds of miles up was the ISS? How many hundreds of miles up?
I think it's like 227. I could be off, but that's the number that's popping in my head.
I mean, you could always use the images from Himawari 8 to confirm that that's in its exact location, which has been done. People have took an image that Himawari 8 has just taken and then went outside and confirmed that the cloud structure is exactly the same as what it is on the picture.
And in terms of the ISS, I'm not sure what you're talking about in terms of referencing government agencies. You're just referencing this thing in the sky, and you're just determining how high this thing is.
Good, how you doing? Yeah, I don't know how long this is going to last.
So you wouldn't be using any government sources. You'd just be looking at the ISS and determining what is supposed to be the ISS. Something that's traveling through the sky at a very fast pace. You could determine the height of that object that you're looking at. No government involved.
Okay, so how are you claiming to do that? You see a thing in the sky, and then what? How are you determining the height of that from what you're claiming?
Geometry, trigonometry, triangulation.
You can tell the speed based upon its same, but you can also add to that Doppler shift and stuff like that. You can have two people look at it, one as the satellite's approaching and one as the satellite's leaving. You can see that there's a Doppler shift.
Yeah, but you don't know what that thing even is.
I know it's a thing that's transmitting the radio signal in question, and there's a Doppler shift.
I think there's a disconnect. I think you can see stuff from 200 miles away.
200
miles.
If I have a directional radio telescope and I look up and I see that the radio signal's coming from it, I can tell you where it is, where it's moving. You see that source is moving.
I got a 4.0 magnitude this morning.
Ground shaker?
Negative 4.0.
You had the ground shake under you at 4.0?
Oh, come on, you dud. No.
I don't know what you're talking about.
The magnitude of the ISS, bro.
Oh, okay.
I think you're talking about.
I don't have an intrinsic understanding of how bright that is yet.
That's the brightest thing in the sky. That's as bright as Venus will get, or the ISS. Venus and the ISS are the only two things that'll get below negative 0.4, negative 4. It's pretty bright.
Kicking.
I could have sworn I could have seen the outline of I could have seen the arms on the ISS last night, because I had a 3.8 magnitude last night, negative 3.8, and I had a 4.0 this morning.
What were you looking at it with?
Just my eyes.
Oh, then you didn't see no arms, bitch.
No, but when I was looking at it, it was 86 degrees in the sky, and it was very bright. And you're right, it could have been my eyes playing a trick on me, but I don't think so, because I could see plainly that it wasn't like a point. It wasn't like a point source. I could see it's almost like looking at Saturn or something, where you can see like a, something sticking out.
Come on, all you Jews have that bad vision. You need glasses. Do you need glasses?
No, I don't need glasses. I bet you're not the only one who's seen that before.
Now, my father had 2010 vision, which used to be fun. As he was driving along the road, he would read license plates, 50 feet before I could read them, and I had 2020. And it's always interesting to see that. It's like, oh yeah, VNR 6725. Huh? There's a license plate?
Yeah, well, sorry to hear that, but I have immaculate eyesight. Okay.
Well, the question is, do you have better than average? Do you have 2010 or?
I would think so. Yeah, I would think it's much better than average. I lost my sense of smell, dude.
Do you have 2,220 miles eyesight? If so, you can see the ISS.
Isn't that the longest, right around the longest distance photograph taken? That's also really close to how far you can see when you're 5 miles up in an airliner. You can see roughly 225 miles to the horizon. So we can definitely see things 220 plus miles away.
You could see things 220 plus miles away, but you could not resolve something the size of the ISS on the ground from 220 miles away. You might see a radio tower top of a mountain at that distance, but that was just a few years ago.
With infrared photography, you could see way further, 1,200 miles. Jay Tolan has seen
Yeah, well, I
very far.
if you've ever looked at that and actually done the research and tried to validate what he was saying, you'd find out that he was either lying or just flat out wrong.
Yeah, I've heard you guys say that, and I found that you're lying and flat out wrong. So try again.
No, I have analysis of the actual topographical
have gotten wrecked
elements.
on that. Every time you bring it up, you get absolutely wrecked.
No. We have the Baja.
You bring it up as if you have something, and every time you bring it up, you fail.
No, okay, you're just making a statement, Gio, and now I'm going to just basically say that you're wrong because I brought up Baja California. Can't see that from Texas, and everything that he shows as Baja and this and that in the Bay of Sio Cortez is not. They're just desert areas in Texas. He doesn't even see past Texas, but he thinks he's seeing because it roughly resembles the shape of the bay, a shape of some mountains down there, but it's not even close. And you can actually validate that very easily by the angular position from that plane to that object. And that doesn't comport with what he's saying at all. So, George, so you to say that, Gio, for you to say that we are been proved wrong is just kind of a little bit disingenuous.
No, I didn't say you proved anything. I said that you think you've debunked something, and what I said is that you've never shown anything that has debunked anything. Every time you brought that up, it's like clearly you guys are so triggered by him because obviously he's doing something where he's seeing extremely far, showing the Earth.
No, he's not. I love his.
So you guys are so triggered, like you, Ruhif, some of you guys, you're like you get really hyped up, and start to spiral instantly about it. You start to try to, and every time I've seen your debunkings, they're so weak. That's all I'm saying. I haven't seen.
No, how do you? So Gio. I take the Baja California from Texas. I show the picture, and I have all the landmarks on there, which are actually very discernible from what he says they are to what they actually are on a real map, or people that have been to Texas and see these landmarks. And you see also the angular position of the Sea of Cortez or the or Baja coast in that picture. And it doesn't comport with what he is saying at all. It's not right angularly in position of field of frame. It's not. So I'm not spiraling. It's just laughable that someone would think that he's seeing 1,200 miles to the Sea of Cortez, to see Baja California, to see Cabo San Lucas, and he's only barely seeing to the Gulf of Mexico across Texas, which is exactly what he should see, about 250 miles, not 1,200 miles.
And that was where I left off. I did the Baja, and I went into terrain finders and stuff like that, the terrain profile finders, and I found the exact image of what he was looking at. It was right at the distance you were expecting. Same prominences, and his prominences didn't match. But you, of course, believe him, but you haven't done any verification of it.
I never said I believed anything.
You're saying he saw that, so you're.
Because there it is. There it is.
An indication that you can see it. You're saying you believe it.
There's the actual picture, Gio, that you were talking about, and this is when he's flying over Texas. And does that really look like that's It's 750 miles away.
At least.
Look where it is in relation to the clouds. Everything doesn't work. Nothing works in that picture, as he's claiming to be.
Right, other things you could do is you could take the angular size of the prominences that he's talking about and say, are they the right size? None of it works.
Right. So, Gio, when we get twisted up, it's because we can't believe people are actually believing that this is what he says it is. Here's the actual items. I don't know if it shows it or not. I have to get a different picture, but this actually kind of points out every single element of his observation and says what these objects are, and validated to show that he's completely and utterly wrong.
The truth is, I thought, Mark, weren't you there back in the day whenever we went over all this stuff in Gems? We actually went pretty deep going through the details on this. Remember, I thought you did specifically. I looked at it quite extensively.
The easiest way is just the angular size. I mean, look at something the size of, and then see if that works out to be for an object 760 miles away. And he's seeing that mountain. He points it out as being Cabo San Lucas. And you look at the angular size of it, and that don't work. I'm not even close. It's really well off, Gio. So
I think he takes good footage out. He's good looking also. He's quite handsome.
Is he?
I mean, yeah, kind of. Not really. I always thought he sounded kind of goofy.
Yeah, he did.
And then I saw him do a live interview for that movie, and I was like, oh, it kind of makes sense. His voice kind of matches what he looks like. I mean, he doesn't.
Look at this big, beautiful flat Earth.
So on a scale of 1 to 10, how hunky is he? Is he like an 8? Like a 9?
I don't call him hunky at all. He's more like distinguished, I guess. Yeah.
If you were watching an ISS flyover with him, would you just make out with him, or would you try to go further?
Oh my god!
I try to go to first. I try to go to. I'd go to the batter's box. I would go right to the batter's box, not to the first base.
You go to third base, Coach O, on ISS flyover?
Yeah, I don't know. It depends on the mood. I don't know.
The other thing you want to look at with that picture Toland produced is that he doesn't really get the obvious. And the elephant in the room is when you see water, like the Sea of Cortez, it should be black in infrared photography. This is basically desert over Texas. This is just desert, not even reaching the Gulf of Mexico, and he thinks he's seeing the Gulf of Baja, Cabo San Lucas. He's putting all these names on things like, oh wow, he can see 1,000 miles away, and he can't. It's not even close.
So, what do you think he's seeing in your severe cognitive need to try to write this away? What are you?
No. What I think. I know that area fairly well. Texas. He's seeing Texas.
What do you think he's seeing?
He's seeing Texas. He's looking across Texas, and he's looking at mountain ranges that are in Texas, and it's not Baja. It's not even the Gulf of Mexico, because if it was water, it'd be black. It'd be black looking in the picture, darker than even the mountains in the front.
What do you think he's seeing? Show me on a map.
He's seeing Blue Mountain in my image. It's the one about center of my the image with the blue lines and red lines on it.
And that makes sense for how wide it is, its angular size from his altitude and its position in the airplane, roughly. Nowhere near.
And to right in his image, you're seeing Coal Mountain or Coal Hills. Oh no, sorry, you're seeing Black Mountain.
It's not infinite wisdom, Gio. It's just kind of common sense in this one. Things that are that far away are going to be really, really small. I mean, really tiny.
What if they're being magnified? Would they be bigger?
Okay.
I don't know why that's funny. If something should be really, really tiny, but it's getting
Something we
magnified, would it be
something we
bigger?
don't see. Something we don't see. You mean in real
Would it
life?
be bigger if it's
When I'm
getting
flying,
magnified?
things that are a certain distance away that I know where they are. I have like an airport there that they get larger proportional with my closure to that object as that I expected to see. It doesn't say, wow, that looked a lot closer because it was magnified. No, it's never that way. You never see things magnified because you wouldn't, because you're at such high altitude. There's very little atmosphere you're looking through.
Well, I guess unless you're Andrew Thomas Young and you claim that there's atmospheric magnification going on.
Yes,
I
but
guess unless you're that guy, I guess.
He gives a quantification of that, which is not going to help you out any.
Right, it's horizontally.
Does he? Because there's a lot of people on your side that totally deny that he even knows how the word magnification is supposed to be used. So does he quantify it, or does he not know how magnification is used?
You showed me where he quantified it, but I don't remember.
So there's definitely magnification happening then, right? Now it's just a debate over how much.
There is some magnification of the sun and things at sunset. It's usually laterally, not vertically, which is really a problem for your idea or
absolutely not a
stab
problem.
at this. But no, it's not a problem for us.
Yeah, and I'm just curious again. You need, like, right now, according to distance and perspective, it should be about half the size. Now you want it to magnify it back up to full size. Now, at any distance that's reasonable, let's say a mountain 100 miles away, I can measure things on top of that mountain, and the angular size will be right. So what is the change in the makeup of the atmosphere that happens in the 200 to 200 or 200 to 700 mile range that makes it suddenly magnified?
Maybe it's an exponential effect, and you guys got confused with your 8 inches per mile
of what?
Squared.
Of what?
And it's actually a magnification amount happening instead of drop.
Okay, so 0 to 100 miles, there's none.
I didn't say that.
We might be able to get to 250, for the record photo. I'd have to, go back to the video image and find out what his camera was and stuff, and try and calculate out what the angular size of that mountain should be left to right, or distance between the mountains. But I'm wagering that we could probably validate up to 250 miles that there's no change in size. Where do you expect this change in size to happen? Just the last 5 feet, it just goes poof, big.
Could be. Who knows how the atmosphere was acting that day? Did anyone get a temperature, pressure, and humidity rating through the readings through the optical corridor that day?
Shouldn't we use reasonable? Like you're saying that it's going to double in size, and you're saying that every time we fly, we see these things, and this magnification happens because of a temperature gradient that's always there. I don't understand.
I've never seen these. I've never seen them picked, so I don't know.
Before supporting something, you should spend a little more time trying to research it.
I was just quoting your guys. You're wondering why things are bigger than they should be. I was quoting your guy that says there's atmospheric magnification going on.
Yes, but you're quoting him and misquoting him at the same time.
I'm just saying there's atmospheric magnification going on, which would make things be bigger, right?
Yeah.
All right.
But before you cite that, you still should come up with a quantity.
And I don't know how much it was magnified by. I don't know how much magnification there is. I just know there's magnification going on, which would give you objects appearing to be lower, all kinds of stuff. Objects appearing to be bigger.
Well, magnification
lower,
doesn't inherently make something
you would
lower.
get the sinking effect. Skiba showed us how the magnification works. Skiba showed us how the magnification works with his sunset videos.
If I take my P900 and I aim it right at the top of a tower and I zoom in on it, that tower will not change from the center frame at all. So magnification does not make things lower. It can, but it's not inherently a property of magnification.
If there's any magnification happening at all, it will make objects disappear bottom up on the horizon.
No.
Actually, yes.
No, I mean I can look through. I can put my P900 at looking at something, and I zoom in all the way in. I take my magnification from 1 to 1 all the way up. I'm not sure. I'm using bad numbers. I take it from low magnification all the way up to high magnification. There will be no change in position of the horizon in relationship to that object.
You're talking about two different things. You're talking about zooming in. We're not talking about zooming in. We're talking
That's
about if the
magnification.
object was magnified because of light. So you take a boat on the horizon, right? And you just, let's say you can see the bottom, right? When you magnify it with the light, let's say it becomes double size. Well, half of it now is underwater, right? This is logic.
I don't see the logic.
It's poor logic. That's what it is.
If you set up a Fresnel lens or Fresnel lens, whatever, Fresnel, and I tip it upwards so that I can't really see the horizon, then or if I change the angle of the objects to the magnifying device, then I can get the horizon to come up.
I'm gonna have to show you guys how light works. And I don't even know any of these things. You guys know all these equations and stuff.
I don't know any
personal
equations.
experience observations.
Whatever comes through that optic gets treated the same.
Magnifying with your camera or telescope is not the same as an object being magnified by light. Because when you use your telescope, you're just basically zooming in, making an object bigger. But when an object, let's say a boat, is being magnified, meaning it's expanding because of light, it's expanding in all directions, and that will make those waves in the front cover up the boat.
If I tossed a lens in front of me, there's going to be a place where there's an optimal focus point. And then I'm going to get weird things that happen like this. If I just take my magnifying glass, I hold it 10 feet away from me on the hinge on my door, and I keep backing up. At some point, I'm going to get to a point where it's maximum size, and then it's going to invert because the light now that was coming in from the top goes out through the bottom. I don't even understand how you guys your magnification magic works.
It's really common with boats or lighthouses; they appear bigger than they actually are.
There's some stretching that happens.
At least make sense? Oh, there is stretching. Well, we can call it magnification. You can call it stretching. But if it's happening in all directions,
I don't see that. I don't see it happening in all directions, which is what I would call magnification. If I see it stretching, I'm going to call that distortion.
You can call it distortion. The boat basically is being increased in size by the light, and that's why
if it's one axis, I call that distortion. I'm sorry, it's a fine point because magnification, I think it was being uniform. But yeah, I've heard it described otherwise, saying that you could magnify on one axis.
When you say distortion, I think like wavy lines. This is a nice, clear picture of a building or a boat. It's nice and sharp, except it's magnified to a larger point than it really is.
Yeah, but in one axis, so it looks distorted, like the Black Swan, where we see that the crane is whipped out of position, or that the building that looks clear but is now twice as tall as it is wide, whereas it was almost a square before. In reality, it becomes a rectangle. And that one, that kind of magnification, I can see stretching. You can't. There's no atmospheric condition that I can think of that will do horizontal, except for
I
like
think
a momentary thing.
I think on the last one you're talking about how that arm is bending, right? So that's not a good example for you because the arm is bending, but the rest of the rig is nice and intact. So not really a good example. Just the
But
arm
that's happening
the
for the
arm
same
is
reason.
distorted.
That's happening for the same reason. Basically, you're looking through a hot or a denser zone and a less dense zone halfway down the crane. So it actually makes one half of it appear higher than the rest of it.
The arm is distorted, but the rig is not distorted.
The rig is distorted also. You can see that its aspect ratio, its length to height ratio has changed.
Oh, so and that's what you call stretching?
Yes, that would be the definition of stretching.
Okay. At least we can talk about the same thing.
Towering. Towering effect, which doesn't change. Actually makes sometimes it makes it more narrow. So it goes narrow at the waist and taller vertically. In towering. It's just like sinking. Some of your sinking type of effects will make it wider at the base and shorter overall. But they don't magnify uniformly laterally or vertically. Hello?
It doesn't matter. Most of them you can't even get to admit that the magnification even happens. They'll deny it tooth and nail. I mean, so.
No, I was very pro magnification. I told you, but it's only one dimension. When you had the sinking effect go on, it was a magnification, but it made it much wider than it was before. Or if it was a looming, it got much taller and narrower, much more narrow.
We should probably look at some pictures. Can you show us some pictures? We'll look at them.
Sure. There's a pretty concise example. This is exactly what we're talking about. I mean, look at the proportions of the foreground oil platform and then look at the proportions of the background oil platform. It's moved in its position angularly, but it's also wider. Half of its bottom is missing. Whereas the one on to the right, you can see the struts below the platform, and it's much more narrow. The roof line and the structure is closer together now. Yeah, and it's disproportionately taller than it should be as well. Look at the one on the left, how it's flattened out. The room, the building on the right hand side is like a box, and now it's really elongated and it's squished, to use a term from Lemon.
I'm not sure what you think is happening here. Can you explain it from scratch?
Yeah.
On the rigs.
So, on the what?
On these pictures of the rigs you posted.
Yeah. So the one on the left, where there seems to be not some of the effects you normally would see, and the kind of day that you would see on a day where there is a lot of atmospheric refraction. We have an object that is in the distance, and it is down below the sea line, because half of it's missing, about 100 feet of it's missing. Maybe 75 feet is missing. And on the right-hand side, it's loomed up and stretched taller and is wider. I mean, so it's narrower, more narrow. And it's loomed
Yeah,
up.
you can see the difference in
background.
you can see the clear difference in the magnification. Like on the left one, you've got that sort of magnified water layer where you can see like it sort of looks different. And you see on the right where it's not magnified, and you see, boom, that planar geometry extending out.
Yeah, but the object is now not in the correct proportions. It's changed. It's been stretched.
Well, who knows when he snapped it, whether that was wavering. You know, it might have been wavering in the heat. So you can't really say that it was like that consistently without.
They're all, yeah. Anytime you get a picture of it, of a loomed up. You get
that doesn't matter.
Video, as I recall,
the concept that this is a globe Earth in which the curvature is adjustable doesn't make any sense for any form of refraction. Basically, what you're saying is that the curve of the Earth just kind of bends and warps and changes to whatever you need it to be to fit this.
No, only when you're close to the water level, you will see refractive effects. All you need to go is 50, 60, 70 feet above that and look at these same objects, and everything goes away. It all becomes very clear. And proportions remain constant. You can check them laterally, vertically to verify that, and you will see that it will be verifiable. But when you get close to the water, that's where you get all the action. That's where you get all the refraction. And it's interesting, but that's not where you take accurate effects. You don't take measurements where you know your measurements were going to be off because of certain conditions.
Now, the one thing we could say about the top image in the 444 one is that one is distorted all to fuck. And we know that boom is not rising up going out 50 feet higher at the left-hand side than it is at the right-hand side.
It reminds me of this one. I just thought about this. Chemo made this, and he sent it to me. He said, "Thanks, Chemo." But he made this little thing showing the atmospheric magnification and the way that it correlates with that Blackpool Tower thing. It's funny, showing how it's a similar type of concept.
Do you see distortion in that image? I don't.
See the what?
Do you see distortion in that image? I don't.
Yeah, now that you guys posted the image, showing the two, right? I'm starting to because okay, flat earthers will say that, oh, when we're seeing that farther horizon, that's the true that's the true surface that we're looking at, but it's way more distorted and blurrier though. How can you think that when it's it's clearly blurry as hell.
It's not that big a difference. I mean, of course, different days are going to have different factors going on. So, I mean, when you look at that one we just looked at there, I mean, of course, there's different atmospheric effects happening. So I don't think you can make all those correlations one-to-one, just because one of them is a little blurry in one way, the other one. But yeah, the question is what is actually occurring? Meaning that, yeah, I would say that one I just posted, the one on the left, yeah, that's showing the extended planar geometry. You're able to see much clearer and much further. And there's clearly less magnification. Look at the water on the one on the left, how there's hardly any definition. Whereas you look at the one on the right, look at all that definition in the water. You're seeing that it's almost like you put a magnifying glass on and you can see all the little ripples and all the little waves in the water. So definitely that's going to change. It's like a bifocal lens. It's going to change the point at which the ground and the sky is going to meet due to the way that the atmosphere is actually magnifying the layers of the ground and the sky and whatever's on the water.
Yeah, I would say the one on the right looks more like what it ought to look like.
What it ought to look like if Earth was a globe?
No, what it ought to look like. Most things seem to appear true in it.
Yeah, just what it looks like, what it's supposed to look like. Whether it's a globe or figure eight, or it doesn't matter. It just looks more like a representative of what everything really looks like.
You're talking about the actual oil rig thing itself?
All of it, yeah. The oil rig,
the whole damn thing
looks more defined, and the water is more defined. Both oil rigs look proportionate. They look proper.
Yeah, there's a lot of factors going on. The atmospheric effects, different days. I mean, this almost looks like a different time of day as well. Like I don't know exactly on the time of day, but the one on the left looks like a different time, and the one on the right, and I mean, the one on the left looks like it's got more like sort of air pollution, and looks more like that kind
Yeah,
of lighting.
It was the reason that the whole looming happens is because we had a really warm day, and so there becomes this temperature inversion near the surface. And that's why you have the looming happening. A normal day where it looks blue and clear and a little chop on the water where the wind's blowing, you don't have that temperature inversion, so you never see that type of looming. Not ever, never. Because it's down in Santa Barbara, you can go there and check it out.
Even the photographer who took the image said that most of the times we see the image on the right.
Hey, Janik, you know how we think that we're probably right, certainly, and that they're definitely wrong? Did you know that they also think the exact same thing in reverse?
Yeah.
So, what if, Zanuck and Moyak, what if we are the ones who are actually wrong, and they're the ones who think that we're the ones who are wrong because we are wrong?
I think it's entirely possible, but I would need somebody to then start explaining a little further as to where I'm going wrong, because to just assert that magnification could cause these things, or to just assert that, well, essentially to just assert that without any kind of a base mechanism, I think I'm more confident in my argument because I have a base mechanism for it.
I agree with you, but think about this. They feel exactly the same way.
But is it a justified feeling since they don't have anything to support?
Well, I mean, that's what they think. They think the same thing about us.
Yeah, I've thought about this whole thing. Like, the fact that Dunning-Kruger exists, right? Like, you're not going to know that you're, Dunning-Krugering, like, you're not going to, that's not how it works. You're going to think you're right no matter what. So all we can do is just, yeah, I mean, you can't help that. I mean, you're either right or you're wrong. And I don't know if you can really break that illusion. Like, I don't know if you can find out you're wrong, I mean, if you're, I don't know, man. It's weird. All right. It's just, you would need some really crazy convincing. It's just not going to happen, though.
When you really think about it, you consider how we certainly feel. We feel like we're certainly correct. We think we're certainly correct also. But that's exactly we both feel the exact same way about our ideas.
Yeah. But every person has their own standard of, how they understand information and shit and whatnot. And that's why we have Globers and we have Flat Earthers, because, half of us, see, this things this way, and the other half think, the other thing, whatever. So, I mean, I don't think it's going to be really, like, I really don't think you can convert, like, a person, unless they're, like, already, like, in the middle from the start, like, not to, make this seem kind of whatever, like, useless, but I think converting, I'm not saying conversion isn't possible. I'm just saying I think you would already have to be in the middle from the start. Like, you would already have to kind of be like on the fence, kind of, like, because I don't know, man. It's just,
what you're saying is that tribalism is very rampant in this community, and once you've picked a tribe, it's very difficult to have anything change your mind.
Well, that too, but I just think that the fact that we have these different sides is because yeah, we have a certain way of thinking, and obviously the people who think a certain way, aren't, the people who the way Flat Earthers think are it's going to be a different way than how, I don't know, man. I don't want to. I'm not making a whole lot of sense, but I guess the point I'm trying to make is that, a lot of it just can't be helped. I don't think. I really like, not to make this sound like depressing or whatever, but I don't know, man.
Look at Jose. Jose was like deep into flat Earth for years, man. He was on Nathan's show for like 2 years, and then after sitting back, watching, listening, he flipped.
Well, I think
Same
I
it's
with
never
interesting.
I never heard of
I think
Jose,
it's
but how do you
interesting.
know he
Like
wasn't a
I hear,
shill?
yeah, there can be like sort of group think that can happen in anything. You know, oh, we think this way, or another group thinks that way. But I think it's interesting to kind of keep in mind that at the end of the day, it's each of us individually. Like I'll just say, like on a journey of truth. Like if each of us feels like we're trying to find the truth, then that means it really isn't about like, oh, my team has the answer or that team, or it's actually just you and how good you are at finding the truth. So if you found it, so it's more like on that level, it's more like you want to call it a contest or something like that, or kind of like a, you know, like a competition. It's more like how good are you at finding the truth? How good am I? How good is someone else at actually finding it? And that's the actual thing. It's not really about like trying to convince others or get with a team that might feel like they're winning or that they're, you know, debunking someone else. So on that level, if somebody flips one way or the other, it's like, are they flipping in the direction of truth or not? That would be the question. Because if not, then they're actually just they're sort of failing in that way. And even if someone feels like, oh, they came to my side, you're not succeeding if someone came to your side that's false.
What do you think about Jose and Ranty getting ostracized after changing their mind? Like they essentially lost all their friends.
That's pretty fucked.
I don't know.
Yeah.
I mean, what do you mean? I mean, I think they had issues in the beginning, and then they did something deceptive. I mean, I can't speak for both of them. I know. Well, I'm talking about Ranty in particular. Ranty lost everything. I mean, no one even listens to him anymore. He's completely irrelevant. He had his little last kind of moment of, you know, popularity, if you want to call it that, when he did his flip thing, but nobody respects him at all anymore because of just what he did and how he went about it. Everyone just saw through. His integrity is so low. So I think he dug his own grave. It has nothing to do with what he thinks about the shape of the earth. Like his actions, his deception, his dishonesty, his inauthenticity made everybody just like uninterested in him.
You don't think he has any integrity?
No.
Why?
Oh, for multiple reasons.
Some of them.
Can you name a couple?
Of what? Of Ranty's lack of integrity?
Yeah, reasons to make you think he doesn't have any integrity.
Well, I don't really want to go on a whole thing about someone who isn't here, and it's not really polite to do that. So, I mean, we could talk offline or something, but
By calling into question his integrity, you've already done that. Now it's up to you to give evidence. Or you shouldn't have anything to begin with.
Well, it's up to me to do exactly what I want to do, and I don't have to do anything that you ask me.
Of course. Well, then you're a liar. I'm just going to call you a liar. I'm not going to say any evidence for it. I'm just going to call you a liar.
Now it's up to you to show how Gio is a liar.
No, I don't have to. I just feel any way I want.
Now you're getting into personal attacks, and I guess we'll have to moderate you if that's what you're going to do.
You don't see the correlation here. You've said something, you've maligned somebody, their integrity, yet now it's just a fact because you've chosen to malign them and not validate it.
I made a couple of general statements about Ranty's lack of integrity. Somebody asked me to go into it. I'm not really wanting to do like a whole half hour tearing apart every single thing that the guy did.
You don't have to do a half hour.
Does anybody in this community think he has integrity at all?
I do, but I will give examples for your in your stead because you have to remember Ranty did tell everybody that there was a lumberjack in his wardrobe, and he also told he also said that he got in a fight with those two dudes who had a license plate Globe 1.
Yeah, I remember that.
I thought that was Arwen.
But I do. I mean, I've known ever. I mean, I've grown to become a friend of his. I don't want to say his integrity is a question, but that those events would put his honesty in question, I suppose.
Yeah, he pulled a series of incredibly shady moves that it seems like, if you want to call it sides of a flat earth and a globe earth, that seems like both sides saw through, which is why he's lost any level of reputation within both.
Well,
I know he will. Sorry, go ahead.
You might have heard it within the community, but like right now, he's live streaming with 353 viewers. Yesterday's video got 5,500 views day before was 7,300 views. So he's doing okay as far as his. Yeah, but I think he's got a different set of viewers from
He's
what he
bigger
used
than
to have.
Nathan, huh?
Yeah,
What,
bigger than Nathan. Yeah.
What does he talk about? Does he not talk
yeah, he's not being suppressed anymore by the YouTube algorithm, so he's they're probably pushing him up front or giving him a normal shot at least.
So,
And it's also been talked about that he's paid for his views and his subscribers. So who knows how much of that was paid for? But
More claims without evidence.
He also is being currently suppressed as he is live streaming the reaction to the Amber Heard Johnny Depp trial, which has copyright infringement written all over it. So he is actively being suppressed.
is that what his content is now? Is that what the? Is this the flip?
That's what he.
Is this
Copyright infringement isn't the same as being suppressed. Those are two completely different things.
Is that the? Is this the channel that he calls Flurf? Is this the Flurf one?
No, this is auditing the absurd.
Oh, okay, so this is the one on like ghosts and meta. Is that what it is on ghosts and?
No, that was another one. This is a new one, I think.
I like that name, Auditing the Absurd.
All right, so yeah. So he claims to have gotten 24,000 subs within a short amount of time here.
Oh, I don't know. I'm just looking at the viewers and the hours watched.
I mean, he's only got 5 no, he's got more than that. So this is all, oh my gosh, he's done tons of videos. So he started this channel 3 months ago, out of the brand new, it looks like. He's mostly talked about Amber Heard and Johnny Depp, looks like the entire time. And there's a claim that we think that he has 24,000 subs from being in business for 3 months, talking about this Amber Heard thing, and then he's got 300. I mean, that doesn't line up at all.
Well, I mean, some of the subscribers followed him from his other channel.
So you're claiming a bunch of globe earthers that, even though he has no popularity in the shape of the earth discussion, a bunch of globe earthers loved him so much, 25,000 of them, that they all instantly subscribed to his channel to watch him talk about Johnny Depp and Andrea Heard?
No, I'm just saying that a portion of those are probably people that are loyal to him as an individual that subscribe to his new channel.
Yeah.
Get it right, Gio. It's Amber Turd, okay?
How about he's just going for the subs, right? Just for the activity. So he's on the flat Earth, not getting great activity. Moves to the globe Earth, much more activity. It doesn't get shadow banned, and then moves to Amber Heard to get more of the hot subs and hot views, whatever's relevant.
I mean, that's how this shit happens. Like, the algorithm pops off. That's probably why he's making a bunch of different channels related to a bunch of different subjects, because that's kind of how the algorithm works. It'll latch onto something and it'll push views out, and you just gotta get lucky. You gotta get lucky and have decent content. Unless somebody knows how the algorithm works.
That's right. In 3 months, when the Heard Depp trial is done, he'll be on something else, whatever is the flavor of the month.
Yeah, I've seen that a lot recently. Just like trying to watch people comment, trying to find people that were commenting on the Amber Heard Johnny Depp trial. I've seen like 2 or 3 channels that I've never heard of before that had very limited subscribers that just popped off over the past 2-3 weeks. Can we take a poll? Who thinks Amber Heard's lying?
At least he's not getting shadow banned now. More subs for him.
Yeah. Yeah.
I'll tell you what, Amber Heard is an extremely good actress, and she's good at acting, but I can see through it.
Yeah, I don't think so. I think she's a shit actress, and you can totally see through the lies. Defamation's hard to prove, but what she's done is so egregious and so obvious. There's a sort of thing that's similar to jury nullification. I guess it's kind of the opposite of jury nullification. Like they could basically find her guilty even though it doesn't fit the definition of the law. specifically for defamation, and that's what I think is going to happen. That would be my guess. They're going to charge that bitch with defamation, regardless of if they think that they actually proved it. When's it supposed to be over? It's got like another 2 weeks or something. She's just so fake, man. It's so bad.
You should
So
ask
bad.
Ranty. He's apparently an expert on it now.
No,
Oh no, I seen Ranty's the videos he's doing next. Wow, he's doing those videos where he's taping chicks doing yoga in their yoga pants.
Wait, what? Wait, what? Now? What?
Oh man,
it's not a bad idea.
Maybe he's gonna do like funny cat videos next.
What's the name of the channel?
I'm messing around, man, but I don't know. Yeah, what is the name of this channel?
Dude, that's like a whole genre of YouTube where like hot bitches clean stuff.
Yeah, no, that was my idea, dude. I was gonna go to San Marcos.
That was your idea?
Well, no, I mean, I was gonna go to San Marcos and just college town, and I was gonna advertise, that we're doing these fitness videos. If anybody wants to do yoga videos, there's a lot of attractive women there, and you give them like $100 to do yoga for fucking 15 minutes, 20 minutes. And I put that on YouTube.
That's pretty creepy, dude.
That's not creepy, actually. What it is, it's genius, because not only do you get to make money off of these people doing yoga, but you get to tape it yourself.
You have that much of a need to creep on girls that you need to watch them doing yoga? I thought you had a girlfriend.
That's not creepy, man. To watch, do they put it on YouTube? It's not like you're spying on them.
Yeah, but you're like sexually getting excited about a girl doing yoga? Yoga is like
How do you know he's sexually getting excited?
Well, I mean,
I'm a
sometimes you want to change it up,
Hey, I have rose bushes at my house. Right? I have rose bushes at my house, but I can go over to somebody else's house and appreciate their rose bushes.
Well, the thing about yoga too, I know that nowadays it's been kind of westernized, but it's really a spiritual practice. It's an ancient spiritual practice. It's not really something involved with like trying to watch for some sexual excitement thing. Like,
well, they put it on YouTube for to arouse dudes.
Just because they're in different positions or whatever? I mean, you could find that on Pornhub.
Come on, man.
No, this is for like the 17-year-olds. You don't want to go straight to that. You want to go like
it's considered like softcore porn or whatever.
Hold on, there's porn on the internet now?
I heard about that. I heard there was. But
Shit, I gotta go.
Later. That's a genius move, Kocho. And the girls, they'd be like, "Oh my god, really? I get to be on YouTube, and you're gonna pay me $100? Thank you. Yes, let's do this."
I will just do it for $100.
Yeah.
I don't know if Coach is into the 17-year-olds, the 25-year-olds, or the 40-year-old males. Which one, Kocho? Tell us the truth.
Well, you broke up big time in the beginning for me. I don't know if it was for everyone.
I have to say it again.
Just to make one last comment about the Ranty thing in terms of his integrity, just because Moyox sort of questioned that. And like I said, I don't want to go into a whole long sort of thing of someone who isn't here, and it's not really fair to do that. But I'll just say in terms of his public kind of persona, he was doing the sort of flat earth thing, trying to get subs and whatnot. And I think the idea that he bought subs is pretty high because of the number of views that he used to have, and the popularity didn't really match that. But then he sort of handed the channel to Brandon, and then it still had limited actual viewers even when Brandon had it. But nonetheless, is what it is. Like, that was that channel. He wasn't making very much money in it. And then there was all the scandals involved with him, all that stuff that went on with Sleeping Warrior and all the stuff with, money, and that he couldn't make money. He ended up announcing that he was just leaving quote unquote flat earth, he was just done with it. And that's when he handed the channel to Brandon. And then obviously Brandon continued that. And then he then was going to create a channel with, cats or whatever to do the ghost stories thing. That didn't go anywhere. He then tried to come back and say, "Oh, I found this photo off Facebook and now the earth is a globe," whatever. Tried to get popularity there, then created a channel called Flirtspective to try to see if he could go to the globe side to get a bunch of viewers, or see if he could do like the Fight the Flat Earth thing and try to get viewers that way. That failed, and now he's just going with whatever the hottest Amber Heard thing is. So if that's not lack of integrity, I don't know what else is. He's just hopping and jumping to different things that he thought could make him money. He thought Flat Earth could, it didn't do it. He thought Ghost Stories could, he couldn't do it. He thought a flurfspective kind of flurf anti-Flat Earth globe thing would do it. That wouldn't do it. And now he just is trying to go with the hottest thing that he could try to get subs on, which is apparently Amber
Well,
Heard.
if you're wanting to be a YouTuber and you aspire to be a YouTuber, are you going to just try one thing and give up, or are you going to be persistent and consistent and try to achieve your goal of being a YouTuber? I mean, I don't think that insults his integrity. I think it might speak to his tenacity in trying to be successful as a YouTuber.
Yeah, no, I mean, if you want to be a YouTuber and if he can find success in Amber Heard and Johnny Depp's problems, I guess if that's where he needs to find his money, then so be it. I hear you on that but the thing is that when it comes to more the discussion of like truth and the shape of the earth, that is where is the form of integrity I'm talking about in that scenario. Like, was he actually in it for the truth, or was he in it to just make money and he was trying to get popularity? Oh, I'll go to the globe side. Oh, I'll go to this flat earth thing. That's the question. Was he actually in it, for just trying to make money, and it wasn't really about the truth at all? And when he came out with that Blackpool Tower thing, trying to get all the Globers on his side, it's like, that's pretty weak activity, pretty weak behavior in terms of having any integrity when it comes to truth and actually being on that. If he just wants to be a YouTuber from that side, yeah, I guess, right? Try whatever, go flat earth, go globe earth, whatever you got to do to make a buck, I guess, if that's his goal. But I don't really see that as very admirable.
Yeah, I mean, he's just fame crazy or whatever, like those girls who go to LA, they do whatever fucking to get famous.
I mean, how long was he in Flat Earth for? He was in the Flat Earth community for years, wasn't he? He would go to He would go to meetups. He would meet people in person. Like I feel pretty confident that he was into Flat Earth. Like he was a true Flat Earther. Like he believed the Earth was flat, and he was trying to promote that. And then at one point he flipped, and he just wasn't convinced anymore, and he had kind of an epiphany. But he still wanted to continue YouTube, so he's just trying that now. I don't think that that's necessarily you can say just because of what he did that he doesn't have any integrity.
Well, I don't know if you were involved through all that when it actually happened, but it was very bizarre the way that all unfolded, because I kind of was there throughout all of it. The way that he kind of handed the channel to Brandon, said he was done, and then he kind of got with Katz and Ruhif, both of these kind of Globe guys that have been pushing the Globe for years. He kind of hooked in with them, and then all of a sudden had sort of funding to do these different things, and then came out with this, even though the guy had been taking photos himself for all these years and analyzing and saying no curvature, no indication of a globe whatsoever. And then all of a sudden he now, somebody claims there's a picture on Facebook that he didn't take himself at all. And then and then to try to say that now he had some big epiphany and is creating a new channel called Flurfspective or whatever. And he's going to try to, make money that way. I mean, and there was a time where Ruhif was like trying to fund him to do this auto level thing that he never did. I mean, the whole thing is just bizarre to say the least. So
I think basically what you're saying is that anybody who leaves the flat earth will be accused of this, because if they had all the evidence the whole time, when it finally reaches their trigger point for believing that it's a globe, all the other pieces fall into place. When you finally start admitting that to yourself, at least that would be my position on it. So I would say that you, at that point, would say that anybody who switches from flat earth is a liar, right?
Well, I didn't call him a liar outward. I was talking about his actual behavior and how that all happened. No, I would not say that anyone that changes their own cosmological perspective is anything other than their own person going on their own journey, whatever it may be. But was Ranty's quote-unquote journey authentic? Like, did he really have some massive epiphany from a picture on Facebook that proves nothing? That was kind of in the limelight for a couple of weeks, and he tried doing debates on it, and then it all just kind of fell apart, and then he ended up just leaving the whole thing because it clearly wasn't making him money, because the Globers didn't go on didn't really get the popularity he wanted from the Globers. So then he just left the whole thing, and now he's on to Amber Heard and Johnny Depp. So I mean, I'm talking about him in particular. I'm not talking if somebody right now, like whoever, I'll just name some people in this room. I mean, myself or Jeremy or who else is Bob Dole or anyone who would say the Earth is not a globe. If one of them said, you know what, guys, I was looking at whatever, and I really think the Earth is a globe, then no, I would not necessarily, because that's what you just said, that they would absolutely be a liar or something. No, not necessarily. People have their own journey, but what Ranty did and the actual unfolding of it was unique to what
I mean, he did invest a lot of time in the flat Earth. Now let's go with a different hypothesis on that, which is he attempted to parlay his newfound knowledge into money and found out that, well, there's not a big industry in trying to prove the Earth a globe. So let me see what else I could do, because this is pointless.
Yeah, I mean, he crafted the skill of, making YouTube videos, I'm sure, editing software, stuff like that, right? So he's got this set of skills that he could try and apply somewhere else. And, I'm sure that's, I can't help but think that's what he's doing. Because he was in the flat Earth community for so long, just like Jose. I mean, I remember seeing it was a documentary where there was a meeting in UK and Ranty was there. Like, he was full force in the community as much as anybody.
Well, the people the people who kind of flip, if you want to say that, like the ones that, I mean, there seem to be a correlation between several of these people you're mentioning and them attempting to get a channel going. Like Jose obviously has had his channel, and his flipping has kind of been like, he tried to get the Globers. Sean G had a similar thing. When he first kind of came out, like he was trying to ride the wave of like Bro Sanchez and Dreads, like You've Been Exposed Dreads, like he was trying to, so he created a channel trying to do that. Then he did his flip thing. So there is kind of a pattern of some of these guys trying to like do a flip to see if they could get, followers to follow him.
Yeah, but we kind of think about it from their perspective, right? So let's take them at face value. And they were flat earthers. And all of a sudden they have this epiphany and they think, well, I've been lied to, I've been had, and they're pissed and they want to fight back, and that's where they're coming from. So that's why they were making videos in relation to flat Earth. So once they have the epiphany, they're pissed. They want to make videos in relation to globe Earth, try and show kind of their thinking, how they're wrong, and they're just pissed in general. Like if you've been had, let's just say, like, you were robbed or something, right? Something of that nature. You'd be mad. So most of the people who flipped are mad. If you talk to them, that's what they kind of say is that, they were aggravated that they got had. That's their feeling, anyways, right?
They got had they got had by the globe lie? I mean, what are you talking about? Who did they get had by?
They got had by flat Earth.
Okay, so they didn't actually go on their own journey of truth to discover something. They just went believing content creators, and then they feel like they were had from that?
Yeah. I mean, what sources of information do we have, Gio?
So they went from blindly believing NASA and the globe to then blindly believing someone in a flat Earth without actually thinking for themselves and coming to their own conclusions, and then got triggered that they were had by someone else, and then went back to being had by NASA?
No, you're putting in a whole lot of extra, my dude. A whole lot of extra.
The other part to that is they all had a softening towards globe earthers, and I don't want to say epiphany, but as their stance changed slowly over time, right? So a lot of them were antagonistic towards globe earthers before, and not towards the end.
Yeah, I mean, I'm sure you'd be pissed. Let's just say, oh God, I'm trying to think of a good example here. Do you like crystals, Gio? Are you into crystals? Do you think crystals have healing powers? I'm gonna guess yes.
Well, I mean, all of what you're saying is based upon putting one's own truth capacities into someone else outside of them, and then being upset about it. Because if you're coming to your own conclusions, then you only have yourself. So if someone's in what you're describing, then they're in their own issues of putting their truth-seeking capabilities into someone else, and then kind of in their own, like, in their own process of being confused about that, and then flipping back and forth and going all over the place because they're not actually discerning things for themselves. So, like, yeah, that can be problematic no matter what you're doing it in, whether it's abortion or religion or anything.
Somebody who puts like any sort of belief or trust into another human being that they don't have like a personal relationship with, they only have themselves to blame if they find out that the person was tricking them. That's like, it's such an absurd idea. But like, if you've decided to believe content creators online about what your reality is, you deserve what you got. You have no one to blame but yourself for being tricked, because you chose to believe somebody else about what your reality is. Why would you ever do that? So of course you got what you deserved, and it's your own fault. The only time you should ever be trusting someone with something important is when you know them, you have a personal relationship with, and then you have a reason to, if they lie directly to you, to be upset that they lied directly to you.
So you're not going to be bitter if you ever figure it out?
That's when discernment comes into play, right? You got to be able to, like, step back and look at it and evaluate what is being, teached or taught.
I mean,
you can learn a lot of things, like how to work on cars, how to work on, plumbing, all sorts of things on YouTube. You just got to step back and look at it. Are these, is this correct information?
Yeah, you guys are kind of denying the culture that exists. I mean, we're absolutely products of our culture and people around us and what people tell us. If we existed 50 years ago, we would all be very different people. You can't deny the effect that culture and people have on you. You can at the end of the day, it's ultimately up to you, but I don't think that's necessarily true, because you're fed different informations and different frames of reference and different perspectives based on the culture that you exist in 50 years ago versus 100 years ago versus 200 years ago versus 500 years ago. I mean, humans are so extremely moldable in terms of thought. I mean, just look at Muslims, Christians, Buddhists, Zionists. I mean, the list just goes on and on. I mean, people are so different, and that's mainly because of the culture that they exist in, right? If it was only up to you and nothing else mattered, I don't think you would have these huge cultural pockets. You would kind of have, some version of that was broad.
At some point, you have to make a decision. Okay, if you are allowing other people and the quote unquote culture affect you without you making any sort of decision in the matter, you're being a bad human being. You've shut off your brain. If you're reached adulthood and are letting other people decide what you are, you're a bad adult. You're basically like a child in an adult body. It's absurd. At some point, you have to decide, I'm going to take this thing that other people are doing or thinking, and I'm going to make it part of me. And if you choose to do that, it's your fault.
I agree with you. But it still doesn't, I still don't think you throw in culture, though.
Culture is only what you decide what it is, dude. It's not like it's some magical force swirling around us controlling what we do. You see something and you decide whether or not you want to be part of that thing or not. That's culture. If you have a group of people that decide they want a thing to be part of their community, that's their culture. That's it. At any point you don't want a piece of culture, all you have to do is decide, I'm not part of that anymore. It's not part of me. There, culture gone, period.
Well, then you'd be part of another culture.
That's right. You would be deciding to be part of something else, in which case it is your fault. You have the repercussions for your decisions. You're responsible for them. So being upset with somebody else because you changed, you decided to change, is absurd. It's stupid. So getting upset because you were quote unquote had because you decided to believe somebody else on the internet, it's your own fault. You got exactly what you deserve.
Okay, so what about, have you heard of Children of God? It's a cult.
What's that? I want to hear about this.
About that.
Children of God. It's a cult. It's mainly in Brazil. It's a sect of Christianity. And they basically...
That's not possible.
they basically they have sex to be righteous with God, and they brainwash typically youngish women like 17, 18, and pull them in and brainwash the fuck out of them, and most of them leave eventually. But people are impressionable, especially females. And being impressionable doesn't mean that you're not necessarily accountable. It just means you're impressionable. When you're young, you're impressionable, and you can't, you don't have the capability to make, right versus wrong decisions because you're impressionable. But Children of God is a crazy cult. There's quite a few in Brazil, thousands. They've been kind of deconstructing it in Brazil, but their whole thing is, basically that's what they do. That basically, there's one guy who sleeps with like 10 to 12 women. And there's also this really interesting cult in Africa where you have. Okay, this is kind of vulgar, but there's this one cult in Africa where they've developed teachings that in order to become a man, you must ingest, a liter of semen or something. So humans can come up with some pretty crazy culture, man. But I don't think you can say it rests on the individual until you're of mental capacity, which to me would be like 25 plus.
Yeah, the idea of setting a specific age for that to take place is ridiculous in and of itself.
Well, I mean, you got to put the bar somewhere. I mean, there's no perfect answer. I'm just saying about 25.
You don't have to actually put the bar somewhere.
Well, there is. Well, Bob, wouldn't you say there's something to be said? I mean, what I was talking about before of having coming to your own conclusions, I was talking about for an adult. I mean, for a 5-year-old kid. I mean, Bob, don't you think? I mean, young children definitely are more, susceptible to.
I said it like 3 different times in what I was saying. I said someone who is an adult who is doing that is being a bad adult. They're like a child in an adult body. Like the entire time I was talking about adults and not children.
So what age is adult? What's an adult?
That's a discussion that we can have for sure.
Okay, what do you think an adult is? What age?
Subjective. Different people
I don't think it's age.
I'd say almost everyone is an adult by 25, but some people mature faster.
I was gonna say if we just threw a number like 20, 25, that's probably
25.
25. That's what I said.
No, what I said was not. What I said was most people are an adult by 25, but some people mature younger. So that like if you take a population, 98% of them are going to be an adult by 25. Some of them might have become an adult by 22. It just depends on. But there ain't no fucking 30-year-old babies around here. That's for sure.
Okay, well, I mean, it depends on what you mean by babies. Like there are people who have a mental capacity that put them squarely in the mindset of a child who are incapable of making adult-like decisions using logic and reason and thinking through consequences of their actions. Those people, I'm sure, do exist. But we don't put responsibility on those people that we would on someone we consider a quote-unquote adult because they've reached a certain age, do we? Because we don't consider them an adult. They are simply a large child, mentally.
I say part of being an adult is having to hold down a job and maybe be responsible for a family or at least some other people. That is a good experience. Join the workforce and to know how to act and work.
I mean, that might actually be like a better way to do it. Instead of trying to put a number on it, look at the responsibility that the community puts on the person. That might be a better way to actually gauge whether or not a person is an adult. Is what are they responsible for?
But I have also a problem with that because there's people who literally are just fucking thieves. Like their whole job is just to lie to people and shit. Is that adult? Is it adult that you lie to someone? I guess, yeah, it is kind of adult that you can go on the phone and convince someone to buy something they don't need and it's a fucking lie. But is that really an adult activity?
I don't associate lying with adulthood. Like children lie. In fact, I would say that's probably like a very easy response for a child who is fearful of like being in trouble, being punished, is they'll try to lie so that they don't get punished. So like, I would say lying is more of a childlike thing than an adult-like thing.
Well, that's actually what's funny. Like when
There's
Yeah.
sorry.
No, I was gonna say real quick. No, what you said reminds me of like those like Indian tech support scammers where they're sitting there all day just collecting thousands of dollars by lying to people.
No, yeah, it's ridiculous. Like there's whole occupations where nothing is really produced economically, yet we think of them as like the pinnacle of adultness or the pinnacle of maturity. Just like politicians for one, or lawyers for another. I mean, there's all kinds of jobs where it's just like, is this really an adult thing? Like it just seems dishonest. Is that why are they touted as being like the most successful in society and the most glamorous and the most adult and mature and sexy to women and shit, when it's like, dude, all you do is rip people off and lie all day. Literally,
Right,
that's
like
all.
yeah, like there's some YouTube videos of people like who basically kind of prank. I think they call it scam baiting, where basically like, you know, they're like a YouTuber and they'll use some voice changer and then they'll call these like Indian tech support scammers and just run them in circles and waste their time and all that. But there's actually this one guy named Kit. His name is Kit Boga is his channel, and he actually mentions flat Earth in some of his. I think he's kind of doing it just to meme, but he says God's green flat Earth. He always says that little statement. But anyways, like in some of those things, like when he gets into it with those guys, like I've watched a couple of those, it's kind of interesting because like once he kind of reveals that he's just, you know, fucking with them, they get pissed off, and you know the scammers do, and then they start to kind of admit what they're doing, and it's funny because sometimes the scammers will be like, well, how much money are you making? Because they know it's a YouTuber making money. So the scammer will be like, how much money are you making? You know, he's like, I'm making way more than you. You know, the scammer starts saying that he's making way more than him. And he's got, you know, Ferraris and he's got, you know, women and all this stuff. And it's like a weird thing because he's like bragging about how he's got all this money and how he's killing it, except he's just literally robbing old ladies all day and just completely lying. But he's got like a nice house and a Ferrari, so he thinks he's like,
Yeah.
he thinks he's winning.
And
It's weird.
do you not find it kind of funny because like they tout like, oh, having a Ferrari and Lamborghini, you're such a mature adult. These things are toys. It's actually very childish. You know what I mean? Like these things are like little action figures, like little fucking Bionicles that you have. I mean, now it's kind of like an adult version since it's a Ferrari and Lamborghini, but it's still that innate drive to be the cool kid with the best toy. You know what I mean? They even call it like, oh, what kind of toys do you have when you're talking to an adult and he's showing you his boats and shit? You know what I mean? But yeah, I don't know. If we're going to talk about maturity, I mean, there's whole sections of society that all they do is waste everyone else's time and rip them off. Is that adult? Is that mature?
It's neither.
Huh?
Lying is not
It's a different
mechanism
thing.
for determining one's adulthood.
It has to do with morals and ethics, nothing to do with being an adult.
Yeah, it is weird. Like, because when I listened to those scammers like saying that, it was kind of like it was interesting to hear how they think they're succeeding. You know, they think they're just and like to them, I think in their mindset, it must be like the way they rationalize it to where they think like the only goal is just getting the money. So that's all. That's it. As long as they get the money, then they're succeeding. They've got a nice house, a nice car, whatever. And it's like it doesn't matter to them how they're doing it. So it's strange how they must kind of compartmentalize it in their mind that, you know, that they're succeeding because they're getting the money, but maybe they're somehow, you know, suppressing the actual morality or the emotional part of what they're actually doing to people.
Hey, by the way, now, you know, showing off your toys. Hey, check out my boat.
Go for both.
See how successful I am?
That's pretty nice.
It's an old beater. 1983. Yeah, I wouldn't call my boat a success story. It's something I enjoy doing. Probably costs more than it should for what I get out of it.
Was that flexing in the image?
That's my son. I can't get a picture of him where he's not doing something stupid.
That's pretty funny.
And you gotta whip out that camera really fast in order to catch him in a normal position. He got like Bruce Lee like reflexes.
You know what else I heard? I was reading this thing on psychology, and it's like mob bosses always try to make themselves look like actual business owners and stuff. And then they see like people who are really slimy always try to dress up in the nicest suits and shit. And it's like some sort of psychological thing to where you basically see what you're doing and then see what is a similar occupation that is virtuous, and they try to kind of like play out that thing. I honestly I can't even explain it well, but I was reading this like basically this psychological thing where they're just saying like these people who do things that are immoral and they know it's like immoral and it kind of bothers them, they always try to like overcompensate them and make them seem like the virtuous counterpart to whichever like career they're in.
Have you heard of the Yakuza?
Yeah,
They always dress nice.
They cut their pinky off too, right?
They dress in suits and shit, ties.
Exactly, and the old Italian mob bosses too, always in the old suits and ties. It's a thing. Like they say that like the more you are like immoral, like on the inside, and you can feel that there's some sort of psychological drive to kind of impress on the minds of others that you're not that thing, basically.
Well, there's also an important point to be made there. You don't want to bring undue heat to yourself, so you actually have to put on a facade. If you look like a legitimate businessman, you get less. There's a perception that you get less heat.
I've actually noticed that it's like kind of a similar topic to that, but not quite. But it just made me think of it. But I've had times in my life where I've had long hair, and I've had times where I have short hair, and it's like amazing the difference in perception. Like when you have really long hair, people just tend to, whether they judge you more like you're, more of a hippie or more of, something like that. Whereas when you have short hair, you're, I don't know. I've just kind of noticed that in like a
You're starting off with one step down. You can earn your position, but you're getting the initial prejudgment where it's like, okay, I noticed most hippie freaks are kind of flighty and whatever else, and you put them into that box until they prove otherwise. Just like a guy covered in tattoos, oh God, you're just some kind of a guy who's hung up on showing off your badassness. Oh God, you are just kind of a nice person. What the hell?
Yeah, it's just weird how people judge like that. Like in college, I had like such long hair that I had a ponytail, like an actual ponytail of long hair. Or at one point, I kind of had it where I would have like the ponytail on the top, So, but anyways, yeah, but like that, and then I would like I had the hair that long, and then I like cut it almost down to not quite a buzz cut, but like pretty short, and it was like very noticeable how just the general. It's not that I was like being outwardly judged or treated poorly because of long hair, but maybe I'm just like kind of aware enough of people's like interactions, just to kind of tell like just kind of how people perceive it.
But you also knew the rules going in.
But I also feel like when you cut your hair short, it kind of gives off that vibe of discipline. And I'm not saying that long hair gives off the vibe of undiscipline, but like I just feel like if you're clean shaved and your hair is short, you have to consistently do that. You have to shave yourself either every day or every other day. If you're like me, I don't know, my hair grows pretty fast. I don't think Asians need to shave their faces often, and then to get your hair cut and keep it fresh, you need to go get it every 2 or 3 weeks. So it kind of shows like, I guess, a stability and discipline. Not that you wouldn't have it with the long hair, but it's just kind of like a signal, I guess. You know what I mean?
My bad, guys. I'm not trying to like red hair from this.
Yes, you are.
I really want to be honest with you.
There you go.
This is just absolutely amazing. All the excuses that Globers are trying to give me about, the ISS crashing in Point Nemo and how they won't have any pieces to display in a museum because it's too expensive. The excuses that I keep getting are
what are you talking about?
It's like
when are they supposed to retire the ISS?
Yeah. 2000. Well, I just posted it right there. It says NASA says trying to display any portions of the ISS in a museum would be extremely expensive and difficult. Site and order technology used to build the football field long station that wasn't designed to come apart easily. And they're trying to, like, this one Glober.
So what's your problem with that?
This one
Yeah,
Glober
what's
said,
wrong with that?
listen. This one Glober said, not only that, but most of the pets will burn up during re-entry. Really? So you're telling me that, you know, the humans that come from the ISS back to Earth, they burn up in re-entry?
You kidding me, Don?
No.
Are you really? Are you being
No, I'm
serious?
just, yes, I'm
If the
yeah.
ISS burns
is our
up, then anything
problem.
on it would burn up.
It's
Yeah.
This is
a
our
very,
problem. The first time we get a chance to test what they say is up there, we can't test it because of this bullshit. That's what it is.
You can test.
Well, you wouldn't believe it anyway. You just say it was a thing that was on the ground. Right? So I don't know what you would hope to get from that, but the long and short of it is, you say that like people come down and they don't burn up as they're coming down. Clearly they don't, because they come down in a tiny capsule that's designed to withstand the heat. This thing is not designed to withstand the heat. It burns up.
Yeah.
All right, so it's not a little bit strange at all that there's no proof that it was put up there. There's no pictures of it being built or anything, and then now when it comes down, there's absolutely no proof that it came down.
Dude, tell me, Gio.
Oh,
This is
no,
absolutely crazy.
Pictures and footage of it being built.
This makes no sense.
Yeah. Yeah.
There are pictures of it being. There are pictures of it being built. There is no logical way that one could, in any way, think of bringing down large pieces of this thing without
There's
burning
pictures
them
of
up.
pictures of it being put up in space. What do you mean?
There's footage of it. Yeah.
Do I get a video
I've
camera
never
of them
seen
put
that.
together in space, like one module connected in space together? You get astronauts out there with the wrench, tightening it like that.
Hmm?
Hey, look, here's the thing, dude, why I brought it up. I'm not denying that there's something up there, right? But this, I mean, you guys make this like religious. Like you just must believe.
Do you admit that there's something up there?
Yes, yes, I do. There's definitely something up there.
And we know that it's at on the order of 300 feet long. That's observable, reasonably observable. So where's your exception?
300 feet long, and you can see that at 252 miles.
Yes.
Really?
Yes.
Really?
I actually did the math. It checks out. Yes.
Really, you can see that something that small, that far away.
Yes.
Why aren't we able to make out buildings from the ISS footage? They're roughly about the same size as it, maybe even bigger.
Well,
Buildings are much bigger than the ISS.
Yeah.
Well,
Why
first
are we
off,
not
you
able to
would have
make
to-
out like ships, cargo ships?
Well, first off, you would have to zoom in, just like how we zoom in for the ISS.
They do.
There's
I mean, like,
pictures of
really zoom
airplanes
in.
from the ISS.
Where's these cargo ships? They're everywhere.
There's pictures of airplanes. There's also pictures of rocket launches from the ISS, if I'm not mistaken.
Video.
There's a video of it.
Really? Where's that at? I have never
I
seen
can look
those.
that one
I
up
watch
again.
ISS. I watch the footage a lot, and I do not see cargo ships that are much bigger than the ISS. And they
The
zoom in.
footage, you're saying that you looked at the low
I watch
resolution
videos,
images that are taken with no zoom?
No, I watch
And
videos.
you-
There's this YouTube channel.
Okay.
And I definitely watch the videos, and I don't see none of that.
It's got to be the zoom, just so you know, because no way in hell are we seeing at least the ISS, without zoom. So the same should apply with these things as well. We need zoom.
Whoever said they have the math to see that proves you can see 250 miles away. Can you please put that math in the live stream? I want to learn, please. Thank you.
Okay, yeah, give me a second.
He just wants to have math. They're gonna put it in the live stream. I don't think it's going there. Let's be honest.
No, I'll put it there. Hold on, I'll do it.
Size. I mean, it's not a real complicated formula. Use a triangle calculator if you want.
Yeah. So
There's also a difference between an object being observed from the ground, whatever that object is, and there's a difference between that and then the idea that that's an actual quote unquote space station with men floating in it and all what they claim.
Now, the only thing I could say from the ground that I could say definitively is, and of course this is with other people's information, but I'm going to treat it as true. They looked at it with telescopes. You could see things changing on it. You could see the ISS meeting up with the space shuttle. So that is a change in its form over short periods of time, in keeping with what's expected. They say space shuttle's going up. They take a picture. Oh, look at that. We can see the space shuttle.
It's a bit strange you said it
We can
changes.
see the modules, the Dragon capsules and stuff connected up to it.
What do you mean as in changes?
It changes shape. It actually, you could see a space shuttle riding next to it and docking with it. At least a space shuttle shaped object.
But how does that make it change its shape? What do you mean?
Well, it was just a tube with some solar panels, and then it was a tube with some solar panels with a space shuttle attached.
Do you have video evidence of this, or you have pictures of it?
I mean, if they're doing this, then why do they never show rockets docking? You know what I mean? Like just straight.
They do.
Footage.
They
I've
do
never
every
seen one.
time it happens.
Oh yeah, I've never seen one. I've been looking for one. I would like to have that though. If you found one.
Yeah,
And what do you think you're going to see? And they show you the capsule coming up. It's viewed from outside. It gets closer and closer and closer, and then it docks. Now, are you saying see something from the ground?
No, like as in a camera attached, front forward facing on a rocket and rear, and it docking. Which I mean, it's.
I don't know if I've seen that per se. I've seen it dock from the ISS. I don't think I've seen from the Dragon capsule or whatever from the Soyuz. I don't think I've seen that.
Does the rocket have to go 17,000 miles an hour to catch up to the ISS?
Of course it does.
Of
course it does.
But apparently,
Or
but
does ISS slow down?
in their model, all speeds and shit are relative, right? So that speed is only relative to the Earth. Compared to the fucking when the rocket is going to the ISS, it just looks like the ISS is going at the same. It could even look like they're going still next to each other.
Yeah, I mean, the
It's only
docking
relative to
process
the
takes
Earth. It's only
hours.
relative to the Earth that it's going 17,000. Nothing else, right?
Yeah, the docking process takes hours. They come in really slow, difference in velocity, and they just sort of inch their way in.
How long does it take the Falcon 9 to go up to 250 miles? Or does it go 250 miles up in the air?
24 hours.
24 hours. What's the top speed of the Falcon 9?
I don't know. The top
speed, I don't know. They bring it up to around 17,000 miles an hour.
Yeah, it's
The top speed, the max speed of a Falcon 9
Don't
is
know.
24,000. I'm telling
there
you.
is no
I'm about
top
to tell
speed.
you. Yes, there
no
is. The
top
max
speed.
speed. Their max speed of a Falcon 9 is 24,000 miles an hour.
Okay.
Yes.
That's not max. That's as fast as it's ever gone.
Okay, max speed. That is what's called max speed.
Go. There's no maximum speed.
So the top speed that it goes is the max speed, meaning
The top
the
speed
limits.
that's ever gone is the speed you're reading. There's
Okay,
no top speed.
so the max speed is his top speed.
Oh, there is no top speed, man.
I mean, I don't know how you're saying there's no top speed. I would say that there might be a top speed. It would depend on the maximum capacity for fuel and the thrust.
Yeah, if they keep adding fuel, then there's no reason they can't stop.
No, you can't. There's a physical, structural consideration. There's only so much space in there. You can only add so much fuel.
Well, yeah, so I'm saying you have to keep re-adding fuel.
Okay. So, like, if I went to space and I fueled it, yeah, I could go theoretically hundreds of thousands of miles an hour.
Like,
Coach, this video you posted, I don't see anything of it being constructed in space. I see a bunch of CGI and a bunch of stuff from the ground and junk, but I don't see anything of it actually being put in space.
Dude,
you gotta not look at the CGI stuff and look at the actual.
Hold on. So the max speed of the Falcon 9, the Falcon Heavy, sorry, it's 24,610 miles per hour.
Yeah, but that is assuming that it's fueled on the ground, and that's the speed you can get off of one. I think Kosho is saying that if you refueled it in space and you started going from 24,000, you could add another 24,000 plus of delta V.
That doesn't matter. The from here to say it reaches max speed in about, let's say, 10 minutes of it going up, or 5 minutes. You said it takes 24 hours, but so it at 24,000 miles, for 24,000 miles, 250 miles shouldn't take 24 hours.
No, you don't. Whatever you put into it, like let's say I'm trying to catch up with the ISS, and let's say I go 1,000 miles an hour. I'm way around the Earth, and I go 1,000 miles an hour faster than it. Now, when I get to it, I've got to bleed off that 1,000 miles an hour, which means that I've got to lose all that velocity. So what they do is they come in on an angle and they bring it into a lower orbit in order for it to overtake, and there's only a few miles an hour difference in their total velocity. And that's what takes a long time. If their initial intercept was 40 miles away, and they're coming in at 2 mile an hour, that's going to take 80
my question
80
to
hours.
Kosho. My question to Kosho was how long does it take the Falcon to reach 250 miles? You said 24 hours.
No, the Falcon doesn't take them up. You talking about the Dragon capsule?
Did I say Dragon capsule? It's
the
definitely
Dragon
not what I
capsule
said,
what
right?
takes what they dock with the ISS with.
It doesn't go.
Now you're just switching it.
Docking is a procedure that you perform, and they're going to follow a certain path to do it, a certain velocity difference. I think the Russians have the record time. I don't remember what that was, but it was only a couple of orbits.
How do you slow down in the vacuum of space?
For the rocket?
You turn around back and fire the rocket.
Acceleration works the same way both ways.
Really?
So
it has
you
nothing to
spin
push up?
around. So you spin around and go the other way, and you like teeter-totter like that.
Yeah, or you just don't travel that fast in the first place. If you're trying to catch up to the ISS, you don't go faster than it and then try to slow down to catch up with it.
You're definitely not going to come in at 1,000 miles an hour. That would be extremely expensive to bleed off all that speed.
Man. Crazy times, man. Crazy times, guys.
Did anybody see the F-50s race in Bahama over the weekend?
Okay, hold on. I just in reference to the previous conversation, Soyuz capsule did it in 3 hours. So about a little less than 3 orbits. That was the record pace.
I want to know.
You think it's possible to hit a bullet in flight?
Oof.
Why not?
Maybe.
What they do with airplanes all the time, they've got airplanes flying. Now, this is not a bullet.
I didn't say
it's a little bit slower, but what you got is you've got the fueling airplanes. They fly. They get with that plane within a couple of feet of its exact target that it needs to be in to get the net from that fueling cable connected. So, yeah, you can do it at any speed.
That's a plane. I'm saying a bullet in flight.
What's the difference?
Well, bullets aren't in the sky for very long.
Let's say if it has conservation of momentum, and you're in space and it's flying through
at the same rate. I don't know what would be wrong with that.
I mean, I can hand a beer to a guy in the car next to me.
Sure, we've done that.
And there's a hell of a lot more going on there. There's roads, there's bumps, there's wind.
Yeah.
I'm not gonna lie. I've seen two different eclipses now, and they don't look the same. One makes the moon red, and the other one just blocked out half of the moon. They didn't even look like at all similar in any way. It was the weirdest shit, dude.
I've only seen red. I don't know which one you're. Which one?
Explain that, but like one was just all red, and then the other one was just literally like a half moon, and then that half moon just disappeared over the course of half an hour. So like,
you must be on the coast.
Well, it kind of does both. Like lunar eclipses, like basically when you're before the lunar eclipse, you'll start to see this black thing, kind of enter it, and it starts coming in almost like it's going to be like a solar eclipse. Like it just starts coming in and blocking it, and then once it kind of gets almost to complete, it then turns red and glows red for quite a while, and then once it's going to sort of once it starts exiting, then that black thing starts being black again and exiting. So there's sort of like those three main phases of it.
Yeah, but he's saying that it turned black and it never had the red phase.
It always turns red. I mean, there's always the
No,
red.
I've never seen it
dude, I'm
otherwise.
telling you, Gio, I'm telling you, I've seen 2 of them now with my own eyes. It's not a video. It's not whatever. I literally was on my fucking dock for both of them. I go out. The first one was a couple months ago, and I shit you not, it just started at one edge, red, and the redness moved all the way to the top, and then the redness moved all the way to the bottom. It was only red. The one I seen yesterday, Gio, I just seen a half moon fucking come over the horizon, and it was black. It was not red. It was completely black. You could not see half the moon. And then over the course of half an hour, that black shit got lifted up, and then you could see that it was actually like a full moon. But the one I saw yesterday was not red in any way. You couldn't see the dark side at all.
There's an
I don't know what you saw, and then, I'd say that you probably didn't see anything unusual. So that's all I can say about it.
Yeah, there's an
Yeah,
illusion.
well, I watched it. I saw it start to finish, and the shadow started at the bottom and moved across. And once it was totally blacked out, then it became red, and it stayed that way throughout the eclipse. And then the bottom peaked out, and then the shadow moved on up from bottom to top. And shadow was on it. It was just black and lit. There wasn't red in it.
There's a huge difference between the brightness of the moon normally and when it's in the shadow. So when it's halfway lit, it gives you an illusion between like how bright one side is and how dark the other side is. I remember when Stanley did his footage in 2019 of that eclipse, and he was recording it. He didn't have his camera set up correctly, and if you don't have your camera set up and you're trying to film it, that's why you'll get fucked up shots, because they're you have the aperture. The aperture's trying to take in. It doesn't need to be open so it could take in the light of the moon. But then once there's a little bit of light, there's only a little bit of light on the moon. You gotta open it up some more.
Well, I'm not gonna lie. The first one I saw, when it was just like a redness, and the redness started at the bottom, moved to the top, and then went away. That one was like, when I watched it, I found it very interesting. Like, I was watching it and I was kind of mesmerized by it. But the one I seen yesterday kind of unsettled me. I don't know why. But half the moon was just gone. There was no redness for me, bro. It was all just dark. And it was only half the whole time. It went from half and then to full.
Well, from what was the level of I mean, I wonder if that has to do with your alignment position. You watched the whole thing?
Yeah. Well, the thing is, it came over the horizon already a crescent. Like,
right, so you missed the beginning.
It looked slightly waned past half, basically.
Yeah, you're on the West Coast.
I'm in Hawaii.
Yeah, you're then. Yeah, that's about right.
So I mean, this was a total yesterday. No, it started out like little over half. It started out little over half, and then went from little over half down to just a full moon, basically.
No, I know, but I'm saying that this was not a partial eclipse. This was a total.
Yeah, so total for some people.
It sounds like what happened.
It was definitely partial for me, dude. I don't know. People could say whatever, but it was definitely partial for me, because I literally seen it come over the horizon, and I watched it literally go from like a crescent, it was basically half, slightly over half, all the way to like slightly over half blocked out, to going to a full moon, nothing blocked out, in the span of like half an hour, maybe 40 minutes.
So did you catch the end of it then?
Excuse me?
Is that because you caught the end of it?
I'm not sure if it's the end of it when it came over the horizon where I'm here. That could be it. I don't know. I'm not theorizing. I'm just giving you what I actually seen and witnessed it.
My understanding is that every lunar eclipse turns red. Does anyone else say that that's not the case, like Kosho or anyone else?
Yeah, it went red at like 11:30 for me last.
But I've never heard of a lunar eclipse that doesn't go red. Has anyone else?
Yeah, it went red for
Mine
me.
wasn't. Mine was it, bro. I swear to God, it was a
That's only
black.
if you're in the path of the total eclipse.
Well, yeah, it sounds like that you probably just witnessed it at the times where it was when it was entering into the Umbra and exiting the Umbra. Because that'll happen. That's what I'm saying. That'll happen when during those times you don't see the red, not much of it, but you do see a stark contrast between the light and the dark. A lot of times the light, the part that's lit up, will completely outshine the rest of the moon, and you can get that effect. So if you only catch a glimpse of it for that time only, I could see thinking it was like a different phase.
Yeah, because it lasts pretty long. It's like, I mean, there's different time periods of how long they last, but
yeah, it was like an hour, almost an hour and a half.
Yeah, I saw one that was like an hour and 45 once. It was incredibly long, and it was just hanging there red. It was interesting. Like the environment was like the most quiet I've ever heard. It was like absolutely silent, just like all the wildlife. It was amazing. Yeah, I saw it where I'm at. It didn't. The moon didn't rise until sort of after the eclipse, I think. So I really didn't.
So you should have been listening to Stellar Million Eclipse too. Then, let's say wherever you guys were, where it was rising right then, you should have been right. I mean, I basically saw one because it didn't start yet, but it was out. It was kind of starting, like it was entering into the penumbra, and the sun was still out. But yeah, if I guess most of us could have seen a Stellar eclipse last night.
Yeah, my half blocked out moon was in the sky at the same time the sun was. It was about sunset when it was occurring, and there you just seen like it was like, it might have been a little bit after sunset actually. I'm not sure if I think the sun was definitely in the sky, but you just seen like a half moon just rising, like the biggest half moon ever, and then like you see the sunset, and then you just see that like fucking half an hour later, and then it's a full moon all of a sudden. I was like, wait a minute. Because it was like we were looking at it and we were like on the beach saying like, oh shit, like that half moon is so fucking huge. You know what I mean? That's why I fucking realized. Because then we drove somewhere else and then we're fucking, I look up, it's half an hour later and it was a full moon. I was like, nah, shit me not. I just seen it was half. And then I asked my friends and they were like, yeah, bro, it was half. We all seen it.
Yeah, you must have seen the end of it. I'm watching this little animation here. Yeah, if you're in Hawaii, this is just from timeanddate.com, but yeah, you would have seen the end of it. You wouldn't have seen the redness. I think that's why you missed the redness.
Well, don't you get redness coming in and going out?
It started at like 10:45 on the East Coast, and then at like 11:30 on the East, that's when it went red, and then it finished around like midnight, 12:15, somewhere in that time frame. So whatever time he was watching, correlated, his time zone correlated to that.
Yeah, I think it's just standard Hawaii time or something, HST or something like that.
Well, that one I just posted, the time of date. If you scroll down like halfway where it says eclipse map and animation, if you click that, then it would show how when you were in Hawaii, they're like, it was red when it was like right above sort of South America, and then some people in the United States could have been able to see it red, but then by the time it hit Hawaii, boom, it was on the end phase. So that's why you probably just saw the blackness that was exiting the moon, and then you just saw the full moon.
Yeah, bro, it was pretty freaky because it was like we were literally like commenting on it at the beach, saying how big the fucking moon was, like how big the half kind of like crescent moon was. And it was like half an hour later, and we look up and it's like, wait a minute, and hold up, like this.
When we're in this conversation, it drives me nuts when people say it was big. Angular size of moon is the same almost every day, give or take, a couple percent. Doesn't matter whether it's near the horizon, whether it's in the middle of the sky. It's always the same size if you measure it.
What's the angular size of the moon?
Okay, wait.
Roughly 0.52 degrees, at least from what I just searched up. Because
degrees. I'm going to find something in my house that is 0.52 degrees.
0.32.
Give me a second.
Or 5.2, yeah.
Yeah, I'm going to be honest with you. The moon looks smaller when it's above you. And it looks
Wait, hang
like
on.
it's
You could use. I could use a.
smaller.
My bad, Noah. You could use a protractor, right, to get 0.52 degrees with an object, right? That's near you.
Kind of.
Yep.
Essentially.
Okay,
yeah.
so how does that tell you how far the moon is away?
It's no, because that's different. We're talking about angular size, all right? That's
okay. So, but my object. Okay, so I have a speaker here, right? And I get the angular size of 0.52, right? And is that the same size as the moon?
No, you need to divide your sphere. Let's call it a sphere of vision, all right? Let's for the sake of this fucking thing, right? You need to divide your sphere of vision by 360 parts, all right? That's how you get the angular degrees, all right? And then from there you can divide into like I think seconds and shit like that. But that you need it. Yeah, it needs to be your quote unquote sphere of vision, all right? You need to divide that in 360 parts. So whatever you're doing with the protractor, that's fucking wrong, all right?
So what you're doing is do you add a presupposition of the speed or the distance of the moon?
What?
Usually we give what are you trying to find out? Like if we know the size of the moon, then we can take the angular size.
I see.
If you
I see what
know
you're
the
doing.
distance, you can tell what angular size it should be.
Oh, yeah, I see what you're doing.
If you know where it's moving above, if it's directly above two places, is moving away from you, then if it's close, you should be able to tell what the angular size should change to.
The trusty old combination of the reification fallacy along with begging the question works every time.
Right.
At least they
Got
think it
him,
works every time.
Got him.
Yeah, this thing that works for everything else just doesn't work for the moon.
I mean,
it just works in their mind every time. It has to be true. It just has to be.
But what I just said is plainly it's a fact. I made a chart to show what would happen based on how high you think it is. But if you know the sublunar point at any 2 points in time, and you can play around with how high you think the moon is, and then you can determine how small it should be. It should be changing as it's moving away from you.
I have a question. What exactly, like, I hear a lot of claims that, like, all the models are based on a flat Earth when flying planes and shit like that. What exactly, other than, like, fake space NASA, uses these, like, globe speed and measurements? I don't get it. It seems like all the maps that I use are flat. Like, every single one of them. I've never used a globe map. I've only used flat maps my whole life.
Have you ever used Google Maps?
Yep.
That's not a flat map.
It is. When I'm looking at it, I'm looking at a flat screen, and it's projecting a flat map, and I'm looking directly at a flat map of the street.
Is there a key in the corner?
You're talking about the one, Kosher, you're talking about the one that goes off Google Earth that has no elevation and it uses a flat baseline to give you the elevation, that one?
Yeah, that's the one. If you look at the corner, the legend, it'll show you the distances that the little line is representing. It'll be like 20 miles, 50 miles, whatever. And as you go north and south, just scrolling, not changing the zoom or anything, that legend will change because the map is actually distorted, and it's distorting it. It's distorting it in real. I mean, it's changing it in real time. That's why the legend.
No, I understand the theory, but what's the difference between that and just a database collection of different flat maps of the area?
That's not a theory.
That's all it's
bro.
doing. It's
When you
different-
physically
it's just
change
different
it,
flat
it changes.
It's just giving you different flat maps, but they're organized in a sphere, but it's all flat maps.
You're gonna have to show that. But go ahead, Coach.
No, I'm not going to have to show
yeah,
that because that's what
that's
appears
clear.
on my screen. My screen is flat. The map that appears is flat. It is only projecting flat maps to my screen. I don't have to show it. That's just the reality of what pulls up when I use it.
Well, I say it's a projection of a globe. It's just showing you
Well, I say
projection
I'm
of the
looking
globe
directly
on
at
the
a flat
screen.
map.
I don't have to. That's just how it is. We
There's
can both
one
do
map
that,
Directly
right?
at a flat map, dude. It's a
But
flat map.
There's
Every
one
ahead,
map
time.
that's
Crystal,
accurate.
rather than
God
having
No
a
matter
damn.
what
split
you, no matter
argument.
what you claim it's a projection of, it's always a flat map.
There is one map that's not flat, and it's the only map anywhere that actually is 100% accurate, and it's called the globe. You take a classroom globe, you take a measurement on any continent, any direction, and you will get accurate distances
Yeah, because you curve
between
those lines.
continents.
Yeah,
It
wait.
doesn't matter. You
Wait.
will get
My
accurate
question,
distance.
my
Get it to
question
work
is,
on a
then why
flat
am I using
surface.
a flat map to navigate everywhere at all times?
Use a globe. You could use a globe, and a globe will work easier.
Well,
It
why don't
just
you
doesn't
use
have
a
the
flat
resolution.
map and why don't you use a flat map and curve those lines like you do on the globe? You curve those lines above the surface.
So wait, use a flat map and curve those lines
Yep.
like a globe. That's what you're
Yep.
telling us to do.
Yep.
Yeah,
Well,
I mean, it's
that's
kind
how
of
jet
interesting.
streams are.
Yeah, like if you go to the Wikipedia page for map projections, it's kind of amazing. Basically, they're just taking the AE map. The AE map is all over this page, and they're just contorting it and twisting it with all these different projections. If that's not a giveaway, it's pretty obvious.
Except for the fact that the AE map doesn't give one fucking accurate prediction, except for the time.
Then why are they using it to make all of their globe projections?
Because
They're
they
not.
don't, man. It's a little
That's
more
exactly
clear
what they're doing.
what
Take a look at these images.
Wikipedia
Every
shows you.
single one takes an AE map and they're contorting it. Here's the genomic one, the stereographic, Twilight, James. They're all coming off the AE map.
Nice.
Well, are they saying that they're getting the AMAP to as a source image to make those projections? I don't think that's the case.
Yeah, cartographers don't just look at the AE, make a new map. That's
Yeah,
I
I'm
mean,
not saying that this page says that the Earth is a planar AE map type thing. That's obviously not what they're doing. But clearly, I mean, that's not what they're saying. But clearly, that's what they're doing.
No.
Well,
Why do you say
why do
clearly
you
that's
think
what
that?
they're doing?
Funny how you draw that conclusion, because the exact opposite is true for me.
I mean, they're saying
That
the
was very
opposite. They're showing
aggressive.
the opposite.
That was a very aggressive opposite there.
Right. They've done the opposite. They're trying to say Earth is a globe, and then it doesn't fit onto this plane. Therefore, we have to contort it and twist it. And so, yeah, they've definitely done the opposite, as you just accentuated.
We understand the
Take any
claim.
flat map of the entire world, any flat map of the entire world that gives accurate numbers uniformly across it. Any
You need the correct one.
flat map. Give me any flat map that gives me accurate numbers across the entire globe.
Accurate numbers to
That's
what?
the entire.
Something that you've been given? You're going to compare that to the globe that you've been given and you think is right?
Isn't his challenge kind of begging the question? Because he just asked for a flat map that goes across a globe.
I corrected that. I said
the
that.
question of the globe and asking us for a
No,
flat
Geo
map.
said it perfectly. You just didn't let him finish.
They did say it great. Yo, go ahead, Gio.
Geo said it perfectly. You just talked all over him at the end. That's all.
Yeah, say that again, Gio.
Well, now I kind of forget what I was saying, but yeah.
That happens, yeah. But that was great.
But I did get cut off.
You were asking accurate compared to what? I think that's what's your
accurate
Oh,
compared
yeah,
to
yeah. Well,
experience.
when Moyak cut me off, I think that's what I was saying. Yeah, is that if you're okay, in a sense, Moyak, I'm not criticizing you for this. I'm just saying you're a dude chilling and you're at home on your computer, meaning you haven't gone around the entire Earth and measured and done everything. So you're not really comparing anything to the Earth. You're comparing things to a globe that you were given and then saying, oh, this doesn't work and that doesn't work. But you're not actually comparing that to the Earth. You're comparing it to the model that you're given.
No, that's wrong.
No, dude.
I haven't been all around the Earth, but everything that I've done so far comports with it. And then taking the extended civilian people who've traveled around the world, they are in keeping with the globe, where they go and they travel from point A to point B, and they know that it's X miles to England and X miles to Spain and X miles to Australia. This is all one guy. And he didn't get any surprises where it was twice the distance he was expecting.
Yeah.
Really?
Go ahead.
So their GPS is now working on 747s over the ocean on phones. How do you track that?
How do you track that?
Yeah.
I mean,
because I know, as far as I'm aware of that, I don't know if they changed it, but it used to be where GPS didn't work in the Tropic of Capricorn.
I know of no place on Earth where it doesn't work. I think that it had spotty coverage on the poles for a while. I didn't hear anything in the tropics.
I mean, I live in the Tropic of Capricorn. It works fine here.
Oh, GPS on airplanes?
Yeah, I mean,
hold on.
even
He's saying, hold on. He's saying that it drops off of the flight trackers. That has nothing to do with GPS. They have GPS. The people on that airplane do not go and say, "Oh shit, I don't know where I am." No, they have GPS the whole time. They don't transmit it through the telemetry system. They call it radar. Some people call it radar. They don't transmit it because they get outside the range of the continental radar systems. They're moving to a satellite system, and you will be very soon getting it all the time.
Right. I'm specifically talking about like the pilots and whatnot. I'm talking about like the
So
my
can I try to understand this? Is that basically the guys on the plane are not tracked by the radar of the land? Like the people on the land can't see them with their radar, so they don't really connect to the continent's radar. But there's satellites above them which are tracking them instead when they're over the ocean. Is that what you're trying to say?
No, the satellites don't track at all. At least the current system doesn't track at all. And in fact, the future system isn't going to track either. What it'll do is you will have your GPS telemetry will be sent to the satellite. The satellite's not determining your location in either case. The GPS just sends out a signal. It's a very simple system. It sends out a signal. You know where the satellites are. You calculate your position. The satellites never know who's looking because it's a one-way system.
All right. Well, here's what I would say. The only thing with that, you are told where the satellites are. That's the difference in what you are told that, and then you assume that that's true.
No, mathematically, that's what the numbers say.
I know, but that's
when
just
you look
a
at
mathematical
the
calculation. Like, for example, I could put up 15,000 balloons. I'm not saying me personally, but you could put up a whole bunch of balloons that are all sending signals. You could then make that. You could hold on. Let me just finish what I'm saying. You can speak after. Just let me speak. So I'm just saying, you can put up a whole bunch of balloons up there. You could then be sending signals to the ground. You can then spoof the system in like a simulation to build a network of what they want to tell you. Oh, you're getting it from this satellite. You're getting it from that satellite. That part you're being told. And then just because the math works does not mean that actually is what you're shooting at. You're just getting signals and then aligning them to a system that they give you.
No, but there are two possibilities from there.
Where it was at.
I mean, if that was the case,
you don't know where it's at. You're just getting signals and being told where it's at.
If that was the case, like either the algorithm would have to be different, right? Because if the balloons, I mean, either the balloons are given the correct position where they are, and you're just have to look to the signal you're getting and see that they're very close to Earth, or they would give you the wrong position that they are to appear like they're satellites. But then you have to use different math to still get your correct position. You can't have both of them, right? Either you change the math.
Yeah, go ahead.
Oh, sorry. Either you have to change the math and the algorithms, or you would just spot that the satellites are actually very close.
It is
my original point, though, is that you're being given the data. Like if I take a GPS receiver and I receive a signal, I'm getting a signal. If that signal also says, "Oh, this is coming from there," that doesn't mean it actually is coming from there. And just because they claim that it is, and then give you a whole system, that's how they're deceiving you.
You could spoof one person. You could not spoof the world. You could spoof one person.
You could spoof as many as you need to. You're building a simulation, and you're building a network by which you are telling the people where the signal's coming from, and you're telling them where those are located.
Hold on, Gio. You're just so wrong in this. I don't even know where to start, but it gives everybody, every swinging dick on Earth gets the same almanac message, gets the same position for those satellites. You can go and verify it across different receivers all around the globe. They get the exact same list of satellites. Their exact
Yeah.
coordinates down to the millimeter.
I'm familiar with that. That does not mean that you're actually communicating with that satellite. You're being given information that correlates the way that they want it to correlate.
I only have 30 choices. In that database, I've only got 30 choices of locations.
And I'm
And
trying to think of like an analogy. Like let's say you're in a room with like 30 people and you're on the other side of the room and they're on the other side of the room and they're all singing. They're all singing, you know, they're all singing at once. And then you receive, you have a little receiver that receives, you know, the voices or whatever. And then the receiver says, oh yeah, that one's coming from there, or that one's coming from there. But in reality, it's just a wall of people singing. And you think that, oh yeah, it's coming from that person's voice. And if I move over here, it's coming from that person's voice. But that system of singing people, that's the one that's telling you where those positions are. If you don't see how they could deceive and fudge that and spoof that, I mean,
the receiver doesn't tell you the receiver doesn't tell you where the satellite is. It's on the satellite signal where it is. So everyone that gets the signal of that satellite is going to get the same position.
Yes, the signals that you're receiving are telling you the position. I didn't say that the receiver is telling you that. Yes, I understand exactly how it works. I've set up, you know, TV systems and where you have to aim, you have to, you know, have satellite internet and stuff where, you know, I totally understand that they're, and this is how people think that they're in space or whatever is, oh yeah, it's, you know, aiming at that satellite. But at the end of the day, you don't have a way to verify that you are actually getting a signal from that single device. You're just getting a signal from a wall of signals, and then you're assuming that that's what it is.
But now you've got this thing where I've got this signal. I've got the satellite position. I've got 30 of them given to me in a database. Now, beyond that, the system has to spoof to me to tell me that I'm wherever the hell I am on Earth. Now, I have a GPS receiver. I know it's a one-way device. I have a spectrum analyzer. I can see nothing's being transmitted from it. How does this satellite determine my location to send me false information in order to make it work?
I mean, if I get 4 people in a room, each one has their different smartphones. Is like the balloon sending a different signal to each smartphone? I mean, how one smartphone isn't picking up the signal that the other one is receiving?
Well, there's several ways it can be done, and since I'm not behind the control panel of how they're doing it, it would not be possible for me, other than if I used like psychic capacities to do it. But it would not be possible for me to know exactly. But there's several ways that it can be done. One way is to have one way is to have it in different zones. So depending on what zone you're in, you're going to get certain information. There's multiple ways to do it.
That might work for a hemisphere, but then you're going to have all sorts of inaccurate numbers for all the people who are on the left side of you than on the right side of you. The system is accurate, and it gives you the same information from the same satellites, verifiably.
What if there was a computer model set up to simulate exactly where all those satellites would be? And
exactly.
They have the balloons configured so that they can give you the data with one balloon as far as like, you know, a general area, and then it's all just computerized. We're in that age now where they could just do a complete simulation of what's supposed to be, and then the balloons aid in giving you the impression that it's coming from up there, but everyone's getting that same signal because the computer blip that you would be honed in on if you were trying to locate it at that certain place, it just sends it straight to that little key that they have that represents that satellite, and then everyone gets the same information straight from the computer system.
In order for that to match the signal and the timings they would get from satellites in space, the balloons will have to send a different signal to each GPS receiver. That's like undoable. That's just not like.
Well, I'm just saying that. Okay, so what's the data that you're getting from the satellite?
Time
that convinces you it's up there.
Yeah, you cross the time between them, and the signal themselves have their coordinates, and then you try to rate their position.
And they're giving you all that. Yeah, they're giving you all that.
Yeah, but
They give you
that's not the argument. Like, I'm not saying you should take that as true or you should accept that that value is correct. That's not my argument. The argument is for that to match satellites in orbiting the Earth from space. You can't do that with balloons sending like a single signal, because that would change the value of the trilateration that you're doing. So in order for them to still match the signals from satellite from space, they'll have to give a different signal for each observer on the surface.
No, or they have multiple.
Wait. Go ahead.
No, go ahead. No, you can go ahead. I was just gonna say, I mean, it's similar to like a Wi-Fi router essentially, or like an extender, where you can get one signal from a particular like Wi-Fi router, let's say, and then it sends to the extender, and then from the extender it sends out. So like you're getting the signal from the extender, but in reality the extender is actually coming from the router in the first place, and the extender can be in a different position than the router. But anyways, go ahead, Noah.
Yeah, I was just gonna say this. No, it's my turn, sir. I was just gonna say this is directly analogous to like the stars positions. Like if you think about it, say you have some sort of on a flat Earth, you have the flat plane, the flat star plane above, but it appears to curve around you in a dome like fashion. Well, right below that starry, I guess plane, there would be a plane of, I guess, man-made satellites that are, I don't know, quantum locking or whatever theory you want to give for why they're up there at these speeds. And this plane would also appear to curve around you like a dome, just like the stars would on a flat Earth, I think. So I believe it's a directly analogous problem, or I guess contention point in the flat Earth model, or I guess explanation.
That's funny.
But there's a difference. Like when you're talking about GPS, you have like the timing is crucial, and it makes a lot of difference. Like what is it? 38 nanoseconds or microseconds can make like 11 kilometers of difference.
You know, it's not even
like it doesn't map very well. I mean,
it's
just
8 microseconds per mile.
Just picture there are two people, and there is like a balloon in the middle of them, which is sending the signal that they're receiving as if it was the satellite, right? And that balloon is, let's say, pretending to be a satellite that is in the same position but way higher. In order for those two people to get the signal at the same time that they would get from the satellite, the balloon has to wait a little more to send the signal because it's way closer to them. But if there are people that are away from each other, that same balloon have to send the signal earlier for those two other people for those people to get the same timing of the satellite. Now it can satisfy both of them. It can either satisfy the ones that are close to the balloons or the ones that are further to the balloon. It can make both of them.
Well, however they have it worked out, maybe they know if the signal comes at this angle, right? They know that from this angle, the satellite should be at this point. So
they don't know the angle.
It's going to be interactive from whatever location,
they
right?
Don't know the angle.
If someone's trying to locate it from a certain location, right? They would know where that location is through their simulation and know what type of signal to send back, and it all could be simulated as if it's happening, but not really happening.
Right.
There's a more crucial point here.
I just like to say that, Bacon, that's like still directly analogous to the stars in that we have like astronomers measuring like quasars and black holes fucking colliding and shit and all this shit, and they all have to triangulate at the same point. That is all exactly analogous in the stars to where the satellites are in this satellite problem with the GPS. In that if you have a flat plane of stars above, it's the exact same problem with all these events that only happen in particular points of time, is the exact same problem as what you laid out in your satellite issue. So it's the same deal.
Yeah, there's an issue that because even though Bacon has a good point what he said, that would make it impossible. The way that makes it absolutely impossible is if you actually know the nature of the signals that they're sending, the actual signals that they're sending, other than the timing, there's specific there's specific channels and wavelengths. So if you're not going to be able to send that out from two different balloons somehow, and have the exact same unique message. sent to some other place to represent 2 different places to represent a time.
Right, but Kosho, that's not what I'm saying. I'm saying
I wasn't responding to what you were saying. I was responding to the topic in total. That if you guys know that if you guys actually get access to this raw signals that these satellites are sending off, it's a direct indicator that there's only 30 of them, just as they say, and they can't be 50 million or however many think there are.
Right, that's not what I'm saying, though. I'm not saying there's 50 million. I'm just saying this problem is directly analogous to the star problem. Obviously, there's no claim in the flat Earth that there's 7 different Sirius stars, and you're only looking at one each at a time. I'm just saying that it is the same exact geometric problem as the stars is as the fucking satellites.
If you don't want to look at the actual numbers, yeah, you could say that. But when you start looking at the actual numbers, that we're seeing, something in the order of, 30,000 miles, depending on where it is in the orbit around you, 30,000 kilometers, right? I can forget the exact number, but it is a number akin to that. And stars don't move at the same rate with regard to the background. The satellites are moving much faster with regard to the background. They're on a curved surface, but all the numbers reflect a much closer curved surface than the stars.
I don't see how saying that this is analogous to position of
and
stars solves the problem.
You could argue that the plane of satellites is much closer to the surface than the plane of stars. Just like you said, the curved surface of the stars is much further than the surface of where the satellites are. It's directly analogous. It's the direct analogy. Stars are to satellites, basically, because they're both doing the same thing in this. Say, like from a flat Earth perspective, I'm saying. I'm not saying from a round Earth perspective. But it's the same problem. You're not bringing up something new.
From a flat Earth perspective, there's no mechanism for it to even work. Because all the numbers be vastly different. Yeah. But if you see the distance of 30,000 miles or whatever, something akin to that, I have a hard time disproving you. But if you don't see that, then the numbers are on a different astronomical plane if it's only 3,000 miles or 300 miles or 300,000 feet.
Anyway, I don't.
And you could say the same for the. You could say the same for the plane of the stars. Then you could say they're astronomically further than the plane of the satellites. See what you're doing? You keep giving examples, but these examples are directly analogous. So it's like, unless you're gonna prove how the stars are only possible on a round Earth, then it's the same problem as proving that satellites are only possible on a round Earth. It's the same exact issue. It's the same exact mathematical problem.
Well, the stars don't send off signals that have codes in them that are timed. So
don't
they're
they?
not the
Don't
same
they? When
timing.
you have a quasar, isn't that a different signal?
Yeah, but
Isn't it when the 2 black holes collide? Isn't that a different signal? Aren't there events in space that happen all the time that only happen once? There's different supernova. Isn't that a particular signal?
No.
Isn't that unique? Oh, that's not.
No, the actual.
That's not the point.
Yeah.
That's not how. I mean, no one's arguing that the stars only work on a globe or arguing that because of supernovas, right? I mean, saying that this is analogous to the stars and how it can also be
you haven't shown anything that's not analogous. Each thing that you've shown so far,
I think I did. Let me.
It is analogous.
Well, how is my example of the? How can a flat Earth solve the example of a satellite being way higher than a balloon and the balloon trying to pretend to be that satellite? I presented a problem why that.
How do you know how far these balloons can go?
Right, because you're being given the timing, so that is the part that could be spoofed. You're believing the timing and believing the simulation system, but you're not able to verify that. So you're just going off of something that you're given, sort of like being catfished. When someone puts a picture online that isn't really them, and then you believe it's them, and you're looking at the picture, you're like, oh look, this is a a woman or whatever, but really it's some 60-year-old guy behind the computer.
Well, you completely missed the argument then. I didn't rely on the data from the satellite being correct. Again, it just isn't mappable. Like you can't just map it back to the balloon if it's actually a balloon. For the timing isn't something that the satellite's giving. The timing is something that you are doing yourself. Satellites don't give you the time you're receiving it. They just send the time that they're sending it, and that time is going to be the same for everyone that captures that same signal, and that kind of prevents them from being wherever they want. Because you can, the same way you can use the distance to satellites where you know the position to find your position, you can do it backwards. If you get different people that have the same signal for the same source, and you know where they are, you can now find the position of the satellite. It can't.
Bacon. How is that different from celestial navigation? That sounds fundamentally like celestial navigation, just using a different plane or sphere. Instead of using the sphere or plane of the stars, using the sphere or plane of the satellites. It just sounds directly analogous to celestial navigation to me.
Because with stars, you don't know how far they are, right? The distance to the stars is irrelevant. The only thing relevant is that they are far enough that there's no parallax. And with satellites and balloons, that's not the case. If they were as far, so far that the signal gets to everyone at the same time, there would be no way to find your position. What gives you your position is the fact that there's a delay between signals, so you can actually.
I get it.
Just to make sure that if it was two halves of a celestial sphere above, and they had these quote unquote satellites, but not in space, just circling around up there somehow.
Technology with drone technology or whatever, that's possible that they could have something up there that's representing the satellites too. It doesn't have to necessarily be things, right?
That can travel for 20 years.
That's what I'm saying, dude. Fucking cars don't even fucking go for 20. Like, the cars get shitty. Yeah, fucking over 20 years. These fucking things that are up in the sky are definitely not the same technology they give to us. For sure not. Are you claiming that
it's not driving? It's in orbit.
Oh, that's
fantastic. It has to use its fuel like once every.
Dude, the technology used on that shit is way different from the fucking shit we use everyday life. And for you to say, like, what makes it orbit for so long, you have no fucking idea what they use on their ships.
Orbit.
Well, I know they claim that the
motion.
You're trying to claim you know what NASA's doing now?
I know they claim that when they do like circuitry, they'll use tin to make them last longer and they won't use that in like commercial products on Earth. Something about tin is not good or something.
10? I don't know about 10. I've heard usually 3 or 4 redundant systems.
No, like when they're making circuits and shit, they use tin instead of whatever they use for the solder or whatever. I don't know.
Oh, tin. Which is 10. I don't know that would make that much of a difference, but I'm guessing whatever they think is right.
Tin is very useful.
I mean, let's face it, they're not going to build these things using the same planned obsolescence they use here on Earth, right?
I don't know. My computer lasts.
Want those things.
My computer's going on 10 years right now.
Did you guys know that radio waves don't work underwater?
Only very low frequency.
Actually incorrect. I already got all the citations you need. You ready for them? They actually don't work.
Okay.
Now you can use sonar, which is pulses. That's sound.
ELF is used at low. Now that might be technically sonar because it's in the ELF, extremely low frequency.
Yeah, but it's sound.
Yeah, you can call it still radio waves.
Boom, boom. So EMF signals cannot work
EL.
underwater. Isn't it amazing though?
Oh, okay.
So it does beg the question because, mainstream science has it that there's over 400 trillion gallons of water in outer space. The sun shoots out water. There's just water everywhere up there.
We can send radio waves through water and
Okay, I'll give you citations then. Dang, why you guys
Water,
don't know
so
this?
it won't go through water vapor? You're telling me it won't go through water vapor? That's interesting.
in NMR, you can put water in an NMR spectrometer.
It says right here, radio waves can penetrate non-conductive materials such as wood, bricks, and concrete.
give you the
They
spectrum.
cannot pass through electrical conductors such as water or metals. So you're telling
So
them
what does
they're
that
liars?
say about water vapor?
Are they liars?
What does that say about water vapor?
Who's telling the truth?
What does that say about water vapor?
So if
I
I
said
surround
water.
So if
Okay,
I surround my
don't-
phone,
don't red
if
hair
I
away
surround
from
my
it.
phone with water, it won't have any signal anymore, right?
Yeah, it won't penetrate it, according to what I have looked into.
Right. Well, let me test it. Be right back.
Here's a spectrum of
You're still up
an
there?
NMR.
And
Please
it's also
explain how
completely-
NMR works, sir.
It says right here, I'll give you the citations. It says, but radio signals do not work underwater. I'll give you that.
Yeah, I don't have. I really depends on what you call a radio signal because sonar is not. No, you can use the ELF. I'm sorry, they're wrong. That citation is wrong.
They're wrong.
Yes, citation is wrong.
I believe
It's
somebody
not,
on Discord over that, right?
Well, you can go look it up. Look up ELF.
Already did. It's a pulse.
Okay.
It's sound.
Yes. No.
But they have a
ELF
hard
is
time
not
doing it. I'm
sound.
going to give you that one too as well.
It is not sound. It is recovered with with an antenna, a multi-mile long antenna.
Or
They drag them behind submarines. Problem is they have shit for bandwidth. And how the emergency action messages come in.
So I have it right here, the one I posted. Today, underwater sensors cannot share data with those on land, as both use different wireless signals that only work in their representative mediums. Radio signals that travel through air drive very rapidly in water.
Yeah, dude,
And
that's what Jason Moyaka just said.
Here's water again, NMR spectrum.
Okay, you seem to be ignoring what's being said, so I'm going to just
Yeah.
stop talking to you.
It's what you've just read out loud. Disagree with what Moyaka just said.
So the question
it's
is, can
ridiculous.
radio bounce off water? Radio waves, can these
It doesn't say that. It doesn't say it can't.
No,
do
I'm
that,
asking
dude.
you, can it bounce off? Can it bounce off metal?
It definitely bounces off metal. That's
So
how
why
they
wouldn't it
find
bounce
you.
off water?
You're talking about a big
Water's
range of wavelengths.
100% radar. 100% bounces off of metal. That's how you don't get lost at sea. You put this fucking metal ball on the top of your mast.
It all depends on the size of the wavelengths, which is what your thing you're just reading says too. That
Bro,
there's
I'm telling
certain
you.
wavelengths that are going to work
I'm
underwater.
telling you.
And certain wavelengths that are used above
I'm
water.
telling you,
and
when
they're
you
not-
go out on the high seas in a fucking sailboat, you put this metal ball on the top of your mast so the fuckers can find you using radar, or else you'll be invisible
That's
to
so
them.
they can see
You could just
you,
you could just get lost and sink and die.
Well, it's not about being lost. It's about them being able to find you and being able to not crash into you.
Exactly.
I don't know what's the point of all this.
I know.
Well, because it begs the question: the emission of light or electromagnetic frequencies, if you will, or radio radar. The duration from up to down, is it hitting water? Because there is water up there.
It doesn't say that it doesn't work. It says that there's just two different.
It
two
does
different wavelengths.
say it doesn't work through
No, it
water.
doesn't say it. It says specifically.
Man,
that they have
Kosha,
to use
you're a
different
liar, dude.
wavelength
You're a liar. You're
communication.
full. You're full.
You
I
just
just gave
you read it out loud. You just read it. You just said that they have two
don't
different sets of
call it a
wavelengths.
liar.
All right, chemists do a method called NMR. Basically, the chemist version of an MRI machine. which your body has a lot. Now, MRI machines still work, so obviously what you're saying isn't true. But they send radio photons at the sample. And that sample can be water or it can be dissolved in water. And the radio waves will go through it. 300 megahertz, 400, 500, 600, 700, 800, 900 megahertz. I think that about 1,000 is the highest megahertz one that I've ever used.
So why does it say right here? Because and I'll give you the citation to it. Because high frequency signals have electricity of large bandwidth (BW). At short distance, high frequencies EM signals cannot penetrate and propagate deep in underwater environments. So
Did you hear
can,
the first word you said was high frequency?
But they
High
can and they
frequency.
can't. They
You
can
gotta
or they
pay
can't.
attention. Pay attention.
No, you pay attention. You
High
pay attention. They
frequency.
can or they
High
can't.
frequency cannot. High frequency
It
cannot.
also
High
says
Aren't
deep.
these high? Aren't these high frequencies
Don,
the ones they sing the signals to the satellites?
It also says deep.
Don. I think what they're trying to say is that the radio there's like radio is like a band. There's different frequencies of radios. Some of the radio frequency are higher frequency, some are lower. The higher frequency ones can't go through water, I believe, is what they're saying, and those are the ones you are reading about in the articles. But the lower frequency ones can, and I think that's what they're claiming.
It says
if I'm wrong, tell me if I'm wrong, Globers.
It says deep as well. That's a key detail. It's talking about penetrating deep into the water, right? So when people say that the sun has enough energy to form the bond between two hydrogens and an oxygen to make a water molecule, it's not saying that there's an ocean of water that the sun is putting out in between us, like the Earth's ocean, all densely, packed together in space. Right?
Okay,
That's not what people are saying.
Right. So doesn't satellites use high frequencies to pass through the ionosphere? Beyond like 500 megahertz?
Ocean of water.
Oh, there's a lot. Over 400 trillion.
ocean
There's
of
more that the
water.
mainstream actually was wrong on how much they thought that was up there. Do you know how much is up there?
Telling me there's an ocean of water.
There's a lot of water up there. 400. There's actually a star shooting out water bullets the size of the Amazon River per second.
A star.
Yes.
It's nowhere near the sun.
Per second. How much water would that be? Do you know?
The dishonesty.
Dishonesty.
Yeah, man.
There is. Okay, I'll give you that too as well if you want that.
Do you even believe in outer space, Don?
I believe it's water.
Painful.
That's
water,
isn't it? All water.
It's mostly water.
It's a water world.
Remind me if I'm wrong, or let me know if I'm wrong, Jace. But water is the most abundant molecule or compound in the universe. But
pretty sure hydrogen is the most common element. They say it's like 98% of the fucking shit is hydrogen or some shit, and that's like directly water when you add oxygen to it.
That's probably why you hear what I said. I said compound. It's an element.
Well, technically,
I'm backing up your statement, Kosho. Calm down. Fuck. I'm just adding a fucking side comment. Jesus. I'm not disagreeing with you. Fuck.
Just typically, just do it when people are done. Like, do it when I'm finished talking.
Technically, H2 is a compound. It's 2 hydrogen atoms, so it's a molecule. And that would be the most abundant thing that's in the universe, yes. Water would probably be in close contention with helium. Like, I don't know the numbers right off the top of my head, but I'm sure it's up there.
The other thing is if I put 100 gallons of water in a room and vaporize it inside of a warehouse, that is not the exact same as having a wall of 100 gallons of water in front of you.
Yeah, that citation it was talking about high frequencies going deep into liquid water, like underwater.
And we don't have liquid water in the atmosphere typically. The rain clouds and stuff, and those can affect radio.
But I'm pretty sure Don's claim is that the space, not the atmosphere, but what above the atmosphere is water, right, Don?
Yes, a lot of it's up there. 400 trillion gallons. That's a lot, and it's
continuing.
It's liquid water, and it keeps going and going and going.
claiming this is liquid water up there.
Yeah, I'll give you all of it.
Vapor.
That's fine, but how much space is it occupying, though? I mean, if you compare the sun compared to the empty space around it, I mean that's not a whole lot.
I don't think it's fine because the pressures don't allow liquid water to exist up there.
It's a water world. Don, would you contend the waters above are different or the same as the waters, I guess, over here? Or would you say they have different properties in that they produce stars and stuff, whereas this water produces land? Or what would you say?
Come again? I was
Like, you said there's waters, like you believe the waters in the sky. You believe, well, then obviously there's waters here, like the oceans and stuff. Do you think the waters are different in some way? Like, because there's stars up there and there's Earth down here, but like, there's no stars down here and there's no Earth up there. You know what I'm saying? Like, do you believe they're inherently different water, or is it just the same thing in some sort of different condition, or what's your theory on that?
Oh, it's a different realm. I mean, I'll go with the firmament. That is, not within the firmament, but above the firmament would be heaven, right? I mean, this could be established that. But the thing is, all you need is sound and water, and there you go.
Hey, I just called to my own phone underwater, and it worked fine. So I guess radio wave can get through water.
Okay, is that a high frequency?
Wait, how did you call your phone underwater?
Yeah, I put plastic around it, put on a pot with water.
Well, with all
commendable.
things with all things like that, it's an attenuation. So it's in 3 foot of water, you're going to attenuate it 90 dB, whatever the hell the number is. So if I start out with a megawatt, it'll go further underwater. Not a whole lot, but if you have sufficient signal to get through that little bit of water, you'll be able to work.
So it's a matter of the strength of the thing, right?
The amount of attenuation versus the strength.
Yeah. Okay.
I mean, you think about like filters on radio systems and stuff. It's a band pass or a high pass, low pass filter. None of them filter out everything. You'll see that when you get to really strong signals that you're trying to filter out.
Isn't it amazing though how like mainstream, actually proves the Bible from time to time?
Don't see.
Like how?
Well, the
Bible
water's
in this
above,
situation.
water's below. It's kind of
There's
cool.
everything
How would they
above.
even know that there was waters above back in biblical times?
Because it was raining like every other week.
Before
they
the
were
flood?
wondering where the water came from.
Wait,
That's
before
a
the
very
flood?
good point.
No, that would be rain.
I had no
They
idea
weren't
how
that
the rain
stupid.
got up
They
there.
would say rain.
Yes.
They wouldn't. That's not that
What
stupid.
direction
There's
was that? What
waters
direction is that coming from?
above.
They would
Yeah, what
say it's
direction did that come
water.
from?
Oh my goodness, you guys are being.
Imagine with
No,
the lack-
Don, he gave you a really good answer and really fast. So you didn't expect that shit.
Yeah, but they knew the difference from rain and then waters above.
No, it's rain is water. I mean, that shit puddles up. I mean, it's water. Like they're not
Yeah,
gonna.
but they knew the difference.
No, come on.
They didn't have an answer for where rain came from or how water got up there, so it makes sense that they came up with some, explanation that there's waters above.
Yeah.
I think they knew about condensation and stuff. Or
It's amazing.
Probably didn't know a lot about condensation. I mean, they knew that you get dew and stuff, but without having modern machinery to create cold or storing ice somewhere, You don't see condensation a whole lot under your control. Although I wager some of them knew something because they would have been sitting there, and on a cold day you breathe out and you can see the water in your breath.
Well, the question is, did it rain before the flood? Because that was when it was written, before the flood. Uh-oh. Yeah.
Doesn't there a mist that's said to come up from the land and water all the seeds that they're planted?
Uh-oh.
Yeah, that makes a lot of sense.
Like it directly states that. It says that all the seeds were planted, but they didn't grow yet, and everything was in its place. And then there was a mist that came over everything, and that mist was the water, and then all the plants started to grow. That's what it says in the Bible.
Yeah, that makes a lot of sense. That's so in keeping with what we observe.
The Bible is definitely an amazing book. That's for sure.
Stood the test of time, kind of. I have reverence for the at least the Torah and the other books and stuff, but at the same time, I'm also familiar with the fact that everyone everyone who wrote it as men, and everyone who told them the stories before they wrote it, they were also men. And so, even though it was maybe some experience that was influenced by something else, possibly, all the stories in there and all the descriptions and explanations were all written by men, and they're all subject to men's. Even today, we have feeble, flawed, ideas of how things work. Some of them might be close to correct, but back then, they were definitely further from being correct than what we know now. So,
I partially agree, but I mean, I think some of it's pretty historically accurate, to be honest with you.
yeah, some of it could be.
If it is like I agree that it is like copy of a translation of a translation type of deal, and like shit gets like lost in translation. But I think that there are some things, like some general things that like weren't lost in translation, are definitely like the important part of the story, and it's right there looking at you, and like you can even go back to like previous versions and look at that in different languages and go, okay, yeah, that is what they were trying to say. Like I think there are parts that are like lost, but I think there are parts that are definitely have been preserved. Like, you know what I mean? Like that it stayed consistent for over like 3,000 years.
Yeah, that's just there. I tend to believe the stories are probably based on truth. The stories, like those people existed, maybe like Moses and stuff. But I don't believe the explanations, like the waters above and the Genesis story of how the earth was created. I mean, to believe the Genesis story is written in the Bible, and then also to insult people for believing in the Big Bang Theory is just kind of ironic because it's kind of the same sort of it's the same sort of criticism, whereas you're criticizing that somebody gave us disinformation about how the universe was created, although we have evidence for it. Whereas the Genesis story is just people passing down a story for how the Earth was created, but there's no evidence for it, but people are sharing the story.
Yeah, I can see where you're coming from. But yeah, like especially with the whole 7-day thing, I can see where you're coming from on that. But then there's also parts of like the kind of earlier Genesis like stories that kind of like I feel hold some sort of significance to the rest of the story. That if you take some parts of the other parts of the story, you understand like, okay, this is probably true, depending if the rest of this is like generally true, But I understand with this whole 7-day thing. I get it. Yeah, it is kind of like the Big Bang. You have to have faith in either one.
Yeah, I didn't mean to compare them so much, so because, like I said, one of them does have evidence, but yeah, just a lot, sort of along the lines of what you were saying that. I mean, this is my personal belief that, and it's just like a faith thing. Like the stories are probably true. Like the people might be real, but you have to with discernment. I think even they would, they wouldn't, you know, they wouldn't judge you for understanding that they probably got things wrong. They're like, damn, they still think that shit we wrote a long time ago was right. Like rolling around their graves. Like, why don't they? God damn, we were wrong about the fucking waters above, dude. We didn't know. We didn't even know at all that the fucking. We didn't know anything about the. What's that called? When the water, water goes up. It's not condensation. What's it called?
Evaporation.
Evaporation. There you go. And they didn't know anything about evaporation or anything like that.
Why does that necessarily have to correlate?
Well, I mean, if you don't like, for instance, if you don't know why the water goes up and then it rains, and then you have some sort of explanation that there's waters above. It could just be that you have the explanation because you didn't understand how water works, right? It's probably less likely that you have some greater idea that most people don't accept today, but is actually true, despite the fact that they didn't even know how water worked, you know?
Or you've been sold a deceptive story about how water works and then kind of think that you're sitting on shoulders of giants, that you have the answers, and then criticizing people that actually knew what was going on in terms of.
So you don't believe in the water cycle?
Well, it's not really something to believe in. I definitely think that there is a water cycle, but I do not think that all of the water that comes down in rain is coming from water that evaporated from the earth. Definitely not.
Oh.
Where did it come from?
Above. The water's above. The ether.
We never see it. We never see it falling from like. We never see it falling from space. I mean, it's like it's always associated with clouds. Are you saying that the vapor came from above?
Well, not always.
Wait, hold up.
Do not say sun shower. I swear, if you say sun shower, literally there are.
Begging the question of space. Begging the question of space. Thank you.
Well, it is possible. I mean, rain can happen without clouds. That is
really.
Yeah.
Really, I haven't seen that.
Yep.
I've never seen that.
Do not say sun shower. That literally that.
No, you've said that 3 times. I didn't say that.
Well, I'm just making sure because I was just trying to predict what you were going to say. You know, so I'm like, don't say that because you can clearly see that there's still clouds, around. It's just,
Where's it ever rained without clouds?
What do you mean where? You want like the country or something?
An example.
Yeah, example of where it's ever rained without clouds.
My experience has always included clouds.
Well, there's a term for it in meteorology called serene.
Yep, I'm looking at it right now. I was about to read it. It refers to rain falling from a cloudless sky. Yep.
Right. That's what I want to see. That's what I want to see.
I'm always willing to learn something new.
Favorite weather is when it's raining, when it's sun out.
I mean, I've experienced it myself directly, but
what do we got? Rain without clouds?
Yep, we sure do. Interesting.
Like drizzles that we have to do.
I'm sure they'll have some excuse for where it comes from, though, Gio. I want to get too excited.
Oh, do you think that it doesn't come from evaporation and condensation? Jeremy?
Well, like for example, like the idea that all the rain is coming from the clouds. Think about, I mean, we've all probably been in pouring rain. I mean, there are times where it is pouring rain, unbelievable amounts of water, just inches upon inches everywhere upon the region that you're in. I mean, just massive amounts of rain. For there to be that much water in the clouds, if you were to fly through that with an airplane, it would be like a swimming pool. You'd smash into it. You wouldn't be able to fly right through it. So, I mean, clearly all that water is not just coming from the clouds. There's some other phenomenon happening to make all of that massive.
In those situations, you're talking about like thunderheads and stuff, when you get that kind of rain. So you have a cloud that's 60,000 feet tall. And you don't think that you could spread water out over 1 inch or 2 inches of water over 60,000 feet and not have it be a wall?
No, to make it rain for days like that sometimes, just massive amounts of water, no way. Just
Well,
that
the air is moving in from other areas where it's not raining.
you could fly right through that with an airplane, and all you would get is a little bit of wind, a little bit of rain on the windshield.
Yeah, bro. When I was a little kid, it rained here for 40 days and 40 nights, literally. Like straight up downpour all day and all night, 40 straight. It's the craziest thing.
Yeah, you'd have to have like swimming pools of water in the clouds that would have to be, and then it would be slowly releasing the rain, and even at that, the pools would have to be refilled.
Marx described 60,000
They are
feet.
refilled.
That's 10,000. That's 10,000. So that there could be a pool that is 10,000 times less dense or spread out, and it would have the same amount of mass or same amount of water, basically. 60,000 feet. That's like six. That's 10,000 6-foot pools.
And then you have water. It's when it rains for multiple days. That's usually a front that's coming from somewhere. It's not like one cloud sitting over your head raining for 40 days and 40 nights.
I mean, I think the clouds are connected to rain without a doubt, even though there are times where it rains without clouds, like I just mentioned, but there is a correlation there. I think that there's an electrostatic effect where the water is essentially.
Yes, it is. There is.
Yeah, Moyak, part of the reason that we have like no ridicule on here is so we can actually share ideas. For example, I just shared my idea and you exploded. Oh, you just left anyways. It just makes the whole environment toxic. Like I was just trying to share.
Yeah, I wanted to hear what you had to say.
Yeah, I was saying I think there's an electrostatic effect where the water is essentially constellated from the ether. It's almost like it's being made in a sense, like it's being created by the electrostatic dynamics of the ether that literally creates the water, but it's like also pulling it from the waters above. It's like constellating it.
Hey, have you guys ever seen? And you're not going to appreciate this probably, but there's a river. They call it a sky river, and it can be viewed from the ISS, and it takes water from Africa to then it goes over to South America, and you can from the ISS you can actually see the flow of it and everything. It's quite fascinating.
Interesting.
Wait, what now? I'm sorry, I kind of blanked out. You said there's a sky river. It takes waters from.
It takes water, dust, and all sorts of material from Africa to the Amazon, and when it's in the Amazon, you can actually see it flowing above the trees. Like it's almost like it's flowing through the trees above the trees, like an actual river.
That's pretty neat.
Yeah, from the ISS, you get like a real good shot, a real good view of it.
No, I think the top of the clouds are more of a positive static charge versus the bottom portions that are negative. There's something correlated with positive and negative, for negative to be flat and positive to have like form to it. Am I making sense? You guys not getting it?
Well, why do you say that there's flat or negative is flat?
Yeah, but it's what I've noticed. Like there's no features to the negative, so it will perceive flat.
I thought they were just opposite.
Oh sure, but I mean yeah, but it's just something I've noticed every time it comes with like a negative. Cause like even like if you look at a radio wave or a frequency, right? It goes up to 12 volts, comes back down to 0 volts. That's like what MOSFETs do: turn on, up, down, turns it on and off, on and off. And that negative is flat. This is interesting. Hang on.
What do you mean? I don't understand what you mean. The negative is flat. What do you mean?
I spaced out a little bit what you guys were talking about, but it kind of linked into what I was still thinking about the water and the rain. But yeah, it's interesting to think of like in a toroidal field, the dielectric inertial plane, which would be the Earth, and then like the toroidal field, the electromagnetic and static field around it, and how that water cycle is like connected to that inertial plane. And yeah, it's pretty interesting, the whole cycle like that. And the tides, like if there is something in the center, like the 4 rivers, 4 islands, like the way that the whole water cycle is connected to the field.
Okay, can we because we are changing the tunes a little bit, and you brought up the ether, and you're pretty comfortable sharing what you think and stuff. You know, I just I'm a believer that there's not really a description of the ether. There's not really a firm description, even to people who believe it. But I think you might have your idea of what the ether is, because you just express it as doing these different things that I'm sure you've thought about before. You're not just saying that the ether is doing something with the water and stuff. So I was just going to ask, like, what are some of the features of the ether that you that kind of you have in your mind, like when you conceptualize the ether? Like, what are some of the mechanisms and features, and what is it capable of interacting with, and that kind of stuff?
Yeah, no, it's an interesting discussion for sure. I mean, classically, in terms of like in ancient times, I mean, ether is like it's like an element. It's like a core element. Like you've got earth, air, fire, and water, but those all come out of ether. So it's like ether is the foundational element by which earth, air, fire, and water come out of, and then earth, air, fire, and water create the earth. You know, you've got the earth itself, the air, fire, and water, and so on that level, like the ether is not really, in my mind, it's not really something different, or it's not kind of this like, you know, strange thing outside of. It's actually like the foundational element by which this entire realm is fundamental to. And so the earth, air, and fire and water, you know, light connected to fire, obviously air is connected to what we breathe, and so on. The earth, you know, and so on. So it's like those elements are essentially functioning within the background of the actual ether element.
Okay, yeah. So that the ether can interact with all those things, then, like the ether, well, specifically like the water, because you said like I don't know what you were saying about it. The water can come from the ether or something like that. You said.
Well, I would say that those 4 elements, the earth, air, fire, and water, are all operating and woven within the ether. Like the ether would be the foundational medium, and then the earth, air, fire, and water are all functioning and being activated within it in various ways.
You know, it's interesting. I've always said this to Lemon too, but if you just tweaked like the sort of understanding of quantum field theory, and then you're talking about the ether and everything emanating from the ether, I mean, it's like kind of it's using different language to describe almost kind of the same thing.
That's what I'm. Yeah, Coach. Be honest with you. Yeah, I kind of correlate them to similar, like the double slit experiment. I kind of look at that, like, you know how if you get a gradient, right, and you get a diffraction pattern inside water, that's a medium. It's a field of itself that's acting upon that, you know, or ripple. If you get like 2 balls and you bounce them around, and they'll bounce into each other. That's its own medium. But when you get the light doing that, and you get the gradient, they say it's the gradient that's doing the diffraction pattern, but it's like, where's the photon? It's here, there, here. We don't know. It's like there's something interacting with these particles.
Conversation shift. I don't know.
No, it's just ether. I think that the double slit. I'm not saying it's proof. It's it's assumption. Okay, it's a thought. Okay, and sometimes you do assume, but that the double slit kind of like goes with the ether. I think it does. That's just from me, from how I looked at it. I need better evidence though for it. Sure.
Yeah, no, there's a lot of interesting connections between some of the quantum physics. I mean, I think they've reverse engineered a lot of that from ether. Like, I think whatever they've done with like usurping the world and the position they're in, they've taken a lot of the ancient knowledge and wisdom about the ether, especially free energy and how to manipulate it and so on. They've taken a lot of that and have kind of stolen it from, the people that they've usurped, the beings and people they've usurped. And then they're obviously hiding a tremendous amount of it that they want to hide, and then sort of releasing certain parts of it, to be studied further and calling it something different and applying it to a different model. So yeah, I think there are ways in which some of what they're actually doing in quantum physics is actually work with the ether, but the people that are working on it think that it's within a different model.
Mm-hmm.
I'm not sure that they're less or more confused about it than say I am. So if I see clearly that the ether kind of the idea of what the ether is gotten naturally incorporated into quantum field theory because they were looking for the same thing. What they were looking for when they were looking for the ether was basically the quantum field, but they are different though in ways because the quantum fields aren't substance in themselves. Although substance can come from it, and everything actually that they claim like all the substance is just excitations in those fields, and also it's not static, so it's like there's no static background that's like everything's fixed in. It's sort of relativistic, I guess.
Well, wait a minute. You said that there's no static background. Is that background in a different medium or realm, if you will? And is only perceived static in our realm?
No, it doesn't. It's not. It's not really. It doesn't seem static at all.
Because I mean, I definitely 100% believe there's different dimensions, or I say heavens, for my beliefs. But how to be able to read those?
And when I say it's not static, I just mean there's no fixed background that you can make as absolute positions. Like the positions are they're relativistic the same way. I think Jace is going to be able to articulate this better than me, but I know that Paul Dirac, he whenever he came up with like the original quantum electrodynamics, or the idea of it when he started to conceptualize the first quantum fields, he incorporated special relativity with what they were learning about quantum mechanics.
Yeah, all quantum field theory is a relativistic field theory, basically. And yeah, Dirac was the first one. He developed the Lagrangian for an electron, and it was just naturally in Lorentz invariant. So naturally, it was relativistic, and then it gives rise to the idea that these are actually a field with certain properties. And then Feynman came along. Feynman, Schwinger, and another guy came along and kind of further developed the whole QED between electrons, positrons, and photons, and then Murray Gell-Mann, I think his name was.
The neutron
guy? He was the QCD. He put together the nuclear with quarks and gluons and all that.
Interesting.
But yeah, so like usually when I teach or talk about quantum fields, either with my students, fellow students of mine, like these are just the fields are just contain the properties. So like the quantum properties, like spin, baryon number, isospin, weak hypercharge, those kind of things.
Right. Well, like I think we discussed this before, Jace. Like I think your photo is of that spin ice, and a class of substance which particles can agree That didn't they use Planck lengths for that? I can't. I think that correlates with the quantum though, as well. It's a theory though, right? It hasn't been passed. I haven't really looked into it lately.
Oh, what did you say? Spin ice?
Yes, spin ice. Yeah, substance in which particles can't agree. It's quantum spin ice.
Well, spin is a property that particles have.
Right.
So,
Right.
like fermions have half integer spin, and
Yeah.
bosons have integer spin. But it's not a prop. It's not like something in the. It's not really spinning. It's the best way.
Yeah. That's They just say that. Yeah, I know what you mean. I know the Royal Institute was talking about it, and I don't know if you watch them on YouTube, but with the monopoles and spin ice and stuff like that.
Oh yeah. Okay. Yeah, I know what you're talking.
Interesting stuff, man. We're learning more and more and more about the electromagnetic fields. That's for sure. There's so much to learn about it.
Hey Jace, I got a question, man, because you know how I know you know how, but you know how neutrons, they have these quarks, what is it? Probably something like
The up, down, down.
Yeah, but one of the quarks is negative 2/3 and the other two are 1/3 or something like that.
Yeah, positive 1/3.
So does that still make a neutron? I mean, its charge is neutral, but I guess it has intrinsic charge. I guess is stored in it, though. I don't know if does that count. I'm just curious because I often bring up neutrons when I talk about matter that is not electrostatic in nature, but technically, internally it is, right? Or is it?
Yeah, the quarks, so like a neutron, it's it's got an up type quark, a down type quark, another down type quark. So the up is positive 2/3, and both of the downs are each negative 1/3 in charge. So that gives it a neutral charge. So yeah, they're intrinsically charged, but this is more to do with, so charge is deeply connected to something called weak isospin and weak hypercharge, and it's more to do with that than the kind of electric charge you think of with an electron that has a complete positive one or negative one charge, and a positron that has a positive charge, etc.
So these are different. These are different kinds of charge.
It's still charge. It's still electric charge, but it's not a complete charge. Obviously, it's negative. The up type quarks are positive 2/3, and the down type quarks, because there's 3 generations of each of these types, and
So they
the
basically
down are minus 1/3. But what it is electric charge, but it doesn't have like any effect in materials or anything like that. It's more to do with the, like I said, the weak isospin and weak hypercharge, and the symmetry with the Higgs field and the electroweak force. It kind of ties all that together more than like electricity. It's not going to have any effect.
It's gonna be a dumb question because I think from what I remember, if a quark is by itself, just in nature, it just automatically like another quark kind of is summoned from the quantum field or something like that. Like it's created basically. Is that right? Something weird like that.
Yeah, the state that the strong interaction is in, the energy, It's under quark confinement. So what that means is, like, if you want to remove a quark from a hadron, like a proton or neutron, or a meson, which is a quark antiquark pair. So if you want to remove a quark from any of those, the amount of energy you have to put in to do that will just create another quark antiquark pair. So you can't ever just isolate a quark.
But
Right.
don't
That's what I was
photons
going to ask.
carry
Is
electrons?
go ahead.
Don't they carry electrons? Photons? I mean, protons. I mean, like they
What?
wrap around it.
No, protons are a composite particle that have a combined +1 charge because of its quark content. An electron is a fundamental particle. It's a lepton. It's a different particle.
Well, that's what I was going to ask. Is I wonder, is there any even way to conceptualize like what would happen if an electron and a quark, or maybe a pair of quarks, something that didn't have a full complete charge? Is that even possible to conceptualize? I'm wondering what would happen if there was an electron and a quark would interact.
No, because of the conservation laws of electric charge and of color charge, you always get you either have elementary particles that have integer numbers of charge, so like electrons and positrons with -1, +1, or you get composite particles made of quarks that'll always have either no charge or +1 charge, -1 charge. You don't get composite particles that have like non-integer number of electric charge.
I gotcha. Just curious.
Yeah.
I'm trying to conceptualize what kind of charge these fractions of charge have.
So do all particles that are made of quarks have integer level charge?
Yes. Yeah. If it's they're called composite particles. There's two kinds. They're the hadron, protons and neutrons. They're made of 3 quarks. And then there's mesons, which are a quark antiquark pair. And all of those will all have either 0, +1, or -1 charge. They don't have 1/16 charge or -8/12 charge or anything like that.
Aren't baryons, is that the one with 2 charge? Or no?
Baryons is just the so like hadron is what's the word for it? I guess it's just another hierarchy in the naming system, right?
Yeah, I got a little
includes protons and neutrons.
I got like a little almost like a Venn diagram, not quite, but here that shows. Okay.
What, Jay? I want to add, isn't that how we get we're talking about molecules or whatnot, but when you have a circuit, right, that carries atoms and electrons, the core is positive and the exterior is negative, and electron. That's why you would get like a current, right? Am I correct on it? I think so.
Yeah, that's right for the most part.
Yeah.
Yeah, so Gummy, just to clarify, so like the hadrons are broken into 2 divisions, and those are the baryons, which are like protons and neutrons, and mesons, which are quark anti-pairs, and those are like pions and kaons. They're things like that.
How does that happen? I thought particles, antiparticles, I thought they annihilate.
What do you mean annihilate? What do you mean?
They're not the same. Like it'll be a the type of quark that it is it's not the same kind of anti-quark, right? So there's 3 different kinds of quarks. There's 2 different kinds. There's up type and there's down type, and within those types, there's 3 different generations. There's a up, a top, and I forget what the middle one is called.
Strange and yeah.
Charm. That's it.
Charm,
There's
that's
a
it.
up,
Yes.
charm, and a top, and then a down, strange, and a bottom. And so like it'll be like a up anti-quark and a like a down quark. So they're not the same kind, so they don't annihilate.
Fascinating. Hey, is it true that antiparticles travel in the other direction in time? Is that right?
That was like a trick Feynman put in to kind of make QED kind of visualizing it and explaining it a little bit easier. I haven't heard anyone say that like that's what's really happening. I think it's just a way to think about it.
I had a weird thought the other day, and it's probably nothing, right? But because there's that issue about the beginning of the universe, and that somehow matter won and antimatter is a loser, supposedly. Well, I was thinking like if it worked the way that like if Feynman had, I guess, joked around or just described that they're going the other direction, then I was just thinking like technically during this event, in our going our direction in time, matter it was the winner, and then going the other direction in time, the antimatter is like the winner. That makes sense.
Well, isn't there a thing about, or is there a property? Sorry, I'm butchering my words. Is there a property about antimatter that is like distinct for antimatter? Like, can we distinguish whether matter and antimatter are just opposites, like charge and like how we can for all intents and purposes call negative charge positive and positive charge negative, and we change nothing? Is that the same for antimatter matter? Or is that like, is there a different property between them?
I think it's just the charge, right? The thing that happens with the symmetry that gets flipped with antimatter is the charge part, the CPT. So I think that's the only way of distinguishing. Like people, the way the positron was discovered, people made these things called, you can use a cloud chamber, bubble chamber, and like electrons will go one way, they'll make a path one way in it, and a positron will make a path, the opposite direction, like it has the opposite electric charge. And then they measured the masses of these things, and they found, like there's this electron that has, the same mass as this other particle, but it's just got the charge is flipped. And so I think that's the only thing, the only difference that there is.
Yeah, because I'm like, because I feel like I remember there was some video or something that was talking about the an experiment that proved that like matter and antimatter aren't just complete opposites because of some symmetry thing, but I don't know. I'm just
Look, it the positron. It has the same mass as everything else is the same, but the charge. And in the Lagrangian, or the equations of motion of the electron, what Feynman was getting at, if you flip the sign of time in that equation, you get the positron, basically. Like the equation just has a positive charge rather than a negative.
But so would it then be equal? Would it then be So could you then say that if we just swapped matter and antimatter, everything would still be the same? Or would that have problems with the fact that time is essentially reversed?
Entropy would go the other direction.
Is that what would happen?
No.
Well, that is that's the parity part,
Yeah.
right? The parity part of the symmetry in the universe is that you can flip the from matter to antimatter, and it'll look exactly the same.
Yeah.
Right? You kind of have to put the three of them together, but it's really CPT. Like if you flip the charge, you flip the parity, and you reverse time, and the universe will look exactly the same as it does today. You know, how we describe it now.
You have to reverse time.
Yeah, because like I said, in the equation, when you go from matter to antimatter, the charge sign flips. The time sign flips.
Is it impossible then that there's, like I said, another universe going in the opposite direction as ours, where the antimatter won over the matter, and it's just going in the other way, other direction?
You know, it could be. It's definitely possible.
What does that mean, though? You said that because you said if you switch everything out, all the matter was antimatter, everything would be the same, but time would have to be going in reverse.
Yeah, right. So I answered it wrong. You have to flip all three. So you have to flip the charge. So you go from matter to antimatter. And I said the wrong word. It's not parity. Parity has to do with its handedness or its chirality. And like there's rules for that. But if you flip the charge and then you flip the parity, so the handedness of the particle, and then you flip time, so you reverse time, and you'll get a mirror universe to ours. It'll look exactly the same. But if you only do one or two of those, and you don't do all three, it won't look the same.
You know what the most interesting thing is that in the particular theory that we have now, the one that the common is that that the universe is not equal in that, so that there was some imbalance at the creation of the universe that allowed it to have this positive matter, if you will, the way we see it now, rather than the antimatter side. So it sort of negated itself out unequally.
Yeah, that's one of the big problems, or I guess big research areas in physics, is trying to figure out the reason why matter won out in that regards.
Yeah, that is fascinating.
That's what I mean, though. If that's the solution,
Did I hear
though, is
reverse
that
time?
it didn't win out.
Oh, sorry, Kosha.
There is a solution for that, and a pretty common solutions.
So there's
Did I hear
solution for that?
reverse time? I know I came in late in the convo, but did I hear reverse time?
I was being silly a little bit. I saw that movie. What's it called? Tenet. And they go backwards, forwards in time and stuff like that. And that's what I was thinking about, the whole particle antiparticle pair. Because like in our universe, particles won out, but in maybe there's a reverse universe time's going in the opposite direction where antiparticles won out. Who knows?
Is there such a thing as an antiparticle?
Oh yeah.
Yeah. We make them.
Bananas will emit antiparticle every couple hours. That's no joke.
I heard about the radioactivity of bananas, but antiparticle, really? What's the property of an antiparticle?
Well, you wouldn't know. I mean, it's the same as the regular particle. It's just the interaction
opposite.
with them. The interaction with the regular, the standard particle and the antiparticle would be a massive one. And obviously, bananas don't create antiparticles, or the bananas would explode.
Yeah, they do. They do create positrons, and the positrons has the opposite charge as an electron. But yeah, they create one every 2 hours. I'm telling you.
What? Oh, yeah. Well, I don't believe you.
If I'm lying, I'm dying. It's not because I'm eating a banana.
Oh, dinner's ready.
Oh, we just lost Kosho.
No, that's me.
No, he said if he's lying, he's dying. I thought that's what he said.
Yeah,
Oh,
you're lying, because from the internet it says once every 75 minutes, so it's not every 2 hours, it's every 1 hour and 15 minutes. So you are lying, so you're gonna have to die.
It's fine. I'm already writing his obituary.
That's what's up, dude. Make some shit up.
Yeah, this says the average banana produces a positron roughly every 75 minutes.
Yeah, like, you can make a bubble chain or a cloud chamber fairly easily and observe these kind of things. I think you could use like isopropyl alcohol is a good solvent to use for it.
And what happens? Can you describe the?
You see the
Yeah.
charges.
Go
Oh,
ahead,
the
go
charges, sorry. No, go ahead. You know more on this, so.
No, it's okay, man. You can.
Well, okay, I'm gonna explain it, and then you're gonna correct me because I'm gonna get something wrong. Essentially, a cloud chamber. When you put a cloud chamber around something that's radioactive, and you have particles that are being shot off this, they will essentially excite the whatever material is in this cloud chamber, and it will emit light. So you can literally see the path that the particle is taking, because that path will be lit up, so to speak.
Yeah, that's pretty spot on. It'll leave a trail, a visible trail, basically. That you can see the path.
Is essentially because the whatever the medium of the cloud chamber is being ionized by the particles being sent off by this radioactive decay.
Yep. Exactly.
Didn't they first witness this stuff in upper atmosphere? Like they used to put balloons up and stuff to go try to witness like cosmic rays interacting with the gas up there or something like that.
Wait, don't you guys feel kind of funny talking about time travel, given that it's never been proven or done before?
No one is talking about time travel.
Yeah.
You're time traveling right now.
Yeah, we're all time traveling at 1 second per second.
They were talking about reversing time, or they were talking about going reversing time or whatever earlier. That's not. It was just their mathematical equations. You got to realize these guys walk through mathematical equation after mathematical equation that has no relation to reality.
Hey, stop ridiculing us. All right, that's against the rules here.
I didn't say that quote. That was Tesla.
Yeah, I know, but we're not positrons, so we don't think that time we can travel back in time.
That's right, Jeremy. So why don't you go fly a kite?
Yeah, it's just in your mathematical equation. I know.
I was on their case, right?
I heard you, Jesse. I
We're
heard
talking
you.
about movies, so I laid off.
No, but I don't think that's possible for anybody to experience, reversal of time. But certainly time travel and into the future at different rates, and some people can go much faster than other people, and some people could get to the future way before other people do. So that's kind of time travel into the future. But
Well, not before other people, but at a different or like a different personal speed, so to speak.
Right. So to them, it would feel like they just got there quickly, whereas somebody else got there.
Yeah, like
No, they weren't
both
talking about
people.
movies. They weren't talking about movies earlier, SC. They were talking about a formula. What was the formula for this mathematical equation?
They weren't talking for real, were they?
I think you were
Yeah,
talking
this
about
is it.
CPT symmetry.
Yeah, it's the Lagrangian for electron, the equation that describes the motion of an electron. If you put the opposite sign in for the time coordinate, it'll describe the motion of a positron.
Oh boy, here we go.
And if you reverse the time, what happens then?
That's what's meant by changing the sign.
Like if you look at it,
So in
reverse
this
the
formula, do you? Go ahead, Ashley.
No,
You're
go
gonna
ahead,
look at
Jeremy. I didn't hear you come in there. Go ahead.
It's fine. I'm about to go into a room that's laggy. Go ahead.
I was just curious, like how do you reverse the time?
I think he's just saying it's a convention.
Yeah, no one's saying that you're reversing time. Like no one is saying.
So then it's a completely useless formula. Then,
No.
in other words.
There's a formula, it's called the Lagrangian. It describes the motion of a particle with mass m, which has been determined to be the electron's mass, right? When you change the sign of the time coordinate in that formula, it describes the motion of a particle with the same mass of the electron, but with a positive charge rather than a negative.
And what happens to the nucleus then?
I don't think there's any nucleus involved here.
Yeah, we're not talking about nucleuses.
Here's a diagram, Feynman diagram for.
Okay, regardless of that, then you just put a formula and you think that you can change time. I'm lost here. I don't get it.
No one's saying
time.
And no one's talking about we're changing time like by will or anything like that.
Yeah, it's just their formulas. That doesn't equate to reality. That's all.
These Feynman diagrams actually they make it real simple. He's just describing it in a simple way, in a way that works, but he's not, like Jay said, he's not necessarily saying it describes what is actually happening to anything. He's just saying that you make the positron going in reverse time, makes it behave like the electron.
In reverse time. Listen to what you're saying. You mean reverse spin?
Oh my God. Listen, there's an equation, right? If you were to send an electron through a cloud chamber, there's an equation that can predict the path and describe the path of that electron and its mass. When time is included in that equation, but when you change the sign of the time in that equation, the charge of the particle it's describing goes from a negative charge to a positive charge, but still has the same mass, and that's what is called the positron. No one's saying that you're actually changing time, anything like that.
So what's actually changing then?
The interaction.
The charge. Okay. That I can understand.
Yes. The difference between an electron and a positive is the charge, and a few other obsolete quantum properties that don't matter for this discussion. The big one is the charge.
But you're saying, let me see if I understand you correctly. You're saying this changes in reality, simply because you change the equation. Is that what you're saying?
No. The way this got brought up is there's a quote or a thing from Feynman where he says you can think of the positron as an electron moving backwards in time. And it makes his representations he came up for quantum electrodynamics to figure out how to do the math to predict the paths of particles, quantum particles. It makes that stuff simpler to think about it like that. But he also said that that is most likely not what's happening in reality. It just makes things simpler. It's a way to think about it.
When Tesla made that quote, Feynman wasn't excluded from that. Or sorry, when Tesla made that quote, I don't know what I just said.
Yeah, I'm just saying what the discussion was. That's what we were talking about.
Wow, that's pretty mind-bending, if you ask me.
You really got to take Feynman with a grain of salt. I mean, he was usually on top of his game, but he was off the rails sometimes.
You gotta take them with a grain of salt.
Never use Feynman diagrams. They're flawed to begin with.
Is that right?
Yeah, that I would have to agree with Gummy on that one.
Yeah. They have no predictive power whatsoever. There's no use to knowing them.
That's kind of the beautiful thing, but I think that's why Feynman should be remembered forever. Kind of like the people that other people forget, like Euler and stuff like that. He made a lot of things that were complex, like really simple.
You
like
guys always hype up the Nobel Prize, so you think this guy that won the Nobel Prize is wrong about all this stuff. So why hype up the Nobel Prize?
He's wrong about
I disagree. If you use perturbation theory to get the first order and some maybe contributing second order Feynman diagram, it will give you the equations, the pieces of the equation for the action to get the path of the particle to a very accurate number value.
I always thought that they were correct.
So you're saying, so is the question though is, have they ever made predictions with a Feynman diagram?
Well, right, it's not meant that just one diagram. You have to use it in the context of something called perturbation theory, where you're trying to pull out the relevant Feynman diagrams to the path of the particle, right? Because the whole idea is that the particle can take all paths. So you have to figure out which ones contribute a phase that is actually, makes a difference in the phase amplitude of the path. That's what you're trying to do with those diagrams.
But they do take all possible paths, like superposition.
Here we go.
Fall for it, SE. Don't fall for it. He said that on purpose. I can hear it in his voice.
Yeah, he's a tricky devil. This one, he is.
He's an antagonizer.
Yeah. Touche, Kosho.
I'll give you another one. See, so when you do this quantum action thing and you solve the integral in the limit of all you take a limit of a certain value, and it'll give you Newton's mechanics will come out of it. The classical one trajectory path will come out of it.
Wow.
You guys got some wicked imaginations, I gotta tell you.
You just made that up.
And you can tell Jace is very educated. He knows what he's talking about. He knows his atoms, his molecules, and all that stuff. It's just that he has no imagination. Don't get this wrong. Like, you have to have self-thought, bro. You have to think for yourself. Take all that knowledge you have and think for yourself. Is it possible? What they're telling you.
You have to have an imagination to work. You have to have a good imagination to work in a field that works almost primarily with models and things that have no actual visual
relation to reality.
No, they have a relation to reality. That's the hard part. Is their relation to reality is you don't have direct direct access to it. So you can't access it the same way you can access like training a dog or something that you can actually see and feel right in front of you. You have to understand the workings of the model and try to conceptualize what the interaction is going to be in order to know what you're going to predict or whatever. So I think
Yeah, but
that's a
it's
pretty active
obvious that
imagination.
Jace
You
knows the
have to have a good
model a
imagination.
few layers, the chemical model. He knows it a few layers beyond us. It's obvious. He knows his stuff.
He works in Plato's cave, man. Do you know what this guy does? My man lives in Plato's cave. Tell him what you do. You look at fucking shadows of crystals on a wall, bro.
Yeah, I determined the structure of biomolecules.
By looking at their shadows.
One of the common ways of doing that called crystallography, where you go to something called a synchrotron, right? And we send electrons around in a magnetic field in a big circle, and they send off X-rays as they travel around in the circle. You can focus those X-rays into a beam and send it at the protein or nucleic acid, whatever kind of biomolecule you have, and based on where the electrons are in that biomolecule, the X-rays will diffract and hit a detector or a film plate, whatever you choose to use to obtain your data. And then you can determine where the atoms were in that biomolecule.
See, sounds like Doc back in the future, no?
But it's funny about the Plato's cave thing is it's like so ironic because what Jace just described, what I was saying about the conceptual models that you have to understand these things. This is like the opposite of Plato's cave. It's like you have to be able to think outside of the cave, someplace you don't have access to.
Dude, he told me he shines lights. He told me he shines lights through fucking molecules or something to see what kind of patterns they make on the wall.
I just told you what we do.
Yeah, that's
just one of the ways. There's many other ways to do it.
What's the way where you're not in Plato's cave?
Oh, cryo-EM. You
How's
just
that
use
work?
an electron microscope.
You use one of those?
Yes.
Now that I would like to get my hands on. So what have you seen? What do you put in there?
Electrons.
No, it's usually nucleic acids and proteins that I'm looking at. So lately, I've done a lot of stuff with something called the main protease of the SARS-CoV-2 virus. The spike protein in the receptor binding domain, things like that.
It can see down to the virus level, right?
Below that.
Oh, below that.
Way below that, right?
Yeah.
You ever seen?
Does it look like the cartoon? Does it look like the cartoon they show us on TV?
Yeah, what do they look like?
That's a different kind of electron microscopy that they're doing, but to an extent, if you just Google like actual images of electron microscopy SARS-CoV-2 viruses, that's what it looks like. The cartoons are just a depiction of that.
Now this is for real, hands-on shit. I would love to look through one of those, I tell you.
Yeah, it's pretty cool.
This is not pie in the sky, dark matter garbage, you know?
It's not.
Wow, dude, you say that in Chronic sitting in the room. Fucking make him feel bad, dude. To be honest with you,
Chronic's the biggest antagonizer of them all. He used to go into gems and just start saying keywords to try to trigger me.
Well, it's because you're easily triggerable and
triggerable.
Yeah, it doesn't matter, dude. The point is that I happen to think that both on the big scale, like you go out and outwards, you look like that, and then inwards, like what Jace is doing, I think they're both equally cool.
Do you think it's fractal?
Well, when I was a kid, I saw this one video, and that's what maybe I just changed my life. But it just showed like the universe, like they went out like orders of magnitude outward, and then it went inward onto this dude's hand. He was like on the picnic, laying on the picnic blanket. Or
Did you just say N-word?
Inward. I didn't say
Oh,
Arnold
N-word.
Schwarzenegger like you do, dude.
So you said the N-word. You're dropping N-bombs and you ain't got the launch code.
Yeah, dude.
Stupid.
Anyways,
So what's the smallest now? Lepton, up, down, left, right. What, Jace? What's the smallest?
Called a puny or something, or a
neutrinos are smallest.
Oh man. So
This is
right,
Jay's department.
there's elementary particles. Those are considered to be the fundamental building blocks within that. And within that, yes, there's quarks, which are
Give us the names, those funny names.
yeah, there's quarks, there's electrons, positrons, neutrinos, gluons, the W and Z boson for the weak interaction.
Brothers.
What's the other ones? There's more. Keep on going.
There's the up type, so the up,
the up, the down,
and the top. Yeah, then there's the down, the strange, and the bottom.
They got really creative on those.
what's the one you missed? What's the twerp one or puny one or something? What's the name of that one?
Neutrino. There's neutrinos.
No, it's got a different name.
Some of the charm, quark.
Yeah,
and
there's
strange.
There's up, charm, and top. Then there's down, strange, and bottom. Those are the six quarks.
You ever heard of a strange star?
I've heard just from YouTube.
Yeah, from YouTube too.
Guys, don't make me go to the science section in this school right now and find out what the name of these things are, please.
What do you do? Those are the six quarks. There's also which are the electron, positron, the neutrino, the tau, the muon.
No, you're not naming the one that I know.
Wow, dude.
Well, didn't they like? Isn't there like a different name for one of them? Like it goes by two names or some shit. Like there's like
They're called twerps or tinies or something. It's some kind of
the neutrinos are they're usually referred to by the type of lepton neutrino that it is. There's the electron neutrino, the muon neutrino, the tau neutrino. Those are
the right word.
There's the Higgs. That's the only, and the photon. Those are the only ones I've left. The basic elementary particle model.
Meson, maybe.
Yeah, those aren't elementary particles.
Right. I was wondering what he's thinking. Like, what is he? I don't even know what he's some word.
I think Jace is the first guy that I believe what field he's in that a baller say.
Only because no one else would know all this. Yeah, only because no one else would possibly know all this nerd shit for no reason.
Exactly, like recited like that off. There's no chance in hell.
Congratulations, Jace. You're the biggest nerd here.
Yep.
Yeah. Nerd award, Jace.
Wait,
so how do you see neutrinos? Are you able to just conceptualize neutrinos, or is it something at a subatomic level you can actually identify?
Think Plato's cave.
No, neutrinos. It's a little bit because they don't have an electric charge. It's a bit more difficult to detect those. Usually, they use if you've ever heard of the super kamikaze experiment or whatever. It's like this thing that's deep underground, and they use this kind of. I think some of them use like hydrocarbons, and some of them can use chlorine atoms.
There's one in Canada, I think. One of the biggest ones.
Yeah,
they put them in like salt mines and shit.
Yeah.
They don't do some react. Don't they have? Don't they? They don't observe them directly. They have to observe. They have to wait for them to interact with one of the particles in there, like a one or something.
Yeah.
Is it possible to just conceptual?
Something's happening.
Well, they say there's billions of them passing through you right now, every
Through your
second.
fingernail, trillions through your fingernails. What they say.
Yeah.
But you know
Well, then,
you
how do
can
they know
image
that?
the sun. You can image the
They don't,
sun
bro.
through the
That's,
earth at
I mean,
nighttime.
that's tall tale right
Yeah,
there.
this is how they got an image of the sun.
Through the
Looking
earth.
down, they got an image of the sun looking down. That one.
Well, I think there's a way to do it with like a bubble chamber to observe neutrinos. Use done this myself because it's a little bit more complicated than a cloud chamber, but I know you can use hydrogen. It's like liquid hydrogen that they use, and basically the neutrino strikes the proton and it causes to a stream that you can visually see.
That's how you get a picture of the sun when you're looking down.
No, that's not fun.
You
How do
know
you
what
get a
the
picture of the
biggest
sun
joke
when we're
is of
looking down,
all?
Jason? Oh, go ahead, Essie.
No, I was going to say the biggest joke of how they find these things, they smash things together. Like, take two watches, smash them together, and then figure out what it is by the parts. And not even that. It's just like, correct me if I'm wrong, Jace, it's the way, like, the line, if it spins to the left, if it spins to the right, if the squiggle goes that way or this way.
Well, in a particle detector, they just have a detector. It detects like the energy of the thing that hits the detector, and that's how they can tell what kind of particle it is.
Yeah, but don't they smash them together?
Yeah. So
To
you'll have either like large hadron. They send protons around, and from that, the different interaction theories. So the weak interaction, the strong interaction, the electromagnetic interaction. They predict these decay chains based on the energy that the protons have. They predict which kind of particles can come out of that and what energies they will have. And then the detector measures what energy the particles hit the detector with.
And that
yeah,
would
but the way
determine what
they
they decay from.
distinguish between these quarks and don't they see like a pattern with squiggly lines on them?
I think you're
What are you talking
talking about the chambers.
Is that the chambers that does that?
Yeah. So like a cloud chamber and a bubble chamber, there'll be a streak that goes through it, particles. Based on the direction that it turns and stuff, you can tell what kind of charge it has. Then you can put a detector in there to measure the mass, and then you can figure out which particle it was.
Yeah, but you're talking about a single particle. I'm talking about when they smash them together. The way they determine, like, these up quarks, down, and all this stuff. Maybe I'm
Yeah,
remembering it the wrong way. But I just
you can do it. I mean, I do know of ones that have like a cloud chamber kind of detector thing, but the major particle accelerators, they just have a normal CCD detector. You can smash them together in a bubble chamber or cloud chamber if you wanted to, and I have heard of people doing that, so you're not wrong.
Well, that's what I was talking about the high altitude cosmic rays. That's how they used to do them back in like the 20s and before that and stuff like that. Was that they had to go up and high in the mountains and in balloons and stuff. Is that right? So they can try to witness these same sort of reactions. They didn't have access to a accelerator. So that was the best they had at the time.
Yeah, I know like cloud chambers where they were the first thing developed, easy to do in the 20s and 30s, and that's how they say they detected cosmic rays for the first time. I don't know if they had to necessarily go up up mountains and stuff, because you can still, if you just have a cloud chamber laying around, you'll see particles going through it. You don't need to be at certain altitude or anything. There'll be just like a natural background of particles going through. Then you can bring a radioactive source nearby if you want to more concentrated experiments on something specific. You can bring a radioactive source into the chamber and then, do your measurements with that. But there'll always be like a background of stuff going through.
Let me ask, when you're doing an experiment, are you doing a hypothesis test?
Xanax, you're gonna have to say that I don't know what that. I would say yeah, for the most part.
Okay, what do you do for a living? I don't want to downplay your profession when I bring it to Xanax.
Oh, you're such a.
He's gonna wait for you to be there when Xenix's there, and then fucking try to jump him like he did with me and George. He was like trying to jump this old man.
Elbow drops, bro.
Yeah,
Elbow drops from the top rope.
Elbow drop George. He's like, oh, not George. Bob. He's like,
Bob.
He's like, what?
Well, Xanax just never gets at. I don't know what he thinks it is. Instead, if he's saying Jeremy's wrong in that, I've never heard him.
He almost slipped up earlier. Did you hear him earlier? He almost slipped up. He said it's a test of something. I'm like, yeah, that something is the hypothesis.
I mean,
so hold on. What does it exactly you do for a living, Jace?
I'm a biochemist.
Biochemist. All right. You got like a PhD or anything?
I'm a grad student, and I work in a lab, pharmaceutical company.
So you got no PhD?
I'm getting my PhD.
You're getting your PhD. Okay, that's good. That's good.
Do you have a master's now?
No, I just went straight from a bachelor's into a PhD program.
Xanax about to get fucked up on this one. I got a biochemist undergrad on my side now. Here we go.
Undergrad?
No, I'm not an undergrad. I have my undergrad degree. I have a bachelor's in biochem and molecular biology, and now I'm in a PhD program for biochem and molecular biology.
So at this point, it's safe to say you would definitely know what an experiment is.
Yeah.
You wouldn't have made it this far without. Okay, bet.
I think it's Xanax's point though. Like,
nah, don't even try it, Kosho. This is why your obituary is going to be all fucked up.
You're rewriting it with one eye. You have one eye on the prize, man. Listen to me, dude. I'm just guessing. I'm trying to make sense of what he said. He probably is just. Sometimes Xanax fights a good fight until the end, even beyond the point of. There's no point in fighting it. But I think maybe what he was probably maybe what he meant was like you can make observations that kind of turn into tests, I guess, but without a hypothesis. I don't know. I don't really want to try to back him up.
Don't try to rationalize what's going on in Xanax's mind. All right.
Yeah, the thing is, Xanax has been wrong many a times, and
He's
it's
literally
very
always
hard.
Wrong. He's always
it's
wrong.
Very hard
almost
to
always.
Yeah, that's fine, but it's very hard to change his mind when he thinks he's right, but he's actually wrong.
But I just like to make sense. It was funny that when you agreed with him, Jeremy, about the Coriolis thing, and he kept saying that him and Bob agree with each other. But then at one time, I don't think he knew Bob was in here, and he was like saying that Bob was so wrong and all this other stuff.
He did not know Bob was in here. No matter what he said, nobody knew Bob was in here. He must have just got in.
No, I knew he was there. He was there for a while. He was there for like 10 minutes. I knew he was there. That's why I was wondering what it was. I knew Xanax didn't know he was there because the way Xanax was talking. But I think he realized last minute.
Either way, Bob did say that I was the most right. So
you mean Rumpus said you were the
most
right?
But Bob was wrong.
That was Rumpus. Never mind. Sorry.
Rumpus was one of the wrong
people.
Rumpus was one of the people wrong in that encounter.
No, he wasn't. He was on me and Xanix's side.
Yeah, until he wasn't, dude. Because I was
What
on
do you
that
mean
side
until he
too. But then,
wasn't?
yeah, but whenever, what would you ask him? You
Yeah,
said that
when he started telling you about how shit can leave reference frames, and we all know Xanax is never wrong. So there you go.
it was what's his name? It was Rumpus who said they can't leave reference frames.
No, he said you could leave reference frames.
Yeah.
Oh, that's right. That's right. And then Gummy Bear.
He
That's
said
right.
that. Yeah.
You said that you were saying the same thing I was saying, but you said it in more elegant words. That there's two different ways of looking at it. Like there's an object can have a reference frame, and an object can
be in
a reference frame. Yeah.
And he said that my way of saying it is the most correct, but he also still reverted back to the way he was saying it, even though it was wrong.
That's because he can't be wrong. You don't understand. It's the Rumpus. He can't be wrong. I don't think you guys know what you're dealing with when you're dealing with a Rumpus.
I mean, I know I'm dealing with a person who said I was the most correct, Jeremy, so I think I'll settle with that.
Who is the most correct? You or the guy that's never wrong?
Well, Rumpus said I am the most correct. So,
Rumpus said that because he wanted to save face without having to agree with me after he'd been disagreeing with me for like an hour.
He probably meant out of everyone else besides him.
I agree, Jeremy.
Well, Rumpus realized I showed him what he was saying didn't make sense. You can't make sense of it without describing like if you don't describe an object, like any frame that you're in, you can describe any object in that frame, anything it's doing, anything at all. You can describe it from the point of view of that reference frame. And for some reason, he wasn't agreeing with that.
Yeah, I can't wait to see Xanax now. He's about to get fucked up.
But that's because he's only thinking about describing its position as a set of coordinates, like that will stay constant. And that's that's the problem is you can describe anything, but only the things that have the same reference frame will have stationary coordinates. And that's kind of what he keeps getting at, is he can't he's not differentiating between stationary with respect to the frame of reference and moving with reference to the to the frame of reference. Because of course that's kind of the way we use the word, is when we say something has a reference frame, usually what we mean is it is within that reference frame, it is at a stationary point.
Right, which is what we were trying to describe. We tried to describe it earlier with the ISS and people flying to it. We tried to describe it with the fucking Jeremy and the stick. I don't know, he's throwing the stick off the planet or something like that in the light.
Weren't you guys trying to tell us the other day Coriolis is one reference frame? Who was it? Blue? Who was it that was saying that?
Yeah,
well, there is. See, the funny.
It is, dude.
There is
the
never
funny thing
just
is,
one.
See, the funny thing is that example I was giving of with where Bob didn't think it was the Coriolis effect, but it actually was. Bob was telling me, trying to convince me that was just an illusion.
Oh,
it turns out it was actually Coriolis effect, and Bob ended up admitting that. So he went from it just being an illusion. What's up?
I thought you had. I hope you have that on tape.
I mean, it's all on Geo. It's all on the Earth Awakening.
Nice.
Yeah, but that's kind of that's why this the language we're using is kind of strange and stuff like that, because from one person's, like if you're in the non-rotating frame and I'm in the rotating frame, from both of our frames, the path that we see is the actual path, because from our frame, that's the actual path it's taking.
No, it's not.
Yeah, it is. But from your perspective, me describing the path in my frame of reference, that does seem like an illusion to you, and same with vice versa. Well, maybe not vice versa, but regardless, in our respective reference frames, though, that is the path it's taking in that reference frame.
The whole thing is the only way, whenever we say like actual path, the only only meaning that's put to is its path with respect to an inertial frame. That's all that means. It doesn't mean that it's like an objective true path and all else are wrong. All paths are true. It's just that's one of the more objectively like describable ones.
Well, that's
I know you guys don't think you know how to throw a
thing
ball.
that's really going to trigger. You're going to really trigger Jeremy with that actual path. Right.
You don't think we know how to throw a ball in a straight line?
You can throw a ball in a straight line.
That's what I'm saying.
How insane do you got to be to not think you can throw a ball in an actual straight line?
In an apparent straight line, yeah.
If me and you and your kid and my kid, whoever, we're all but in a rotating frame or in a fucking same frame, and we're throwing a ball, and we're throwing the ball in our frame in a straight line, then in our frame it looks like it's going in a straight line. There's nothing wrong with that. But that's not an actual frame. Like that's not the universal frame. That's not like the most correct frame. That's just a frame.
That's what you think because you think Earth is rotating. However, down here in reality, we know how to throw a ball in a straight line.
This has nothing to do with Earth rotation.
If Earth wasn't rotating, would we know how to throw a ball in a straight line, Kojo?
I just told you, in our frame, especially if the Earth wasn't moving, in our frame, we can throw a ball in a straight line and make it look like a straight line from our frame, and blah blah blah. But it doesn't mean that that's the actual path the ball's taking. That's just the actual path it's taking in our frame. Like there's no.
That's the problem.
There's
that's
no
the problem,
absolute
Jeremy.
path.
They keep describing it, and Bacon just said it, or not Bacon. Gummy just said it. When they say actual, they only mean actual in accordance with the reference frame they're speaking of, right? So, but when you say actual or I say actual, we're talking about the objective reality of actual, which is that it's straight because that's you threw the ball, it went straight. Now it may look like it's curved from two different reference frames, but the actual path is straight.
If Earth wasn't moving and Earth was stationary, it would be, no matter what you think, it would be an actual straight line. We're not moving. It's an actual straight line.
The only problem with that is, and I
Yes,
said, I can't convince you.
We're not moving. We're not moving.
That's not the way motion is described. And until you guys accept that, then you can't even go to the next step about anything about motion because that's a bare minimum. It's like the entry. That's a Galileo principle of relativity.
We're not describing motion. We're describing not moving.
Yeah, that's
non-motion. No motion. Our
Yeah,
Earth is not moving.
So, in other words, everything you describe as actual, you're only describing as in reference to Earth. Now, you believe Earth isn't moving, and that's fine, but that means that you're actual. When you say actual, you mean in reference to Earth. And for us, when you reference Earth, that's not actual. That's in a non-inertial frame.
No, I'm talking about the bug on the ball, right? That would be able to perceive if he's going in a straight line or not. The bug on the ball knows he's going in a straight line. He's not curving, right?
But you said he's on a ball.
Yeah, well, if he was able to stay on the ball and not fall off, just like nobody really can, because we would fall off. No, if it's just like this, if you're throwing the ball to the person across the merry-go-round from you, it's a straight line path. We all know that. It may look curved from a different reference frame, but that's just the way it looks. There's an appearance and then there's an actual.
So where is actual measured from?
From the point at which the ball, just take I mean, I know it's all about reference frames, but as far as measured from, well, it depends on if it's, then you could argue that it deviates. If I was going to say a bullet, but then you could argue that it actually deviates because of the Coriolis force or whatever. But I'm just trying to think of like the most straightforward way to say it is that if you're throwing a ball straight, it goes straight. The ball isn't curved. It may look like it's curved because the frame below it curves and you're on that frame. Or you're above the frame, it may look like it's curved. I don't know.
But the thing is, if you do it that way, when you do it that way, you develop circular logic. You're saying that it is actual because it is actual. But when we're talking about actual, we're saying that when we say actual, we mean in reference to the in reference to the inertial frame of reference. So we have a definition for our actual, but you only have a circular definition for your actual. That's what we have a problem with when you say actual, is because you can't actually physically define it without using the word itself.
Yeah, I understand. I'm just trying to point out that the reason that there's been so much confusion over that word. And Jeremy's saying we can't actually throw a ball straight. Of course you can actually throw a ball straight. But the way you're describing it makes it sound like you're saying that the ball's not going straight, or that you can't throw a ball straight. It's because you're saying it's actually curving from this point of reference. And it confuses people. That's all.
Yeah.
It doesn't confuse
No, I ain't
people.
confused. That shit is just
It's
dumb.
nonsense.
Yeah.
It's nonsense. They're saying two things at the same time. They're saying the ball is both going straight and curving.
Yeah, from two different frames
That
of
is a
reference.
classical case of dialetheism.
Blue said it was standing. Blue said it could also be going straight, curving, and not moving. The other day.
Yeah, that's
Blue's here right
who was
now.
saying that the other day? Was it Blue?
Yeah,
Stationary and moving at the same time.
Absolutely. If you're from
Of course.
the ball
There it
is
is.
not.
Okay, so SC, can I ask
Let's
you?
let Bob. Let
Blue talk. Let Blue talk.
Yeah, let's let Blue explain stuff.
I'll try it again. If your frame of reference is the ball is stationary. It is not moving. Everything else is moving. If your frame of reference is an inertial frame, the ball is moving in a straight line, simultaneously with standing still, not moving, if you're in the ball's reference frame. If you're in a rotating frame of reference, non-inertial type, then the ball is curving. It's doing all three things. It just depends on which frame of reference you're looking at.
Now I have to invent a new word, trialetheism, for that one, Blue.
I'll come up with about 300 more of them if you'd like, SE.
Blue, you can't sincerely really believe that.
It's
In
really
one
not,
reference, it's
you
moving
cannot wrap
backwards,
your
and
head
the other is moving forwards.
Listen, I don't want to derail this, but Blue, when you do a scientific experiment, are you doing a hypothesis test?
I'm doing an experiment. When I do a scientific experiment, I'm doing an experiment.
Yeah, and what is an experiment? Would that be a hypothesis test?
Call it whatever you like to. I don't care.
I'm wondering what you call it.
I don't call it anything. I'm not into that.
Not into that? Naming things?
I don't care to.
All right, it's fine. I got the biochemist, undergrad, PhD motherfuckers. We're all good.
Not an undergrad, dude.
Whatever. It doesn't matter.
You know what an undergrad is, Jeremy?
It doesn't matter. I got a biochemist on my side. I'm all good.
You're an undergrad, bud. He is not.
I don't even know what that means. I don't care. I got the guy on my side. It's all that matters.
You know what it means. Stop using it.
Whatever. He said some kind of grad thing. I don't know. He's a PhD. He's getting a PhD. That's all that matters.
He's a student in a PhD program. That's not an undergrad, for God's sakes.
Right. It's not important. What is important is what a scientific experiment is. That's what we should know all the time we spend talking about science.
Yeah, it's important that we name something like that, but it's not important to get somebody's title correct. I get you.
It's not. Yeah, it's not important.
I'm concerned with these petty victories you dwell on, man.
This is not petty. We've been fighting years for this shit. All right? You think this shit's petty? Dude, you know how many arguments I've been in over this?
It sounded like you wanted to beat up an old man last time we did this, man.
Yeah, wait till you see what we're going to do to Zanuck. No more leg drops, all elbows. That's word to Macho Man.
Okay, so can I ask my question now?
Yeah, go ahead.
So I was going to ask. So we have this is based on a question that was asked the other day as well. So we have a car that's moving at 50 miles per hour, and inside that car, a guy throws a ball at 10 miles per hour. What's the actual speed of that ball?
How fast is the car going?
50.
And the ball's going 10?
Yeah.
Same direction?
Sure, yeah.
60.
So that's the actual speed?
You got any more brain busters for us?
Well, no. So are you saying that's the actual speed? There's no more information you need to know.
Don't need to know anything else. Ball's going 60 miles an hour.
Well, because here's the thing: is this was happening on a moving aircraft carrier, and the aircraft carrier itself was moving at 50 miles per hour.
The bus was driving on the ground.
I said the car was driving, and the ground that it was moving on was an aircraft carrier runway, and the aircraft carrier was moving at 50 miles per hour as well.
How fast is the aircraft carrier going? How fast is the aircraft carrier going?
It's moving 50 miles per hour as well.
So 110.
Okay, so
Boom,
that's the
there we go.
actual one?
Yeah, that's the actual one.
Okay. Well, we were actually currently shipping the aircraft carriers. It wasn't in the ocean. It was on a big-ass fucking tanker.
So how many times are you going to switch it? Just stay straightforward, bro.
He's trying to prove a point.
This is the point. So for each one, in reference to the car, it's 10 miles per hour. In reference to the aircraft carrier, it's 60. In reference to the ocean or whatever, it's 110. That's the thing. All speeds are in reference to something. That's my point.
And different dudes in all those different frames with speed guns would measure different speeds.
And they're all
So are you
correct.
saying you can't have movement if you're not referenced to something? Is that what you're saying?
That's true.
Yeah, you can't describe movement if you're not referencing it to
That's
something.
not what I asked. That's not what I asked. I said, by your logic, you cannot have movement without it being referenced to something?
Rotational
No,
movement.
I'm saying you cannot describe movement without it being in reference to something.
Describe movement. Okay.
It's the same thing, though. I mean, I would just say yes to what he said. Other than rotational movement, yourself, then there's no meaning to movement if there's nothing that is referencing.
So you're telling me if I'm traveling now somewhere in this mythical space, right? I'm traveling, let's say, 50,000 miles an hour, example, right?
Then
with
I'd have to
reference
ask.
to some. Yeah, I know you're gonna ask with reference to some faraway star, right? Okay, that satisfies you.
Sure.
I'm moving at 50,000 miles an hour, reference to star A, right?
Mm-hmm.
Now, and I didn't come up with this one. I forget who it was. I'd give him kudos for this. Now, if I'm Thanos and I snap my finger and I remove all matter from the universe, am I still traveling at 50,000 miles an hour, or am I not traveling anymore?
Wait, when you say remove all matter, you mean everything except you?
Yeah.
Just to be
I
sure.
don't think you know how the Infinity Stones work.
What would you say there, Gummy?
I would say, yeah, you're not traveling.
So I'm not moving. I was moving 50,000 miles an hour, but when we removed all matter, somehow I stopped moving as well.
All you did was remove
now you're
that
no
star.
longer. Now you're no longer moving in relation to anything. Because
Yeah,
there's
moving,
only
no?
you. Yeah, but there's only you. And there's no difference between moving and not moving.
Right? Isn't movement based off of distance and speed, distance and time? It's literally just meters per second. So if there's no meters to anything, there's no distance, and therefore you can't have the speed. You need the distance I guess the distance is a necessary antecedent to the speed, basically.
And I would say one thing that would make your question a bit different would be, what if just star A disappears? That would be...
Well, then you would say, how about the other star? Then you would reference it to another star. That's why I took all the stars away.
Exactly.
So you think then you stop moving. You're not moving any longer because you removed
Well, there is
other
no
things.
such thing as movement anymore.
Right. You see how you think?
Because you're not getting further.
Illogical.
Well, you're
Totally
not getting further.
illogical.
You're not getting further or closer to anything. So there, you can't even define movement anymore.
I'm not asking you about define. Are you actually still moving, or are you not moving because there's no stars?
There's no such definition. There's no such word anymore.
No, this isn't that difficult. You know, it's easy.
Yeah, it is easy. It's very easy for me, but I don't see why it's not easy. So you're saying there's no stars, then there's no moving. You stop moving for some reason.
There's no anything.
How about if there's just gas that you can't see it, you can't reference it? There's just, there's space, But there's no visible stars to reference it. Now you still stop moving?
No, now you're moving because you cancel reference to something.
But you can't. It's invisible. You can't see it. There's just space.
You don't have
There's
to
nothing
move.
there.
You don't have to see it to talk about movement in relation to.
Then how are you going to reference it?
Well, are you moving through it, or are you saying it's just really far away and there's some dust there?
No, I gave you a scenario. You're moving. You're moving now, right? You're moving. You're going 50,000 miles an hour. Then you remove all the visible matter, so you can't reference anything to it. Have you suddenly stopped moving, or are you still moving?
I would say you have stopped visibly moving, but since there still are stuff there, then yeah, you'd still be moving.
But what do you mean visibly moving? You can't tell
As
you're
in,
moving all of a sudden.
yes,
you can't
you
hear your
cannot-
engines any longer. You can't feel vibration of your aircraft, your spacecraft. What do you mean you're not moving?
Well, why would there be vibration of the aircraft?
Dude, you never seen a space movie? You hear the engines.
Okay, so first of all,
when you take all visible stars away, all of a sudden your spaceship, the engine turns off.
No, so we've already turned off the engine. We don't need any more speed. We're already going fast. There's no vibration because there's nothing to cause vibration. Okay, so what
now? You're changing the parameters.
Well, yeah, because I didn't like the parameters. They were really dumb.
Yeah, of course. I'm sure you didn't like reality. Yeah.
You add acceleration in there, then you're going to be able to feel that.
Okay, so here's the thing. Okay, let's agree with you then. Okay, the engine's running. Okay, good. Well, then we are moving in relation to the fuel being expelled. There you go.
Backwards or forward?
To the fuel being expelled, huh? Yeah.
Correct.
Okay.
Okay, or no, let's say this is a fuelless car or spaceship. We'd still be moving with relation to I don't fucking know. Anyways, can we move to something that's actually logical?
Yeah, you need that relativity. You just can't let go, right?
Well, I'm clearly showing how without being able to describe motion to something, you don't have movement. Can you describe movement to something without having the something to refer to?
I just did.
By saying,
what's the meaning?
Oh, it's moving 50. It's moving 50 kilometers an hour. Okay, what's the meaning? You're not moving towards something. You're not moving away from something. What is the meaning of movement?
Well, I just gave you a simplified idea so you can see how you think. You don't think logical.
Well, you thought about a vibrating
you suddenly made a ship. Sorry. You want to go ahead or you want me to go?
You go ahead.
You suddenly made a ship that's moving 50,000 miles an hour in relation to a certain star. But when I remove that star or other stars, in your mind, that ship stopped moving.
Well, you removed everything in existence. Then yes.
In the beginning, in the first exam, then I saw where you were heading, and then I left everything. I just removed all the visible things, so you don't have anything to relate it to.
And then I said, yeah, you are still moving, but you can't visually determine your movement, but you are still moving.
You're still moving. Okay. All right.
Yeah.
Good.
Because we can, yeah. Because you'd still arrive at something whether you can see it or no.
Okay. Fair enough.
Yeah.
Like right now, there probably is a star that's moving at 50,000 miles per hour in reference to us. And from that star's reference frame, you'd be moving 50,000 miles per hour. And, that's irrelevant. It's irrelevant to you, but it's still some movement that can be described. And it would disappear if you made the star disappear, of course.
Well, one question would be, yes, you witness this star, and you say that you're moving at 50,000 kilometers an hour. How do you know if you're moving towards the star at that speed or the star's moving towards you at that speed? How do you know the difference?
Well, that last scenario, I was going to say, it's kind of interesting because without the matter to reference anything, it'd be like the opposite of what you guys say the globe actually does, where you could actually feel like you're moving, just not be able to tell if you are.
No, you wouldn't be able to feel it either.
Yeah, there's no reason to feel it either.
There's nothing to feel.
Well, no, I'm saying, what if you were moving in a way that you could actually feel the movement, like you have that sensation of movement? You know, like
so
flying.
So if you made the statement that in this scenario we can feel movement,
yeah,
well then you've kind of solved it by just claiming that we can feel this thing. But the thing is, you inherently cannot. That's
I wasn't trying to solve it. I was just pointing out that it would
I'm
be
just
the opposite of the globe. Where you could feel it, but you just couldn't tell if you are.
Yeah.
And the globe, you're supposed to be able to see that you could be moving, or the stars could be moving. But if you are moving, you just can't feel it.
Yeah, because we don't feel movement.
Says you.
Well, no. Says anyone ever who's ever tried to describe it.
I know. What do you mean you don't feel movement? You can feel acceleration.
You never feel movement. Yeah, is acceleration movement? No, it's a change in movement.
Type of movement.
Okay. Well, now it's just a definition scheme. If you don't want to call that a change in movement and call that movement, then sure, we feel some kinds of movement, not all.
Well, there's water. You know, the vestibular system in the ear uses water, and that's part of how we know we're level, because the water is level, and when you're standing upright and so on, when you're lying down, that's how you get the different sensations. So, in what you're claiming, do you think that you could have glass calm water that's moving at 60 miles an hour?
Yeah.
How? No ripples, no movement at all. 60 miles an hour. You've got to have that water be absolutely still, as if it's just stationary on the earth.
Yeah, 500 miles per hour.
Yeah, how could you do that?
You'd need to get it moving, and in order to get it moving, of course, you have to apply a force, and that will create ripples. But if you then let it calm down, then there's no more things to make it ripple.
Yeah, how are you going to maintain? How are you going to maintain it moving at that speed and have it be absolutely still without moving?
Well, you'd have to. Okay, if you're saying that we have to do this on Earth, then yes,
that's what you would need. That's what you would need. I'm making the relation that there's water in your ear, so that's what you would need. You would need to have the water be like, if I'm sitting here completely still, the water in my ear would be absolutely still. What you have to then do is move me at 500 miles an hour and have the water be as still.
Well, the problem with doing it on Earth, and why we would say that we can kind of feel movement on Earth, but we're not actually feeling the movement on Earth. We're feeling the wind resistance. And that's the problem. If we were to try and move a large amount of water, it wouldn't be the fact that we're moving. It would be the fact that we've got wind resistance that we have to counteract, and that would create ripple. But if it's in outer space where you don't have drag, then yeah, there's no problem with that. But that's why we would say we don't feel movement. Even on Earth, we would feel the wind resistance.
But that didn't really
But outer
address my
space
question.
isn't empty. Outer space isn't completely
didn't really
empty.
answer what I was saying.
Here, let me give it a try, Gio. Right, so
You went to outer space. I'm not really talking about going to some other land that you've never been. I'm talking about here on Earth, because that's what we're talking about.
All right, let me give it a try. Right, so the water, say I accept to any speed, be it 50 miles per hour, 500 miles, whatever it be. When you go from your reference position on the Earth and I start accelerating you, the water in your ear is going to start moving, and your vestibular system will register that. But once you get to that constant speed, the force is taken away. So now the water in your ear, that system is going to settle back down into a state that you're just in constant motion, like you're on an airplane or something, right?
Yeah, I understand that very basic idea, but the question was about feeling movement. Now, I would be willing to say, and obviously this would be kind of hard to do, but if you put like blacked out the windows in an airplane and then blindfolded me or blindfolded someone, and you don't tell them whether they're getting on the airplane or not. Now you could like you could just have an airplane on the ground. Problem is you'd have to simulate the sound to make it sound like you're moving. But are you trying to tell me that if you blindfolded someone that they wouldn't be able? I mean, I see. It depends on. We say field movement's a little bit subjective, you know. So like different people may be different. I mean, some people you can punch them on the arm, they won't feel it. Someone else you punch them on an arm and they're in crying pain. So obviously there's differences in people's bodies and sensitivities and so on. But I can absolutely tell if I'm making movement through the ether without any question of a doubt. Even if I'm on an airplane, there's actually noticeable forces on an airplane. When you, even if the airplane's going the normal 500 mile an hour speed, when you walk to the back of the airplane to go to the bathroom and you walk back to the front, I can absolutely notice that I'm walking backward or forward. And if you blindfolded me, if you blindfolded me, I would be able to tell which way I'm going back, forward or backward.
Would you be able to separate that from the fact that most aircraft travel, the attitude is about 1 degree incline, so that they're getting lift from the body of the plane as well? So most planes fly with their nose slightly up into the air.
Yeah, I'm aware of that. And yes, I can delineate the difference.
And then also you do feel turbulence.
In all practical situations, there's always very minor, be it vibrations or accelerations that you can obviously feel, and you know you're on an airplane, you can feel it vibrate, etc. But it doesn't feel like you're in takeoff constantly, right? So if we were to idealize this, where all other nociceptor sensations are cut out, all other vibrations and things like that of these trains and airplanes are cut out, it's just the constant motion, you wouldn't be able to feel that, right? It's impossible to do in practicality, but we're talking about an idealized situation, I think is what the Globers are trying to say.
Well, the way I've thought about testing this would be to take a device, kind of like those gravimeters that take a little ball and drop it, but like basically make one like that. So you'd have like a machine that would drop a ball, right down onto a plate. And then the plate would have sensors all over it in every little square millimeter, so you could really detect exactly where it hit. And if you were, just stationary on the earth and you drop it, the ball is going to go right down and hit the exact center of that little plate. Whereas if you were then on an airplane going 500 miles an hour and you did it and you drop the ball, you wouldn't drop it with your finger, it'd be part of the device. But if the ball drops, will it go straight down and hit the center, or will it drift back a tiny bit? Because the ball is only keeping that 500 miles an hour as long as it's being kept, held in that 500 mile. The minute it's dropped, it starts losing that 500 mile per hour momentum.
No, it doesn't.
Well, the way I just described would be a way to test it that would be pretty detailed, that I've never heard of being done quite in that way before.
There's no reason for the ball to lose any momentum.
Well, things don't just move through the ether without being kept at that speed. You wouldn't stay moving at 500 miles an hour unless the seat of the airplane was pushing against you, keeping you going 500.
That's not quite true.
What you're saying is at odds with Newton's laws of motion. So
yeah, because those are wrong. They're false.
Well,
that's something you'll have.
What else is new?
Yeah, that's something
you conservation of momentum holds throughout. It doesn't dissipate at all. They think
Newton's laws have been proven true over and over and over millions of times, and to say that they're false, you would need to demonstrate that.
Okay, I will right now. An eagle picks up a mouse. An eagle picks up a mouse, starts flying, right? It's flying at 10 miles an hour. It releases the mouse. Are you going to say the mouse is going to keep its conservation of momentum forever? It's not going to fall to the ground?
Yeah, it starts slowing down. Now they would say the wind would be blowing against it, air resistance. Obviously, on an airplane, you don't quite have that. So they would say the drag, but even if you made some kind of canister for it that would block that, absolutely it would start to slow down. It's not just going to keep going 500 miles to the end of the world. What goes up must come down. What starts moving will stop moving. The resistance of the environment, of course, it will stop.
No, of course it's not. There's no reason for it to.
I told you that's what they think, Gio.
There's no reason.
Yeah, no, it's slow Earth relativistic pseudo physics that they need to support the fake model.
I'll tell you what else I can do. I can put you in the airplane in a 20-degree bank. You won't be able to tell it, and I can drop the ball, and it will still land in the same spot.
Except if you have a drone that's stationary in that plane and you bank it, the drone flies into the side of the wall.
The drone's independent. and it's flying under power.
That's right.
That's their conservation of momentum. That has to be like that, or else their whole thing falls apart.
Exactly, because they're telling us we're all spinning on the globe and we're all just going along with it all, and we can't tell.
Yep.
It is like that. Sorry to bust your bubble, but that's the way it works.
At 1.2 million miles an hour?
Relative to what?
1.5.
Relative to
Yeah.
what?
Have you guys ever heard of the process called blood spinning?
Centrifuge?
Centrifusing?
Yeah.
Yes.
Right. So why is none of that going on when we're spinning so much?
Gravity.
Well,
It's only one revolution
What-
per day. Come on.
Yeah. Like, what's the speed and the radius that centrifuge is
Well, it all
going?
adds up to
Is
millions
that,
of miles, right? I
that
mean, even
we're
1,000 miles
not
per hour is a
quite
lot.
doing that, right? We're not going that fast, tiny of a radius.
Well, just because it's relative to something else doesn't make it a slower speed.
Well, we're in a
No,
centrifuge moving twice as slow as the hour hand of a clock.
That's only if the Earth were as small as a clock.
No.
Yeah, because if you made that clock as big as the Earth, that hour hand would be moving at 1,000 miles per hour.
4,000 miles away, it would be. Yeah.
That relative doesn't make any difference. You're still moving. The hand would still be moving at 1,000 miles per hour.
The hand was still
But it's not when it's the size of a watch.
That's the angular velocity of it. And the angular velocity is not dependent on the diameter of the damn thing.
Well, the hour hand of the hour hand of a clock doesn't move at 1,000 miles per hour, does it?
No, of course not.
Well, the tip of it would be if it was as big as the circumference of the Earth.
I don't disagree with that at all. Absolutely.
There you go. That's the difference.
But the centrifugal force of the hour hand on a clock is no different than if it was 4,000 mile radius. It's the same out there as it is in there.
Are you sure about that?
Isn't that right?
Say that one more time.
The centrifugal force of the hour hand of a clock is the same in a 1 foot circle as it would be in a 4,000 mile circle. Is that right?
No, I don't think so. Just because the centrifugal forces, the radius is included. If I understand what's being said correctly.
That would be an interesting calculation.
Yeah, I always mess around with stuff like that. Remember that time? I don't know if you remember. I was just trying to describe how you would make a ladder go to the moon. I got the math all wrong.
No, the centrifugal force, the acceleration is omega squared r.
So yeah, the radius changes it.
Right.
So what does it calculate on the Earth? Isn't it like 0.03 meters per second squared or something like that?
Yeah, that's right.
Yeah, about that at the equator.
And then you got gravity opposing that at 9.8 meters per second squared.
And that's by far the strongest. When they talk about all the different vectors, that's the biggest acceleration is the that rotation, right? The centrifugal force. But like all the orbit and all the other movements we're doing, regardless of how fast it's going, the accelerations are much smaller. I've asked this before, Mr. Perspective, but it's a fair thing to think about at least. But try to come up with a way that you can feel movement without feeling acceleration, without feeling wind or anything like that. Just if you were moving 1,000,000 miles per hour versus 10 miles per hour, how you would feel that?
Just the fact that you would entertain that notion, like ask that question, is mind-boggling.
It should be easy to just answer it then. It should be a simple
Okay.
answer. Maybe look like a
You're
fool.
asking me, how do I tell the difference between 1,000,000 miles per hour and 10 miles per hour? Really?
Saying what is it about that speed that you're gonna experience? Not the acceleration, not the wind resistance or the friction or you moving past some object, just you moving at those two different speeds.
I don't know. I think that there are probably a lot of things that would go on, regardless if there's a difference in the way you would feel if it was constant, but just the movement in that direction, at that speed. I don't know. I can't even imagine what that might be like. I mean, I bet there'd be like some kind of real health hazard to it. That's for sure.
Well, imagine 1 mile per hour versus 1,000 then.
Well, because other than this kind of space medium that government agencies claim essentially that's out there, other than that, what we're used to speed being is moving, traversing through the environment, the atmosphere, whatever you want to call it, and there's resistance and there's turbulence and all of that involved. So that's the only way we've ever experienced or measured speed on any level. Now they're making this claim of a vacuum and all this other stuff, but so I mean, 1,000,000 miles an hour here on Earth would be absolutely inconceivably fast.
Yeah. How they get away with the vector math is crazy. Saying that it's all one smooth motion, completely frictionless.
Oh, that's another.
Every single, they take all these different directions and move it and put it all into one thing and then times it by G and all that, make it one constant motion. That's the way it works. That's the way the math says it must be that way.
Yep, I counted 11 of those vectors a while back.
Yeah, and what would you feel, Etsy? What would it be that you feel as opposed to being
I mean, you just think about it. I mean, you can drink a cup of Coca-Cola or whatever. I'm here in my truck. I got me a cup of Red Bull, and I'm going 65 miles an hour. If I were on a plane going 500 miles an hour, I could still drink that cup of water. I mean, it's not like the cup of water's hung out of my hand.
You don't see that's a non sequitur though. I mean, it's one linear direction.
It isn't. It's a difference in
one linear direction at a constant
and 500 miles an hour. It's just the difference in speed, and you're not going to tell the difference.
Well, but there's acceleration changes, there's momentum changes. Especially because it's going so fast.
Well,
who's to know what those acceleration changes? I mean, I know you can calculate it and make it seem like one vector, but there is direction changes. You have to admit that there are momentum changes and acceleration changes. You can minimalize them and think that it wouldn't be a problem, but I would imagine it would be.
There should be every day as the Earth spins, because when you're on the one side of the Earth as it's spinning, you'd be going with the movement of the Earth around the sun, and then every time when you spin back around, you'd be going against that movement. So there'd be change in just that movement every day.
Yeah.
In reference to...
That's hilarious.
Hey, you guys, you know what would be hilarious? Wouldn't it be funny if we really were on a spinning ball and you wasted all this time talking to us?
Can you imagine if we were moving? Oh my God.
Yeah, well, what you said a second ago. Oh yeah, right. The different. But that's why I asked you about the speed. Like, what would you feel with the speed? And then you said, oh well, there's the accelerations. We already told you. We're not trying to downplay the accelerations. We're just telling you plainly what those values are, and they're just absolutely small. So you can talk about the accelerations, but they're absolutely small. And you can talk about the speed, which is what I'm asking you about. But I think you'll find that when you're just talking about the speed and you're isolating it from everything else, that you realize that there's no answer to that because it It just isn't a thing. You can't. There's no experience. There's nothing that you will experience with it unless you're interacting with something that's moving at a different speed. In which case, you're talking about relativity. You're moving relative to something else, so you're going to have a reaction.
What's your response to running back and forth on the bus?
People have to explain their experience doing that, but usually what they're not realizing is when that's happening, that's when the bus, which is stopping and going and stopping and going, it's accelerating. If it's a constant moving train or a constant moving plane that's not accelerating, you're not going to have this experience.
I absolutely disagree, and I can only say from my own personal experience. But if a bus or a train or something like that I'm in that's going the exact same speed, 55 miles an hour, if I go to the back of it and run to the front versus going from the front and running to the back, there's an absolutely noticeable difference. When you run from the back to the front, you feel like you're like in slow motion. It's like you're in quicksand. And when you're going from the front to the back, you go so fast, it's like you're going to fly into the back of it. And furthermore, I'd be willing to bet that if you blindfolded people and did this like as a double blind test, that even statistically, people will be able to tell whether they were going forward or backward.
Do you think do you think that happens in an airplane going 600 miles an hour?
Yep, it's similar. Yep.
So if you think it would affect you on a 50-mile-an-hour bus, would you compound those effects on a 500-mile-an-hour airplane? Wouldn't it be such a great force that you just couldn't go forward? It's ridiculous.
Well, there's a different ratio because, essentially, if the bus is going 55 or 500 and you're on the bus or you're in the airplane, then you're now going that speed. As you run from the back to the front, you're now picking up speed. You're using the 500. It's like being on a treadmill. You're using the 500 speed, 500 mile an hour of the plane moving, and the fact that you're already going 500, and then you're now moving forward. So now you're going to go 501, 502, 503. When you're going from the front to the back, you're also, before you start, you're going 500. And as you start running back, now it's like a treadmill. So that 500 is pushing you that way, and you're getting more speed going backwards.
It doesn't work that way.
It's like you're running on it. It's like you're running against a treadmill versus with it.
Excuse me, but I'm going to go hang myself.
Don't say that.
Well, we don't.
It's okay. It's okay,
Please don't do that.
It was specifically
Soil 911.
It was specifically targeted towards Blue, and he laughed, and I know it.
We can't condone any.
It was just a joke. It was just a joke.
We don't know that.
Call the suicide hotline ASAP.
They'll kick in your door and shoot you, trying to save you.
I can just see Brenda calling him up. Oh my gosh, these people, they don't think things work like I do.
Well, the thing is, Joe, what you just said, though, about the running with the 501 and 500 miles per hour, if you didn't feel the 500 miles per hour because you were moving with the plane, then why would moving 501 miles per hour be anything different than just moving 1 mile per hour?
Momentum?
Yeah, that's right. Momentum's there, but how is that making a difference? Your momentum is the same. Your momentum is with the plane, the same speed the plane's going.
Turning. The turning at each end would give it away.
You turning or the plane turning?
No, you, as you're running backwards and forwards.
I don't think so.
Well, it's because, the medium is the medium. Let's say for a moment the medium's stationary, just for the sake of this discussion, and then the plane's going 500, you're going 500 with it, and if you change your movement one way or the other, it's like you're using the floor of the plane essentially as a treadmill at that point. You're already going as fast as it, so it's not like if it was just going 500 under you, then it would rip your legs off. But obviously you've already been brought up to that speed by the fact that it took off and you slowly got up to that speed.
Yeah, but you're explaining it just fine there.
Exactly.
Yeah.
All right, so let me ask you this: if you got 30 people, had a big airplane with all the seats taken out, and it's all perfect in that way, and you could even evaluate like the tilt of the plane. Like you could actually, even though you'd be going down a little bit in altitude, you could actually make it level instead of being tilted up while the people do it. But anyways, if you blindfolded all of them in an open plane like that and had them run from the front to the back to the back to the front, do you guys think there would be a statistical consistency that the people would report whether they felt the momentum, either way?
It would depend on how smooth you could get that plane, which I'm not sure if you could get it all the way smooth. But maybe you could. It's possible. But I think
But
there's still
the turbulence is not really the factor. The factor is when they start running, do they feel like they're running, picking up speed, or do they feel like they're running against in quicksand?
Yeah, no, but just by virtue of the plane using lift, it's going through the air and it has to use. There's going to be drag on the plane, and even though they're going to cancel each other out, it's not going to be perfectly. So yeah, so I think it's possible that some people might not feel it, and some people will feel slightly though, but be able to pass that test or whatever.
But my point is that they're blindfolded, so they don't know whether they're going front or back at all. In fact, you could even make it more complicated. You could have a control group that's on the ground. Like I said, you'd have to simulate the airplane sounds, but you could have one that's on the ground as well and have them run forward and backward.
I forgot what I was going to say.
I think a more scientific way to do it would be like the ball dropping, the gravimeter type. It wouldn't be used as a gravimeter, but a little machine that would drop a ball. That would be a little bit more measurable and scientific rather than using people running around with blindfolds. But
you use your phone. Your phone has all these tools on them. You can use this in your car. I mean, I used the GPS and the other shit when I was on the airplane last time, so I wanted to see like the speeds I was moving and stuff. But I was going to say something to you before you brought up that test. I forgot. Yeah, right. What you said about the treadmill. What you said about the treadmill was completely correct. That is just like doing that, but that's what being on a treadmill. The treadmill's not moving at all, and the conveyor belt is, and the speed that you're actually moving across the conveyor belt is the speed the conveyor belt's moving. That's how it knows how fast you're moving. So, that's exactly what would happen on a plane too. If the plane's moving, or if it's stationary, and you're stationary in reference to it, you're going to be moving at whatever speed. The speed that you're moving is going to be in reference to the plane. The same way that when you're on the treadmill, the speed that you're moving is in reference to the conveyor belt, not the ground. In reference to the ground, you're not moving at all.
I do think that a good thing to do would be to test it with a blindfold. But the thing is, I thought of maybe a chair on wheels, but you would feel it. It would depend on the floor. You would feel the bumps in the floor. Maybe if it was on a track, you built a track.
They have really fast speed trains, and so speed trains have little friction.
Just like in somebody's garage. I'm thinking about something that they could do that would be easy, and you could do it in your garage or your basement. A
Only if you
blindfold.
have this, like the most fantastic imagination in the world. Can you imagine traveling at 1,000,000 miles an hour and any apparatus and not feel it?
Well, I put a video in the chat of a train moving at 350 kilometers an hour without a coin rolling backwards or forwards.
So you think if you were in there blindfolded, you wouldn't feel it, eggshells?
I hold with most of the people here that are saying the only thing you'd feel are bumps and movements in the tracks. And if the tracks are laid very well, as it appears this train has taken a video from, no, don't think you would.
You wouldn't feel no vibrations at all.
There is no known way to feel displacement.
Oh, the water
If it was
has some
maglev. Maybe it was maglev. That would be cool.
So imagine being on a tilt-a-whirl. The one that like at the carnival, it goes like up and sideways in circles and all that. So how would that have to move so you couldn't feel it?
No, you're going to
not
feel all of
changing vector drastically. That's all it needs to be doing, not changing vector drastically.
You know what you could do, writing, is you could buy one of those big neodymium magnets, and you could get some liquid nitrogen. People can get both of those things, and then a track or a rail of some kind in your basement or your garage. That could be cool.
Or you can go on a plane when it's smooth weather, and when you're in cruising altitude, you're not going to feel any motion.
That's a cool video, Eggshells. The water moves a lot.
Yeah, the water is definitely jiggling and wiggling, which makes sense.
It's
'Cause obviously,
all over the place.
yeah.
All over the place, or just
That idea with the coin made me think of another way to test this, similar to the running back and forth, or similar to the little ball that would be dropped. But you could possibly do it with a coin like that too, or like a wheel, where I'm not surprised that coin is like that because it's being kept to the same speed of the train. But if you then had a way to, not just with your finger, but like mechanically, to push that coin forward or backward, like kind of like Brenda was saying, maybe on a track or something like that, but you're pushing it with the same force, it'd be interesting to see whether the coin rolled as far going forward as backward. If you put the same force rolling it after.
See, I'm thinking of an excuse to buy a big ass magnet and some liquid nitrogen. That's all. Because you can do a lot of stuff with that. A lot of stuff.
This train example with the coin sitting up on its edge and the pin standing up, the bottle of water, it's a perfect example of what we're talking about. You just do not feel constant speed. That's all there is to it.
There's just no way to feel it. Yeah.
Seriously, now you're equating
ways to feel it we haven't found.
Yeah. You would have to
Are you
have
guys
the
seriously?
train flipping over and going in circles, and I mean, you'd have to have the train doing a lot more motions than that to compare it.
Well, no, there's
100,000 times faster.
There's it's deeper than that actually, because it's not that there's no way for you to feel it. There's no way for it to affect you.
I'm just looking for an excuse to play with dangerous magnets and chemicals in the name of science. That's all.
I don't know, entertaining
You're
that
just
kind
not
of speed.
you're just not getting the humor. What is wrong?
No, we
These are
got it.
good
We got it,
jokes.
Brenda. Ha ha.
These are
We got
good
it.
jokes. They're good jokes. Come on.
Are you guys in disbelief that you can't feel constant motion? Is that like a groundbreaking discovery, or some people doubting that?
Well, it
Are
relates.
you claiming that you're traveling in a linear path? Is that what you
Are
think
you
constantly?
claiming-
Or first of all, is your sphere, is that a linear motion? We'll start off with that.
It's a constant motion. It's not
Is a
accelerating or
linear
decelerating.
motion considered a
Do you
constant
deny
motion?
the feeling of constant motion?
It's not what I asked you.
There's a lot
Listen
of
to the
factors.
question.
I mean, I started with a question, then you returned my question with your question. So I don't understand.
Did you start off? My bad. Please go ahead.
Yeah. I asked if is it groundbreaking that you can feel you can't feel constant motion, was my question.
Well, it depends, because in your brain, in your guy's brain, somehow you can eliminate the sound, the vibration. Somehow you think that you can eliminate all those things, and if you can, then your question makes sense. But we try to tell you in reality, can't do that.
We
Because
always
you're gonna feel, no matter what apparatus you put us in, I'll bet you $1,000. You blindfold me, put me somewhere, and I'll tell you if I'm moving or not.
This guy
Pick
new?
anywhere, pick any device here on Earth.
Is this guy new?
Yeah, I mean, that would put to rest the question of feeling it. But the thing about the motion of the kind of globe Earth idea is that you're not just moving. Like in a train, you're going one direction. You're going forward on a straight
Exactly.
line
Yes.
in one direction. On a globe, first of all, you're on an oblate spheroid, as you guys would think. So there's that. And then the Earth is spinning. There's the equation of time, which is another factor, so that there actually is variation as much as 7 minutes difference. But that's just a more minor one. We'll leave that out of it. But you're spinning every day. So you're literally changing direction all as you're spinning one direction, the other direction, that's happening. And then that whole thing is going around the sun, supposedly, and that whole thing is elliptical. So the fact that it's elliptical would have all of those changes. And then the whole solar system going around the great attractor, et cetera. So you're going in multiple different vectors.
Yeah, that's where
That's
I was
all
leading to. Yeah,
extremely
exactly.
slowly.
Very, very slow, considering it takes how much, a year to go around?
Yeah,
Very,
slow.
very slow.
Yeah, it's
Just
like
very
vectors,
slow in
Victor.
terms of the distances out there and the size of the Earth.
So
Slow
very
vectors,
slow.
it's like
Victor.
5.5.
Victor.
It's like 5.5
They're-
trillion. You guys would claim it's 5.5 trillion miles a year. So that's not a small amount.
That's
massive.
In terms of space, it is very small. The distances, yeah. In terms of Earth distance, it's very, very long. Very, 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 very long. But in terms of the size of our or what we understand space is, it's very, very, very short distance. And
Yeah,
very
relative to other things, you can call it slow, but it doesn't
Yeah.
change the miles per hour.
No, the miles per hour is not like, okay, so here's two questions. And if you can't answer it, then we have to go to the other question is, how do you observe, or how does speed affect you? And you're going to say acceleration. And I told you.
And change in
all
direction.
the things that you guys just described, the change in speed, the acceleration, those values are extremely small. Very, very,
And
very
change
small.
in direction. Don't forget that.
Yeah, change of direction. That's change of velocity. That's acceleration. So that acceleration that's being described, I can give you all the values, and I can add all the values together and compile them onto each other, and they're still going to be less than. They're going to be slightly more than the centripetal or centrifugal force of the Earth rotating, because it's just going to be added to that.
Oh, don't worry. I'm sure they took all of these factors into an account when they reverse engineered it, so they knew they could convince people that it would be very minimal relative to the rest, and that you could really make it, seem like you're going this fast and this far, and you had to make sure of that. They couldn't just say, "Oh, well, it's going this fast," and yeah, you just don't feel it because you don't feel it. There's no backing behind it.
Dang.
So when they reverse engineered it, they did it very carefully, I'm sure.
Okay, he gigs up. He caught on. Gigs
Busted.
up.
I think we all did, Brenda. That's maybe you haven't yet. I don't know.
So you guys think you can travel at a spot at 1,000 miles an hour in a non-linear circular motion without feeling it? Is that what you think?
Depending on the magnitudes, and as we just expressed multiple times, the magnitudes are extremely small.
So let me repeat that again. You can be standing at a spot traveling 1,000 miles an hour in a non-linear path, traveling in a circular path and not feel it.
Wait, non-linear? Is that what you said? Non-linear?
Non-linear, yes.
That's what,
because the rotation of the Earth is what again?
Rotation.
Exactly. And what is a rotational path considered? Is it constant?
No, it's accelerating. Of course.
Thank you.
Yes. It goes at the whopping speed of 1 revolution every 24 hours.
Mm-hmm. Yeah, of course you're going to go to revolution. 1,000 miles an hour at that speed, at that spot.
Yep.
Non-linear motion, constant acceleration.
Yep.
Just
You're
that
right.
alone. Never mind the other motions that Gio explained.
Yeah, you're absolutely right. And in fact, your weight will be different depending on where you are on the Earth, because different parts of the Earth are faster than others.
And yet we don't feel anything.
That's measurable.
It sure is.
I heard Neil deGrasse Tyson's say the other day that if you go to the equator versus at higher latitudes, that you could weigh as much as like 6 pounds different. He told the guy on this interview.
Wow.
The guy said he weighs 192, and he said, "Well, if you went to the equator, you would only weigh 185."
Wow.
There would be a difference. I'm not sure that's the correct amount. I don't know.
So if you're a fighter and you're trying to cut weight, you can eat that pizza, a couple of days before, because you'll weigh 5 pounds less and you'll make the weigh-in.
think Neil Tyson got that wrong, to be honest with you.
Yeah, he did.
Yeah, that can't be right.
He's
Yeah.
a fact. He's an order of magnitude off.
Yes.
Oops, another thing Neil
He's
got
human,
wrong.
though. He's
Bam.
human.
About 0.3% from the pole to the equator.
That happens when you talk faster.
Maybe
than
got the
you think.
decimal wrong. Got the decimal wrong, maybe.
You guys got to fire him and get a new science communicator.
Why he's fine? I mean,
I tell you
Well,
what,
we
if he don't,
Globers don't really cite him that much. I mean, you guys do, not us.
Well, he's one of the only ones out there sort of pushing this globe thing, it's, in terms of the mainstream, at least.
Bill Nye, but he doesn't.
Bill Nye, the bow tie guy, is doing it too a little bit, but not really these days as much.
They're both clowns. Why do they put clowns in front of us to represent your side? It makes no sense.
man, it wasn't my pick.
I agree that they're clownish, but apparently people feel that that's what sells well in the market, right? That's what.
You mean Don Pettit? He's a selling point. Don Pettit.
Well, the marketing. I mean, I don't know. I'm just saying maybe the people in marketing say this is what gets us the most views, the most clicks, or whatever. I mean, I don't know.
I think they're trolling us.
Yeah, well, you know I like Don Pettit.
He's my favorite astronaut.
By the way, Coach Joe, did you ever find any childhood pictures of Don Pettit?
I stopped looking pretty quickly.
Yeah, because you couldn't find him. That's why, right? Mm-hmm.
No, it just seemed like a weird thing to even do.
Why was he? Was he never a child?
Yeah, I know. As I'm saying, I don't even know what the point of.
Should be some background information on the guy, some history to his childhood, pictures and stuff. He's a famous guy, right?
Yeah, Howard, he was grown in a laboratory as a grown adult.
Yeah.
He's not really a famous guy.
I think it could be Steve Jobs just trolling us.
Yeah, maybe. It's not like Don Pettit's really in the spotlight. You know what I mean?
Well, I've heard he's an expert of what you do if you get a leak on the ISS.
Well, you have a leak. Of course, you have a leak. And chugga, chugga, chugga.
I mean, I'm surprised they even let that guy even if NASA was legit, why would you have that guy speaking about anything? That would be like if you had a company that was a multi-million-dollar company and you put that guy as your front man to talk about why we can't go to the moon anymore.
I don't know.
Exactly. That's why I say they're trolling us. They're trolling us with.
I would say that they barely know that you even exist. To be honest, there's just a very small community of people who are flat earthers.
Just look at that guy.
That's actually not true.
After one interview, would you hire? Would you let him back on TV again? Seriously, come on now. You're the CEO now, and you see this guy talk on TV, right?
Well,
are you going to fire him right away or what?
They were going to get Buzz Aldrin to do it, but he kept punching people.
Yeah. Yeah, but Buzz at least, had some spunk in him, This guy's a total moron. Like, there's no other word to explain it.
Don't ever talk about Buzz Aldrin like that again. Wow, I'm putting together these numbers, my man, for USC, and it's not really. I don't know what to say. I don't know. Now, imagine take a nuclear submarine, right, or any submarine, right? I got
they
it.
do drills, okay? Now, even the cook, the guy that peels potatoes, he knows his place in the. When there's a leak. And they form a line, and one guy does this, the other guy does that, right? Even The guy that peels potatoes knows his place and what to do when that siren goes off. And this guy spends the most time on the ISS taking pictures of anybody, and he doesn't know the safety drill?
You think
Really?
he doesn't know the safety drill?
Yeah, he doesn't, clearly.
Clearly?
Clearly, when asked, he said, there must be a plan, something
No,
that
he didn't say
involved the
that.
space.
He said, if you
That's what
got
he said, yeah.
you got a leak, you got a leak.
You didn't see the interview?
Yeah.
The lives of everyone on board are only at stake, but he took it as, you have a leak. No big deal.
Yeah, because I don't think it is that big of a deal to him, at least. Either the station's gonna blow apart because there's a catastrophic leak, or it's gonna be contained, because it's been contained, or it's gonna be so small that it's not. They put duct tape over it.
You have a leak.
Duct tape.
Yeah, that's what
Duct tape, your thumb, duct tape, a little gum, bam, done.
I mean, they do say duct tape can be used for anything, but plugging holes in a space station, really?
Yeah, sure.
Me too.
The pressure would not be that great.
Yeah.
Oh my God.
Well, somebody worked out there was one where a micrometeorite punched through part of the hull or something a while back, maybe a year or two back. Yeah, somebody figured out what the pressure on that would be. It wouldn't be much.
Then why do you need a spacesuit to be outside?
Because there's no air.
So you could just go out there with just one of those little scuba tank things, those portable ones, and you'll be fine?
No, of course not.
Why not? There's not much difference.
I didn't say that.
15 PSI, that's the difference.
It's less than half of the air pressure in your tire.
Yeah.
So what would happen to your body if the scuba tank ones that are like a foot long? You just put it in your mouth. So what if you just floated outside with just regular clothes on, street clothes, and one of those things to breathe? What would happen to your body?
You're gonna die. At any altitude above about 57 or 58,000 feet, you got to have a pressure suit.
So why would you die? The pressure on the blood?
Yeah, you're going to literally bleed out through your skin.
Wouldn't your blood boil?
There'd be a lot of things that happen to you.
If I remember right, you sort of feel it on your mucous membranes, the oxygen coming out of like your saliva, so it would feel fizzy. If I remember remember reading an account. They said that's what they felt.
Yeah, that's the single test they've done that we have of an actual in a vacuum chamber, and
it was a. Sorry,
I think that's the one you're referring to.
Yeah, it was his saliva starting to boil. It was his saliva starting to boil because water boils like when you get close to a vacuum. He said his like before he passed out, his saliva was bubbling, starting to boil.
Yep.
Yeah, it makes perfect sense. The problem is that the rest of you starts to boil too.
Is that where they say your blood's boiling? Is that where it comes from?
It's different.
I know, I'm just kidding. I just thought about blood boiling.
So you'd think under those conditions, like the guy that spends the most time in the cupola, he'd know what the procedure was, right? It would stand to reason.
A 14.7 psi pressure difference across the railroad car. What's the pressure on the ISS?
14.7, Brian. In a quarter of an inch hole, you just stick your thumb over it. It's not a problem. Try it. Get a vacuum pump and try it. No problem.
I don't think differential's the same when you get down by a vacuum, man.
And it's exactly the same, Brian. Get a vacuum.
Sure about that?
Yeah. Get a vacuum chamber and try it. I have.
Yeah, I could do that. I haven't never done that.
You brought a vacuum down to 10 to the minus 12 torr, Lou?
Well, it doesn't matter how, get it down to 1 torr. That's good enough.
Is it? Same thing?
Close enough. You're 1 torr away from 0.
So you think that it's not a big difference from that to 10 to the minus 12 torr?
No,
where
I think
the conditions in where the
I think
ISS is, you don't think that's a big difference?
no, it's not. I think the difference between 0 torr and 1 torr is exactly the same as from 1 torr to 2 torr, or from 759 torr to 760 torr. The difference is all the same. It doesn't matter.
If it doesn't matter, then okay. Do you know what the highest or the lowest torr reached here on Earth by our greatest scientists?
I don't want to play that silly ass game with you, SC. I don't know, 10 to the minus 9th or 10th or something. I forgot now.
So there is a, so it's hard, right? There is a difference, right? Substantial difference, right?
No, it's not substantial. Pressure wise.
Then why can't they do it?
To achieve it.
Then why can't they do it here if it's not that big of a deal?
Because it's hard to get a pump that does that, SC. And if you ever tried to buy a high vacuum pump like that, you'd find out why.
I'm not saying me. I'm saying the greatest minds, the greatest facilities, NASA, JPL.
Yeah, I know. And it's
JAXA, JAPSA, whatever.
It's hard to do, SC. That's all.
Yeah, that's
it's
my
hard
point.
To build a mechanical device that can pump down to those kinds of pressures.
So it is a big deal. It's not like you're saying, it's like a tire, right?
No,
it is a big deal, right?
It's a big deal to generate that vacuum. The vacuum itself is not a big deal.
You need a lot of horsepower, though, don't you, Blue, to get down? I mean, you don't need much horsepower to get down to 1 torr, but to get down to negative torr, you need horsepower, dude, and a lot of it.
It's not negative torr. You don't go to negative torr. There's no such thing as
It's not. I didn't say negative air pressure. I said negative torr.
You said negative torr, and there's no such thing as negative torr.
Well, you know what I mean.
10 to the minus 17th is not negative.
Well, you know what I'm talking about. If you go into 10 to the minus, okay, not torr. 10 to the negative 17, not torr then. I'm not talking about we don't have nothing strong enough to do that. But to get down to about negative 5 or negative 6, whatever, untorr, we need some a lot of horsepower, right?
Yeah, negative 6 untorr. You need a lot of horsepower to get to negative 6 untorr. Yeah. It's going to take a long time, too.
It does take a long time.
So nothing like duct tape can handle, right? That. Little gum and duct tape, like you were saying before. Not that simple, right?
Good thing we got that force that only acts like a force, gravity, protecting us from that 10 to the negative 17.
Yeah.
You can quite easily demonstrate it. Get yourself a vacuum pump.
Yeah, those are, I would think you'd almost have one of those. If you're in construction or anything, you might have or stuff. I guess I don't know. I guess I don't really know.
I assure you, you don't know. If you look into this pump stuff and what it takes, you will be a little bit surprised. I assure you.
I said what I meant, SE, is I don't know what the typical construction worker would have at just lying around his house. I would think maybe you'd have an air pressure tank, but not a vacuum pump.
There's no reason to have a vacuum pump on a construction site.
I don't know these things, so
not normally.
No, nothing like this. No.
What about for blowing insulation?
That's a blower, not a vacuum.
I don't know much about this. I don't know.
So how could we test this whole idea that this gravity out the
You're
air in the way
really
flat
roboting
earthers
this
claim?
time.
Try again, Dave. You were roboting. Yeah, it's all robot.
I'll try later.
Well, we heard that.
Yeah, I'm driving, so if you can't hear me, can you hear me?
Can hear
Yeah?
you. Yeah.
You can hear me now? I was just saying, how can we do that vacuum test with some kind of gravity, allowing air to not get sucked completely out of a tank or something?
Lou, I've often thought about like difficulty in pulling a deep vacuum in a vacuum chamber. And I know it's little molecules are hard to get out. I've wondered about putting some sort of like flappers or agitators inside the chamber that would flap around and stir it up, if that would help pull it down.
Oh, I don't know what good it would do.
I think that the globe model would have done well to like make up some kind of like membrane type thing, rather than just using gravity. They should have like made up something about like some kind of container, because that really blows it for you guys.
No, gravity works just fine.
No, it works perfectly. Sorry.
Yeah.
Why would we make something up?
Yeah, exactly.
Well, I'm saying if the whole thing's made up, they should have made up the whole part about the membrane, because it's really hard to believe with the way they describe it.
If the whole thing's made up, it's easier to make up a simple lie. Like just say like there's like the Wizard of Oz sort of thing. Like there's a dude behind the curtain, and he makes those things happen. And we live in a snow globe and you can't leave. And then don't have to do any of this fake in space or any of this other type of stuff. That's what you do if you were gonna make up this huge lie.
No. The more elaborate the lie is, the less the easier it is for people to say there's no way they'd make that up.
I think simple lies work the best. That's what Kosha was saying. Really.
Right. Well, gravity's kind of like the man behind the curtain, right? Gravity works like the man behind the curtain. It does everything. It's like gravity is the god of heliocentrism.
But a membrane wouldn't solve the problem, because we still have a downward vector that we have to accommodate.
Well, you know what you could do is you could fund some people on the internet to claim that the Earth is flat, and then people discount that, and so then they just keep on believing that the Earth is a globe. See how that works? Because the flat earthers say stuff that you paid off. They say stuff so ridiculous, people keep believing in the globe. Genius, right?
Oh, you mean have flat earthers say stupid things on purpose so people will still believe in the globe?
Yeah,
they do that. They already do that.
Yeah, it's called the Flat Earth Society. They've had that going for years.
I don't know if it's just them. I don't know.
And the other planted people they have around.
It could be anybody. Anybody could be in on it. It could be in here right now.
Maybe all of us are in on it.
Yeah, we're all being paid.
No, I think there's very few that actually are, but there's a couple. But yeah, they don't have to have very many because they know that there's enough people that they've convinced of this to kind of do it for them for free without even knowing.
What kind of people are getting paid?
Brenda should be. Brenda should be getting paid. Her and Rumpus. When I heard her and Rumpus on Nathan Oakley's trying to defend the globe model, that's what That's what sold me. Like that's when I was like
I haven't been
officially a
on
flat earther. When I
I haven't
heard
been on there
Brenda
in
and Rumpus.
years. I haven't been on there in years. It's been years.
Yeah, that's how long ago it was.
Did you hear what he
I
said
was
though?
like,
He said that you pushed him the other way, meaning that
not
he,
just her and Rumpus. Listen to them defend the globe. I was like, oh my god, this is the fucking globe defense. It's ridiculous.
See, I
But
kind of hang around.
I
kind of
actually have wondered, Brenda, if you're controlled op for our side.
See, I got paid extra for that. That was so brilliant that I got a bonus.
to push people away from the globe. You would have gotten docked for that.
I'm just making shit up. Come on.
Didn't you say one time that a shoe is an observed phenomenon?
Yeah, don't you observe shoes?
We do got some of the best.
In the hypothesis, it's a shoe.
Yeah.
We do got some of the best quotes from you.
You know
ever,
that
Brenda.
some
I mean, you're
shoes, Jeremy, some shoes are actually cakes.
Oh my god, dude! I'm actually making one of those cakes today. I'm making
Yeah. Yeah.
a shoe cake, but a beer can.
There's a gal on the internet. She has a YouTube channel. Her shit looks totally real.
Probably her channel that I saw. Like they got to. I
Yeah,
gotta watch
the
the
one,
whole thing.
yeah. It's amazing the detail that she puts in. Like she had a frog that was a cake. Looked totally like a frog.
Brenda, I have a question. Would you call yourself a truth seeker, or use that terminology? I'm not saying that exact term, but that you're on a quest for truth or always wanting to seek truth.
So I'm 65 now, or will be in a few days, and so I'll be retired. So yeah, I enjoy learning about things. So I like to learn about things, and to be perfectly honest, Flat Earth has motivated me to learn about things in physics and astronomy that I never would have on my own. So I'm actually sort of grateful to Flat Earth because
Well, happy birthday, Brenda, from Flat Earth.
Yeah, I'll be
Happy
65.
birthday.
I'll be 60. I'm a Gemini. I'll be 65 this month. So Flat Earth has motivated me to learn things, right? So I'm sort of grateful in a way.
Cool. That's awesome. That's awesome. So I guess just that was kind of the first part. Although thank you for sharing that as well. That was kind of the first part of it, because I was then going to ask if in your lifetime it's fully aware, like all humans, as it were, are aware that the Earth wasn't a globe. Whether in various ways how that would unfold. My question to you is, how would you look back on all of this time you spent? Like, meaning if you knew for sure, like, okay, wow, it really isn't a globe, and they were actually correct, the Earth, is not a globe. Would you feel? I mean, it sounds like you still have that grateful feeling, so you would still have that. But would you regret any of it, or what would you think about?
Would I regret it if what?
Well, essentially, I'm saying if the Earth, to you is proven indeed to not be a globe, how would you then look back on all this time that you spent, sort of defending the globe and doing what you've done, sort of against, as it were, people that are saying that it's, stationary and flat?
I would really want to know where and how I went wrong, because that doesn't really seem possible. I would want to know how I made the mistake, because it would have to be the case that somehow I made a mistake. And I think that's that's true for anybody. Anybody can make a mistake and get things wrong. But I'd want to know how, so I don't do it again.
Well, if it was reverse engineered to make you think it was a globe so brilliantly, then it really wouldn't be your mistake. It would just be that you bought it.
Well, and I guess that could be perceived as a mistake if your quest is to discover truth, and if you bought something that wasn't true and then kind of shared that with other people or told other people they were wrong, in that sense, who were actually not wrong. And that could go either way, quote unquote. I mean, I don't really see this as sides, but I'm just saying that could go for any position that's the case.
Happy early birthday, Brenda.
Yeah,
thank you.
if it's not a ball, there's definitely. I mean, I don't think anyone would disagree that it was reverse engineered. It wouldn't just be like they thought it was a ball and got it wrong. I mean, there definitely would have had to be some very careful engineering and reverse engineering going on.
Brenda, let me ask you something about a scientific experiment. Would that be considered a hypothesis test? You know,
What? I'm not sure. What's the hypothesis?
as a scientific experiment, would you consider that to be a hypothesis test?
Yeah, generally, yeah. You have some kind of phenomenon that you observe. You come up with a hypothesis to explain it, and then you test it with an
All
experiment.
right, I'll check it out later if I remember.
Not on
Yeah.
Jose's panel yesterday. Stingray and a couple other people. In fact, nobody thought that experiment was part of the scientific method. And I told him specifically, I ain't talking about just science, because we've argued about the word and or as far as the definition of science involving experiment, which is observation and experiment. So we've argued about that. I'm talking about the scientific method. And they're like, no, there's plenty of scientific methods without experiment. I was like, oh, brother.
Oh, and
No,
Brenda, did you say yes, it was a hypothesis test experiment?
Sure, but we were just talking in generalities, right? So I just gave you a general kind of answer.
No, I'm talking in terms of science, very specific science.
I think that in general, yes, in most cases, right, an experiment is going to be a test of your hypothesis.
So, do you think you could have an experiment without a scientific experiment, without a hypothesis?
I don't know what it's kind of how much you go into it. So if I go to my door and I want to know, is my door locked? Well, then I just try the door. I mean, is that really science? I mean, it kind of fits. I have a hypothesis, my door is locked, and then I jiggle the door to see if it's locked. Well, that was my experiment. So my theory is confirmed, right, that the door is locked. But I don't know if you really want to count that as science. I mean,
no, we know the cause of your door being locked. You locked it. That's not science.
No, the hypothesis is simply that the door is locked. I don't know why.
What's the observation? The observation is
you know what? Never mind. It's fine.
That's kind of like when things fall down, it's because you picked it up.
Yeah, left lane. Was you wasn't there yesterday on Jose's? Was you? I know. Blue wasn't.
I was there for a minute, but I wasn't there long.
How come you didn't defend me, man? When I said that the scientific method requires experiment.
Well, I didn't hear. I wasn't there for that, but I don't think it does require experiment per se. I do believe that you can figure things out through watching, through observation.
Brian, them dudes at Jose's are off the hook, man. They were trying to tell me if you had 3 line of sight, if you had 3 pyramids over Earth, line of sight on each other, and you drew straight, non-bending lines in any axis at each of those points, then you'd have spherical access, bro. Them guys don't know what they're talking about. If you want to fuck with some ballers, man, that's the wrong place, dude.
I disagree. I get a lot of content from there. I can't wait to make a video about them saying the scientific method does not involve experiment.
I mean, yeah, if you're trying to get content of Glover saying, off the wall shit, then yeah, I guess that is a good spot. But
Jose's accommodating though, man. He'll give you a voice, so I give him that.
I don't know, man. Last time I was on there, I actually left his server. It used to be fair.
Why is that? Why is that? Why did you leave?
I remember him always being fair and shit, and keeping the room under control and like.
Yeah,
I don't know.
Yeah.
I didn't get that. I didn't get that feeling last time I was there.
I'll say this: like sometimes if there's like a bunch of flat earthers, but if it's just a couple of us, man, he'll clear the air for us, man, and he'll jump on them. I mean, I imagine if you're moderating, it's probably shit goes up and down sometimes, man. Maybe kind of moody, depending on the moderator.
Yeah,
but
maybe it was a bad day. Maybe it was a bad day or
He's
something.
sold me out before, man. I mean, I've deserved it, and probably, I've just, but I don't know, man. He'll shut him. I mean, he'll let you get your point out. That's the one thing I'll give to him, no matter what. If they try to keep interrupting, if he's there listening, he'll back them up. He'll let you get your point out. Me anyway. I used to love fucking flat earth debate, dude, back when Brenda Rumpus and fucking Stingray and dude, there was always somebody co-show. There's always somebody new in there, man. And they just kind of evolved into something
Yeah.
different.
Oakley became a pure ass.
I mean, he ain't really. I mean, he's the same ass he's always been. But I don't know, man.
How do my balls taste?
I wish he'd let him. I wish he'd let him beg the question a little more, man. Maybe not a lot, but a little bit, man. We got to let him beg the question a little bit to have a fucking debate, don't we, guys?
That's what I'm saying. Yeah, definitely. You gotta let the. I like when the conversation flows like naturally. You know what I mean?
Well, you can ask him, but I don't think that would go well. I think he's pretty kind of set in his ways now.
Brenda, you were the best on there. I'm not even gonna front. You were one of my favorite. Was you?
Thank
You
you.
were Rumpus and Zan. Between you and Rumpus and Zanuck were my top three.
I don't think I
there.
don't think I'd go in there now. I just don't see any point to it. There's just no point.
Yeah, I hear you.
I'm so surprised y'all don't go in there. If I was a Globe Earther, that'd be the very first place I would be. I don't care what he said.
Oh,
What
I'd
he
go
said
lay it
about.
down. Yeah, I'd go lay it down in there. Lay the globe down.
I don't think you realize how it works, man. It's not like you get to be.
Or
It's
you
not
get
like you get to
globe.
express
Who's in there?
yourself.
What's up?
So it's not like you get to express yourself.
Yeah, he shuts it down pretty quick. You don't let the bullshit fly, you know? I'm not hating on him for that. I just like when the conversation, everyone gets to say their piece.
Yeah, he mutes people and then pretends like they have they're gobsmacked or something. They have nothing to say. Like, oh, nothing to say. Like, yeah, like acts like you're not muted.
Give me an example when you had a point, you or anybody else had a point to destroy his argument without fallacy. And think for a second. You ain't got to just get one off the top of your tongue, but just think about it for a minute and tell me the best example you come up with where if you could have talked, you could have destroyed his argument.
Yeah, I did talk and easily did, but he was arguing. He was trying to call me retarded because I thought that gases were fluid, and he was arguing for a long time that they weren't, and screamed at me about 20 times until I think a flat earthers in the chat like looked it up, I guess, and then told them they were.
No, dude, you used to try to equate gas to solids like babies and shit.
What?
Remember that analogy?
That was
Liquid,
David.
though. You know what he
When I
was
was talking
talking
to
about.
David, yeah, sure.
He was saying fluids, but he meant liquids, though. You know, that's what he meant.
He said
I remember
fluids
that.
nonstop.
Yeah, I know, but he was referring to liquids, though. But yeah,
I
you're
remember
right.
he made
You're right on that.
did
I'll give you
made a
that.
video. Yeah, he made a video coming back and saying that. That's what he said, but I think that was just to save face.
Well, he was
There's a lot of
describing
ego
liquids.
here. A lot of ego.
Everything he said about it, he was describing liquids. But yeah, you're right, though. He was saying that they weren't fluids at the time. No, give me. But that doesn't. That how would that win you the argument? I'm saying, give me a like it doesn't even have to be you. Give me an example of if he would let you talk, you could bust his argument without Faust.
I can't think of one time that it wasn't the case. Everything we ever talked about. When we talked about gas, we talked about closed and open systems. When we talked about hydrostatic equilibrium. When we talked about
You guys are
Coriolis.
still confused. You guys are still confused about closed and open systems.
I don't think so, man.
Yeah, can a closed system exchange matter?
Closed systems are expressed as not exchanging matter, but you can be describing a system where the amount of matter that's being exchanged is negligible. It really depends on the purpose of what you're doing.
So you're telling me you can have a closed system and it.
Oh my God, Jeremy, we've gone over this 1,000 times.
Zanuck, I'm so glad you're here, buddy. So glad you're here. I have a biochemist on deck ready to squash you. When you do an experiment, you're doing a hypothesis test. My man is getting his PhD soon.
He's underground. He's an underground, Zanuck.
He's underground, bro. He's as hardcore as it gets.
Deep.
Listen
He's
to me.
deep underground.
He's undergrad.
He's deep in the streets,
Undergrad,
bro.
okay.
Listen, he's deep in the streets, okay? And my man knows what an experiment is, and he says it's a hypothesis test. All right, you got issues.
I told you it was a hypothesis test. It helps you test hypothesis.
Seriously?
And here we get this.
You don't listen. You just don't listen.
Zanuck, you're like a battery. You flip polarity whenever needed.
No, no one's listening. Gio, that's why I get so fucking excited, because people just don't listen anymore. Hey, Keish, for example, Kosho, please tell the audience what I meant about the test and the hypothesis relationship.
Probably about the cause and effect relationship between
what the experiment was, what the hypothesis is, and how that tests the hypothesis to give it validity.
Right. By using using something that you can alter or that can be altered, that you know about, that is going to then have an effect on the dependent variable.
Correct.
Hey, so you're telling me the whole time we were arguing about if an experiment is a hypothesis test. Are you serious right now?
No, the experiment is not a hypothesis. It is a hypothesis test. Yes.
That's what I just said, a hypothesis
I know,
test
and I
is an
said that to you
experiment.
then too. You just don't listen,
You were telling
Jeremy.
me it wasn't.
Oh, no,
We were
I said
arguing
it's not
for
an
45 minutes
experiment.
earlier on this.
A hypothesis is not an experiment, but it is a...
I've never said a hypothesis is an experiment.
I don't know if you did or not. I disagree with you saying it was a hypothesis test. I said it 4 or 5 times today. My God.
You disagree with me. Hold on. You're telling me you disagree with me when I tell you an experiment is a hypothesis test.
No, it is a hypothesis test.
That's what I've been saying the whole time, and you were disagreeing.
I know.
with me.
No, I was talking to somebody else about something else, completely different. It was about experiment being with Witsit. The experiment is not a hypothesis. The observation is not doing science. We all agreed on all of it. What I said was,
no.
First, let me finish. You don't say no when I'm in the middle of a sentence. God damn it.
It's like the Amber trials.
I said the hypothesis is the story, and then you use tests, experiments to test whether there's validity to the hypothesis.
Okay,
so yes,
just so we're clear,
an experiment is a hypothesis test. Sure, absolutely.
Why did you not agree with me with this?
I did agree with you. You weren't listening. You never, because you're talking over me always.
Somebody go back 7-8 hours from now.
Go back.
Right?
You'll listen to it. Jeremy.
You'll hear Zanuck.
Jeremy, no.
Arguing that an experiment is not a hypothesis test.
No, I never said that. I agree with you and wholeheartedly, and said we all agree about that it is a test of the hypothesis. It's how you validate that hypothesis, meaning it's a test. If you validate something, that's what you test for. You're testing to see if that hypothesis is validated, and you do that through experimentation. That makes perfect sense to everybody but you for some reason.
Okay. If you agree with me now, how come earlier you were arguing that
I wasn't
you
even
can do a
talking to you. I was talking to Witsit.
After Witsit, how come if you agree with me now? Earlier, you were arguing that you could do a scientific experiment without a hypothesis. Aha!
Yeah, you can do an experiment without a hypothesis.
If an
Yes.
experiment is your hypothesis,
An experiment doesn't always have to test the experiment doesn't always have to test the hypothesis. But yes,
this is
all
golden.
experiments with a hypothesis do test the hypothesis.
You can't have. So you're saying you can have a scientific experiment without a hypothesis?
Sure. I wonder
Yes.
what'll happen if I put this with this. I wonder what'll happen. That's
It's not a scientific experiment.
Oh my God, this is like the worst of semantic arguing I've ever heard.
It's not a
Dude,
semantic argument. This
it
is goofy
is.
shit that you guys try doing to
You
get out
can
of
do an
having real science.
experiment. I can do an experiment without a hypothesis. Like someone said, what if I put this chemical and mix it with that chemical? There's no story. There's no assumption. There's no prediction. All we're doing is an experiment to see what happens. And you know what's funny about this? Ironically,
When you say you're doing an experiment,
would you fucking stop talking?
when you say you're doing an experiment, you mean a hypothesis test? Because we agreed
No,
that's what an experiment
no.
is.
No,
So
experiment
an experiment is not a hypothesis test.
No, experiments test hypothesis, true, but it can also not be a hypothesis test. It can be both.
Listen, you agreed with me 2 seconds ago. An scientific experiment is a hypothesis test.
Yes.
You said those words yourself.
Yes, a scientific experiment is a hypothesis test.
Okay.
Maybe the better
we do
wording
a
should be can
scientific
be.
experiment? Can we do
Better wording should be can be. It doesn't always have to be that
you are
hypothesis
the
test.
flip-floppingest motherfucker I ever heard.
Hypothesis tests are experiments. How about that?
You agreed with me 5 minutes ago. An experiment is a hypothesis
tests
test.
are experiments. Doesn't mean that all
an
experiments are
experiment's
hypothesis
not a
tests.
hypothesis test now.
Doesn't mean that all experiments are hypothesis tests. It means that all hypothesis tests are experiments.
You told me 5 minutes ago a scientific experiment is a hypothesis test. You're backing up on that now? Are you backing down on that now, Xanax?
Take the L. Take the L, Jeremy. Just take the L.
What do you mean take the L? He just flip-flopped. You guys heard him flip-flop.
I'm not flip-flopping. These terms have multiple meanings.
Oh, my goodness.
Is an experiment.
Unbelievable.
So here's this is why you fail logic. Is an experiment a hypothesis test? Yes. Can a experiment not test a hypothesis? Yes.
That doesn't even make sense. No,
to you it doesn't. Of course it doesn't make sense to you.
You can't tell me an experiment is a hypothesis test and then tell me you're going to have an experiment without a hypothesis, because an experiment is a hypothesis.
I can tell you that. I can tell you that exactly. Now, I want SA to chime in and say how I am a dilithium crystallist.
Way to go be a Star Trekker.
Dilithium
or whatever the fuck that is.
Paralogism is the other one.
I'm a dilithium crystallist.
That'd be you use warp drive because that's what you use the warp drive. Star Trek.
I had to bite the bullet on paralogism. I didn't think that was a word, but it turned out it was.
All gorillas are mammals, but not all mammals are gorillas.
Yeah, they are.
Listen to me, you double speaking, you son of a bitch. You just told me a scientific experiment is a hypothesis test. You said those words, right?
All gorillas are mammals, but not all mammals are gorillas.
Okay, and all scientific experiments are hypothesis tests, right? You just said that yourself 2 minutes ago. You said that 2 minutes ago.
Let me change it around again. Hold on. All hypothesis tests are experiments, but not all experiments are hypothesis tests. How about that?
You're going back on what you said not 5 minutes ago.
Does everyone see what I'm saying?
Well,
does anyone disagree with me?
But I got to be honest that
explain sets and subsets to Jeremy.
Well, hold on. I
know, right? I know exactly right.
I know Kosher wants to jump in. Let me just say one thing. I think for the room, you guys should both define what you mean by experiment and hypothesis tests. That's one thing I think that would help.
You test hypotheses with experiments, but not all experiments are hypothesis tests.
Even though he just told us that an experiment is a hypothesis test, not five
Look at
minutes.
the image I posted.
Okay, so
A
that's
and B can overlap.
if that's your
Add
definition
the
of it,
word
then
scientific, boys.
if that's your definition of it,
Scientific
then
test.
what is your example of doing an experiment that isn't a hypothesis test? Because the way I would see it, if you have a hypothesis, you're then going to test the hypothesis and or do it's like a pre-test essentially.
Right. Right.
So every experiment would, unless you're saying doing an experiment without a hypothesis at all, you're just
Correct.
doing.
Correct.
Yeah, I like that.
So if I just mix two chemicals together to see what happens, I will then have a reaction. And now I don't have any idea what I was going to expect or what was predicted. I just said, I want to see what happens. So it's a type of experiment. I'm going to experiment and say, what happens when these two chemicals are mixed? Now the hypothesis would say, I think when I mix these two chemicals that this kind of reaction will occur for these reasons. And then you break down an experiment to make that happen. Here we do it. We measure the temperature rise. We measure the composition of the product of these two, the combination of these two chemicals, and so on and so forth. So the hypothesis was said. We validate the hypothesis with the experimentation. So the experiments are the hypothesis test. But if we don't have a hypothesis, we can still have an experiment. See?
Yeah, it kind of reminds me of the difference between zeticism and the current sort of modernized scientism method. Because zeticism, you don't have to come up with some fancy, wild theory that you're trying to get other people to prove wrong, even though you don't have proof for it, which is what they do in the scientism. Versus with zeticism, it's more about just going out and actually observing or doing a measurement or doing a test directly, and then just getting the actual results directly from that, and then using that as your method of deciphering truth. Like getting it directly from the actual experiment or the observation or the measurement, rather than, coming up with some theory and then trying to prove it right or wrong. And then you don't ever prove it. And then you just push it as a thing, even though it's not proven. And then you try to tell other people, oh, well, then you have to disprove it in order to say it's not true because we have all this money and popularity behind us. And it's like, well, you never proved the thing true in the first place.
There's a lot of that. People stumble upon all sorts of amazing ideas and things by just random experiments.
Exactly. I was going to say before, I hadn't heard you say that, but because Jeremy had said you said that, so I was going to argue. I was going to say, you know what, I'm going to see maybe he said it because of this. And I was going to say something along the lines of what you basically said about doing an experiment that's not, following some sort of hypothesis. Like you just
then when you ask a physicist or you ask a biologist, go ahead, sorry.
I was going to say though that to be fair to Jeremy though, the way he worded it, the language was kind of,
literally just double spoke.
Well, we still need to get to the bottom. We still need to get to the bottom of that. So we got to throw it back to Jeremy. Jeremy, what do you think Xanax said, and then what do you agree or disagree with it? Let's review that for where you're at. Where are you at with it?
Yeah, you're definitely not going to be doing a scientific experiment without a hypothesis, for one, because an experiment is a hypothesis test, a scientific.
Yes, test the hypothesis. We all agree.
He's roboting pretty bad.
One of the things.
I mean, that's not even a question. No, you said you don't have to test the hypothesis.
Jeremy, but the context of the discussion. So when you say you went out and found a biologist, and you say, "Hey, is a experiment a hypothesis test?" And he goes, "Yes, of course. We do a hypothesis, and we test our hypothesis with experimentation." So yes, Jeremy, hypothesis tests are experiments. And then I said earlier when we were talking, we don't need to have a hypothesis to have an experiment. So not all experiments are hypothesis tests. But yes, in a hypothesis test, it is an experiment. They both can be true. It's not dilithium crystalism.
You like that word, huh?
Oh, you're back. Good. Yes. I'm a dilithiast.
You're definitely a dilithiast. Definitely.
I don't think you've ever said the word right, though, Zanuck.
Dilithiast.
No, he hasn't.
Form of self-deprecation, really.
He's gotten it wrong every time.
Dilithiast?
Dilithiast, isn't it? Dialetheism.
Dilithiast.
You still can't say it right.
That if you're a dilithiist, that's dilithiism. You practice dilithiism, correct? I just rather say dilithium crystalism. It's funnier.
It's close enough.
Dialetheist? Is that what you're trying to say?
Dilithiist, yes.
Well, you're not saying. I think
Dilithiist.
Di-L-E. I think that's how it's pronounced. So
dialecticism.
Yes.
You're just saying you're leaving the E out, but
just using it, just slurring it with an I, a soft I.
What it means in short is you believe in two truths.
I believe in a lot
Well,
of truth.
in the spirit of the
That
word,
statement can be both true and false at the same time, is what it's saying online, which is quite similar, I think. Yeah.
Yeah, same
Listen,
thing.
this is from lumenlearning.com. When conducting scientific experiments, researchers develop hypotheses to guide experimental design.
yeah, they kind of say dialtheism. That's how that pronounced.
Yeah, that's totally wrong. Sorry, I only heard it through my
So
computer
is there
speakers, and then when I put it through my headset, I was like, that is wrong.
so just you can all just say, accept apology now and say that so everyone pronounces words slightly different. Doesn't mean they're wrong, but everyone's trying to get a gotcha here. You notice that? Everyone tries to get you. I got you. I'm smarter than you. I got you.
All right, well, listen. So to label something a scientific experiment without a hypothesis would be incorrect. You can label something an experiment, but not a scientific experiment.
Boom.
Seriously, Zan,
I'm gonna put this water in this particular freezer to see if it freezes.
Well, Brent, so it's still Jeremy. So what's the one that? I guess I'm still not clear on what was the one that Zanuck had stated earlier that he turned on, and then how do you guys disagree on this?
He literally just did it. He literally just did it 5 minutes ago. He came in and said, a scientific experiment is a hypothesis test. He said those words 5 minutes ago.
It is.
And then he dropped the word scientific deliberately.
Yeah, that's the strange part. That's why I pointed that out.
Is there something wrong about that a scientific experiment is a hypothesis test?
No, it is.
It's the same as a scientific theory versus a theory. There is a difference, yes.
I posted a citation in chat. Backs me up.
And I said that yes, a hypothesis requires an experiment, and that experiment is a hypothesis test. That's the context for which the discussion was being held. Now I'm also saying, with hypotheses, they require tests, experiments, and those experiments are considered hypothesis tests because they validate or invalidate the hypothesis. Not all experiments are hypothesis tests, though. I'm not saying two different things. You have to listen to the context for which I'm using the word experiment.
But
let me read this again. This is from Lumen Learning. Scientific experiments. Researchers develop hypotheses to guide experimental design. From Lumen Learning. I posted it in the chat.
Operative word. Hypotheses are created, and then they're using experiments as hypothesis validators.
I like how you're
saying.
A hypothesis. No, they're using a hypothesis to guide experimental design because an experiment is a fucking hypothesis test.
Yes, it is. It tests the hypothesis.
So you agree?
But not all experiments. Not all experiments test a hypothesis. Not even scientific experiments.
That's not what Lumen Learning saying. That's not what Lumen Learning saying.
You just don't. You're not able to comprehend the English and how it's written and what it actually means.
I don't know if is there a point in continuing
There's
this?
no point. Actually, that's the funny part. There's no point to this at all.
Yeah.
No,
I think what Jeremy's trying to say is that if I have a scientific, so let's define a scientific experiment. If that is only applicable to validating hypothesis, then Jeremy would be right. I'm not really convinced that that's the answer, but I don't really confess to know that answer. We're just talking about experiments and hypothesis and the difference between the two. And that's what Witz and I were arguing about because he thinks that all hypotheses are just experiments. And they're not. They're different. The hypothesis is a
I don't
story,
know if he
and the
said that or
experiment is
not.
validation of the story. That's where it came from. And that's something came out right out of
Hypothesis
QE's
is part of scientific experiment.
right out of QE's playbook. When he doesn't understand that the cause and effect relationship can be applied to a hypothesis in a broad scope, or it can be applied to an experiment in the form of a dependent-independent variable relationship. The independent variable dependent variable relationship is not the hypothesis. Not at all. Even though it's a cause and effect relationship in both, they're not the same. The cause and effect relationship in the experiment is the independent variable, dependent variable relationship where you actually manipulate the independent variable to see its effect on a dependent variable. They're different.
Yeah, that's what your
That was the argument.
hypothesis is made out of. That's what your hypothesis is
No, it
made out
tests.
of. Your
It
dependent and
tests.
independent variable.
No, that's where you're wrong.
Yes.
No, go talk
Do
to
I
your
gotta get another
biologist. Get
citation
him on
that
here.
you're not
Yeah,
going
get
to
him on
read
here.
it out?
I'll
Do
have
I
him
got
out
to
with
get
you.
another citation? Do I got to get another
Yes.
citation that you're not going to read
Yes,
and tell me I don't
another one you're going to
understand?
misinterpret. Yeah, another citation you're not going to understand.
Yeah, I know.
Yeah, at least you know something. Dude, it's not that hard.
You don't
Hypothesis.
understand.
Shout out Buster. That's right. You don't
That's
understand.
actually a good song. And he's a decent musician. I told you before.
Damn right he is.
So is Issa.
Issa's
Told
pretty
you,
good
watch
too,
out.
yeah? I
They're
told him they should collaborate.
completely wrong about the shape of the earth, but decent musicians.
Watch out, Buster. East is coming for that ass.
Well, here's the question: does an experiment prove and disprove things?
Experiments validate or invalidate the hypothesis. Provides
No, my
evidence
You,
for.
you know what another word for validate is?
In the English language, it might be proof, I'd imagine.
Yeah, you know what
Evidence.
synonym for validate?
But in science,
Look
that word is not used. You don't use that to proofs are only
Yeah.
used in mathematics. Proofs
Right,
are only
because
used.
you're doing
So I'm going to keep on
pseudo-
saying it until you stop talking over me. The proofs are only used in mathematics. In science, we have evidence, and the stronger the evidence, the more validity there is for that. You can't have more proof. I guess you can. You continue to have proofs, and eventually you can prove it to be right, like in court. But science doesn't work like that. It just has a higher level of confidence that this is actually the reason for something happening.
Of
So you
course
have
they're
less
running
than one
around
globe.
saying you can't.
My proof of
they're
the
running
globe is
around
horizon
saying you
drop,
can't prove shit
with altitude, and the focal
Sanic, I know
pendulum.
you heard me talking, dude.
No,
I know
no,
you
I was
heard me
asking
talking, bro.
Someone else asked the question while you were in the middle of your diatribe.
And I don't do diatribes, dude. What the fuck are you talking about?
You were.
Listen to me. Of course they're going to tell you that science doesn't prove things when they're running around doing pseudoscience that doesn't prove independent, dependent variables, prove shit. They don't have that, though. So, of course, they're going to run around saying science don't prove shit.
Who's they?
You, guys like you.
Wow. Okay.
Yeah, the
You're
word
they.
proof. Part of the word proof is defined as to establish truth. So if you're not establishing truth and proving things, then what are you doing?
You're trying to validate assumptions or ideas that
There
might
you go.
explain.
You just said
Hold
it.
on.
No, I have to
Yeah,
interrupt
okay.
you because you just said it perfectly to repeat it.
No, you can't do that. That's not
You're
fair.
just
Joe. You
trying
can't
to
interrupt me.
validate ideas.
No.
You're right. I shouldn't have
Yes,
interrupted.
we're trying to validate ideas of why certain things happen. And the more evidence you put, for example, if I say the earth is round because this is my evidence, and I give you a list of 10 things, all these things added together give you enough evidence to say, you know what? He's probably right. Zenek probably has an idea that the earth is round for these reasons. It's very strong. Now, it's still a possibility it's not right. Is it probable he's not right? No. Is it possible he's not right? Yes. But it's not probable.
It's always
He's wrong.
probable. It's always probable. Unless he
That's
is,
right.
To that, though, Zanuck?
Unless he is right, then it's always probable that it's false.
No, it's always probable. There's always probability you're not right. But is it possible? Excuse me. It's always possible he's not right. I misspoke. It's always possible I'm not right. But is it probable? No. It's very high probability that I'm right because these evidence is so strong.
I got all these citations right here.
quick,
Hey, let me just real quick. From thought.
Go ahead.
And let me just read the citation real quick from thoughtcode.com, right? A hypothesis is a tentative answer to the scientific question. A testable hypothesis is a hypothesis that can be proved or disproved as a result of testing, data collection, or experiment.
So I'd argue both of those are wrong. I don't agree with that, nor do I agree with Xanax.
Oh, wow. Well, you don't agree with
My
that.
view of the scientific method is actually that it seeks to disprove its hypothesis. Any test should have a failure condition that would disprove the hypothesis. And if that fails, you haven't proven the hypothesis. You've just shown it as the probable cause because you set up conditions in which it could be disproven and it wasn't.
Yeah,
if what you said was, it ever does prove anything.
No,
I'll agree with that, Iggy.
That's exactly what I said. I'm saying it provides evidence that validates or invalidates it.
Yeah, hold on, Xanax. Go ahead, Jeremy.
Well, Gio, real quick, while I'm addressing what Eggshells just said, can you Google search synonyms for validate? Now, as to what Eggshells just said, if that was true, you'd always be trying to show that your null hypothesis was true in an experiment.
Possibly.
That would be. You know how silly that would be? I don't think you realize how silly that would be.
Your side of it, Jeremy, well, not your side of it, but the side where you suggest that it proves, suggests that there is no other cause. You've established the only ever possible cause.
Yeah.
Whereas that is not the case.
Yeah.
I mean, it may be the case, but it's not necessarily the case.
Yeah. It may be. Yeah. I think that's really well said, Whites. It may be the case that temperature alone causes water to boil, but you haven't proven that because could find out that at very, very low pressures, it boils at a different temperature. So it would no longer be valid to say it. But could you disprove that day of the week causes water to boil? Yes. I think you could. So, while I try to avoid using the word proof at all, I think the only somewhat reasonable way to say it is to say that scientific experiments disprove things. It's actually quite similar to, let me find it, not Bill Nye, who is he? Feynman.
You were talking about the synonyms for validate, Jeremy. So yeah, I posted the link, and I think Eggshells also posted a screenshot of it.
Yeah, there's a great short of Feynman talking about it.
Is there proof in it? Is the word prove in it?
So
we've got approve, certify, confirm, corroborate, endorse, justify, legalize, legitimize, ratify, substantiate, verify, and then there's more. You're saying is proof in here? I'll have to see.
Yeah, prove. I know an antonym for validate is disprove.
That's true. That is, disprove is listed as an antonym. Yeah.
Yeah. So, I mean, what do you think we're doing when we validate shit, guys? Come on, man. This is fucking dumb.
No, there's Jeremy. Check what I posted, Jeremy.
If you were trying to disprove your,
there's a reason they don't.
If you were trying to disprove, if you were trying to disprove your shit all the time or falsify it or whatever, you'd be trying to make your null hypothesis true. That's easy. We could just be making dumb hypotheses all day, and we could be falsifying the null hypothesis. There would be no point to it.
So can I say the bit that Feynman's saying in this bit that I posted? It's in the first 49 seconds if everybody wants to do it. He says, first you'd make a guess, which is essentially his words for hypothesis. Then you make a prediction based on what that would say, and then you do computation to work out how you would be able to measure that, and you compare that to reality, observation, or experiment. And then the final thing he says, which is the bit where he says this is the crucial part, he says if it disagrees with the experiment or observation, it is wrong. That's the kind of view I'm taking on it, which is.
But that's exactly. Actually, I don't think I know you want to disagree with me, but that's not really what I said. And Don actually posted something really interesting here. And even though he has the word prove in there, it says it must be possible to prove it. I mean, it has to have the potential to be proven. Although we don't prove things in science, it must be possible to prove that hypothesis to be true. Right. It must be possible to prove that hypothesis false as well. And I don't agree with that. We're finding evidence to invalidate the hypothesis. We're finding evidence to support it. I think most people would agree, even Feynman. Go ahead. I'm sorry.
Okay, what Eggshell says. What happens
in
if
my view, I don't think it is. You're setting up conditions in which it would give you an A or B result. And sure, if you think your new wonder drug cures cancer, then that's the one you want. But the proper test for me, the core of it, the what's his name, Karl Popper, it's just got to be falsifiable. So yes, while you're still trying to prove yourself right, the proper test is failing to prove yourself wrong.
But that's not the function of a hypothesis. That's the requirement of a hypothesis. The result of what a hypothesis is something that is a story, or like Feynman actually explained pretty eloquently there. But what you do is you test it to either invalidate or invalidate it. It's invalidatable and it's validatable. That we know it has to be. But the purpose of this hypothesis is to tell the story, and the testing is part of the scientific method, which either validates or invalidates it. So if I say that plants grow because of water, that is, and water and sunlight and photosynthesis and all that's the hypothesis. And then you try to invalidate that. You try to do all the experiments that show that those things you said either contribute or don't contribute to the dependent variable, the growth of plants. And that's supporting
I think we agree on most of it. It's just I guess I balk at the bit about either validate it or invalidate it, whereas I would say it either invalidates it or fails to invalidate it.
Either invalidates.
The second bit would what I would say instead, in place of that it validates it.
So it's standing up to scrutiny, is what you're saying.
Yeah, we're subjecting it to a test that it could fail.
All right, so we're just two different sides of the same coin. Okay.
Yeah, but the problem is one of those allows for a huge amount of deception and manipulation to go on, when the other one is actually getting towards something definitive and only validates something that's definitive rather than just invalidating something that was fabricated.
Well, let's play around with that, Joe. What you're saying. So let's say I say, I think there are spins because we have a Foucault pendulum. And the Foucault pendulum works, and I tell you all, we've gone over this a million times. I'm not going to go into detail. This is all the reasons why the Foucault pendulum should work, and we're going to start testing it. So we start testing it, put it in different latitudes, show what we expect to see, and sure enough, that's what we do.
Here we go.
Do this, do that, do all these things we do, and it keeps on. Hold on, it keeps on supporting my hypothesis that the Earth is spinning due to this test with the Foucault pendulum. Now, what kind of result would the Foucault pendulum have to where it would not? Or would it invalidate my hypothesis?
Real quick, guys, real quick. What does it mean to validate something? This is from Merriam-Webster. Validate, confirm.
In scientific terms, it means to support it.
Zanuck, hold on.
Okay.
Mean to validate something. This is from Merriam-Webster. Validate, confirm, corroborate, substantiate, verify, and authenticate all mean to attest to the truth or validity of something. Validate implies establishing validity by authoritative affirmation or factual proof, parentheses, a hypothesis validated by experiments, end parentheses.
Uh-oh.
Boom, motherfucker. See what I'm saying? You guys are bullshitting.
No, you're looking at Merriam-Webster's for scientific definitions of words. Yes, most of that is true. Validation, it means substantiating, give support for all the things you said. It's all true, but how it applies to science is that we're just looking for support, like you said, the validation of this experiment to support the hypothesis. Why is it so complicated?
As White said yesterday.
Yeah.
The idea of
I put your part of the Merriam-Webster. I posted it in the chat.
The word theory means something different from a lay person to a scientific person. You made that point.
Yeah, yes, that's true.
And just like pseudoscience,
I've got a theory that guy nicked my shit. That is not the same as when somebody has a theory.
Yeah, like a scientific theory.
And just like pseudo force.
Hold on, Zanuck. Except for the context I posted in, they used it as an experimental validity or to prove something.
Okay.
That's tough.
Like I said, if you use Webster's dictionary to look at the meaning and implied meaning of certain words in the context of the scientific community or in physics, you will be likely incorrect because things like, and we always use this example, the word pseudo, in front of force doesn't mean fake force. Oh, actually, it kind of does mean fake force. But hold on. But the meaning inside. Hold on. The scientific meaning of that fake force is not that it's fake. It means that it is dependent upon reference frame and it doesn't have a source. So we have to understand these words in physics do have slightly different meanings.
They used it in a scientific context context. They know the meaning of words and they use it in a scientific context.
So if I say pseudo force, it means it's a fake force?
Dude, I don't know. I gave you the citation, Merriam-Webster. They use
No,
it
I'm
in a
giving.
scientific
Go
context.
look at Merriam-Webster. Go look at pseudo force and see what it says.
Well, if we're
Or
talking about
pseudo, the word pseudo.
if we're talking about the Coriolis effect, it's definitely a fake force.
It's fake. It doesn't exist.
It's not real. Yeah, it's a fake force.
It doesn't exist. Doesn't have any effect on anything because it's fake. That's what fake would
It
mean.
doesn't. It's a visual thing. Yeah, I explained that to you. Remember the example with Bob?
Wait. Things that happen visually are not real? Hold on.
Remember the example with Bob? Yeah, remember the
Yes,
example
and
with Bob?
Bob walked it
when
back.
you're throwing the ball over.
Bob walked it back.
Remember the example with Bob?
He assumed certain constraints, which I don't think were too applicable to the discussion.
I'm going to explain to you why it's not a real force, Nanik. You want to hear it or no? So
Yeah,
the reason why it's not a real force.
First define real. First define real, and then we'll go from there.
Force that has
Before
a
you
real
start
effect
telling me
on
what something
things.
is
A natural observed phenomenon.
Oh, really? That's real?
Yeah.
Okay, good. I'll go with that.
They're not going to let me.
Lightning's
I know.
real.
Jeremy, it's because your mic keeps cutting out.
Yeah, how's that sound now?
Better.
It sounds better.
Yeah, so the reason why it's not a real force is because in the experiment, in the thing where we were throwing the ball over the roundabout, turned out that was the Coriolis effect. You can't have the Coriolis effect without the Coriolis force. However, the ball is just going in a straight line. There's no force acting upon the ball. It's going in a straight line.
Then how does it make a turning path?
It doesn't make a turning path. The ball just goes in a straight line. It just visually appears.
With respect
it's
to
a visual.
With respect to someone in the Oh my God, Jeremy, really?
I know.
Gio, see how this is working? I'm trying to say something.
Yeah, my bad. Go ahead.
Okay.
You asked me a question.
Here you go. You're doing it again. Just let me talk for a second.
Dude, you have to understand there's kind of two styles. One of them is like you both totally just pass the mic back and forth, but where you don't overspeak. But then there's another mode where you might like want to go back and forth and like answer quick questions.
I don't mind that.
Well, yeah, but you just have to figure out if you can do that with someone.
I know, but he's just being I'm just making you aware that other people do what I do, because I do that sometimes too, I admit. But it's just kind of normal when people get excited. He's very excited, you can tell. So no, Jeremy, the deviation we see, we observe, we actually see this optical phenomena, because we see it, it's visual, it's optical, is due to someone viewing that motion from a rotating reference frame. When you look at things from a rotating reference frame, things will appear to defy the laws of Newtonian physics and mechanics. It doesn't mean they don't happen. Sorry, go ahead.
In that example of us throwing the ball over the roundabout, Bob described that as purely a visual, as an illusion. I think he used, because there's no force being put on the ball. The ball is just going in a straight line. There's no force knocking it off his path. It's just an illusion.
Well, he was speaking
kind of close to correct.
Yeah, he was speaking
that's my
about it.
What a pseudo force means.
Yeah, he was speaking about it in terms of its inertial state. So he's being very clear about that ball, when it's thrown, once it's released from that force, the force applied to it is removed from that body becomes inertial. And that inertial path, as we know how inertial items and objects move in inertial reference frames, it moves straight because it can't defy the laws of Newtonian mechanics, means that any movement or any change of this direction will have to have a force associated to it. So we assume it going straight. But if you're looking at and viewing things from in a non-inertial reference frame, it will appear to curve. And if it's acting between those two frames, you can have a force being generated by it. Like centrifugal force.
Or actual force.
It's an actual force. That's
where dialetheism comes in.
No, it's not, because Wait, Jeremy, let me just reply to Essie real quick, because he jumped in. The centrifugal force is just like that. It's a pseudo force, but it has very real effects if you have a car that takes a left turn. And why does someone fly out the right door? Because there's a force. And why would he bust his head on the window as he exits the door, as he's thrown out the door? That force is real. It acted on him.
About that. Yeah. You said that the ball both travels straight and curves, right? And I'll give it back to Jeremy. You said that the ball travels both straight and curves at the same time, correct?
Yeah, depending on what reference frame you're looking at it from, yes.
So that's dialetheism, bro.
No, it's not, because I gave a dependency factor. I said it's
So,
either from the
Zanuck,
reference frame of...
Go ahead, man.
I said it's from the inertial reference frame or viewed from a non-inertial reference frame. That will both show an object doing different things. Both are very real with respect to those reference frames.
You're changing it now. You say show.
It's curved, viewed from the non-inertial reference frame. From the rotating reference frame, it absolutely is curving.
Let me just wrap this up with him with this Coriolis force thing.
And I can prove that
not
there's a
the same
force
as
there. Hold on 1 second, Jeremy. Sorry, just a side note. I can prove that, SE, by if I had a set of railroad tracks on a sphere that was rotating, and I moved the train from the equator on this rotating sphere to its northern pole axis of rotation. The closer I got to the axis of rotation, the faster this sphere would be forced to accelerate, and that acceleration is due to the conservation of angular momentum. And that shows that you cannot have a change in angular momentum due to the conservation laws unless there's a force involved. And we can calculate what that force would be.
Finish
Hold
up
on.
with
That's the
Jeremy.
same.
Finish up with Jeremy.
That's the same reason. The same reason that ice skaters, when they pull their arms in, will accelerate.
Okay, so
Jeremy,
the reason why the Coriolis effect is a Coriolis force isn't a real force is because when we see the two guys throwing the ball over the roundabout, the ball's going in the straight line. There's no force being apart on the ball. It's purely a visual thing. You guys calculate what the force would be if there was a force there, but there is no force. That's why they call it a fake force.
I think that's accurate. Yeah, if you're not interested in the movement of the person as they go around the roundabout, so weird to me. You guys call them roundabouts. To me, that's what traffic goes around. Anyway, then there is no force. There is only a pseudo force if you choose the perspective of somebody who is moving.
Well, how do you have an effect then if it's not?
Because you're choosing somebody who's moving. You're choosing somebody who's going round in a circle, and you're saying how would the path of this ball look to them? And because I want to know the vector it's coming in at so I can catch it or something like that. That's when there's a force. If you choose to ignore that perspective, which I think, at least to my understanding, is totally valid, then it disappears.
So you're a believer in both things as well? The ball actually traveling in a straight line and curving at the same time?
No. No, the ball is doing what the ball is doing as you describe it in different ways. It's like, put it this way. If I said I'm in a car and that car is going down the highway, I could say there was a car like coming towards me. Let's say I was gaining on another car on the road. That car's still doing 90, but I'm doing 95. So I could say from my perspective, that car is getting closer to me. I could say that like in one way of describing it, it's almost like it's coming backwards towards me. But we know from the frame of reference of the road, both cars are moving forwards, one at a different speed. It's not that it's doing two different things. It's how you're asking the question, in my view.
You're breaking up again, Jeremy.
You're breaking up with Jeremy.
Jeremy wants to get closure and he's not getting it and he's frustrated. Answer his question for the love of God.
I mean, I think this is just taking a very literal and semantic view of something.
But you can calculate this Coriolis force, and this force, those train tracks, back to my little train track from the equator to the North Pole, you could calculate the force on the western side of this track as it moves forward. No, sorry, eastern side of this track as it moves forward, or as it rotates. And that force will act on the object to accelerate it. So because we've moved the mass from the equator at a high tangential velocity to a point of lower tangential velocity, as it moves on a fixed track from north to south, it will start acting on the body, and that force is called the Coriolis force. That's the best way I can explain it.
Hello.
Yep. Yeah, but here's the thing: when you throw a tennis ball, right, on a merry-go-round, right, and you throw it right in a non-inertial reference frame, doesn't that still have centrifugal force? And that would be a force acting on it. Just like you were saying, like the car like brakes, you'll fly forward.
Both the same thing.
It still holds that.
Did Zanuck ever respond to what I said about the Coriolis force not being a real thing?
No, not yet. No, I tried to get him to.
Can you please, Zanuck,
I just
can you
got to
please
tell you,
respond to that?
I just got to tell you, yes, that Coriolis force is very real as viewed from or shown within a rotating reference frame. So that spinning sphere would have a Coriolis force acting on the railroad tracks as the train traversed south of the equator to north. As it moved north, it would be applying a Coriolis force to the sphere due to the conservation of angular momentum. And it would be a force acting on the sphere, and it would speed up as the train moved from equator to the North Pole. That force is real.
In my example of the guy throwing the ball over the roundabout, where we clearly have the Coriolis effect, remember that?
Yes, it's an optical effect.
Yes. When that ball's being thrown, the guys on the roundabout, they see the Coriolis effect happen, right?
Yeah, how would they know?
Because we can see it.
I know.
Because we can see it from both straight. It doesn't matter how they know. We know it's the Coriolis
No.
effect.
How would you know if you were those two guys whether there's a Coriolis effect?
Dude, why are you trying to run away from this? Why are you running away from this, Danik?
Jeremy,
you're running away right now.
I'm not running away. I want you to know why. How would these people know that there's a Coriolis effect?
It's irrelevant. This is a huge red herring about the one.
It's actually very
you know
relevant.
I'm right.
You're not
scared
right.
of what I'm about to say.
You're not
I
right.
know.
I'm not scared of anything you have to say.
You're scared of what I'm about to say.
I'm not.
Okay, so the guys on the roundabout, they know it. Okay, so the guys on the roundabout, they know it's the Coriolis effect. Now, we know that the ball is just going in a straight line and there's no force being imparted on this ball. No actual force. Right? Just going in a straight line. Right, Zanuck? Yeah, it scares you. I know.
That's right.
It should. That's
no,
why
I
Bob
love
was so
it. I
quick to
love
deny
it. I love your enthusiasm. And yes, I'll answer your questions. Yes, there's no force acting on it.
Yeah, so but the Coriolis force is there, is it not?
With respect to the rotating reference frame, yes, it is. Because in a body making a curved path, hold on, a body making a curved path that with a radius, I can calculate by its velocity, its mass, and its radius what that Coriolis force is going to be. To make it make that curved path with respect to the rotating reference frame.
And it's purely
No, it'll actually have a force in that reference frame as well.
There's no actual force being imparted on the ball.
So there's
transform.
There's transforms.
There is no force on the ball, Zanuck. The ball just goes in a straight line. In reality,
with respect to the inertial reference frame, you're right. With respect to the non-inertial reference frame, no, there is a Coriolis force acting on it.
Zanuck, hold on 1 second. Hold on.
It's why we have hurricanes, Jeremy. This force, if it wasn't real, they wouldn't spin up these clouds.
In reality, the ball is going in a straight line. Do you agree? There's no actual force. So you're telling me that in one frame hold on. So you're telling me you calculate.
Jeremy, there's a fair amount of like delay or roboting or something. Maybe start over again, see if you can do it again. It wasn't coming through.
It sort of drops out.
Yeah, can you hear me now?
I think so. Yeah, I could hear that. Yeah.
Yeah. So Zanuck, you're saying in the inertial frame, there's no actual force, there's no physical force being imparted on this ball, but then in the non-inertial frame, there is a force being imparted on the ball in reality, or is it just something you calculate?
No, there is a force acting. It has to be a force because things can't make a curved path without a force acting on them. So they have a force acting on them in the non-inertial reference frame. It's called the Coriolis.
So there's a force. Yeah, so there's a force acting on this ball in reality. Something
just like I spin a ball.
Something physically forcing Zanuck. Is something physically is something physically acting upon this ball in any frame.
Yeah, in non-inertial reference frame, there is something acting on the ball.
What's acting on the ball in the non-inertial reference frame?
The frame.
Oh,
The
man.
frame?
The frame is
What
acting
does
on the
that
ball.
even mean? Dude, what does
Oh,
that
It
even
means
mean?
if the ball is in a track, picture like a track that the ball is rolling on, like a bowling lane, and has sides, and that track was going on a spinning ball, rolling. As it went to a lower tangential velocity region, it'd be a force acting on the rim, on the walls of this particular track. That'd be a real force that is reference frame dependent. It's like no different than no. Hold on, let me finish. No different than centrifugal force. When I spin a ball around my head, hold on. The part that's holding it to the string and to your finger is an actual force, but the force that's pulling it outward, that's making the string taut, that force is a pseudo force, is a reference frame dependent not origin force. It's a pseudo force. Centrifugal force is pseudo. It's the same exact thing.
Yeah. Pseudo means not real, because in the example of the guy throwing the ball over the roundabout, the ball is just going in a straight line. No matter what frame you're in, there's no physical force acting upon this ball. It's just going in a straight line.
If I have a rubber band,
the curve. Hold on, Xander.
If I have a rubber band on a ball, if I have a rubber band on a ball and you swing it around your head, will that rubber band elongate and take a force to do that? Yes or no?
It's not the same thing as my analogy. I don't know why
it's because it allows you to grasp mentally what's happening here. It's the reason that there's effects.
It's because my analogy blows your shit out of the water, and that's why Bob didn't want to admit it was the Coriolis.
You think it doesn't?
It does.
Just listen. Does that rubber band expand as you swing it above your head?
I don't know. I don't care. I don't care.
You know it does. And the reason it does is because there's a force called centrifugal force. It's not, because it's very analogous to what Coriolis force is. They're both pseudo forces for the same exact reason. They are reference frame dependent. I don't know how many more times I have to tell you that.
Panic. In my example that you desperately want to get so hard to get away from, and I know why, because it scares you. But in my example,
it doesn't scare me.
In my example, there is no.
I'm frightened for you that you can't get basic elements. There are actually factors involved that don't incorporate normal forces, and these normal forces are not part of the pseudo forces. They're not. It's a family of forces that are reference frame dependent and they do not have origin, and that means that they are very real in that reference frame that you're looking at them from.
In my example, there is no physical force acting upon the ball, making it deviate or do anything different than going a straight line, which is what it's doing. It's purely visual, and it's a mathematical calculation of what the force would be if there was a force acting upon it.
Right. Yes, there's no force acting on it yet. Certain things can change mechanically, physically in that reference frame that would allow that force to be applied. For example, if you had the train track scenario, that would show that
my example again.
You throw a ball and you see it take a curved path. There's no force acting on it. It is inertial in a non-inertial reference frame. We all agree with you, Jeremy. The force is only a calculation. There's no effect of that force on the ball. Is that what you want to hear from me? So I'll agree with you.
That's why I'm telling you it's not real. It's not real. It's only a calculation.
Hold on. Now, if you were to try to
Xander, come on, man. It doesn't really seem fair to say all that and then just keep going. I mean, it doesn't even give him a chance to respond.
That's what I've been telling you this whole time. That's what I've been telling you.
He's not allowing the next step. So, okay, there we have an inertial state. We all agree it's inertial. It has no force acting on it with respect to the either frame. I'll even go so far as to say either frame. Although we do see an optical effect in a non-inertial reference frame. I would agree. It's an optical effect. That effect does not cause any force, any resultant force, similar to a centrifugal force, until something else acts upon it. For example, you force it to go straight. If I force that ball to go straight in both frames, the one that's rotating will have to create a force on that ball, and the ball would create a force on it.
It can't go straight in both. It can't go straight in both.
I could force it to go straight with a track.
You couldn't force it. Listen, you're trying to get away from the point. I know you disagree.
I'm not. I mean, I'm desperately trying to make it.
Hold on, man.
I'm desperately trying to explain things in terms to understand.
Let Jeremy speak, Xander.
I guess I'll just have to.
disagree
I'll
with
have
me.
to mute him. Just go ahead, man. I'll mute him for a bit for at least a second so you can speak.
I just want 20 seconds, not even. You agreed with me. There's no actual force being acted upon the ball in my example. It's purely mathematical. That's why I'm telling you that the Coriolis force is not a real thing. It's purely mathematical for what force there would be if there was a force acting upon the ball. We know there's not because it's really just going in a straight line because the guy standing on the ground threw it and the guy standing on the ground caught it. So there's no actual physical force there. It's purely mathematical, and it's not math is abstract. It's not real. That's all. Over and out.
Gio, I wasn't even talking. I was
Mathematically,
speaking.
there.
Go ahead.
I'm just trying to understand your position now, Jeremy. Mathematically, there is a force, but because maths isn't real or it's abstract, well, I don't understand that bit.
No, it looks like there's a force. It looks like there's a force, but we know there's not a force. They calculate how much force there would be if there was a force. But we know there's not a force because we know the ball is just going straight in my example, and there's no actual physical force acting upon the ball.
Well, when the ball is tossed out in a non-inertial reference frame, it does go off to the left. It does curve. I would say that's due to drag and conservation of momentum.
Listen to me. In my example, there's two guys standing on the ground, and they're throwing a ball in a straight line back and forth to each other. And there's a guy in the roundabout in the middle of them, witnessing the Coriolis effect. There's no force there.
This is the video I posted.
That's why people were so hesitant. It wasn't only Bob. I pitched this to these guys in Gems a long time ago. They told me it wasn't the Coriolis effect either. Do you know why? Because that example of the Coriolis effect scares them because it shows that there is no force and it's purely mathematical.
Jeremy, you're just not listening to me. It is a Coriolis force.
I heard you, Danik. You agreed with me.
I told you the ball is in an inertial state when you throw it, but from the non-inertial reference frame, it is taking a curved path. Those curved paths require forces. That force is actually calculable with math. It's not real math calculated, right? To give it transformation of what it's doing with respect to an inertial reference frame. We're doing a transform, okay? Now this transform gives us a potential force that this operation, this tossing the ball in that frame can provide. It's a potential, and that we can realize that potential by making that ball go straight. If we force that ball to go straight in the non-inertial reference frame, it will have a force associated with it. It'll be a real force. All you have to do is throw the ball down some tube. Throw it a straight tube. You have a ball inside of a tube. Hold on, let me finish because I'll let you finish. Throw the ball down the tube. It'll preference aside to one side of the tube and put force on it, and it would make that particular, depending which way you threw it, either speed up or slow down due to the conservation of angular momentum. So it is a force that can actually have real effects, but it's reference frame dependent again.
Okay, so if you got a tube curving it, I mean, I know you desperately want to change the example that I have, but if you have a tube curving it physically, yeah, so that's why the Coriolis force isn't a real thing.
It's real. It's reference frame dependent. It is real.
Well, it actually does happen with the merry-go-round, but the thing is, it doesn't happen with helicopters, blimps, and airplanes. That's the question.
Why would that be something you'd want to look into?
Wouldn't airplanes be in a helicopter or a drone would be in a non-inertial reference frame?
No, so you're confusing like QE does and Nathan Thompson and Nathan. All these people confuse this particular little example. No, doesn't mean that when something has Coriolis because it's in that reference frame that it has Coriolis. In order for something to have Coriolis in a rotating reference frame, it has to move in that reference frame. It has to actually traverse it.
And be a non-inertial.
Hold on. You got to let me finish. It has to traverse. It has to move within that reference frame. Otherwise, these effects will not happen. So a balloon doesn't experience Coriolis if it's just hovering above the ground. A helicopter, same thing. A drone, same thing. And airplanes airplanes are affected, but it's very, very difficult to measure because it's so slight.
All right, so I would agree with you 100%, Zanuck, that Coriolis could be demonstrated on a merry-go-round. 100%. But not with a drone, not with a balloon, and not with a blimp, not on Earth.
Well, it's because it doesn't happen with those.
I know, because we don't have Coriolis effect because the Earth is
No,
moving.
because you're not giving it a situation in a condition where they would be experiencing Coriolis. Again, did you miss the part about it having to move within and through a rotating reference frame? It has to be moving, otherwise there's no Coriolis. And we see this in real life by shooting very high caliber, large shells from cannons over 25 miles, and they're 100 yards off to the east if they're shot north.
Well, wait a minute.
Oh, let's prove this.
Yes, that's in every naval
But then we have
artillery manual that there is.
rubbish.
That's rubbish.
It's in a
Well, we
manual.
had to talk about this before, Zanuck. We did 25 miles at the equator. We shoot it from the land, right? It'll be about roughly 8 miles off if they don't count for that.
Where?
You said what, like 6 miles. What did you say? It was a
100
long
yards. 100 yards. 24
if they're
miles.
25 miles, I'm saying 25 miles.
Now,
Oh,
What's
you were
the busy
confused. You were
chatting,
confusing the arc. You were confusing the arc length for a flat surface or an arc. That's not what this is discussing at all. You're missing the point entirely when you say that.
Yeah, hang on. What about those who operate submarines and aircraft carriers? They don't. They said they never encounter Coriolis, and they don't.
If they're shooting something,
when they hang on, you see, this is how it goes, like a shit show. I'm talking, and you decide to talk when I'm talking. When I'm finished, I'll tell you.
Wow.
All right, I muted him.
attention.
It does get excessively interruptingly excitable. But yeah, go ahead, Jin.
I was just going to say that, according to those experts who protect the free world, they don't account for Coriolis effect at all. And aircrafts pilots said that when they fly their planes and they come to land, the runway is not moving from east to west, west to east, north to south. They don't experience any of that. The Coriolis, as far as they're concerned, doesn't exist. I'm finished.
So if then you could find some manuals that we're talking about Zanuck's point, which is about artillery, not about submarines or planes, and you did find it there, what would that tell you?
I would say to you, I can right now link you to 44 governmental documents that state Earth is flat and stationary. I can link you that right now. 44 governmental.
I'm asking you a specific question. I'm not saying can you show me other
no, that's my
documents
reason.
that make
You see how you talk when I'm
simplifying
talking.
assumptions.
Do you see how you talk when I'm talking? Do you see that? And
Oh,
then you
Jin's
wonder why
fired
I
up.
lose my temper.
It's because I asked a
I'm
specific
finished,
question.
I'll tell you. That's all.
If we did have
allow me to
manuals that
speak.
showed
Allow
artillery
me
do need
to
to
finish
account
what
for,
I'm
what would that
saying.
mean?
What is this? What is this? So you can't allow me to finish what I'm saying. I'm going to finish what
stop
I'm saying.
whining, Jen. He's being very calm.
Shut up, Zanuck. Shut up, Zanuck.
Well, Jin, some people want to go like faster back and forth discussion. Other times they want to speak for a longer uninterrupted period. But to be fair, Writing did ask you a question. You then started responding. He did interrupt a little bit, but he jumped in because he was clarifying his question. If you don't want to answer it, that's fine. But that's what happened there.
Oh yeah, but I understood his question clearly when he first asked it, and I'm addressing that. And that would mean that if he's trying to show me a document that proves the Coriolis or whatever, which I know doesn't exist anyway, I can link him to 44 governmental documents that state clearly from the governments and other organizations that the Earth is a stationary and motionless flat plane. 44 of them.
The question I'm asking, it's fine if you just want to say I don't want to answer it. I'll stop asking you. But I just get the impression you feel you are answering my question. The question is simple. If there are documents that say that artillery, the example Zanuck is using, does need to apply for that, what would that mean to you?
It would mean that the experts from the aircraft carriers are the ones who operate their ships 24/7, 365 days of the year. They're wrong. They're the ones in the theatre of war, so they're wrong. They're in a recent video called "Flattening the Curve."
Artillery are wrong because the people who do use artillery say that their Coriolis is a force. That would be your position on it.
Well, I'm talking. I'll let you finish. I'm referring.
I would agree with you. I would think the people who know less about artillery are more likely wrong, and the people who do know about artillery and write those manuals are more likely right.
I'm not going to disregard the experts in the field themselves in a video telling me that they don't account for this stuff. And if the Earth was indeed a globe, their equipment wouldn't work. They're the ones I'm listening to. They're the experts. So if you bring a document to me, I'll say to you, you need to go and check it with him, because what can I say? I can't believe that document.
Right, so you choose to disbelieve the document from the experts who do fire artillery, and instead go
I would have to see the documents myself, first of all, and then I would have to question those people. Are you sure? Because these are the guys
was posted in
who
live
use
chat.
this equipment. There are three types of three experts.
Yeah,
That's
my
what
neighbor.
I'm saying. Yeah,
I would just
my neighbor shot artillery in Vietnam, self-propelled howitzer, and he told me that you'll account for Coriolis or you'll miss. That's a guy that shot artillery.
yeah. Well, I don't care about your friend from whoever
Well,
that's
that-
rubbish.
So what
Today's
you have
experts, today's technology cannot do it. They don't encounter it. They stated it
sounds
clearly.
like it just sounds like what you have is second-hand testimony we can only get from you, not from them, from people who don't fire artillery, saying what artillery does, and we've got multiple examples here of people who are experts saying you do. And I'm just trying to say, how do we weigh these?
Well, with all disrespect to you, mate, all you have is second-hand information yourself, or even third-hand, or even fourth-hand. You have nothing that is concrete, really. Okay,
Well,
I can link you to
posted
the
something
documents.
pretty good in the chat there.
Well, it's pretty
The
good.
correction
That's what it
tables
is.
dependent on latitude.
Well, we have the experts themselves standing by them, telling you that they don't do that. Okay, so
But
and
which
I've
experts,
never
that's
seen that
what
video.
I'm trying to get at.
Flattening
Which
the curve.
experts are saying you don't?
I'm saying to you that the video that I posted to you, maybe 2 weeks ago now, they're in that video. They tell you themselves that if the Earth was a globe, the equipment they have couldn't work. They stated this. Did you
Right,
watch
but they're
the
not
video
talking about
from start
artillery,
to
are
finish?
they? I'm trying to stay specifically as
Well,
much as we can on the topic of just the artillery.
Yeah.
Not
Okay,
what you're
look,
interpreting about what somebody who worked on an aircraft carrier said about something other than Coriolis on artillery.
Well, these
I'm just trying to stay on
are
this one because
aircraft
of
carriers. Aircraft carriers have an artillery contingent, don't they?
No, they don't.
Submarines
No, they don't.
have missiles.
When have you ever seen artillery on an aircraft carrier?
Well, you know, when I say artillery, they fire shells and missiles, do they not?
No, they don't.
They fire
Aircraft
projectiles.
carriers don't fire artillery, Jim.
Most they've got is AA
They fire
guns, is my
projectiles, do they not? Do they
No,
not? Do they fire
the only
projectiles?
projectiles I understand they fire is anti-aircraft guns in case they're under attack from aircraft. But my understanding is the way they're usually deployed is, again, submarines don't have ballistic artillery. What they have is guided missiles that have control
Okay, they're
surfaces
guided
that guide them
missiles.
in
Well,
flight.
well, it's a similar thing, isn't it? It's a similar thing,
but
though,
it's
isn't it?
crucially importantly different. What we're talking about is unguided munitions and how they behave. And you're going, oh, but in these cases where they don't use that, they don't account for it. Exactly. That's what we would say. When people don't need to know about Coriolis, they might not know about Coriolis. So
They don't encounter for it. They don't encounter it. The Earth itself hasn't been, and the Earth itself hasn't been proven to be moving anyway. So why would they be accounting for something that the Earth isn't moving? And then the documents that I did say therein,
Is that called moving the goalpost, Jim?
that this is coming. I'm not moving the goalpost. I'm still sticking with it. 44.
No, you moved the goalpost quite a bit.
I'm not moving. The documents that I have said I would link you to states that the Earth is a motionless flat plane. In fact, it states flat Earth several times.
Yeah. It says no topography and no wind, so that's bullshit.
No, this is
debunked.
We know that aircraft flex. It also says a fixed mass, but we know that they change mass as they deploy their munitions and use up their fuel. But why does it say in one paragraph, in a run-on sentence, on a flat, stationary Earth with a rigid aircraft of fixed mass? It states 4 things in that, and 2 of them we know to be false. The other 2 are in contention. Does it sound like what they're saying is, here are 4 statements that are false that we are using to simplify this equation, or 2 of these statements are true and 2 of these statements are false, but we use them all in the same sentence for some bizarre reason? Which of those?
The main thing we take away, the main thing we take away from that I took away from the 44 documents, which I can link you to, The Earth is stationary and flat. It means it's not moving and it's a leveled plane. Not moving, leveled
You're just
plane.
stating your
Flat
conclusion.
Earth.
You're not really responding.
That is what
the
the documents state.
Waste of
So
time.
there we are.
Cherry picking the documents.
I'm not going to keep on reiterating what I'm saying.
Okay, let me do a gin then. But as we know, the Earth is turning. Everything you're saying is false because we've determined that the Earth is turning because we know why the Earth is turning. Therefore, it's false. It just becomes a non-conversation, Gin.
You don't know that because there's no evidence there. It hasn't been proven, and even Einstein has said it himself. So no. You're stating something that can't be proven. Default, the Earth doesn't move because when we stand on Earth, it does not rotate at all, not at all, and it's flat.
Can I ask a
we don't
question,
measure it on
Jin?
curvature, do we?
Evidently.
Go ahead.
So, Jin, the documents say that the Earth is flat, so there's no topography. Do you accept that?
Of course, I do not accept that, do I?
Okay. And the documents also say that the atmosphere is stationary in relation to the Earth. Do you accept that there's no wind?
The documents didn't say there was no wind. The documents state that the Earth is motionless. It means that the Earth is not rotating on any axis, and it's a level plane. When you take an overview of it, 71% of the Earth is water. Water is always level, so it's a level plane, stationary.
Tries 10 points again.
Able to follow the conversation.
Yeah. So
the
documents say that the atmosphere is stationary, so then there would be no wind. And also, now that you said that it's 71% water, how do you get to 71% without using the globe?
You don't use the globe to get 70. Why would you need a globe to prove that your Earth is water?
Hold on.
Why would you need that? That's silly.
Jin, hold on. Where did you get the 71% from?
Where did you get the 71% that the Earth is a globe? How did you get that?
No,
Where?
no
evidence for it.
You just said that the Earth is 71% level water. Where did you get the 71%? Okay, where did you get the? Hold on. Where did you get it from? Because that comes from the globe.
It's a known fact that the Earth is water is 71%. The globe, as you put it, is a fallacy that hasn't been proven.
So you're going to use that?
Hold on, Jin.
We're getting it from the flat Earth, flat stationary Earth is where we're getting that from. From the flat motionless flat Earth, that's where we get the 71% from.
Jin, if 71%,
we don't get it from a globe because the globe doesn't exist, does it?
Jin,
it doesn't exist.
So,
speak, mate.
Jin, if you get this the 71%, if you have the 71% water, you know that 29% is dry land. So we can take the dry land and measure the area of it, and then just do some math, and we get the whole area of the whole flat Earth. And that's not what you get.
Sphere make in reality. That's the problem. In reality, the Earth is not a globe. So that's just words. It's just words. It's intangible reality where we live in. It's not there. And the experts who protect the so-called free world tell you themselves that they don't encounter Earth's curvature or Earth's spin. Their equipment wouldn't work.
And you're still not answering my question. Where do you get the 71% from? No, you didn't.
I've told you the 71% comes from the fact that the Earth is flat, and that's what's been observed for eons.
No, that's not how you get 71%.
I don't get it from any globe, that's for sure.
Okay, so where do you get it from? You have to get it from somewhere.
He got it because
I don't get it from globe. I get it from the flat Earth. From the flat Earth is where I get it from.
The 71% comes from the globe. I mean, you can just do the math yourself.
It's water, as you well know. Water is level. You know that. You know that.
And also,
you know that yourself. Wherever you've seen water, bodies of water, whether it's in your bathroom, swimming pool, out in the ocean, lakes and ponds, the surface is always level.
Wrong in this.
This is pointless again.
Yeah.
No, it's the truth, isn't it, though? But it is the truth, though, isn't it?
But you're not responding to questions, mate. People are trying
to
ask you questions
I'm
and you're just using it to shout words at us all. It's boring, mate.
Yeah, Jin, it's not truth. It's not truth when you don't know where you get your 71% from.
It's truth when you see it with your own eyeballs. Wherever you've been on this earth,
you haven't seen
you've
71%
never seen a
of the earth.
water. I'll carry on. You've never seen water conform to the exterior of a spherical ball. You've never seen that in your life. It's never happened.
Have seen that.
Especially when the ball is spinning. The water just flies off.
I have seen that.
Well, you'd be one in a million.
I think most of the people have seen wet balls.
of the human race has never seen that.
I've even
Okay,
played
wherever you see
basketball.
water, it's always level in its container,
Hey,
in a
Jen,
lake, in a pond, the
Jen,
ocean,
you just Jen,
bathroom, swimming
you're
pool.
rambling, man.
I'm not rambling at all.
Yourself, mate. It's so
I'm not,
dull.
I mean,
it's okay to
It's so
I've
repeat
got him
dull.
caught.
myself.
Yeah, now
Don't
he's
accuse
just
me of rambling.
Well, Jen, I think a little bit the feedback
resent
you're
that
giving is that
gratefully
you're
because I'm allowed to say what I got to say.
Just
well, hold on,
filibustering
Jen.
with
Let me just say something. I think maybe a little bit of constructive something I could say here. I think what they're saying is you tend to kind of like a lot of output, but you're not as much actually like interacting with what's being said, you know, individually. Like you're kind of just using it as like an all output, you know. Does that make sense?
Okay, I'll tell you what I'm doing, Gio.
They want to engage
it's the
a little bit
basic
more. It sounds like.
foundation. I'll tell you.
You're so diplomatic,
I'm engaging
Gio.
perfectly. I'm engaging perfectly because I don't want to go into. I do not wish to go. Hang on. I do not wish to go into the weeds, and I'm holding them. I'm holding them to the basic fundamentals, and that is water lies level. And that's the basic fundamental. I'm engaging perfectly. I'm just not allowing them to run ragged with silly little theories. That's all. I'm shutting them down.
Shouting
That's what I'm doing. That's
repeatedly
it.
your conclusion.
It's a
at us, not
deliberate
engaging
action.
with the points we're making. It's dull. That's the feedback you're getting from everybody here. Can you respond to that feedback as a teacher? Would you
You're not
like
making
your
any
students
point.
to be good at responding to feedback?
Look. I'm not going to change my stance.
Why not?
I'm not going to change my stance from this. because I'm going to lay
that
down
not
the
what
basics.
big people
That is
do?
water is level. You haven't conceded what I've said. I've made a few points that water, where you sit, is level.
haven't.
Wherever you sit, you haven't actually addressed that.
But
You
Jen,
haven't. Have
I
you?
addressed it.
That's why
I
I repeat
addressed
myself.
it. I addressed
No,
it. I
you
said that
haven't.
I've
You
seen.
haven't addressed the fact that water lies level wherever you see
Water
it.
lies level.
Wherever
No,
you
it
see
doesn't.
water, it's level, isn't it?
No, it
Wherever you
isn't.
see it is, you see?
No, but it isn't.
So you're saying that when it's in a bath, is it level in the bath? Water's
Sure.
not level
Yep.
in the
It's
bath.
level in the bath. Yes.
Water's not level in the swimming
Is
pool.
it level? Is it
Not
level when
in the
I have a
swimming
drop
pool.
of water, or
In
if
the
I have a
swimming pool.
basketball that's wet?
Questions in the swimming pool.
So
In a
you're not
pond.
going to answer any
In
question.
a lake.
No,
On the
this
ocean.
is just so pointless. He's just
You're not addressing the points that
And
I've
that's
made.
always the case
You're
with him.
not addressing the points
He's
that
trying
I've
to
made.
address your point, Jen. Hold on, guys. He's trying to address your point, Jen, but you're not addressing his response that he responded to you back. You're not having a conversation. It's fucking boring.
It's so boring.
Yeah, I'm not gonna address him
It's
anymore
exactly,
because
that's what it is.
pointless.
Do you
He's
think
just
that
gonna
you'd be
preach.
better at sharing your truth, Jen?
You are obfuscating the truth. You're acting dishonest because you know water lies level.
God damn it, Jen.
The answer is
that, you
yes,
idiot.
yes.
Jen, he addressed your point about water being level. You didn't respond to him at all.
Yeah, then you gotta let them respond, bud.
No, he's letting them respond, but Jen's not responding to them. Did you hear his response to when you said water's level?
Where is water? He didn't say. I asked him the bathroom, the lake, the pond, the oceans. Is the water?
And he gave you multiple examples of when it's
in
not
the
level.
areas
He said
I
yes.
mentioned?
He said
I didn't
yes.
hear him say yes. They are.
He said yes.
Okay.
Yeah, he said yes. That is level, and then he gave you examples of when it's not level.
You're breaking up.
What examples? What examples? What examples?
You didn't hear
What
because you
examples?
were running
Not
your mouth.
listening, mate. Don't complain to other people.
I am listening. What examples did he give? Examples did he give?
Well, maybe hold on. Here's one suggestion, Chin. Like maybe like it doesn't have to be like a big like aggressive showdown, you know. And maybe that's why you feel more like you have. And then there is sometimes interruptions, but we can just have a good discussion. You know, it could just be like having a cup of coffee together. You know.
That's a good idea.
Coffee.
I don't drink coffee. Now, come on. Where are your examples of water sticking to a board? That is
Coffee with knuckle
He's on
dusters.
fire.
spinning board, please.
Repeat
water sticking.
Maybe a cup of tea. How about a cup of tea? Like a cup of chamomile tea. Very relaxing.
Cup of tea and knuckle dusters.
A chamomile tea and a joint.
A glass of water room temperature would do nice.
Sit down and
I
have.
don't hear any examples.
Well, let's get back to where it was at. How about Mailman? Ask your question again or whatever, and then Jen, see if you could possibly speak to it directly.
Yeah, I wanted
so
to hear his
where,
examples of water sticking to a spinning ball.
it's impossible.
Jen, hey, Jen.
Do that. Let's have me talk again. I heard what you said, Gio.
Hang on, guys.
It was
Hang on.
gin time.
Hang
That
on,
was what you said.
hang on. Jen, let Mallman speak and then you respond.
Yeah, he needs to respond to the question I asked him. What examples? What examples does he have? I'm picking it up exactly where we left it off. What examples does he have? Can you
I'm
give
going to
me
make
the
a call
examples,
here.
I don't want to try it.
Your examples, please.
Jen, if you're not going to cooperate and have discussion, we're going to have to just mute you, and you just have to be quiet.
Go ahead, Mo, man.
It's up to you, mate.
Yeah.
Can you control yourself? Can you manage yourself enough to speak?
All right, eggshells.
We don't need extra heckling.
Like, it's so simple, mate. Everybody's telling you this.
Go ahead, Mo, man.
Yeah, so if water is always level, then if I have just a droplet of water on a table, that water is level. And also if I have something like a basketball or a golf ball that is wet, then that water is also level. So do you agree with those two examples, June?
No, I don't agree with those at all. No, because I did say a spinning ball and water sticking to it, bodies of water where you can swim and fish on a spherical object. It doesn't happen, and you learned that when you were a little boy playing in your little bath. You learned that. You pushed the ball
So you
down,
have to have
it flew up and popped you on the head. So come on, man.
So swimmable or fishable water is level.
I'll ask you again. Wherever you've been on this earth and you've seen the water, bodies of water, level or not? That's all I'm saying.
I would say they are level. Yeah.
Yeah, level.
Yeah, level.
Right, well, that's it then. So there you go. Where's the globe? No, man, come
Well,
on.
there, just there, level.
Welcome to the flat earth, as we say. Welcome to the flat earth.
From the center. Just level, yeah. With the definition. But I'm still baffled to where did you get where did you get the 71% from still? I mean, that baffles me that flat earthers keep using that number when it comes from the globe. The area of the sphere.
Yes,
I don't see a problem.
Actually, for a while.
Well, there's a lot of water. I mean,
yeah.
Whatever the percentage is. Obviously, there is
the problem is
water.
The problem is that if you agree with the 71%, then you kind of agree with the globe because that's where the number comes from the area of the land and water on the sphere.
Yeah, I think.
No, that sphere is fantasy.
No, that's fine, but I don't think when people say that point, I don't think they're trying to say like that it's that exact number on some limited sphere. I think they're saying that just meaning that there's a majority of water. I mean, I can't speak for them, but yeah, that is kind of a mainstream thing. But either way, like that, it's a majority water is the point.
So, Gene, do you agree with the 71% water?
I agree that the Earth has 71% water when you fly across the Earth.
I mean, on an AE map, it'd probably be more like
it's a wash with water, of course. It's a wash with water.
80.4.
Where are you with this jets don't use fuel business? Because in that same video you keep touting each time you come in here, they specifically address that and say that not true. Where are you with that?
Do you remember my last comment? I'm still looking into it, although I am paying attention to the experts in the video who stated that not everything is a conspiracy. Jets do use fuel. My contention is how much fuel do they really use still? So it's still for me. The jury's out on that one still. Okay. Although so I'm listening to what he said, and I'm saying that I'm not disregarding. I'm not disregarding. When I'm finished, I'll tell you. I am not disregarding what the experts have said. I am now looking into it. They brought it to my attention again.
Good work.
So it's still under review for me.
So the experts,
that's all you can do, Jim.
You may be right on this, and the experts may be wrong. Is that that's what you're saying? In this video that talks about many things, including the shape of the Earth and whether planes use jet fuel, you've decided that some of those, despite being experts, might be wrong.
Well, I'm intelligent enough.
Yeah, I agree.
I'm intelligent enough to discern. to discern that.
Experts can talk out of their field, can't they? They can talk out of their expertise. They may be experts, but they should stay in their lane.
Yeah, bang on. I absolutely agree. Yeah, I think they could be wrong. I think we're both on the same page.
Yeah, that's right. So thank you very much. You know my position.
They're wrong
Please
about
don't
the
ask me again. Yeah.
I think they're right about whether planes.
Or
use
you
jet
may
fuel.
ask me again because I may
The bit
find
that is
out.
inside their field is how planes work, how jet engines work, and on that bit that was inside his field, he was unequivocal that not everything is a conspiracy. Planes.
Wouldn't that be Boeing and like Mercedes?
This guy in his introduction said, I've been an aeronautical engineer for 20-something years. I forget how long. I've worked on all planes, big planes, small planes, passenger planes, military aircraft, choppers, jets, the lot. And there is a conspiracy going around the flat Earth circles. That,
And he didn't say any of that. That was just a bit over the top there.
I can get you the clip if you want. His name's Rob Taylor. And he says,
I know his name's Rob Taylor, but he didn't shout all that stuff you said anyway. But carry on.
He said, not everything is a conspiracy. Planes do use
that's
jet
correct.
fuel.
That's correct. Keep it clean. That's exactly
So
correct.
on the bit he's inside his wheelhouse, as you would put it, or his field of expertise, I would agree with you, Whites. He's probably right. On the bit about the shape of the Earth,
okay.
I think like Jin, I think he might be wrong about something. It's just that I think he might be right about the thing he should be expert on, and wrong about the thing he might not be expert on.
Okay, you're
just because he's an aeronautical engineer, he could just be like a service tech though as well. Like he just services them. He might not have anything to do with the R&D and actually developing a jet turbine.
This heuristic of like, are they an expert, therefore right, is a very rough heuristic that can regularly be wrong, but it's just a useful one. Is this an expert who is commenting on something inside their field of expertise?
I can imagine a service tech of one of these jet turbine engines talking himself up. I'm an aeronautical engineer.
Would Lapua be considered a expert source for long-range ballistics?
I think so.
The quote you made about experts being regularly wrong, that's totally, that's a baseless claim. Experts are not regularly wrong in the fields they're in, okay?
Okay,
so
Jin, I agree with you.
That.
Would you please explain to me why Lapua, who we agree are experts in long-range ballistics, have the calculations in their ballistic app for Coriolis effect?
Yeah, again, like I've said, you know, that I'll never ever believe that because from my knowledge,
can you at least attempt to address the question, please, Jin?
Okay, look, I listen to you. Can you allow me to speak without rumming up
Would
your
you
mouth?
address the question then?
I'm going to address the question. I'm addressing it. I'm saying to you that I will never believe that because of the knowledge I have that the Earth is a stationary, motionless plane. Okay, that's my experience, plus professionals in the field, plus documents. So what you have to say has no meaning for me.
But Jin, the professionals in the field are Lapua, who included Coriolis effect in their ballistics app. Why?
Let's test it. Let's test it.
Yeah, let's do it. Sure. I can tell you right now, when this app became legal for competition scores increased. So you feel free to test it. It's a great app. It's free. I just posted in chat a little while ago.
You had a fucking rave?
Just need a cannon, something we can shoot, you know, a good bloody 20 kilometers with, and get to the equator so we can do a north-south.
Wasn't it? I forgot they have this shit shut off, and then Mackenzie's lights were on. I was like, oh shit. How much longer we got left?
Are you talking to us, Jeremy?
My bad. I'm hot micing. No.
The
I mean, I'll tell
Lapua app.
To shut their fucking gate if you want.
The Lapua app, one of the reasons I bring it up is because it's designed for shorter range, using non-artillery, but rather shoulder-mounted or shoulder-fired weapons such as sniper rifles.
Oh, you'll never tell the difference with wind and everything else that goes on. Like that's just not here, not there.
I think Zanek's example of the artillery is better because 25 mile range and a big difference like 100 meters. That I imagine is difference between hitting your target
from the equator, north and south, where you can just literally turn it around and shoot the other way and see it happen exactly the opposite direction. You know what I mean?
We can also go east-west to
it's bullshit
because you'll go left or right, north or south, but you'll go up or down, east or west.
To Jin and or Whites, whoever wants to respond, or anyone, do you think that there is or could be an effect happening on a stationary Earth that causes what they call the Coriolis effect? Like, do you think the phenomenon is actually happening, even though on a stationary Earth?
Regarding the snipers, regarding just the snipers, when they fire their projectile from the rifle, they have to account for the projectile, the elevation, wind speed, and a distance to the target. Okay. Now, when they fire, they do some of them do like a sight around, and if it's moving to the left or the right, they adjust accordingly. That's because of the wind and also the spinning of the bullet as it's moving, heading towards its target. That's it. That's the only thing I can say.
No,
that they account for.
no. In fact, you also have to adjust for elevation, temperature, air pressure, barometric pressure, humidity. All of these things are factors that are required in an accurate long distance shot, Jin. What the hell are you talking about?
You don't know those things over the corridor of your bullet. You're guessing them.
Right.
There are indications. Yeah, it is guesswork, but there are indications there are indications as well.
But it's not due to the answer.
And to answer Geo's question, I don't know exactly, but we see the stars and all that move around us. So if they're attached to some sort of field, then that field is obviously moving. So there could be some effect.
Yeah, I would agree with that myself too. Exactly that. Yeah, we don't really know, but I would say no. There's no Coriolis. That's for sure.
I think
certainly not due to the Earth rotating.
Yeah, it might not be due to that, but I think it's an important question that Geo is asking, which is like, could there still be this effect that people have always mistaken for Earth's rotation because it matches with the
Yeah, it's a good question.
It could in fact be something else.
Not mistaken for it. I would say that it was reverse engineered.
Hijacked.
Yeah.
There you go.
But I mean, by a modern person who's firing an artillery shell, who's deliberately aiming left because he's pointing north or whatever the fuck it is, could he mistakenly think I'm doing this because of Earth's rotation, because it comports with as if in a rotating Earth, but might be wrong about that. That's what I mean by mistaken for. I don't mean like
that's what the story says. He's never thought to test it.
Yeah, in my 5 years of military experience in Britain, the word Coriolis never came up once. Not once.
How many times did you fire artillery?
We didn't fire artillery rounds, but we fired long distance shooting. But again, it never. When we were shooting, we did the word Coriolis did not come up at all. So when I went in 2015,
let's just have a bit
in 2015, can I speak? Can I speak without you interjecting? Moderator.
Not long filibusters. The simple question was, what's the longest shot you took?
Oh, right. So now I can't speak now. Then you accuse me of barraging in. Quiet. When I heard about the Coriolis, it shocked me. That's all I've got to say.
That's how we're going to do it. Okay. I mean, I just think it's a fairly simple question that you should be able to answer, which is what's the longest shot you took? I can tell you mine, and I doubt it would be more than 200 meters. It probably would be above 100. The longest I've ever shot at anything, target or otherwise, about 150 meters.
I have to say around about 200, maybe a little over 200 meters in my experience. That's the longest I've ever done. But even in that shooting, we never heard of the Coriolis effect. That word, I was in the military in the 1980s. It never came up.
Would it be important to tell somebody about Coriolis effect if the furthest they're going to shoot is 200 meters? Does that make any sense at all?
I don't know, really. I mean, I don't really know. The fact is, I never heard of it at all. And you ask any military man in Britain, they'll tell you they've never heard of the Coriolis effect, and they don't take it into consideration.
Jin, do you know that they do put it in certain writings, though, in certain military manuals? You do know it's in writing, right? It's in their documents.
Definitely there.
Yes, yeah, I heard. I don't know about the British manuals, but in the American manuals, yes. I don't know about the British manuals.
Well, longer distances, usually with longer distance ballistics.
Exactly.
Yeah.
Nobody needs to account for it at the distances that you're talking about, like doing something small scale, 200 meters, that it would be such, like, I mean, we could probably calculate it. Muzzle velocity. Let's do it. Do you want me to do it? Will it convince anybody? I won't do it unless it's of some interest.
Not really necessary because, like I said.
But I can.
You could test it with a gun. You could test it with a rifle setup. One of the ways I've thought of doing it, which I thought would be so cool, would be like where you have like you're not going to have a human holding a gun. So Jen, your mic's echoing. you wouldn't really want a human holding the gun. But if you had like a machine, you know, like a stand, like a really high quality metal stand that was very, very solid, you know, built very well, and then you have that be able to rotate, and you could rotate it remotely, so it would be on like a, you know, like a remote control system. And so you set up that rifle. Of course, if you could have it indoors to where you don't have wind blowing, would be great. So a huge indoor like arena type thing. You wouldn't have to have very tall ceilings, but just a massive floor size. And then that gets into the distance and the margin of error to be able to pick it up. But nonetheless, if you had like a turret like that, like a gun setup, and then you have multiple targets at sort of like the positions of like, you know, like the 12 positions on a clock, something like that. You have one at the 12 o'clock position, 1 o'clock, 2 o'clock, 3 o'clock, and you have targets at all of those. And then you can control the gun. You can, you know, control the gunshot and the rotation of the gun and, you know, the aiming of it as well. And essentially have it to where it's a completely controlled environment, and then have it shoot in all of those directions, and therefore then be able to pick up not only if the effect, but also how the effect varies depending on what exact position the gun is. And if you got a consistent like bell curve of an actual drift effect, that would be amazing. You'd be actually picking up the vortex of that.
Yeah, absolutely. I think that's yeah. I just don't think that. I think that'd be a great test. The longer distance, the more gross the result. The bigger and more measurable the result. Which I think it'd be great. The position I'm taking that I think that Jin needs to either acknowledge that he has understood or rebut is I doubt you would see that effect at 200 meters. I imagine the effect at 200 meters. My guess, having not yet done any of the Coriolis calculators online, less than a millimeter. And I suspect he was only required to be able to hit a silhouette of a man at 200 meters, not be able to get a 20-cent piece at 200 meters.
What effect would the spiral? What effect would the spiral grooves referring to as barrel rifling have effect on the spin? Wouldn't that cause it to drift up to like say the it would cause it to drift.
Left and right-handed wind drift. So
right.
To do Geo's thing, you'd have to do one with left-handed rifling and one with right-handed rifling and compare them, which you could do.
You have to do that east to west, right?
Or just shoot a left-handed rifle barrel and a right-handed rifle barrel both times for every test. So shoot one east-west, shoot one north-south.
Yeah. Okay.
Yeah. And then you would be able to get the wind drift effect. But my understanding is, that will be more a bigger effect.
You would have to do this in a warehouse though, but so you can count for wind.
Exactly. Because wind is an issue. The other issue is, at least unless Jin was in some specialized sniper unit, which they wouldn't be shooting over 200 meters. You can correct me on this, Jin, but I'm going to bet that you were shooting on iron sights. Is that correct?
No. Targets out in the field, but iron targets, yes.
Iron sights, yeah, and not, and I'm also going to guess no magnified optics. So there was no scope on the gun.
No.
So iron sights, I've shot with iron sights plenty of time. Don't go hunting with them for this reason. On iron sights, even if you hold them perfectly straight, the area that you're looking at, even at only 200 yards, the center of your crosshair is about the width
200
of a
meters
20-cent piece anyway. It's a big old, because it's iron, I don't know, if anybody's used a gun, they would know what I'm talking about, but like they can't file it down to a tiny little pinpoint because it'd get damaged when you sort of jump over a berm or something like that. So the iron sights are quite stocky, somewhat tough little chunk of metal.
Yeah, of course.
But as a result, you don't get this tiny little pinpoint where you're aiming at. You just get this it's kind of, it'd probably be about a closed fist would fit neatly on that iron sight, and you're hitting anywhere in that closed fist at 200 meters. So if Coriolis is far smaller than the accuracy you can get just looking through the sights, let alone firing the bullet, it's not the
No, I totally understand what the Coriolis is, and I can stake my life on it that the Earth is not moving and there is no Coriolis. I'm prepared to die on that one, regardless of what the documents that are being printed in said artillery and that. Okay.
Well, the thing is, Jin, I mean, there's a couple phenomenons that are happening. Like you've got the full call, Jin. I guess, Jin. You've got it's the echoings. You got to fix it, please. But Well, I think Jin he tries to locally remember to mute himself every time, but of course he doesn't do that, so it just stays open because obviously it's hard unless he's on the habit of muting, unmuting every time. But what was I actually saying about? Oh, I was saying there's several phenomenons that's occurring. I mean, you've got the Foucault pendulum phenomenon, the wind patterns in the north and south, the bullets and the projectiles,
Gyro compass.
Gyroscopes as well.
Yeah, gyroscopes, gyro compasses. Yeah.
There's a difference between something appearing to deviate and something actually deviating, though.
Yeah.
You know what I'm saying, Gio? So, like, the way we can tell on the roundabout if something's deviating, if it's Coriolis, is we can see it from both frames, right? That's how you prove that it actually is the Coriolis effect happening. Not with math, not with no bullshit, right? You can go to both frames, see it's happening.
Yes, 100%. You should be able to just observe this without all over the place.
That'd be tough on Earth because you'd have to
Shouldn't planes be flying backwards? What, do east-west? The Earth rotates east. They should be appearing to fly backwards going west.
Appearing? What do you mean by appearing?
If they're going, okay, so going with the Earth, okay, so if you're going from, say, New York to California, the Earth rotates east direction. All right. So if you're going New York, okay, so the plane would appear to be going backwards due to the Coriolis.
That's painful.
Yeah,
no, it's tough.
It's just not understanding Coriolis. I'm sorry, mate. If you get the Coriolis calculator and show that that's the effect you'd see, then sure, we can entertain it. But what you're talking about doesn't sound like even Coriolis. It just sounds like another way of saying why do helicopters stay still.
There's a lot of people under the misconception that think that if Coriolis happens, then a hovering helicopter would deviate.
Yeah.
But it's not like that. You got to change your tangential speed. So you'd have to go up or down, or you'd have to go, north or south or something to a different tangential speed of Earth's rotation.
You've got to be going exactly as you said it. So it's
the
effect that you're talking about is not Coriolis. It's a different conversation, Don.
That's what would happen if the atmosphere wasn't moving in lockstep. Yeah, if atmosphere wasn't moving in lockstep with the Earth, then that would happen. But they got the atmosphere moving in lockstep, which is absolutely ridiculous.
So here's what you ask them. So whoever said that, here's what you ask them. At what height can I hover without conserving momentum? Because in their model, there's almost no atmosphere at 10 miles. But if you go up there, you're still...
Sorry.
Go ahead, man.
Conservation of momentum is not the only reason for it. It's also because the atmosphere is moving with the Earth.
That's what I'm saying. When we get up to 10 miles,
launch east.
When we get up to 10 miles, there's no damn atmosphere to carry me along, hardly. So, at what height does this conservation? At what height does the atmosphere quit dragging me along with it? I've never got an answer to that.
The conservation of momentum doesn't run out, though. If there was no atmosphere, you'd still have the same thing.
Yeah.
The atmosphere being in lockstep with the Earth, or there being no atmosphere, you'd get the same thing.
You've been drinking the Kool-Aid a little too long, Jeremy.
Dude, I don't know. That's their model.
He's explaining to you our model. What you're not getting is you're conflating two topics. The topic of whether
no, it's added to it.
There's two things can happen while still being different topics. Conservation of momentum is why rockets launch east, because the Earth is spinning east. So even when they're up beyond almost all of the atmosphere, they've got that. The closer to the equator they are, the closer it's going to be to 1,000 miles an hour free.
I get your point, right? But I'm saying when the plane flies from New York to California, right? Since not fully lockstep, but sticky gases would make the airplane appear to be going backwards. But just like Brian added to it, it's less dense up there as well.
You're saying if it's going like 600 miles an hour into 1,000 mile an hour Earth spin, that it would look like it's going backwards, like 400 miles an hour. Yeah.
It would appear like that.
Well, they don't quite claim that. They don't quite claim that's how. Well, they kind of have to. It's strange. Like it's almost like they say, oh, it's 90-something% that everything's lockstep, clung to it, water, air, everything, to where you can't tell you're moving at all. However, there's this little bit, maybe only 1%, where there is this little bit of difference between the gravity, the atmosphere, and the spinning Earth that does make that effect. But they claim that it's such a tiny amount that it wouldn't be as much as like spinning into 1,000 mile an hour thing and then actually going backwards.
I got to find a way around it, I guess, somehow.
I mean, there's no way to find a way around somebody's misunderstanding of something.
There's definitely no misunderstanding, because you guys will say the Atmo does go with it, so we barely see it.
It's two separate things that are working in
Okay, so
concert with
why
one
we don't
another
observe
for the
an
same base
airplane
effect.
going backwards?
I mean, like, I don't know how many other ways to explain it to you. The air is an accelerator that disappears away from us, right? It's mostly with us, but there's winds that go in different directions, and at different latitudes that will mean a greater or lesser thing. But I don't go from 0 degrees latitude on the pole to in an instant be standing on the equator. If I did, then you would get the effect that you're talking about. If you could teleport a plane there, but it conserved its momentum, you would find that the plane is nigh on stationary at the pole, and then as you teleported it to the equator, it would suddenly be going at 1,000 miles an hour. Yes, but those are separated by thousands and thousands of kilometers. So as you go to that thousands and thousands of kilometers, what you've built up by the time that you get there is a new tangential velocity going sideways, helped along by the atmosphere that's moving because it is subject to the same force.
If only it was turning, hey? You were right, Shells.
Yeah, if
You'd
only
be
it were
right.
turning, it would, yeah, all of this would make sense. None of this makes sense if we're not turning.
None of this proves that it is. We just need to go back to the basics. First principles. Are we turning? Or is it just turning above us?
Man, for real though, how many of you guys have seen an airplane go backwards?
Yes,
The way
I've
to
seen
prove
it look
Coriolis,
still, like perfectly stationary, which was fucking trippy.
like I said, the way you prove Coriolis is you get in the inertial frame, you see it going straight, you get in the fucking non-rotating, the non-inertial frame, you see it curving.
But here on Earth, we're in the non-inertial rotating frame, so you would have to go to a point in outer space to observe it from an inertial frame of reference.
Even then, if they did that, they would just move at 1,000. I don't know.
Wait, hold on. He almost answered my question. Howard, you just said a point in outer space. Okay, what point would I have to go to? What's the lowest? You ain't even got to be exact. Just give me an idea of what height do I have to get
100
to?
miles. 100 miles.
All right, fair enough. You're the very first person to ever answer that. Hey, kudos to you, man.
You said 100
miles.
He just said a number.
You got to keep that. You got to keep that.
Can I ask?
I don't care, dude. That's the first time in 5 years I've ever got an answer. I'll give him a pat on the fucking back, whether he's right or wrong or fucking. I don't care.
Can I ask a question and then a follow-up?
Go ahead.
When people disprove flat Earth by misunderstanding it, seeing it, for example, as a disk floating in space, why are all these other planets round when this one's flat?
Oh boy.
Yeah, old boy. What is your reaction? Tell me what's behind the old boy.
Mixing two models together.
Mixing two models. Yeah, misunderstand.
Yeah.
Would it be also characterized as attempting to debunk your model by mischaracterizing it as something it isn't, and then debunking that thing that the model isn't? Right.
Yeah, when you mix two models together, right, and try to make one look like the other, you're kind of gonna be like, dude, you're gonna be wrong.
Conservation of momentum. That's what's happening right now. People keep mischaracterizing the model and then attempting to disprove this misunderstanding, this misconception of what it is, rather than trying to understand it deeply as it is, and then show why that is false, or just choose to disbelieve it anyway without.
Well, no. You guys say that helicopters and balloon, that they blimps don't, the Earth doesn't rotate underneath it because, you know, it's actually not fully lockstep with the atmosphere, but it's moving with it, right? So, I mean,
So
how
what
is
you need to
that
be able to do,
misunderstanding?
So what you need to be able to do is demonstrate a keen understanding of exactly what we're saying and showing how that's false, whereas this stuff about blimps and drones and stuff totally misunderstands the model. And then goes, why doesn't this misunderstanding, this mishmash of my model and yours, show what just your model says? It doesn't,
Eggshells. It's
because the bits
either
you
the
put in
Earth.
there.
Eggshells. It's either the Earth rotates underneath things, or everything rotates with the Earth, and we don't observe either.
Wrong. Couldn't
So,
it be bits
what do you
of
mean
both?
wrong?
Couldn't it be bits
It's
of
both. It's both.
Couldn't it be that many things, most things, rotate with the Earth, but there are some things, like the moon, like satellites, like
Oh man!
planes
Oh,
and
here we.
things that move somewhat independent of the Earth. That me as a human, when I walk across the Earth, if I walk east, I'm in some ways mostly matching the tangential velocity of the Earth, but by walking speed in whatever direction I'm going, I'm either adding or subtracting or changing that vector slightly. So is everything either in lockstep or completely divorced from it? No. Right? That is a misunderstanding of the model. That's what I'm trying to get across to you. When people say, how does this disk floating in space work with these other things? You go, that's ridiculous. You're not understanding my model by trying to debunk it. And then I'm saying to you, that's what you're doing.
Yeah, in order to get Coriolis on the globe model, you got to change your tangential speed.
Yeah. Go to a different latitude is one of the most reliable ways to do it, which is why north-south shots are affected and east-west shots aren't. They're affected by yacht force.
You could,
Even
you
though
can do it up.
they're unbonded, you know, we give them that. We let them beg the question. Even though we know gases are elastic collisions, they're unbonded even to themselves. We still let them take the atmosphere along with them, even though we know that the wind moves separately from the ground, whatever you want to call it. We give it to them usually on this channel just for the sake of conversation.
Just for the sake, Brian. Yeah, you got it. You got it right there. Unbonded. Isn't that just tough writing?
Not really, no.
I mean, yeah, if you
don't
if
even
you
know
want to
what that
argue
means.
that,
No, I mean, again, what you need to show, if you want to impress me, I think I would like to hope that I would be big enough to admit it. I think that Left Lane would, because he's very fair. If you demonstrated a keen understanding of the model and then showed why that was false, I would like to think I would be big enough to go, okay, great, proven. We've been debunked.
Hey, Ryden, if you are on those,
I'll do. I'll let you use any ball in the world. Okay, I won't even make you use a vacuum. You could just use regular air, which is a very big concession on my part. I should make you use a vacuum, but I'm not. Take any ball in the world and start spinning it. And if it starts, if the air starts rotating along with it, then yeah, then I'll concede. I won't even make you use a vacuum. Right?
All right, sure. Can the ball have paddles on it to help it along?
Man, I'll paddle your ass, man. You come up me with some bullshit like that, man. No, I'm just kidding.
Can the surface of the ball, like, here's what I think. If the surface of the ball...
Yeah, as long as it's... Hey, you can have paddles.
Brian.
You asked the question, bro. You can have paddles as long as they're ratio, as long as they're the same ratio as mountains on Earth.
Okay. So could we accept that if it was perfectly spherical, honed, like polished to perfection, it would be very difficult to get any effect off the Earth. But if
it'd be harder than if it was paddler.
If it was a tennis ball that had giant 6-foot long paddles radiating off it, we could very quickly go, yeah, that's going to push some air around. So all we need to do is go, 0 is none, some is some. Do we have 0 topology on the Earth, or do we have some?
Okay, well, what I said is you can, as long as you use the same ratio as the mountains on Earth, or trees, or whatever you want, as long as it's the same ratio. Yeah, same scale. Sorry, same scale. Yeah, you can use that. So
okay,
let's do it.
So tiny paddles on this ball. Great. The only other thing I would require is a 0.
Please quit with the fucking paddles, would you please? Please.
Okay, so tiny mountain shapes on this ball that are acting like paddles. The other thing I'm going to add to this is outside that, as close as you can get to zero friction. And then the only other thing I need to add is infinite time. Maybe not infinite time. Let's give it.
If you use paddles, I'm changing my shit. If you use paddles, I'm making you do the vacuum,
No, I'm
man.
saying tiny little mountains that are acting like paddles, and infinite time.
Okay, half a vacuum then.
Okay, so close to a vacuum, very long amount of time, little paddles. Yes, I think the air will move with it.
That concept,
I think that's how fans work.
Yeah, it's just not hard for me to grab that concept that the planet has been rotating for such a long period of time that of course the atmosphere would be rotating with it.
Howard, at least you're not prescribing to paddle Earth, bud. Kudos for that too, bud.
You did
Do you
it
get
down.
the point that I'm making that mountains could act like paddles? Like acknowledge that point and then rebut it rather than just sort of.
No, that's why I said ratio, because if you were to use a pool ball, you'd have to smooth it a little bit because the mountains on the pool ball will be bigger than the ratio of the Earth.
Sure, but they won't be perfectly flat, will they? They will have some effect.
So not like a fan, Ocho, not like a fan.
As a mountain, as wind rushes along over, say, the ocean, I would say fairly undisturbed can maintain quite a bit of speed. I would say when it hits mountains, slows down. I would say those mountains are acting a little bit like paddles. Sure, to the proportions we're talking about with a pool ball, you'd have to polish a pool ball up. But are they there? Are they imparting some effect? The tiniest bit of effect, provided it's not absolute zero, then all I need to do is dial up the time factor. And then it's having a
all right, I'm invoking the vacuum again.
But near infinite moments.
I'm invoking the vacuum again. That's it.
Uh-oh.
Well,
oh, you just lost your non-vacuum rights.
Oh man.
Well, the problem with this idea of this atmosphere that's going with the Earth is we have winds going in too many different directions. You have winds going in 90-degree opposition from one layer to another, showing that it can't be the Earth's atmosphere going with the Earth. It's going in too many non-uniform directions for that to even be a thing. And so more than likely it's flat with different layers of air doing whatever on different days.
So we could have winds on flat Earth. We can't have winds on a globe.
Well, the Earth appears to be motionless, and there appears to be some other source of the wind blowing it this way and blowing it in another direction.
You can only have a vacuum on a globe and guillotine wind shear.
At the very least, it's motionless. Now, the shape that is, like you appear to be implying, irrelevant to the blowing of the winds, but at the very least, it's motionless. And the globe Earth has movement, so at least one pillar, the movement of the globe model, has been destroyed by the different movement of the winds in different layers.
Yeah, I'm kind of. I mean, yeah. If part of your assertion is, but the Earth's flat, then yeah, we're going to struggle to have a conversation beyond that about whether it's flat.
Hey, Ryden, let me
How about the motionlessness? You have a moving globe model, but the different layers going in different directions fly totally in the face of that, some pun intended. So at the very least, it's motionless. If you're going to go with a globe, fine. But at the very least, it's motionless.
I don't agree with that. No, I don't know where we go from here, though. Like that's the thing. It sounds like you're demanding that we accept your premise that is wrong in order to.
I would think the dynamics would be more difficult to explain on a motionless Earth than it would be on a rotating Earth.
Yeah,
but the thing is, we
these
would
things
need
that
to
line up with one another really nicely, which is a
great way to go is
a
at
gyro
least
compass and a please, Brian.
Sorry, man. Sorry, I got a lag. Sorry.
We've got multiple things that seem to stack up, showing a 15-degree an hour drift. The sun, the moon, the stars. You know, almost all of them moving at almost perfectly 15 degrees per hour. That matches with a 15-degree an hour physical gyro compass on the ground.
No, what the thing is, when you change elevation, that reads differently.
No, it doesn't.
Bob even showed that, actually. He got 21 degrees when he changed elevation.
That was a longer time.
He got a failed result. Like, yes, an inexpert person multiple times proved that there was rotation, but he was sometimes got a bit of an incorrect result as to how much rotation. He never got negative 15 degrees an hour, nor did he ever get 0 degrees per hour. So
And
if
if you
somebody
look at
inexpert uses a tool poorly, I wouldn't count that as a result.
Yeah, if you look at the time interval on that 21 degree thing, it was more than an hour.
Really?
Yeah.
Yeah, but he figured it out like
awesome.
he figured it like almost a degree and a half off. But look, and he predicted that. But here's the thing. I posted that. I'll repost it. But the DRS documents for the engineering of GPS, the early day engineering, it clearly states that Sagnac is not due to Earth curve. I mean, due to Earth rotation. I'm gonna repost it. It's a short video. Anybody wants to watch it.
So even though the manufacturers of the compass specifically say that it is affected.
No, this is GPS. This is the engineers for the GPS. It's in the documentation.
GPS isn't affected by Sagnac. What Sagnac effect is only
No,
for
the Sagnac is not.
report.
No, they have to adjust for Sagnac, and they say the other ways they also have to adjust for the same effect. It's not Earth curve. It's the motion of the receiver. I'll let you read it, but it's not Earth. It's not Earth rotation. It clearly says in the documentation. This was before the debate too, so they're just shooting it on us. They ain't had a chance to change it yet, but they probably will.
Yeah, who?
Yeah, let's not forget that we went over this frames of reference thing for like an hour.
Yeah, I wanted to add to
earlier.
it actually.
So there's no if there's no such thing as objective motion or fixed points in absolute space, then there's no way to tell whether the gyro is moving because of Earth or because of the space that it's in.
Fair. So what about if we said we don't know which it is, the gyro moving or the Earth, but they are disagreeing with one another on the preposition that they are both stationary? So indeed, it could be that the Earth is rotating around the fixed point in space that is the gyro, or that the gyro is moving around the surface of the Earth. So we can still accept that, and then we go, we don't know which one's which.
But there's other possibilities. If space is an ether, a substance that's like a fudgy substance, it could move the gyro and process while the constant precession of the gyro, while the Earth is flat, motionless, and stays in place. So there's another possibility that's worth exploration.
Why don't we
that
feel
possibility is just absent any explanation.
Yeah, why wouldn't we feel that?
This field could pass through different objects, having a subtle effect on other objects. I guess the field is just affecting objects differently. It's like being in a river.
It only
A fish can stand motionless in a river while everything else moves around it. I guess that's us in the ether.
Electricity. Look, I'll give you an example. Like if you drop magnets up against copper, it's going to flow fine, or you could set it there gently. But if you drop it real fast, go into a copper, it'll shield itself like right before it gets there, or it'll drop through a copper pipe real slow. You got to have the motion. Without the motion, you get no effect. And there's a lot of examples I could give, but that's the first one that comes to mind. But vortex is its own science, man. It's progressing, man. They got to let go of this Earth curve shit and get back to reality, man. Like the GPS system engineering documents, who specifically say it's not, it's not the curve, it's not the motion of the Earth causing the effect. We could figure this out if we get back to reality. And you asked a question earlier, Eggshells, about where can you go from there. You don't have to accept the flat Earth, but at least consider the logic that we spit at you, man. At least consider it. That's all we could ask.
Try to consider it. I do try to. I mean, obviously there's dissonance and things get in the way. I do try and consider it, but the point that I've been trying to make or coming back to is, for me to consider it, one of the things that I think is important is that when I hear people on the flat Earth side say, here's what the globe model presents, and then when I investigate that, I'm like, that's not what the globe model says, then that makes me go, well, that makes me doubt their conclusion. If they go, based on my understanding of the globe model, I've proven it wrong with the following method, but they don't understand the globe model, then their disproof doesn't make sense, right?
Well, the flat Earth opens up different explanations for the same phenomena from a flat Earth perspective. It's just a change in paradigm and a change in thinking about this normie science from just a different, flatter perspective.
Sure. I don't. Yeah, I'm not disagreeing that it's a different perspective.
Well, give an example where you say something is wrong. Somebody made a claim about right?
The choppers that what the claim you made a few moments ago. If Coriolis, then choppers and hot air balloons. As Jeremy said, that is not what Coriolis is talking about. It only talks about things that are moving north or south, or essentially, Jeremy said it better. Sorry, change in tangential velocity. Something has a tangential velocity when it takes off over a fixed point on the Earth, but that doesn't change. So
yeah, that's right.
Coriolis doesn't affect it.
That's
It is
right.
still
Because
affected to other, subject to other forces. I'm not saying it's sort of hanging there doing nothing. But if the core question we're trying to go is what happens to things when they change tangential velocity, and you point at something that doesn't change tangential velocity, it shows you haven't understood the model. So what you're rebutting
I definitely
is
in
you're
a model.
misunderstanding
You guys have a paradox when it comes to explaining Coriolis with the Earth. That's why you guys want your cake and eat it too. You want it where the Atmos moves with the Earth, but then it doesn't move with the Earth. All things do deviate from straight and curve. Oh, they don't. We don't observe them. You guys, it's just a whole paradox about misunderstanding.
I'm not understanding which one within those you want me or anybody here to respond to.
What gases are unbounded, correct? So that actually doesn't rotate it. So we do not see Earth turning underneath things like blimps and drones and all of that.
Do your best job at steel manning what it is you think mine or Left Lane or any of the Globers' position is on this bonded versus unbonded.
The air would have to be bonded to the Earth for Earth to be moving and carrying the air along with it. As far as we know, that only happens when
for a steel man.
Yeah, that is the steel man of your position. You're basically saying that the air is velcro to the Earth and going with it somehow, like it's
no point
stuck
hearing
to the
any
Earth.
further. Sorry, Lemon. If you're presenting to me my view and it is wrong, and then you're going to attempt to.
So hold on just a second, riding on eggshells. We know that air only goes with a solid object if it is contained. Your model does not have containment for the air like a firmament, so we have a problem. I'm going to unmute you now, writing.
I don't appreciate being muted while we're having a conversation. I don't think I was being rude then.
You interrupted him because even if you thought he was not steel manning your position or whatever, you could have just just waited and then responded. So you have to let him finish is what he's saying.
Okay. So what I was saying was, Don, can you do your best effort to steel man what it is you think our position is? If you agree with this idea that you should be able to understand a worldview in order to rebut it.
My bad if I'm steel manning. What is your position, Raiden? What is the Coriolis on the globe?
The position about the bonded and unbonded, I'll give you first. It is not an either or proposition. Those are speaking in absolutes. To me, it is the territory in the middle. To me, virtually nothing on the Earth is bonded completely to the Earth. Not even the trees. They sway, they move, tectonic plates shift. Nor is anything completely unbonded from the Earth, because according to the model, gravitation, even the gravitational force, decreases at a inverse square law. So in essence, every object in the universe has, however minuscule, some effect on every other object in the universe. So it is not that the atmosphere either moves completely in lockstep with the Earth or totally divorced from it. It is mostly quite close to it.
Right. If the Earth was rotating, right, solids would rotate with it if it's fixed to the Earth, correct? But we're talking about gases here. Why are you talking about trees?
So now is your opportunity to do the steel man.
No, you're talking about trees. I went from gas. That's like me saying, "Hey, man, what do you think of these graphs?" And you point out lines over there.
Yeah, he's pointing out that
You
to
don't
say
understand
that
what
say
I'm
that
saying,
the
but you
atmosphere
think
is
I'm wrong.
steel man is
No.
Velcro is a straw man.
Well, isn't that what the model says, that the Atmo rotates with the Earth?
Yeah, but that doesn't mean that it's Velcro.
This is funny.
It means that it's Velcroed if you have it being carried along without containment. Most of the time, the air trails behind a solid object as the solid object moves forward in space. The only way that you have air carried with a solid object like that is if there is solid containment, unless somehow the air is Velcroed to the Earth. That doesn't make sense.
Has anybody seen a paddle wheel, paddle steamer?
Yep.
Right. Is the water, left lane, bonded to, Velcroed to the paddle wheel?
No.
Okay. But does it move somewhat with the paddle wheel?
Yes, it does. Just like fan blades can move the air.
Right. So I think you and I would probably be pretty good at steel manning our position. In fact, I reckon even left lane, do you want to have a go at steel manning? What do you think it is at Don Lemon's position?
That would be difficult. I mean, you know,
How much air is staying with the fan, do you think, at the tip of the blades, like locked on? Or do you think it's cutting through the air eggshells?
I think that it would, like, you're not going to find, like, if you looked at it at 1 second, you could sort of give a name and a name tag a single air molecule to a tip of a fan blade and then move on. You would never find that they're the same. Just the same as if you labeled a bit of wind that came past a mountain peak, you wouldn't find that bit of air was there. But that generally that mountain peak slowed down a gale force wind that had rushed across the ocean and hit the...
No, hang on. Forget wind. No wind. That's a dynamic system within the closed container or the isolated system. Forget wind. We're just talking about still air and the Earth moving. So the molecules above a mountain, sure, there's a little bit of fucking, high and low pressure moving around, but essentially, they stay above the mountain and they move along in any 30-second window. They're not moving too far away, are they? So what about in terms of at the end of the fan blade? Do you reckon there's some air staying with the tip of the fan?
I mean, yeah, it'd be roughly comparable if you compared the fan blade's turn to a proportion of a day. So 30 minutes is going to be 7 degrees. Yeah, it'd still be somewhat still close to that tip of the fan blade.
So if I run my fan in the lounge room for long enough, all the wind around it would eventually be in lockstep with the fan.
No. Again, This is why I'm trying to invite you, your team, if you will, to challenge to go, can I describe the model such that left lane and riding on eggshells and the other globers in the chat go, yes, that is what we're saying, then debunk that. But when you start with...
No, because you double speak.
Even double speak.
Definitely is double speak.
Man. Do the double speak steel man and then show why that's wrong.
That's
what I'm suggesting. I mean, if you're not able or willing, that's also okay.
Well, this is why the way I described it earlier, like the idea of a globe Earth, then you've got gravity, and somehow the gravity does this thing where it kind of clings everything to the ball. It makes it basically seem like it's stationary. It does everything perfectly. It clings all the trees and the leaves that are falling and the grass. Everything on the Earth is as if it's stationary because of the gravity. And then you've got this atmosphere thing, whatever that is, kind of connected to the gravity vector. And then that atmosphere thing, whether you call it Velcroed or clung or partially clung, whatever wordings. But the thing is that they will claim, my understanding, that, the greatest percent of it, 98, 99%, is essentially Velcroed and clung to it with the gravity and everything keeping it on it. But then there's just that little bit at which it's not. And I'm putting that in just simplistic terms, but there's that little bit that it's not to where the Coriolis is happening. But other than that, the whole thing is just as if
that's pretty good.
Yeah, that's pretty good. That's a pretty good feel, man.
Basically, they're saying that the atmosphere is going with the Earth. Where the Earth goes, the air goes. But most of the time, objects cut through the air, and the air doesn't just go wherever solid objects go through the air. That implies Velcroing from the globe side riding on eggshells.
Can you go back?
Now, do you see why
Can you go back to basically they're saying and try and get the same response that that Geo got. Geo gave a good steel man then, such that both left lane and I went.
Riding on eggshells, you're wasting our time. And that's why I felt the need to mute you, because you're taking us nowhere in this fucking conversation. We're playing semantics with you. And we've been playing semantics with you for like the past 5 minutes. To power through the bullshit, I had to mute you
a little
to get the main point out of what the hell we were talking about. That you seem to be, acting stupid like you don't get for some reason. This is a very simple
I didn't know that people were allowed to insult in this server, let alone the mods. But evidently, I'm learning.
You're just being exasperating, Riding on eggshells. It's like you're trying not to get it on purpose. It's just, very frustrating.
To finish my point, Lemon, the point I was making was quite simple. It might have been before you got here, and it was, if you are debunking a model, is it or is it not important to accurately be able to represent that model to show the flaws?
Riding on eggshells, we were Globers. We're well aware of the arguments.
So
we do not need to rehash the arguments.
You filibuster. This is how we mod in this server.
This is a 6-year-old argument, Riding on eggshells. Why do you think that we need to rebunk or represent the Globe arguments when we were Globers already? Why do you think that we need to do that? That's ridiculous.
Because if you're saying this is wrong, you need to show that you've understood it and you understand why it's wrong. Geo was just able to do that. You've demonstrated you are not.
Yeah, but that's the point to add to Geo. That's why I said planes should be observably going backwards
in the pocket, mate.
East to west.
Stupid.
If you're flying from New York to California, why has anybody observed the plane going backwards?
We understand the argument just fine, Riding on eggshells. You're wasting our time. You're just wasting our time, eggshells. I don't need to mute you again. It's pretty obvious that you're wasting our time. But anyway, eggshells. The Globers are basically saying that where the air goes, the Earth goes in the same direction, but we have layers of air that are going contrary to one another, sometimes at 90 degrees opposition to one another. When you look at the clouds in the different layers, that is very contradictory with the globe model, which would demand, or at least imply, that all the air is going in more or less the same direction, uniform over the Earth.
We do have weather.
Yeah, we do. At least we can agree on that, right?
Yeah, got weather. No, that's wrong, Lemon. Again, that is wrong. That is not what I'm saying. But I mean, that's clear to everybody. You're obviously not able or willing to do the experiment.
Use your words, Riding on eggshells. What is wrong about it?
I mean, I'll make the point one more time. See if you can get it.
I'm asking you very specifically, Riding on eggshells, what is wrong about it?
I'm trying to do it. It is a false dichotomy to suggest that the only two possible propositions are completely in lockstep or totally divorced. What I'm suggesting is that all things on the Earth are in some way linked to its motion, but not completely dictated by its motion. They are influenced by it. The atmosphere as well.
So you're trying to say that it's influenced by it, but not totally dictated by it. But that just sounds like you're trying to have your cake and eat it too. We should see clear evidence of homogeneous air motion going with the Earth, yet we don't see that going against a globular rotating Earth at the very least. And so it looks like you're trying to salvage your model by having your cake and eating it too, by saying, even though we don't see uniform air motions like we expect, we're still going to try to salvage the model and say that it's influencing the air motion while not totally dictating it. That sounds weak, Riding on eggshells. I'm sorry.
So is that what's happening in a paddle wheel? Is the paddle wheel influencing the water of the movement, but not completely dictating it, such as there are little eddies
cutting through the water,
toroidal vortices and stuff that are caused in the water?
It's cutting through the water. For the analogy to be analogous, Riding on eggshells, it would have to carry the water with it. It doesn't do that. It cuts through the water.
The question was pretty simple.
I've got an idea.
Of course, it influences the water, Riding on eggshells, but the context of this conversation was whether or not the air is Velcroed with the Earth or not. You're using a paddle that is cutting through the medium, not carrying the medium with it. Don't you see the problem with the analogy?
These little...
The question is it in lockstep? Is the water in lockstep with a paddle wheel? Is it completely divorced from the paddle wheel? Or is it Please let me finish the question, Lemon. Or is it somewhat influenced by the paddle wheel?
It's cutting through the water and pushing off the water. Your analogy is flawed. And it doesn't help us answer whether the air is Velcro to the Earth or not. So what you're talking about is a non sequitur. How does this help us see that the air is Velcro to the Earth?
It doesn't.
That makes no
It's
sense.
not.
How many times do we have to tell you we're not saying it's Velcro?
It is painted on.
Well, isn't the situation that they claim where essentially gravity, if you want to use the delineation that writing's saying, like gravity does 100% dictate everything in their model, meaning it's completely active on the sphere thing at all times, doing everything. The atmosphere, they claim, would be a little bit more like, what were you saying, influenced versus dictating?
Yeah, influenced.
So I think in their model, they would say the atmosphere is somewhat more influenced, even though it is dictated by gravity as well.
Yeah, it's pretty darn close to it. It's the influence of the paddle wheel on the water is that generally the water will move in the opposite direction of the movement of the boat, but it doesn't mean there aren't eddies and currents. And probably if you really went down to the micro scale, I wouldn't even be surprised if in those little eddies around the paddle wheel, you found some molecules of the water going forwards, even though they were just pushed backwards.
Yeah, but that would happen just as well on a stationary Earth with a swirling environment.
Yeah,
Yes,
I
right.
absolutely agree with that. None of this is disproving flat Earth. All it's suggesting is if you want to debunk the model, then you need to understand the model. To say it's Velcroed to the Earth is not understanding the model. It is presenting a straw man and attacking that. You need to be able to steel man somebody else's view.
That's what it states.
Who states
What do you
that?
mean?
Show me
That's
that.
what we're given, and we read it, and we give it off back to
Show
you
me where
guys.
you read it.
Okay.
I only ever hear that from flat earthers. I've never heard anybody but a flat earther suggest that the atmosphere is Velcroed to the Earth.
Well, that's because Globers typically don't understand their own model and its implications.
Great.
The
Show
air would
me the
have to
model
be
and the
Velcroed to the
implications.
surface, riding on eggshells, for you to have the excuse of why we can't hover in a helicopter and see the land shift below us and rotate below us. They come out with that excuse saying that the air is moving with the Earth, Velcro to the Earth, and moving in step with the Earth. Therefore, you don't see the Earth rotate beneath you as it rotates below.
As you continue to strawman.
No, it's a steal, man. You guys are just bullshitting. You're bullshitting. You know that that's exactly what your model dictates, but you don't want to come out and say it. You're full of shit. I'm sorry.
No, we're saying
Are we allowed to insult the server now? Fantastic. Lemon, you're a piece of shit. Good.
Yeah, we're
Wow,
telling
I
you
didn't know this was
point
allowed.
blank that we don't say
And
it's
you are
Velcro.
wasting our time and trying to fuck with our minds. Sorry. You're full of shit. I'm sorry.
Yeah, cool. You're a piece of work.
There you go, writing. So bounded to the Earth by gravity, most of the atmosphere spins along with it as a result of friction with the.
Right. Most of. Could you go back to that? It sounded like it said most of the atmosphere spins.
Just like what Geo said, around 90.
Sure. So does that sound like incomplete lockstep, or does that sound completely separate to, or does that sound like what I said, which is influenced by? Some of it does, some of it doesn't. Most of it does, some of it doesn't. Which does that comport more with, what I said or what you guys have been saying?
Right, but if most of it does, or a majority of it's influenced by the spin of the Earth, wouldn't there be a visible bias?
Sure.
Did you say sure?
Yeah, I think there probably would be.
And do we
What
see
kind
that?
of visible bias do you mean?
Well, I'd say the majority of the winds would be that we experience on a daily basis would be, primarily in one direction.
Oh, that kind of thing. No.
Yeah, like is this wiggle room that you're bringing in, this idea of like a wiggle room? Like I'm thinking of like a contact lens when you put it on an eyeball. Like it mostly stays there as you move your eye around, but it moves a little bit independently of the eye, you know? So if you're saying the atmosphere does that, where's any indication of that? Measurements or any observation where the atmosphere goes and it bows indifferent than the Earth?
Yeah, I would say wind is a good example of it. Watching any of those time lapse, what is a quite good example of it is watching any of those time lapses as a wind rushes up to meet the tip of a mountain. You can see it sort of pour over the top, almost looking like water. And
so that's because of the Earth spinning, you're saying?
No, I'm not saying it's because of spinning, but I'm just saying that's where you can see it is clearly not moving.
So you're saying when like smoky wind stuff is kind of going up over a mountain, you're saying that's because the Earth spin?
No, I just said no. I'll say no again. No.
And what was the link to that then? So maybe I missed it.
That it is not moving, clearly not moving in lockstep with the Earth. Nobody thinks it is because we all know we've got wind. So anybody who says the globe model suggests that it moves in lockstep with the Earth is thinking that there are super smart scientists out there who have their mittens on really cool equipment who haven't spotted that there's wind. And I don't
Of
think that's
course,
the case.
there's
I don't think
wind,
that
but the wind should have an
even Don's
overall
example
direction.
agrees with me. Most of the atmosphere spins along with it as a result of friction with the ground, which is like the paddle wheels I was talking about.
Your mic just got really loud, by the way.
But riding on eggshells, if it was like the paddles, if the paddles were, say, a helicopter hovering above the surface, you would see the water going past you with the paddles, just like you should see the earth rotating beneath you. Out pop the Glober excuses that are full of shit about the air going lockstep with the earth. I'm sorry to call you full of shit, but this is just double speak.
Not clearly.
This
Are
is
you
just
okay today,
sophistry.
Lemon? I've never had you be so offensive and
So anyway, powering past the sophistry and the doublespeak,
Nasty
your
new side of
analogy
you I haven't
implies
seen
that you should see the medium going past you while you're hovering within it, and or the thing below the medium, the earth, rotate below it. That's what your analogy demands. If the paddles with the water have any sort of analogous, meaning to the earth with the air over it.
The best I can do is explain to you my conception. I cannot force you to agree with it, nor can I force you to understand it as I say it. I can repeat it, and then if you're able to repeat it back to me as I say it, I will be comfortable that you know it, but I'm not going to be able to understand it for you.
I don't care about your analogy riding on eggshells. I understood it very fine. I'm wondering if you're exploring the implications of your analogy, and you don't appear to be doing that. So unfortunately, since you're not doing that, that falls on the person that you're talking to, your conversational opponent or whatever, to do that for you, since you're not doing that with your own ideas. You're not exploring the implications of your own ideas here.
I mean, if you knew what my ideas were because you were able to state them to me so that I agreed with them, I would agree with you. But every time I invite you to share my view with me, to steelman my position, you fail atrociously or flat refuse and default to insulting me.
But you don't point out what's
I'm not
incorrect
able
about
to
them.
investigate my ideas with your help because you're not able to represent my
If
ideas.
there is something incorrect about what we presented, then you can just simply point it out and save us time in the conversation, as opposed to you trying to work on us and get us to try to, I don't know, do some listening exercise where we say back to you whatever the hell you think that we did or did not hear from what you said. Just point out what was wrong about what we said in our interpretation of what you said, and we can just go on with the freaking conversation. Okay. We're trying to establish whether or not the air is Velcro to the earth or whatever the Globers are saying. And you're not even saying what's right or wrong about our conception. You're talking about some sort of inferior analogy about a paddle through water, which really doesn't help the situation because it's not even analogous. Why don't you point out what's wrong with what we're saying?
I will. You are presenting a false dichotomy of completely in lockstep or totally divorced from.
Fallacy.
So, let me say it again because Don was getting in there. You're presenting a false dichotomy, an extremist view that either something must be completely linked with like completely linked or completely unlinked. I'm saying there is a middle ground which is influenced by. That's what I'm saying you're wrong about. That's what I'm saying is my view that you need to respond to.
Okay, you're saying something about some sort of middle ground where the air is going slightly with the earth or slightly not. Is that what you're talking about?
He's saying that it's Velcro. He's saying, let me steal, man.
Okay, so the next question, riding on eggshells, for us to establish whether this model is full of shit or not, is how much of an influence does the motion of the earth have on the air? You're going to need to answer that now if you're trying to go in the middle ground. How much of an influence does it have on the air then riding? How much?
They're saying is that the air is Velcro to the earth in between gusts, Lemon. In between gusts of wind, then the air is Velcro to the earth, bro.
How do you explain the layers of air that appear to be going 90 degrees in opposition to one another? How do you explain that on a rotating earth where one would expect all of the air layers to be going more or less in the same direction?
Yeah, like if the winds are affected by it, it should be affected by it universally all around. It wouldn't just be spotty in different areas. Like if the wind is definitely caused by the spin of the earth, then that should be consistent.
No, clarify. Sorry, Gio, for jumping in. I'm not saying winds are caused by the spin of the earth.
Well, even in the model they do. That's why they claim hurricanes, Coriolis. I mean, they do even in that.
Yeah, that would again be a difference between caused by or influenced by. Coriolis.
I mean, I think that's caused by the movement of the sun. So I do think there is a vortexual nature.
Nice, Gio. Yeah,
that's
with
my
you on that.
understanding. It's caused by when the most wind is caused by, I thought, water. Sun hits air and water, heats it up. That causes an expansion, which causes a high pressure cell, which causes the wind to rush away from that area, which, broadly speaking, mostly is caused by sunlight. Yeah. I may well be wrong on that. I'm not a meteorologist.
No, I agree. That 100%. The sun definitely has an effect on that. There's no way around that.
Yeah, wind is caused by a differential pressure. That's why air moves from high pressure to low pressure. Second law of thermodynamics, guys. Remember? I mean, not really, but that's what you guys always talk about.
Yeah, that's right. About that Earth curve, though. Where's that at?
I'll put a picture in the chat for you.
That one's on the to-do list right now. We'll put that on the to-do list for a rainy day. See if we can get that measured up.
A placeholder.
Innocent until proven guilty, or guilty until proven innocent?
Guilty. Bring him down.
Well, wait a minute. According to the globe model or how they're presented, it could be both, right? Gio? It could be going with the Earth or not going.
Yeah, true until proven false, or false until proven true.
Oh, that's the steel, man. Look, the atmosphere is rotating lockstep with the Earth. It's velcroed to the Earth in between gusts.
Yeah, and what about the jet streams? How much are those affected by the spin, do they claim?
They're
totally random.
They're caused by the spin.
They're totally random.
So those are caused by the skin. So it's just selective. This Earth spin. It does the jet streams and it does the hurricanes, but it doesn't do other winds. But Riding said it does smoke over mountains. I don't know what. It's a selective thing, huh?
It's conditional. So jet streams are caused by the Coriolis effect, and local winds are caused by high pressure moving to low pressure. There's convection currents, which are caused by other things as well. So there's all sorts of causes for why air moves around.
If the spin of the Earth causes jet streams, then
yes, because the Coriolis causes.
Why such an isolated incident there?
It's not isolated. It's predictable and repeatable and quantifiable and measurable, and
it's random.
Use it.
And also happens the same way at different latitudes, so it's not like it's like
and goes in different directions at different elevations. It's random.
Yeah, so you're telling me that this jumbled mess is because there's Earth spinning? So how about this? Can you recreate any ball, like Brian was asking earlier, a ball with air clinging along to it? And then that's when Riding got into paddles and all this stuff. But in reality, you can't. Now, the next step to do it would be to create a ball in which the air is going with it, and it's going in all these wild different directions, all from the Earth spin.
Well, and to add to it, actually, further away you get from say, Atmo moving with the ball, more linear momentum you'll have further away you get. So we should actually see airplanes moving much faster.
So we believe jet stream exists, or we don't.
Of course they do,
because it's got to explain the scorchingly fast flights from Australia to South.
Well, they absolutely do. I mean, on a stationary Earth with an entire system that's moving, the sun, the moon, the heat, there would be all kinds of vortexes within that. Absolutely. Different layers and levels within a toroidal field like that. Absolutely.
But there's no vortexes. There's no hurricanes caused by the jet stream. They're not located near the jet stream.
there's an effect. I forgot what it's called, but it's the jet streams are attributed to an effect of the air coming up, and also there's you know, you can say there's air coming down, but mainly the air going up is feed the jet streams. They literally feed the jet streams. It's not. I don't even think the mainstream stance is that the spin causes jet streams. I forgot the name of the effect. Let me see if I can find it.
Yeah, as the air moves from high pressure to low pressure, from the lesser dense air at the equator to the colder air to the north, the air moves northward, and as it moves, it shifts to the right, to the east, at such a velocity, in such an addition to the velocity that it goes faster than actually the spin of the Earth.
Well, then that would be the cause would be the sun.
He just it's
the cause of the cause.
Stream,
yep.
The cause of the cause.
It move faster than the spin of the Earth.
That article that Don posted actually had that in it too. Yeah, it said that, like, what did it say, 250 miles faster?
Yeah, exactly. Yes, 250 miles faster than.
That's what I'm saying. The linear speed. The linear speed would be more, like, further away you get from the Earth. But then you can argue.
In that article that Don posted, it says this. It says, above 200 kilometers, however, the incredibly thin atmosphere actually spins faster than the Earth. The cause of this bizarre super rotation effect remains unclear, but has also been detected on Venus.
Yeah, I had to add that in there. Detected on Venus.
Yeah, they probed Venus and then found that this bizarre super rotation effect, and then now apparently the Earth does it.
Wouldn't surprise me, actually, if given the like what we were talking about before with the paddle wheel thing, if you would find that those, see how the vortices and stuff on the ball that Xanax posted is super, super, like, ugly. I imagine my supposition is this: the more uniform the surface of the planet, so the fewer mountains and stuff, the smoother the surface of the planet, the more uniform those streams will be. They'll look just like horizontal bars, latitude bars. But as it changes from water to land, you know, ocean to land or liquid to land, that's my theory.
Well, the concept of a stationary Earth in which the sun and the entire sky and there's a whole vortex occurring, you would get obviously all kinds of temperature changes, wind changes, jet streams at different levels. And if you bring in electrostatics and electromagnetics, you've got a whole charge system of the sun and the moon, the anode and cathode, that are creating this entire complexity of all of that system. Now, if you want to then say it's the Earth's a globe and the globe is spinning, you can attribute a lot of that to a globe idea and just make the globe spin and reverse engineer it. And that goes into like Foucault's pendulum and a lot of those things as well. You can do that, but that doesn't mean that is what's actually going on. But that's what they've done with the globe model. They've just reversed all of that. In my viewpoint, everything I just said that would happen on a stationary Earth, they're just obviously they have to account for it somehow, and then their spinning globe is the way that they do that.
Yeah, I think that's probably right. It's sort of, essentially what I would agree with is without the globe spin, we wouldn't have explanation for all of these different phenomena. So if you insert globe spin, suddenly all of the maths and the observations and everything snaps and you go, yep, that fits.
One of the ways it doesn't fit, though, is the jet streams. I just posted a couple. When you put it on an AE type map with the sun that's circling between the tropics, you get this beautiful, like, sacred geometrical circle. And the eclipse patterns also, like the path of the solar and lunar eclipses, also make circles like this. But when you make that into a globe, now the jet streams are all contorted and don't click and fit at all. And then the eclipse paths on a globe also are all slashing all the way across it and don't have any symmetry.
If I'm just looking at the jet stream ones, it looks like it's not really following. The jet stream on the left, on the ball, looks like it goes north-south while mostly going east-west. It's like a wave. I'm not able to see anything approaching that on the flat Earth one. It looks like it's, if I just copy that flat Earth one to the globe, it would just be a band around the equator. So it looks like it's got one that looks messy and more detailed on a globe and compared it to one that is more neat and put that on a flat Earth and gone, look how neat the flat Earth one is.
Well, you know about the earth.nullschool.net? Because that was, you haven't seen that? It's basically a interactable map that uses all the data from like the NOAA and NASA, all of the weather data, and puts it, and you can select through different layouts. Like you can do a globe projection, or you can do, and so it's called earth.nullschool.net. You can go to it right now. I think it's still up. And you can look at all of they have like temperature ranges and pressure ranges, and you can change the distances and the layers, and you can look at all the jet streams and stuff. And originally, this was years ago, and flat earthers found that that there was an AE map selection. You could select AE map, and when you put it on the AE map, everything locked into gear. Everything looks symmetrical, completely made sense. And then when you flip it to the globe model, everything's all chaotic. That's what some of these images are from as well. But then people started realizing that, and then within a very short amount of time, they removed the AE map. So they literally removed it. However, people backed it up, so we still have the backup of it, but they removed it off the official one.
Right.
But yeah, that shows
the point I'm making, though. You can see what I'm saying, though, right? Like if I look at where that is, that's got a jet stream that comes in around sort of Alaska, western seaboard of Canada, goes pretty much due south to down near Mexico, then hooks back around at Texas or thereabouts and goes pretty much due north to go to the Arctic Circle. If you look at the same landmass of America there, that squiggle's not even there. It's just a band that starts east and goes west. You get the objection to that meme, right? Sorry, left lane. I was talking over you before.
Hey, New Perspective. If you're here, do you remember the name? Do you know the name of the website where it's backed up, where they still have the AE map projection? I know that, like, I think Bob from Globebusters had put it up on a domain name. I just forgot the domain name of it. I think I might have.
Oh, I don't. I have
Bob
it maybe somewhere.
Bob Wins. That's it. Is that it? .com?
Yes, bobwins.com.
Let's check out. I mean, everyone knows this already, but it just doesn't make any sense. Are you guys still talking about jet streams? Like, just look at the two pics I posted in the live stream. For the jet stream to go in those little curly Q things, like, it's just the way that the globe model has to make it look, but it works much better on a flat Earth than the perfect circle.
Sure. How do we confirm that those jet streams do that?
I don't know. How do they do it on a globe? You guys don't know that either.
I mean,
well, this data,
I don't know for sure how that happens on a globe either.
I just posted it, by the way, the bobwins.com, but this all comes from NOAA, the U.S. National Weather Service, is where the source. Is that what you're asking?
Yeah, just.
Yeah, so I mean, it's quote unquote official data from the NOAA. Now, yeah, I agree that it's not verified. That's why, like, I'm not saying this is some 100% thing. I think it's really interesting the way it looks on the AE map and how it seems to create these vortexes and counter vortexes that seem correlating with the tropics and the way that it lines up on here. But yeah, this is not verified, any data that I've verified.
Yeah. Even the Bob Wins one that I've opened that web page, it's a very cool looking web page. What I'm definitely seeing is still vortices and things spinning backwards, and looks like it's seemingly affected a lot by islands.
Hey,
rather than land masses almost.
Hey, Jill,
over open ocean easier.
My bad to interject there real quick. Jill, have you ever tried the Pierce map with that? Are you able to do that? Like how that would look?
You've only got
Right, that would be
conic.
sweet. Yeah, that would be awesome if they had that. They have azimuthal, conic, equidistant, and globe on this one, and then the original Earth.null school. They have a couple more actually on the actual. Yeah, if you go to the original Earth.null school, like they removed the AE, but they have several others. Let's see. Oh wow, yeah, they've got a couple on this.
Dude, if they got the Pierce map on there, oh man,
that would be sweet. Yeah, we should make it.
Do I really want to get that pilot that was it debated? What I'm really curious. How did he come up with that? Actually, because he must have not. Maybe he knew, and that's how he got it, or he did not know, and the map was there the whole time. And that's if he's seen the map. If Witsit like just pulled it up, just say he did in the debate. Well, check out this Pierce map. It looks just like your design there. That would have probably just blew his mind away.
Pierce map. I haven't even heard of it.
Yeah. Yeah, I wanted to talk to Witsit about that, actually.
Pierce, Arizona? No. How do you spell Pierce map?
Peary Rays. I think he's trying to say the Peary Rays.
Yeah,
that's P-R-I, and the next word is R-E-I-S, I believe. Peary Rays. Is that what you're trying to say?
No, it's the Pierce quantical projection. It was made in 1879. Give me a second, I'm getting to it. I'm just gonna post it right here. It's made by triangles, guys. There you go.
Quincuncial. Yeah, the Pierce quincuncial.
There's your quadrupole.
Yep. Yeah. Yeah, this one's awesome. I like this one a lot.
That one puts New Zealand so far from Australia. Poor little New Zealanders all off there in the corner by themselves. What do they do?
Yeah, but the thing is, we don't really have no data in the center of the north to be able to really go. I mean, this would be more accurate around the tropics in certain areas.
I can tell you it is inaccurate.
Due to our limit.
Sydney to New Zealand many times.
This says right here, the Pierce quincuncial projection was used by U.S. Coast and Geodetic Survey for a world map of air routes. So apparently they use this for air routes.
Yeah, that's what I'm saying. That's why I want to talk to that pilot. Dude, that's why I want to talk to this pilot right here that Witsit debated. Right there. That guy. How did he come up with that? He said he used all those distances and known distances, and that's what the Earth should look like if it was flat, he said. Well, little does he know there's a map that looks just like that.
I go with the azimuthal equidistant, AE till I die, or something like the what's it called? The Gleason map.
Well, that was still right. Well, here's the thing, Lemon. That still would be considered that. I mean, a square and a circle.
Yeah, it looks basically like the only thing it's missing is Antarctica. Antarctica's on the corners, but it looks more or less like a similar map.
Yeah, and the concept of the four corners of the Earth in so many of the ancient texts, and
I'd go with the circular dome enclosing within the square, and the square, corners being outside of the circular dome.
Yep.
check that one out. It's got like a bunch of them. That's like puddle theory. And they're all connected through squares. That one's pretty wild.
Oh, I'm going to Australia, but which Australia?
That's different. I've never seen that one yet. Where'd you find that one?
That was actually on, it's a tessellated version.
Yeah. It's got Antarctica, and it would fix a lot of your problems with the flight routes to Australia to South America.
Dude, look how big Africa is, though, man. That's right there. That's how big. It's huge.
Well, Australia's the one that misses out in the in the Mercator projection maps. Australia is about as big as continental US, but it looks. Is it? No, maybe I got that wrong. Continental US looks at a higher latitude.
What's interesting about this one is how it really does have that four spokes, like north, south, east, west, kind of like a cross, but then there's like land missing on the one side.
Mm. Yes, I listened to Go to Sleep the other day about a documentary about Captain Cook and one of his, not his final voyage where he died, but one of his final ones, because they first they sent him out to like look at a transit of Venus, but they also wanted to check because they were like, the globe doesn't make sense. It should have, in order to have this even rotation, should have another massive landmass somewhere west of Australia. And so they sent him out to go and find it. And it sounded like a pretty awful voyage. A lot of effort for not much result, really. But yeah, it was quite an interesting thought. Kind of makes sense too, doesn't it? You'd expect, like, in terms of balance.
If the Earth is laid out with that, with those kind of four corners, and each one of those is one of those celestial poles, the southern ones, that would completely make sense. Why anytime you're in one of those like sectors, if you want to call it that, like one of those four sectors, you're just going to see that southern sky.
It would make sense for that, but wouldn't it make it a bit confusing that in order to make that work, there's multiple Australias? Oh, you don't mean the tessellating one, sorry.
Well, the tessellated one type thing, like that puddle thing, I mean, you could have, that would be complicated, but you could essentially have like a quadrupole then connected to other quadrupoles. And if each star system was like reversibly viewable, it's not quite the right term, but like where you'd be looking south, let's say you're in South America and you're looking south and you're seeing that southern sky, there's like that's someone else's south as well on the other side of it.
That would fix that. Why do we in two different places see the same thing? I think though, at least unless I'm missing something, what it would cause is why one person should see clockwise, the other person should see counterclockwise, because they're on opposite sides of the rotation.
It's just like going, on a highway, man. If you're on one side looking from cars going right to left, you go turn around, they're going to appear to go left to right. It's just your position. It's
exactly
all perspective.
On your position of one side of your car's wheels, it will appear to be going clockwise. If you looked at a different car wheel, or if you're on the other side of rotation, it will be going counterclockwise. That's the point I'm making.
Yeah, that's not like, I mean, that's
clockwise or counterclockwise.
I mean, I could go on a whole thing about toroidal fields as well, but even just taking a simple thing of gears, if you take two gears and put them together and spin one goes clockwise, one goes counterclockwise. It's like that vortextual. It's the same as a toroid field. The energy comes up through the middle, circles round. So that makes sense in terms of that. And just simple gears do that. Like this kind of pattern, a toroidal field. But if you had, let's say the North Pole is on the right, and then one of the South Poles, let's just take the one South America, whatever is on the left, then you would have those, and then the energy is kind of coming up through the middle. Then you would have kind of like those two rotations of the vortex coming through, up and through the middle. I mean, that one's one of my favorites because it's kind of animated, but it shows that concept of.
Yeah.
If you look at the right or the left, it's counterclockwise and clockwise. Yeah.
Man, that is awesome. Yeah. Each body has that too. Each person, all of us, our own field, just like that. It's amazing.
And then if you added a quadrupole to that, is what I think is happening. So then you would have like a whole star field, whether it's liquid or sonoluminescent, whatever the stars are, in their paths, like electromagnetically and electrostatically held in their paths. And then if there's like the 4 poles, like a quadrupole system, then if you focus the magnetic energy at each of those poles, and those stars are all going to function like a quadrupole, where they're all going to like focus on those southern regions and then the northern one. And I think it's interesting too, all the old maps about at the North Pole where there's like the 4 islands and 4 rivers. So that kind of correlates with that. And then the way the continents all come out in like 4 different directions.
Well, just to add to it too, Geo, man, with the electricity, atmosphere electricity that you can get, when the guy sent up the drone, he was at 300 feet and couldn't get the motor to turn. When he went to like 390 feet, he did. So higher you go, more charge there is. More current, if you will.
Yeah, that connects in with like Richard Feynman. Yeah, like 100 volts per meter of potential current.
What's crazy is that when I used to love Stephen Hawking, or whatever they wrote for him, or however they came up with the theories, whoever he was, the way that in his book Brief History of Time, that he described the universe working just like this, like the toroidal field almost, but it's like a constantly enveloping, kind of like donut shape, like one of those balloon things that you used to get with like a jelly filled thing in it, and it would slip out of your hands because it would have that stem through the middle, and it would fall out because the weight of it would make the jelly thing fall. You guys remember those? It was like a little hot dog thing that had a balloon that was like inverted, so it had like the balloon was going in and out, just like that map that you posted. You guys know what I'm talking about?
Yeah, I know what you're talking about.
And it would just like, you'd try to grab it and it would just keep falling out of your hand. Well, he described the universe that way. So like if you were on like a quadrant that was on the outside latex part of the universe, then a wormhole that kind of acts like a button between the inner quadrant and the outer quadrant would be possible then, right? That's the whole concept of it. It's just interesting that they proposed that the universe might work exactly like this if they already knew that the globe worked, or the toroidal field around the dielectric plane works this way.
If you think about it, even like all vertebrate animals are set up like toroids, because we all vertebrates have our intestines. We're just topologically donuts, basically. Our intestines are just a tube. Yeah, exactly.
Yeah, and I always think, speaking of intestines, this is such a wild idea. Have you ever heard the idea that, our intestinal tract from our mouth to the anus is actually outside of our body?
Yes. That's
Yep.
That's wild.
It is saying you're essentially like a big leave for food to turn into poop.
Well, I mean, obviously there's an interface because the blood, once everything's, food's broken down, obviously there's a connection to the bloodstream, but it's interesting to see it that way.
Yeah. And even I think I like to think of cooking. Cooking is just a further extension of our stomachs outside of us. Like that's why humans have weaker stomachs, is because we've slowly lost some of the digestive abilities because we've just outsourced them to fires.
Yeah, although the real version of that is fermentation. Cooking actually kind of damages enzymes that are needed for digestion. Cooking can like soften it up in a way, in different ways. So it can have that effect in a way that could help with digestion. But there's also a lot of ways that cooking denatures it, destroys enzymes, whereas fermented foods are truly pre-digested, because then the enzymes that are actually utilized in your stomach are being utilized on the fermented food, essentially pre-digesting it and creating more probiotics for the system once you consume it.
It's weird to think that if we didn't evolve, like the way that we're told, then what were the stages of development in any of these things, right?
Yeah, absolutely.
What do you mean? Can you?
Like, would we have to go from the caveman status of not using fire to cook, and then eventually learning that, or would we have some of those things like already like in our knowledge?
Yeah, what if we just entered this world like fully already designed? We just entered into it, like through a portal, or just literally manifested into it, and we didn't have to evolve from sea slugs or anything. We just are what we are from the beginning.
Well, I think that's how God intended it, right? That's my belief with God. Like it's already in us.
Yeah, if we didn't evolve, then the first human was fully human,
ready to go.
Are there any?
I don't know if they provided cookbooks and instructions on how to do that, but
just add food and water and a little bit of love, and there you go.
Is it safe to say that most flat earthers reject evolution, or do you know flat earthers that entertain evolution?
Well, I would say it's safe to say most of them, yeah.
No, well, it depends on what evolution.
It's just a matter of proving it.
Well, I'm a flat. It depends on what type of evolution you're talking about.
That's true. I mean, I could also. I've heard of that. There's kind of a flavor of flat earthers that see Earth as like an experiment or like a petri dish, and in those cases, like I could see them being okay with evolution.
Are there? Because I've only come across one non-religious, like religious in my sense. I know that other people here would disagree with that because to them it's organized religion. But like, I've only come across one flat earther who doesn't believe in a higher power. And I would say a significant chunk, maybe not many here in Geo's server, but like in 24/7 and places like that, the Bible, the Creator, is a significant reason for their belief in the rest of it.
Higher power is the wrong word. Creator, yeah. Higher power, no.
Yeah. Sure, creator.
Yeah, we're all creators, so we're all on the same level. That someone has created us doesn't necessarily mean they're higher power.
Sure. Yeah,
I don't think that many people
I don't think I'm
came to it
speaking
from
ill
the
of him while
Bible.
he's
I don't know.
not here. But one of the first, when I did my video interview with Bandsaw, I said, "What are some of your reasons for like desiring to believe in the flat Earth? Not like why do you believe in the flat Earth?" And his first answer was creator, and I think that's the case for some people.
Well, no. Well, you don't have to argue. You go outside of the Bible and destroy the globe with just logic and actually holding the feet to the fire, basically. Well, you don't even need the Bible. I mean, that really.
I'm not saying this is sort of how you argue it or how you reason there, but that's why I just explained to Entmonk almost all flat earthers. I would say vast majority of flat earthers believe in a creator, and it is in some way entwined with their view of flat Earth.
I would say most likely, I think that I would say that flat Earth led them to believe in a creator more so than belief in a creator led them to flat Earth.
Maybe.
Yes, I agree with that. And if I may just interject, sorry, Riding, flat earthers do not desire to believe in the flat earth. We don't carry that mentality. We believed in the globe. If I can finish, we believed in the globe by mistake because I myself didn't check it. Okay, I wanted to know that the earth was a globe, but unfortunately, to my disappointment and my ignorance, it's flat. Okay, that's what we've discovered. That's not through desire. Okay, so just be careful when you say that. Sorry, carry on.
Hey, Jen, could we talk about 70% water?
Yeah.
I'm just kidding.
Yeah, it's a joke.
I was just gonna say, you're begging the question by even acknowledging that it's 70% water, but I'm not gonna get into it. Sorry.
Right?
They
When
say
only like what?
it could be tons more water, tons more land. We don't know that that's fact at all.
Right when there's only like what 5% of the oceans that's been explored. I mean, come on. How much is there?
Is that right? Is that what they say? 5%?
5%. Yep, it is 5%.
That's their claim? That's really surprising.
Yes, that's their claim. Yep.
Why is that their claim? Like, wouldn't they? I mean, obviously it's not a real claim. So why wouldn't they just embellish it and say we know where? Like, it's funny, they know more about the universe than our oceans.
Right, and they got this so-called technology that traverse through space, it's a rough terrain, but can't go certain depths of the ocean.
Right. Yeah, we can go to space and go to
If
the
they
moon.
haven't mapped it all fucking very efficiently.
I mean, the nice thing about space is that you can see really far in it, which is not the case with the deep ocean.
Oh, you know why you think you can see very far? Is because they tell you stars are light years away. That's why you think you probably can see should be able to see China on a flat Earth. Is because this misconception of being able to see stars so far.
I see the sun setting behind the horizon.
Oh my god! Here we go.
I love that phenomenon. It's amazing, isn't it?
By the way, speaking on that, have you guys seen that new documentary? I think it's called The Next Level.
Not yet.
Yeah, it's Sean Hibbler. I watched it the other night. Yeah, it was good. And but at one part, it just made me think of. I don't know if I've seen this particular David Weiss video before. I would imagine it's on his channel. But he's in a hallway. It looks like a big hotel room type hallway, and he's got he's carrying a circle that would be the sun. And he's just walking away, and he's got the camera down at the other end, and you see the sun perfectly set, and all he's doing is walking away over a planar surface, and he's keeping it at the same altitude above the ground.
Nice.
The same angular size.
From left to right, yes.
He didn't have the atmosphere. He didn't have the atmosphere magnifying it or anything.
Yeah, I mean, it's just a small scale demonstration. I actually was planning to maybe go to his channel, see if I could find it on there, but because I hadn't seen that actual one before. But yeah, they had a cut of it in there that looked good.
Oh yeah, that'll be fascinating because my understanding was the laws of perspective are called laws.
He's got some really good zoom ins on the sun after it supposedly sets too, like zooming in and getting the sun completely full view again after you think that it's set. He's done that some good stuff with his drone to capture that.
They need to do is take these big old giant freaking telescopes and have those suckers look over the horizon.
Yeah, I thought the P900 was going to kill the distance to the stars, but I don't know how. I mean, you really can get some detail on those with the P900 that you wouldn't think from trillions and trillions of miles away that you'd be able to get, regardless of space not causing any interference and all that. It's just if that's the case, that is so mind-boggling that we get any kind of image, and that the image you're getting would have to be from a star how many times bigger than our sun than they say our sun is. I mean, it's just
baffling. Like VY Canis Majoris.
You're just looking at remnant light.
Look, what about VY Canis Majoris, right? They say if it's in our solar system, it'd be from the Earth all the way to Jupiter. That's how big it is.
Wow.
Yep.
And then you zoom in on it, and you're getting this.
It's all expanding.
You're getting a lot of detail to it, a little disco ball thing, but somehow that's the way it looks. It's from trillions of miles, and it died out 1 million years ago, and you're only getting the light that doesn't even exist anymore in reality. It's the infinite
cool story, bro.
Exactly. They had to have that. Otherwise, parallax kills it. You have to have the stars infinitely far away. Otherwise, parallax just destroys their model.
Well, you can get
parallax.
parallax.
And it doesn't even work with that, in my opinion.
You can get parallax. It was one thing I learned in my talk with Chronic was if you want parallax of stars, the best way to do it is 6 months apart, because in your orbit that will be the greatest distance you can cover, the greatest place you can make two different observations. And for very close stars, you can get some parallax.
Sure, well, they use parallax as a way of saying how far they know how far away the stars are. But I'm saying the parallax that you'd think that you'd get if they were close enough, the closest they seem, then yeah, those stars would be completely off by the minute.
Oh yeah. If they're as close as they look, when you look up at them, particularly on a really clear night, you feel you can reach out and touch them, and parallax.
And do we have depictions of constellations? that are like from like hundreds or thousands of years ago that we can look at parallax from?
Barnard's star is the only one that's moving quite quickly, and my understanding is that's moving at like, what is it, like an arc minute every decade or something like that, which is
right. Let me add to something to this. Say I put you in a warehouse that's 50 by 50 by 50, right, and all access, right, and I have two lights that are the same. I have one and then I have them set up in the room. It's black. You could barely see your hand. I placed both lights wherever I want to, and you're gonna have to triangulate, use angles to see how far they are. But one is brighter than the other. One is 10,000 lumens, and the other one's 5,000 lumens. Would they appear to be the same distance? Just due to the brightness alone.
If I were just going off my like gut guess, I could easily mistake a brighter, further light for being closer to me than another one. Sure.
Well, yeah. So how do we determine that?
If that was the only way to determine it, I would agree with you that was probably they're doing it the wrong way. I don't think it is though.
Well, the self-illuminating, our stars, they supposedly say they're gaseous, right? So they would obviously be self-illuminated.
Yes, but you've not picked the bits in contention, right? You've just been, it's like, well, if they're self-illuminated, and if they that's the way you test them, and then I say, well, if that's the way you test them, and you go, well, they are self-illuminated. It's like, come on, man.
Well, I don't know off the top of my head. I don't know off the top of my head what globe model says how we can tell how far the stars are away from us. Do you know?
Some of the method is the one I described, which is if you take it at 6 months apart, you're at opposite sides of your orbit, so you can get parallax from that. Stars.
But that would only
in the foreground.
Right, but that would only work for like the closer ones, right?
Yeah,
I mean, I guess it's. I would assume. My guess is that it's something like that. We know that there's some property of light that changes over distance that we can measure, but that's just a guess. I'll look it up.
Yeah, it's something that I think it's also to do with what are they called? Cepheid variables, and something to do with the rate at which they blink is something that tells you size. I don't really know. If Chronic is listening to this, he's going to be like, fucking eggshells. How many times have I explained to that guy?
So the first answer that comes up is the parallax one, the 6 months parallax one that you said.
Hey. Does that mean I'm the smartest person in the world? Or I just can sometimes remember things?
Yeah, that's confirmed. That's confirmed.
Good, I'm glad. Everybody hear that?
Oh, I thought of a good question earlier. So, I'm sure this was already talked about, but I haven't been around in a while. So, with all of the Elon Musk stuff happening, you know, that there's kind of an interesting paradox. You know, not necessarily paradox, but obviously Elon Musk is a space guy, but he's also kind of a self-appointed bastion of free speech. So, what do the flat earthers think of him?
What do you know? Actually,
he's a World Economic Forum stooge, mate. So that's what I think of him.
What do you mean he's against free speech?
Sorry, I said a bastion of free. Like he's.
Oh, I heard you. My bad. No, I don't know.
Well, I think they're propagandizing us with that story, nonetheless. That Elon's here to save the day and liberate us all from all, the free speech type of thing. And after the whole pandemic thing, so yeah, they might be playing up that story, but yeah, he's just a pawn in their narratives and propaganda.
Right. Have there been any attempts to, like, I don't know, to see how he? Do you know of any flat earthers who are like, he's a secret flat earther and he's eventually gonna like disclose or something? No.
I heard somebody saying that.
No, but I know he's a con man. I know he founded X.com or something, a banking thing, and then he had an employee or one of the employees try to tell people that the product he had wasn't what had happened. So he had to sell the company $300 million. Bought a Ferrari or a Lamborghini, a McLaren. He bought a McLaren, crashed it. This dude was wild, man. And then he tried to say he made PayPal when he didn't. It was these two brothers. I think they were brothers. Maybe I'm incorrect though. Forgot the name of it. Starts with a C.
Yeah, PayPal. I haven't found anything anywhere where he states made PayPal or states he created Tesla, but I certainly would agree that he doesn't do much to dissuade people from believing that when he did. I mean, I'm just not sure it's a complete rebuttal. I don't know if
he's got
electric cars or he's just one of the most successful proponents or sellers of their tech.
Did you know how he got actually? So when he was, I think he was born in Africa, wasn't it? What was it? Yeah, and his dad had a mine that was getting jewels like rocks, and they found so many of them they started selling them over here in U.S. That's how they kind of got all that money. I forgot the
billionaire diamond miner.
Yeah, something like that.
But again, I don't think he ever makes a pretense of a rags to riches story.
God no.
Got a string surrounding around him though.
Went to the same school as Trudeau and Ardern and all the other ones with Klaus Schwab, though. At the end of the day, he's all part and parcel. He's in lockstep.
He's velcroed to the NWO.
I went to the same school as the reason why potential as a guy who's going to be quite possibly going to be a future prime minister.
Uh-oh.
Is that an Illuminati member?
No, as everyone else who went to that school ended up in cabinets all around the world influencing political decisions, or not?
I mean, yeah, it does have past prime ministers went there.
Past prime ministers? Oh, there you go. You are. That just confirms it. You are on the books here, aren't you?
Okay, or it could just be where rich people send their kids to school.
No, you're paid to be here by the lizards. Who went to the lizard school?
It's interesting that the main method of influencing people to be horrible human beings is money, but the people they try to influence are already rich people.
It's all right.
Gibberish?
No, we were just all controlled by lizard people.
Why is it lizards?
Free speech.
Like of all animals that it could be, why lizards?
Well,
it's reptilian.
Do you have lungs?
Very specifically. Have a look at the Vatican.
There's
if you have lungs, lizards have lungs.
Do lizards have lungs?
Yeah, I think they do.
But of all the animal hybrids that they could be, why specifically lizards? Why aren't they like?
Because human
ask them,
we're already in South Park.
Why? It's like asking us why be human? Why pick human?
I guess I'm looking from a different perspective. Like I'm thinking like if of all of the theories of like what the animal hybrid that controls humans are, what it is, why is it lizards? Why is it reptiles?
It's the symbology that they put out there, mate. So it could just be propaganda and they could all be guinea pigs, but it seems like they're reptilian in nature.
Yeah, I definitely do not hand wave that idea. I don't fully believe it 100%, but it's very curious. It's interesting.
It's biblical. I mean, there's a snake. Snakes are a big deal.
Well, you got to think before the snake was cursed, right? Did it walk? Because he cursed it on the ground below the beast, thou shall they go. Well, then it entails that it walked before or something.
And shapeshifted.
Ooh, polymorphed.
Uh-oh.
I prefer that word.
I'm reading Paradise Lost right now, and I'm getting to the part where Satan possesses the snake. It's interesting too. In Paradise Lost. In Paradise Lost, he doesn't. The description of it is not that he shapeshifts into a snake. It's more so that he like possesses a snake that's already, going around.
Oh, poor little snake.
Right?
Sounds like Brilliant. You know what?
It's funny that evolution is not true because you can't just go from kind to kind. But now you can go from human to lizard in seconds.
Well, no, that'd be
Yeah.
like
Kind
that'd
of
be
a good
Boom.
point, actually.
dude. The fallen
As
angels.
long as the
man.
carbon dioxide goes up high enough.
So you can have shape-shifting lizards, but
Yeah.
you're not able to have lizards slowly give birth to things that are less like them.
Yeah.
No, I mean, if you have angelic beings, what you call aliens, you know, mating with our seed, they're gonna produce something weird.
I don't know. I still think mailman.
If I was an alien and flew down from space and saw someone banging chicks, I'd be certainly fucking having a go. There's no way you'd be like, nah, that's disgusting. You'd be like, yep, let's taste a bit of that.
Yeah, but Don,
And a bit of
Don,
that.
what you said is that something will bring forth not after its kind. Like if the humans mate with aliens, and the kid would be something different, then
It'd
the
be a
Bible
different.
would be wrong.
It'd be no, it wouldn't be wrong. It'd just be a different, you know, angelic, a different being
Kind.
that came from the same
Yeah, different
source.
kind. Yeah, so something that brought forth not after its kind.
Does it work like mules, where like mules can't have babies or something?
Yeah.
Yeah, they have inert.
Well, I'd like to add to it, which is really funny, you know, where if you look at the book of Enoch, where the 200 angels met in Mount Hermon, there's actually a UN building on top of it. Strange.
Is Book of Enoch one of the Dead Sea Scrolls things?
Yeah, part of it. But that UN building, you should check that out in Mount Hermon. There is a UN
Mount
building.
Hermon. I'll look it up.
Yeah, that's right where they supposedly and that's where I think Jesus took his apostles to the bottom of that mountain. Said, "Do you believe I'm the Christ?" I don't know if it was referring to the Book of Enoch or something about the fallen angels.
In Colorado?
No, in
I will put signs of the biblical end times wherever I so please, even in Colorado.
I just find it weird that there's
there's gold in our hips.
Don't you guys find that like interesting?
No.
Interesting that what? You broke up.
That there is a UN building right on top of the mountain where all the 200 fallen angels met. Azazel and all of them.
No, it's probably just to freak people like you out. So you think it means something.
Hey, maybe. Okay.
Not saying it's a bad thing. There could be something to it, but they can also do things deliberately because it is somewhat, expected. Yeah.
Sure. But what's funny is just like I say about not too far left. I think it's east. I can't remember which direction. Yeah, I know when Gabriel said bind Azazel up, right, and throw him into utter darkness and put jagged rocks over him. Not too far from the mountain, there's a bunch of like a big old hole there with a bunch of jagged rocks, which is actually weird too.
What's the deal? I hear this. There's this phenomenon where people think that the controllers of the world, the UN, the Cabal, the Illuminati, they explain to people what they're doing. Like they explain to people what they're doing, almost like they're making fun of them. Why would they do that? Why would they like reveal what they're doing just to mess with you?
Most people don't.
Bound to a certain code that they're not able to sort of.
It's kind of like grooming.
Misuse us without telling us what they're doing.
No, it's kind of like grooming, right? About each a little bit at a time. Desensitize people first.
Wouldn't it be easier just to do it totally without even worrying about telling people and just deceive them?
No, it's free will. There's the free will component.
They're bound to allow free will?
Yeah. Yep.
Huh. I didn't think about that. Why would they be bound to free will if they're going against
Then it's
God?
not our choice, is it? They can't force us into anything, but they can deceive our surroundings to make us think. We choose what we want, but we're actually making choices that they've let us into.
If they're evil and they want to deceive you, why would they risk Why would they risk disclosing themselves? Like if their goal is to deceive you?
Because how are we to discern truth? How are we to do that? How are we to know how we're being deceived, or what is the deception? Like, it could be 50-50 down the line with fucking everything, and we'll never know. We can't ever verify pretty much anything.
I guess I mean, like, from their perspective, if you're running a big, deception, which, and don't get me wrong, I know there's a ton of deception that happens in the world, even though I'm
sure,
but why would they like shove it in your faces, like in the way that I've seen people talk about it on like this server, where they're like they're making fun of us, they're putting this UN thing on the mountain just to mess with you. Why would they do that? What would their motivation to do that be?
You talk about the United Nations logo?
Sure, yeah, I mean that's a good example, right? Like do you think that they made the United Nations logo that projection just to mess with flat earthers?
No, create division, create not conversation so much, but well, yeah, I suppose talk over the topic. Everything in the background of pretty much all government propaganda is strategically put there. That there's not one thing that's there that's not meant to be and means something. Sure, there are random press conferences where everything in the background has no fucking meaning, but there are plenty where everything in the background is very strategic. Even down to the time and the clock. Although no one can ever verify that.
And who are they communicating to? Like these symbols that they use, who are they communicating
to? Whoever understands the messages. Like simple. If someone was speaking a language that you understood, and only you understood it, could you watch a TV commercial and hear that language and understand it, or would you not understand it because it was on a TV commercial?
I understand. But like, why would they be sending these messages? What motivation would they have to like send these coded messages to people that they're trying to deceive?
Because how else do you communicate without other people knowing what your message is? It's like symbology. It's all the same stuff. You can't just say a direct message, but you've got to give.
Okay, I can see them. I can see like maybe the symbols would be used to communicate with other members of the elite, right? But I've heard before, in different conspiracies, that these messages, their target of the messages are like you. Like the target of the messages are like the people in the know, the people who have taken the red pill, right?
Well, I wouldn't say necessarily that's the target. Are you familiar with the idea of truth in plain sight?
I mean, I understand the phrase, but I don't know what that reference.
Well, I mean, it kind of comes down to like the idea of the art of deception, and I'm not saying that these people are deceptively artists, but just that kind of concept, like when to deceive people. So there's a concept within deception of truth in plain sight, where they put the truth right there, but they don't call it the truth. And they have a whole bunch of other things that they are calling the truth. But the fact that they put a little bit of the truth in plain sight, sort of like on a subconscious level, gives people the confirmation that the rest of the bullshit behind it is also true. And along with that, I would say like there's that concept in general. And then along with that, I think that these people have these entities, I should say, have psychopathic roots, to where like that also the concept of duper's delight, where part of their psychopathic nature is to, it's a way that they control people more so by like duper's delight, where they kind of get like some sort of a power position, or at least in their minds they do. And in a way it is effective when they fool people, and they also want to put it in their face, sort of like, the way gangs like put up gang signs and things like that. So there's some similarities with that. But yeah, I think duper's delight along with the truth in plain sight. And it's a way that they found that they could get more like mass adoption if there's a small part of truth. And like that concept of truth in movies, they put the truth in movies and then the lies on TV.
The Simpsons.
That makes sense. I like that. When you were talking there, I was thinking of like how in the Matrix they allow the Zion to exist temporarily, you know, like they have a deal, like they say, you know, we allow the resistance to exist because it helps our plans, sort of thing.
Yeah, it gives people hope.
Mm-hmm.
It's still a way to control people who don't want to be controlled.
Yeah.
That does raise an interesting question, which with that Zion example, which I've asked it quite a few times, which is if there are like these what do you call it, psyops that do catch people, how do you know that flat Earth isn't a psyop? Because it's certainly something a lot of concavers think. You know,
Well, that's why we're looking for evidence.
Why is
you know?
Would you feel like a psyop, like a controlled release?
Yeah, controlled opposition kind of thing. Like
I
one of the
think
memes
it
that
is.
I've seen All Glory post is essentially saying, "Don't you think it's weird that you've only got two options for which model you want to believe?"
Yeah, I think 100% slowly and surely. There's going to be movies behind this, video games. There's going to be. We haven't seen nothing yet of Flat Earth. It's just getting started.
But the question I was asking was, how do you know that the psyop, if it does exist, isn't flat Earth?
The debate is the psyop. Getting caught up in the debate back and forth, that's the psyop.
Reckon? Okay.
Yeah, I can see that. I saw a video today. It was like some clips from a podcast with Sam Hyde, who just makes me laugh. And he was actually talking about flat Earth. He was ragging on people like me who argue with flat earthers, you know, almost like as a hobby.
Oh, you enabler.
Exactly. Well, he was ragging on us like, motherfucker, if you know, if you're already getting fucked by the government and by everything wrong with society. The Earth might as well be flat. Why the fuck are you arguing about it? Which I gotta say, I don't. That kind of roasted me. I don't know how. I don't have a response to that. I could post the video. I always love his stuff.
There's also the component of, okay, so if the globe is true, then I guess some folks might be able to say, oh yeah, you know, kind of, you know, defending the globe or asserting the globe and trying to, you know, could be like, you could try to say that you're, you know, trying to defend truth or something. However, I don't think truth necessarily needs that, but I mean, you could make a possibility idea of that. However, on the other side of it, if the Earth isn't a globe at all, and, you know, many people talking about how, you know, the Earth is not a globe and there's a massive deception going on, to then come in and defend it, now you're literally like a minion for those demonic forces.
Yeah.
To put it in the most hardcore way. I mean, I'm not saying everyone is completely that, but I'm just saying at some level now you're actually supporting that and pushing it and actually furthering that larger deception.
Well, that's why flat Earth is so juicy. That's why flat Earth is so juicy, is because it, even though it doesn't affect my life at all, like all of us go out and live our lives basically with where this argument doesn't influence our lives at all. And yet it has these like high stakes. It feels like high stakes, you know, especially when you're really in it. It's like you're fighting for someone's mind. You're fighting for someone's, you know, like you're fighting for their mind. It's crazy.
or you could be fighting for your own mind. Is I mean, well, that depends on the
just at the pub having a chat, man.
That all depends on the individual, because more so I get into to sharpen my mind more. So I mean, yeah, I guess it all depends. Have you guys heard of the Butterwall from Teen Titans though? Because we were talking about being controlled release.
Butterwall, yeah. Bloody kids shows are fucking classics, man.
Dude, my son watched it. I put it in the chat right there. Pancake Earth. They even say NASA images are fake. It's pretty funny.
Yeah.
Yep, check that out.
Every now and then I catch myself fucking watching these things and thinking, oh my god.
Yeah, they're putting it out there.
Fucking nice, man. It's funny as.
But yeah.
Well, that's it. They're hiding the truth in plain sight. The Earth is a globe.
Well, I mean, let's say for the For the
yeah. You can just reverse it. It makes sense.
Where is it though? Plain sight? Is there somewhere where I can plainly see this globe?
Yeah, in the cartoon there.
In the cartoon.
What do you mean?
Images of Vesa.
You mean in reality? Yeah, you could just go to the beach and see the horizon.
So cartoons are truth? Are you saying cartoons are truth? Because you said it's truth in plain sight, then you said the cartoons. So are cartoons truth?
No, just because Don said that this cartoon is they're hiding it. They're hiding it in plain sight because
Well,
of
it's
this
just
cartoon.
controlled release, man. There's no doubt in my mind.
Sure,
that
off the globe, yeah, off the globe, not the horizon.
Oh, I see.
I just reversed it, yeah. And you can easily say that the flat Earth is the psyop, just to make people not trust the government anymore. I mean, it's
or a like a espionage. It would be very in line with something Russia would do, I think.
I love it.
The bits I think Russia have done. I think it's quite similar to it.
And hope there's Russian bits.
To say the Earth is what all of our ancient ancestors since the dawn of time have always known it to be, that would be a psyop.
But you're not like the proposition is, could flat Earth be a psyop? If flat Earth is a psyop, you need to accept for the sake of the proposition that the Earth isn't flat. If the Earth
how
isn't
do you know
flat,
that the history?
could it be in Russia's playbook?
Describe the psyop.
New Perspective had an interesting theory about how the Earth could be flat and flat Earth be a psyop. So I think if I remember correctly, it goes like
yeah, I've said that many times.
Yep. If I remember correctly, it went like they're trying to disclose. The plan was always to disclose at the right moment to create enough chaos that it would destabilize things so that they could take control. But he's here, so he could explain it better.
Yeah, kind of like that. Yeah, use it as a psyop, but it's based. The only reason it works is because it's based on an obvious truth, and they could use it as actually. I've said it. These guys have heard me say it. Basically, it could be their perfect tool for uniting the world, because look how it's united us. I mean, it is that powerful. And it could be not all bad. It could be like they use the truth.
Here it is, guys. I'll walk you right into the fucking fire.
Yeah.
Go ahead, take the wheel.
It could be, yeah, exactly.
Drive them off the cliff.
Also, I think there was somebody was saying something about, or we were talking about like the fact that there's going to be less money or less jobs, and maybe like the materialist mindset would be also put on the back burner if everyone realized that the Earth is flat, and that could be like a way of like easing the pain, I guess.
Bringing Klaus Schwab's fucking dream come true to light. Oh,
Right.
yeah, just accept it. Dude, look at this guy. What is going on here?
He just
You'll own
squirted
nothing.
everywhere.
You'll own nothing, and you'll like it because the Earth is flat.
I mean, I've wondered about this too. In Meta, right? In Zuckerberg's Meta, you could totally live on a flat Earth, right? Yeah. Or you could live on a globe.
Right.
Earth.
It's not Zuckerberg's Meta.
You can choose whichever one you like.
Yeah, all
virtual. I got stuck in a fairly staunch debate with my mate.
Real quick, all virtual environments are flat Earth environments.
The only thing you can really do is eat a sandwich.
You could build it either way.
Every psyop that they push, though, they push it. It's on the front page of the newspaper. This one, not only they're not pushing it, if you want to use this term flat Earth, they're suppressing it all the way around and trying to ridicule it. So clearly it's not something they're trying to push on that level at all.
But that makes it an even better psyop.
Obama mentioning it put it in people's consciousness, and it's that powerful that people have to laugh at it first before they can even accept that it might be a real thing. So
they have allowed some of it on like mainstream news and things like that, but that was pretty limited, and there was very controlled characters. Like we know who they are. Some of the people that were kind of the only ones that were on there on a lot of those, and those were also very brief and were meant to be like a little flyby thing. It's like they knew that so many people were talking about it. They had to address it to some level, but they still kept it very simple and suppressed.
Yeah, but
Right.
there's all these cartoons using it, and there's like references to it. There's commercials now that one after the other. They got that Matthew McConaughey one with he's in a hot air balloon. He's going space, the final frontier, and he goes, "Nah, we need to worry about what's here on Earth." I mean, there's so many like little things that could be seen as predictive programming. That I mean, and also the fact that it's so. I mean, at least in my mind, it's so blatantly obvious once you look into it that I don't think they would risk even trying to even joking about it if they really wanted to protect it, in my opinion.
Once you look into it properly, eggshells.
What would be looking into it properly? I feel I'm pretty good at. I think I understand.
Or
most
coming
of
to the same
flat Earth
conclusion.
proofs.
Now, if you come to the same conclusion,
looking into it properly means you just agree with what Lights tells you. That's how you look into it properly.
Well, you must have.
If
If you come to the same conclusion, you must have looked into it properly. Fuck, simple.
I think it's interesting that people say that you should look into flat Earth properly, but like how?
Water. Just look at water. It's flat. 70%.
Look at water. Yeah, that's another one today saying that 71%, and that's the.
Well, Mailman, let me ask you. Let me ask you this.
I was joking.
In terms of looking into, on a scale of 0 to 10, from what you can tell, how much, 10 being somebody that has researched the topic of the Earth, let's just say being a flat, stationary, planar surface, not a globe. So I'm not really counting concave and all that kind of stuff at the moment. But if 10 is somebody who's researched it the most thoroughly, and 0 is somebody who's hardly hasn't researched it at all, what would you say if you had to put yourself on that scale?
I mean, it depends on what you mean with like research. Like, if you do you want to know how much of the Earth's surface I've been on, or like what do you mean with the research?
I don't know. It's just sort of an open question. And obviously you would only know what you've come across. So you wouldn't know what the totality of information is, or you wouldn't know what someone that has researched a 10 out of 10 would be compared to a 4. So I understand it'd be hard to get exactly. But I'm just saying, of all the information, like including everything, stuff you could find outside of yourself, like on the internet or movies or books, things like that. Not really movies, but I meant like documentaries, videos, books, writing, book, etc. And also your own, if you have done any experimentation or measurements or observations. So I guess it would sort of be a combination of all those, is what I was asking.
Yeah, I mean, I've seen videos, but I mean, obviously those are fake, so those are not researched. Then, I mean, I don't know, maybe not much.
2.
Well, what's fake?
Solid.
I would argue the videos that I've seen about the Earth, they are fake.
I would argue that like
those
9 or 10
videos are fake. You're right.
I would argue that 9 or 10 you'd have to have done your own sort of experiment. I think I'm pretty well researched. I think I've spent quite a bit of time and I think I'm pretty familiar with all the arguments. But I have yet to try experiments myself. I still want to, but I think that's why I wouldn't say I'm like 8 or 9 or 10 yet, because I haven't done them myself.
Well,
but Entmonk, you said you'd be fully on board with us if you were to find out that it's true, right? That it's not a spinning ball. You'd be like,
sure,
be all about it.
Yeah, sure. I mean, if I did some horizon experiments and I did set up a Foucault pendulum, those are, and if I do a Cavendish, all of those are experiments that with enough work, I think I could do myself. And if I did not find what I was expecting with those, then for sure I'm going to do some reevaluating.
You just can't assume the cause of all those things. I mean, if it is the ether, you have to accept it could be another cause besides the turning of the Earth or the gravity that works sideways.
Exactly. Come up with something new, man.
For those experiments, if I didn't see what I was expecting, if I didn't see the answers that I was expecting, then I would totally reevaluate. But if I saw what I was expecting, the theoretical basis of it doesn't change for me.
Yeah, but it's not about your theoretical. It's like, what's the reality? It's not just about the theoretics of this. It's like, do you really think about a spinning ball or not? Don't you want to know?
There should be something that goes against the globe model, not just.
There is actually something that
goes according to the globe model. Then.
Well, if I did horizon experiments, if I bought a P900 and did some horizon experiments, and if I did the Cavendish and I didn't see what it, or if I did a Foucault pendulum and it didn't give me the answer I was thinking I would get, then for sure I would reevaluate.
Or if you had an alternate explanation for those phenomena, wouldn't that also
Right.
work? If you had a
Right.
workable explanation for why
But I think
frequency
that
goes the other way.
Yeah, but I think that when I've thought about all these experiments, the globe model explains them more elegantly and more coherently than the flat Earth model does. I'm not saying that there are other explanations aren't possible. Like maybe there is an ether that is doing all these things, but I just don't.
We know the
It's not
stories are
coherent to me.
more.
But choosing models is different than choosing realities, right?
We've gotten into this argument before. I don't know that I want to get into it again. I think I'll just say this. I'll say this. I think that the inherent epistemic limitations of science mean that it can only pick between models. That's just what I think science is.
Oh, I like that. Science
Oh shit! Excuse me.
Yep. It's all. It's the
Great.
whole
So what you're
point of it
so all you're
is just
doing
pick
is
between
just
models.
right. You're just philosophically picking between which model makes most sense to you. Right.
I'm
There is
using
no
experiments.
objective.
I'm using
No, even with
experiments to pick
experiments.
between models.
Yeah, the experiments. The experiments will
Okay,
help
which
you.
one?
Help you. Well, if you say one is the Earth's rotation does affect this spinning weight, and one is it doesn't, or there is no Earth's rotation rather, then
Or
regards.
or there is rotation, but you can't tell what is rotating because of relativity.
Yes,
Fixed points.
that's another explanation. That's another model. So what we would
Exactly.
do,
Exactly.
what we do though, is we do a bunch of different experiments, and we see which of those models better and more elegantly explains all the data. And for me, the globe model does better.
Right.
Mm.
But you still can't prove it
You're
because of the
correct.
underlying principle.
Correct. The underlying limitations of science mean that science never proves a model to be true. Science just rejects models that don't predict, or it chooses whichever model. It defaults to whichever model predicts better.
But you don't need to prove it scientifically.
Do you know the
Right.
definition
Any
of a
model could predict
Science
anything.
doesn't prove. Science
Yes, it does.
doesn't prove.
Yes, it does.
You don't
Math
need to-
proves. You can
Okay,
write
but
math proofs.
You don't need to like fall back onto scientific evidence to prove it. You can prove it empirically.
I don't follow that.
You shoot out launch a spacecraft out and then take a video, keeping the camera on the horizon. Let that horizon slowly turn into a circle.
It will, because the circumference of light over a flat plane.
What?
Uh-oh.
You don't want that, Art. You ain't ready for that. Hey, Gio, but hey, let's interject.
It won't turn into a full circle, Don.
Yes, just interject real quick. Hey, Gio, Bandsaw said Stingray might do this with me in Blender. When I set it up with him and bring everything I got, you want to stream it? Be able to screen share and all that stuff so you guys can see this? Because Armin wanted to do it today. He wanted to do it today, but then I was like, okay, no, I'd just rather do it with the guy named Stream. So I was just wondering if he would be willing to stream
But
it.
it was Arma's first thing.
Sure.
Yeah.
All right, go ahead, guys. Yeah,
Another empirical proof and monk would be dead reckoning, like from South America, tip of South America or Africa or something like that, and going circumnavigating Antarctica.
Why dead reckoning to do that?
Why don't you just dead reckon along the equator?
Without using bearing.
Do that at the
Dead
equator.
reckoning uses bearing.
It doesn't need to.
Well, you don't even need to go over You don't even need to go over Alaska or where'd you say, or Antarctica. You could use my idea. Dead reckoning with using a star as a reference point, and then see if the Coriolis actually makes you off from the spot you expect to arrive at by 200 miles.
At the equator. Use the sun at the equator and dead reckon using that. It's a straight line.
Dead reckoning, at least to my understanding, when it's used in nautical terms, means navigating without cell nav. So it's just using your approximate current location, speed, and bearing to get an idea of where you are.
I would say if you really want to do that, you would follow a star that you know is in a direction and dead reckon towards that star. I think that's where the term comes from.
Yeah, cell nav is better than dead reckoning. It's just that, like, the great example is Shackleton's adventure when they're trying to find this Shepherd Island or something to get to because his expedition's gone awry. And was it Avery or somebody had somebody on board who was apparently just master navigator, the only reason they all survived apparently. And he had to use dead reckoning because out of 14 days at sea, he only was able to take a sun sight once or twice, sorry. And so in between, you can't get a fix from a single star, a sun sight. So most of what he was doing is dead reckoning. But what you're talking about, Geo, yeah, absolutely, it's better to be able to do.
But that would actually work, though, right? That would work if you use the star as a way of dead reckoning, and you went from one city to another, and you knew that you're going in a straight line because you're dead reckoning. Then you would know if the city, moved underneath you or not by the amount that the Coriolis displacement would create. Then you would know if it's actually turning below you or not.
Yeah, the only thing I'm trying to correct is it is either dead reckoning or celestial navigation. Yeah, dead reckoning is given as the counterpoint to knowing where you are.
Okay, Riding, you're using the specialized navigation definition of dead reckoning. When I was saying it, I just meant I'm estimating your position based off of reference points. You don't need to use
eggshells.
The compass readings.
Sorry,
and
I'll stop using the correct words.
So, for instance, if you're circumnavigating Antarctica, you could just maintain the same angle proportionally to these different reference points to ensure that you're going in a straight line. Maintaining the same angle to that cliff on the side and the mountain on the right. So it's proportionally, you're always approaching them from the same kind of relative angle.
You're always getting bloody corrected by percent, aren't you?
I don't think percentage is correcting me as much as inviting me to use his different definition of dead reckoning.
Oh, yeah.
Why don't you just go to the equator?
Keep on in percent.
Go to the equator and travel behind the sun on a straight path. And get back to where you started from. Traveling on a straight line.
Hey, Pac-Man map?
No, it's gonna blow.
That's a lot more distance to cover and doesn't really
It doesn't matter.
chase.
All you gotta do is just
Why not?
Just take a zip tie and just tie your steering wheel straight and then just go and make sure you never turn the steering wheel.
Yeah. No, just have observers there and see that the sun is traveling on a straight path and just have one traveling below the sun 24 hours around the Earth.
I couldn't even say that without laughing.
That's dead reckoning.
What are some ways that anyone could prove it to themselves without using optics or instruments or planes or anything?
We could get
a big long line.
We could get Reknor and sacrifice him to the gods, and then we'll have dead Reknoring.
Well, you could do it with stars. You could decipher that with stars.
You can just,
if you did a freeze frame of the sky, meaning you have to take at a certain time of night, let's say you're doing it at 2 a.m. or something every night, but you have to account for the 4-minute difference between this for the stellar day, the sidereal day. But so once you account for that, you get the exact same snapshot position of the stars. So if you then dead reckon toward a particular star, let's say you're in Ecuador and you pick your star and you dead reckon towards it. You then get to the GP of that star. Then you can dead reckon to another star, but as you're leaving the one that you're leaving, you can do a reverse dead reckoning. So you can create a straight line with it by using so you get to that star, you get to the GP, and then you leave that star, and then you connect that with another star. And there is a way to do that to where you could see whether the web and that system is actually taking you around a circle, around the North Pole, or whether, Mailman was saying, on a globe, it would be that straight line, he was saying. There's going to be variation between the stars if you pick the right ones and you're just dead reckoning to and from stars.
Or you could just use the North Star.
Yeah, you could do that like a north-south circumnavigation type deal.
Yeah, use that one, or use Sigma Octantis if you can see it.
That won't happen.
If you could, that would be like the ultimate version of it. Yeah, to go to exactly to do it that way instead of doing it east to west. Like you've got those sort of polar regions. So yeah, that would be one of the most poignant ways to do it. It'd be so straightforward. You wouldn't even have to. You would literally just travel towards the North Pole. You'd get to the underneath of it, and then you would start going away from it. And then once you saw Sigma Octantis, you would go directly to that and see if you could make that whole loop.
Yeah.
Never gonna happen, but give it a try if you want.
Good luck.
Beat you on the other side.
Hey, and Monk, I think I've asked you this before. But what if you analyzed all of NASA's footage and you like logically came to the conclusion that they were just bullshitting us? Would that make a difference one way or the other?
So it would definitely, if I like came to the conclusion that for sure NASA was faking like a lot of their footage, it would definitely reduce my confidence in NASA. But NASA is not responsible. Like NASA is not the reason I think the Earth is round. Like I think there's a lot of other sources of evidence that give me confidence outside of NASA. Now, for sure, it would shake me, and but the biggest sources of evidence that I see are not NASA.
There was an interesting concept that got brought up the other day by Witsit that I hadn't heard before. And I don't know if you have either, but the whole idea that gravity can't be considered a real force, not, or at least it's convenient that it's not considered a real force, because if it were a real force, it would have to follow the laws of forces, and the whole bending of space-time would straighten out, supposedly, if there was an equal and opposite reaction. I don't know if you've looked into that or heard that theory, or if anyone else is familiar with it, but that's an interesting thing. And if gravity is not a real force and it just acts like a force, then it's really hard to, like, you know, that's a tough one, you know, because then we have to think that that's also the force keeping us upside down relative to each other and everything else without being a real force. And I don't know how you guys get your minds around that.
Well, so this concept of like a real force, there's a lot of different kinds of forces. So there's like apparent forces. There's, you know, there are, so like, and there's the, in relativity, in relativity, like relativity looks at gravity, it models how objects interact with gravity as this field, as like the slope vector of a field, right? The thing that we have to remember is that force is just a concept. Force is just a mathematical concept that we use to model things in the physical world. And gravity can be the force that pulls things towards mass, right? We can model that as a force in the Newtonian style, or we could model it as a slope vector in a field, like in relativity. These are just math.
You agree it
to
can't be both, right? Like you agree that there's no, you're familiar with the concept that there is actually technically no pull, only push.
But
right,
what we're talking about when we compare like relativity or like Newtonian mechanics, we're just talking about two different mathematical models that both try to make predictions about the same phenomena. So I don't see it as like we're choosing between one, you know? I see they're both just attempts to explain phenomena that we see.
So the Cavendish is an example of bending space-time.
If you're analyzing it in terms of, relativity, like Einsteinian model of gravity, then it is bending space-time. If you're analyzing it in terms of Newtonian, where gravity is just a force, then you can analyze it that way.
But then we have to get into the idea of like, what's the objective reality, right? That's more important than anything. I mean, that's what this discussion is about. Do we have an objective reality?
Science cannot give that to us.
Right. But I mean, that's why we're saying outside of science, what's our reality?
I mean, so when I'm really like reductionistic about what science, like the epistemic limits of science. but I think of science as just one of many ways that we can attain knowledge. Science is just one sort of language and way of communicating, and
exactly.
it can give us one direction, one way of getting at knowledge. I think there's a lot of other different ways, different philosophical systems that can get to knowledge, but they're going to get to different kinds of knowledge with different kinds of limitations of their own.
Well, then how would you combine all of those to decide what you personally feel is your objective reality?
I think while it's a good pursuit to try to unify things, I think to expect that everything should fit together perfectly, to expect that you could find one way to see everything you experience in life under the same roof, I just don't think that that's reasonable with how complicated human life is.
Well, don't give these guys the wrong impression. Actually, Ed Monk's a really creative person. He's read like all the lost books of the Bible and has like thoughts beyond just science oriented, how science oriented he might sound right now. At least that's what I think. Am I right about that?
Thank you. That's very flattering. But science is a very powerful way that we can learn things, a very powerful way to get at knowledge. It's not the only one, but I don't expect there to be a unified way to integrate all of these things. I'm constantly at battle in myself, and I accept that maybe I'll never fully integrate all of the things that I think.
Well, at some point you could be like, like if you had $1 million and you had to bet one way or another, you had to bet that, right? Do we live on a spinning ball or not, right? Right now you think maybe you do.
If I'm gambling, right? Gambling is a different thing, because gambling is about probabilities, and if I'm gambling, then for sure I'm gonna gamble on the globe, because that's the model that I think explains everything the best.
Right. And for a lot of
finished saying we'll never know.
Our gut instinct says it's fucking flat, not just because, not for the obvious reasons that it looks flat, it seems like stationary, but just our gut instinct about the whole thing is like it so resonates with the idea that there's no way we're on a spinning ball.
Well, this is good because gut instinct is another very powerful way to get at knowledge. And if for most people in human life, they're going to use gut instinct more than they use, the scientific community, right? And it's going to work for them a lot better in most cases. Gut instinct is another very powerful way to get at human knowledge. The question is,
until it comes to the shape of the Earth, of course.
The question is which questions about our world should be answered by which systems of knowledge? And for me, I think that the shape of the Earth should be answered is a question that falls under the purview of science rather than gut feeling.
Leave that to the experts, boys and girls. Just trust.
Not just the experts, though. I don't think of science as just the experts.
If the experts were lying, though, your gut instinct might change, right?
My answer does not just come from the experts. My confidence in the globe doesn't come from experts. It's a big part of it for sure. But when I've looked at what the experts have to say, combined with what the experiments that lay people have done, I don't see any other explanation.
Yeah, Enmont really changed my mind about Globers in general, to be honest, guys. I thought most Globers just haven't looked into it enough, or they've got some agenda, or they're just defending it because they're, in cog dis. But I think he really does think he's on a ball. And it was like, going back and forth with him was what made me change my mind about that people really can look into all of the different concepts and still truly think it's a ball. And that amazes me, because I thought as soon as I figured it out that it was just a matter of time before everyone realized it too.
Yeah, it's interesting.
Thank you. That's very, very flattering. Very flattering. If all I can convince you of is that I really genuinely think that we're on a globe, then I'm happy, I guess.
That's it.
Took a while, man. I was like, man, I've thrown everything I got at this guy, and he still takes it. You know, it's like you gotta explain how this like net quality of air moving in one direction is moving a plane to match the tangential speed. I don't buy that one. I don't think you do either.
Were you guys talking about the like the atmosphere
No,
stuff
we
earlier?
were last time you were here. Like we were talking about how the wind moves in all directions. So how is this magical Coriolis wind moving you into the tangential speed to make it seem like it's completely stationary below you? So conveniently, no matter where you fly with that jet that I had to propose, you know, that the jet that flies 1,000 miles per hour has 40,000 pounds of thrust resistance, can hover in midair, and it can't get to a point where it sees the ground moving left to right underneath it? What? I don't think so. I think that jet can prove it.
I mean, do you remember my objection to the jet?
Yeah, winds.
What about the
That
wind?
the winds would perfectly keep it in sync with the Earth, that it would never be able to see the Earth spinning below it relative to its own motion. But those winds go in all directions, and you were saying last time you were on that the net force of the winds, regardless of which direction they're going, somehow these tachyon particles or whatever that are going to be moving in one direction are making the force. They're forcing this badass jet to stay in sync with the Earth, and I think it's a stretch.
My basic objection to the jet is that, or this idea that, you know, we could move a vehicle enough to where we could see the effect of Coriolis. And I saw this, you know, when I wrote the simulation, the thing, which I really should figure out how to port that onto a website. My objection is that the Coriolis effect is so much smaller than the average effect of just random wind in the environment that the signal would get lost in the noise. If the signal that we're looking for is like visible, is like somehow we can see the Earth moving under the plane, right? As the jet has to fly through a ton of noise, a ton of random wind in order to get to that signal, right? To get far enough to see that signal. And it also has to deal with the fact that, you know, let's say, now I think it could work in a vacuum. I think that your jet example could work perfect in a vacuum. But on Earth, when there's wind buffeting the jet in a much stronger way than the Coriolis effect is, I just think it would be almost impossible to see.
Even if the jet can fly as fast as they say the Earth spins.
But as the speed of the jet increases, so too do the forces of wind that, you know, as you're moving faster, the forces of wind are going to impact the jet all the more.
Yeah, but if you're going north as opposed to south, the wind's going to still be going east either way.
Yeah, and
so
when we calculated,
prevailing easterly winds aren't going to push you into the right tangential speed to match that when you're going north as opposed to south.
So it's not that the winds are going to push you in all perfectly in the opposite way of the Coriolis. It's that when you're flying a plane, you navigate the plane based on the ground. The plane is navigating based on a trajectory that's drawn along the ground. And whenever you're following a trajectory that's drawn along the ground, you're counteracting a whole host of wind forces to stay above that line. And the Coriolis essentially just gets lost in there.
Well, that's why I'm saying if you use the North Star as a dead reckoning reference point, and you know that you're going straight, no matter what, then you should be off by a certain amount of kilometers or miles by the time you get to that city that you were expecting that would be right in line with you and the star. And if you get to that city, the Earth hasn't moved. If that city's moved, you know, however many miles you calculate to the left or right, then that means the Earth moved underneath you.
It would work the same for Polaris. It would work the same for Polaris as if we're dead reckoning with Polaris, or if we're staying above a line, a trajectory drawn onto the ground. It would work the same. As you fly towards Polaris, right? You're trying to fly as straight as you can towards Polaris. Inevitably, because you're flying in a plane with air, flying around, wind changing, all that stuff, you're going to be correcting to keep your trajectory towards Polaris.
Right.
All of those corrections that you make throughout the flight are so much larger than the effect of Coriolis that as you fly to stay lined up with Polaris, the Coriolis effect is just going to get lost in comparison to all of those little
but it's not
corrections.
it's the destination that you're because we figured this out. If you were going from New York to Florida, by the time you got to Florida, if you were going at a certain speed, you should be this many miles off if you were able to travel in a straight line.
Yeah, but the question is, so like when we look at it in the big picture, when we look at the big picture and we see like what is how far away the city is compared to when you started, it's easy to get caught up in that. But in practice, what the pilot would be dealing with is the Coriolis force as it's applied every second of the flight, right? And we can calculate that. We can calculate the acceleration due to Coriolis that the pilot would have to correct for, right? Consciously or not. We can calculate that. And it turns out it's so small, it wouldn't even show up on any dials, any readings.
But it shows up when you shoot a bullet straight.
Correct, because a bullet, what we're dealing with a bullet, the reason that we can see it a lot easier, and even with a bullet, it's still really difficult to see when you take into account wind and stuff. The bullet isn't correcting its path during the flight. The bullet is just going straight forward. It's not correcting its flight. But
that's the whole idea. If you're mimicking the straight path of a bullet, then you should have displacement.
But a bullet flies for 30 seconds at most, or planes are going to be flying over the course of hours. Corrections are going to corrections, and the impact of wind and corrections are much a bigger thing to deal with planes as opposed to bullets. And with bullets,
but if you
it's easy to see.
Straight, then you should be off a certain amount of miles by the time you get to the destination spot, because you're correcting for wind no matter what.
We don't correct for wind to stay going straight. We correct for wind to stay on our chosen path.
Right.
And the chosen path is a trajectory that's drawn on the ground.
Right.
Right.
So that's why you have to use the star. So you're not, irregardless of the ground, you'd be going.
If we
straight.
go towards the star, then it's effectively still just a path drawn on the ground. We're just going north. We're just going north with respect to the Earth.
The whole idea of Coriolis is that the Earth moves below the bullet.
Yes.
Which is why it would be off course. So if you go over many more tangential speeds over longer distances with a jet that's able to go in and out of the jet stream and fly all around in circles and get out of sync in whatever way it needs to, but in a straight path, you should be able to predict that if you're headed for Florida, by the time you get to Florida, it's going to be 200 miles east of you.
We've